everyone, welcome to this Generative AI Full Course by Simplilearn. So whether you're new to AI or want to take your skills to the next level, you are in the right place. So in this course, we will start with the basics of generative AI and show you a clear learning path to help you understand this exciting technology. You learn about important AI tools like large language models, deep learning, and agentic AI, all explained in simple terms. We'll also dive into some powerful tools like OpenAI Codex, Hugging Face, LangChain, and DeepSeek, and guide you through tutorials on machine learning, reinforcement learning, and AI workflows that anyone can follow. Along the way, you'll get hands on experience with popular AI tools, learn about transformers and GANs, and also discover how AI can help you if you don't know coding through no code development. And towards the end, we'll explore advanced topics like AI benchmarking, quantum AI, and other cutting edge innovations. Plus, we will help you get ready for job interviews with special AI tools designed to give you an edge. So let's get started. Before we commence, if you're interested to master the future of technology, then the professional certificate course in generative AI and machine learning is the perfect opportunity for you. Offered in collaboration with the ENICT Academy IT Kanpur, this 11-month live and interactive program will provide you hands-on expertise in cutting-edge areas like generative AI, machine learning, and tools like ChatGPT, DALI 2, and even Hugging Face. You'll also gain practical experience through 15 plus projects, integrated labs, and live masterclasses delivered by esteemed IT Kanpur faculty. Alongside, you'll earn a prestigious certificate from IIT Kanpur, and you'll also receive official Microsoft badges for Azure AI courses and career support through Simplilearn's Job Assist program. So hurry up and enroll now and find the course link in the description box below and in the pinned comments.
Hello all, welcome to this course on Generative AI for everyone. So let's start with what is Generative AI. Generative AI is a type of artificial intelligence that focuses on creating new content rather than just analyzing or recognizing patterns in existing data. So unlike traditional AI, which might be used for tasks like predicting outcomes or classifying data, generative AI can generate entirely new items such as text, images, music, and even videos that did not exist before. So at the heart of generative AI is the ability to learn from datasets. The AI is trained on massive amounts of data. This could be millions of images, articles, or pieces of music. So through this training, the AI learns patterns and structures within the data, and then it uses this knowledge to create something new. For example, if you ask a generative AI to write a poem, it will use what it has learned about how poems are structured, such as rhyme, meter, and themes, to generate a brand new poem from scratch. So the core technology behind generative AI often involves advanced machine learning models, particularly GANs, which stands for Generative Adversarial Networks, and transformers. So these models learn how to create realistic and relevant content by processing vast amounts of data and understanding the underlying patterns. For example, in GANs, two parts of the model are there. One generates content and the other evaluates its authenticity. So these work together in a sort of competition, which pushes the system to improve its ability to create convincing and realistic outputs over time. So generative AI is incredibly powerful because it can be used for many practical applications. It helps automate tasks that were once very time consuming, like content creation or design, and it also allows for innovation in areas like entertainment, marketing, and healthcare. So for example, AI can be used to create realistic video game environments or come up with product designs for business. In marketing, AI can generate personalized email campaigns or social media content at scale. However, as impressive as generative AI is, it also raises important ethical concerns. One of the major challenges is its potential for misuse, such as creating deep fakes, which are hyper-realistic fake videos, or generating misleading information. And another issue is bias. So if the AI is trained on biased or incomplete data, the content it generates could perpetuate those biases. Additionally, there's a question of job displacement, as AI-generated content becomes more common in creative fields like writing or art. We'll look more about these in the following chapters. So now let's see, how does GenAI work? So generative AI works by using sophisticated machine learning techniques, as already discussed before. So the key concept behind generative AI is that it doesn't just analyze data, but rather it creates something new that mimics the patterns it has been trained on. So the technical foundation of generative AI is built on complex algorithms and models, with GANs and transformers being the most commonly used techniques. So let me just break it down in more detail. The first step is, of course, training phase, which is learning from data. So generative AI models are trained on large data sets that contain examples of the type of content the model is expected to generate. So for instance, if you're training a model to generate images of cats, the model would be shown thousands or even millions of images of cats so that it can learn the various features that make up a cat, like shapes, colors, textures, and so on. So this process involves a training algorithm which adjusts the model's internal parameters to minimize the difference between the generated content and the real data. So essentially, the model starts by making random guesses and gradually improves over time as it learns more about the data it's being trained on. The process of training can be computationally expensive, often requiring powerful hardware like GPUs to process large datasets quickly. So now let's move on to the key models in generative AI. So number one is GANs, which stands for Generative Adversarial Networks. So GANs are a popular architecture used in generative AI. GANs consist of two neural networks, the generator and the discriminator. So the generator's job is to create new data like images, videos, or text, while the discriminator's job is to evaluate whether the generated data looks real or fake. So here's how it works. So the generator starts by creating random content, for example, an image. So it doesn't know what a real cat looks like at first. So it starts with something that could be completely random. And then comes the discriminator's part. The discriminator then compares the generated content to real content from the training data, like some real image of the cat. And then it tries to figure out if the content is real or fake. And then the generator learns from the discriminator's feedback. Basically, the discriminator will give the feedback if the content generated is correct or not. And then the generator learns from the discriminator's feedback and tries to improve. And over time, the generator gets better at creating realistic content, and the discriminator gets better at detecting fake content. So this back and forth training process improves the overall ability of the model to create content that looks and feels real. So GANs have been used to create realistic images, generate new fashion designs, and even create human-like faces in photos. And then comes transformers. So transformers are a different architecture used primarily in natural language processing, NLP, for tasks like text generation, translation, and summarization. So the transformer model is known for its ability to handle sequential data like text, where the order of the data matters. So the main building blocks of transformers are attention mechanisms. The attention mechanism allows the model to focus on different parts of the input sequence, like words in a sentence, when making predictions. So for example, when generating a sentence, the model pays more attention to certain words in the context of the sentence to ensure the output makes sense. So here also we have two parts. First is the self-attention. So this is a key concept in transformer, self-attention. It enables the model to consider all parts of the input data when making predictions, rather than just focusing on a fixed window of data. So this helps the model to understand the relationships between words that might be far apart in a sentence. And then we have the encoder-decoder structure. So in many transformer models like BERT or GPT, there is a two-part structure. The encoder reads and understands the input, while the decoder generates the output. So the encoder takes a whole sentence and creates a representation of it, which is then passed to the decoder to generate the corresponding output. So one of the most well-known transformer-based models is the famous GPT, Generative Pre-trained Transformer, which powers tools like ChatGPT. So GPT generates human-like text by predicting the next word in a sequence based on the words that came before it. So it can produce anything from short answers to entire essays by learning from vast amounts of text data it is provided with. Now, once the training phase is done, the next phase is the data generation phase, which is creating new content. So the data generation phase is where the trained generative AI model uses the knowledge it has gained from training to create new content. So this phase involves several steps, and the type of content it generates can vary significantly depending on the model and the input provided. So the first step is input to the model. So the model needs some form of input to begin generating new content. So depending on the type of model, there could be various types of inputs. The first being the text generation. So in text generation, for example, like GPT, the input is usually a prompt or a starting sentence. So for example, if you give a prompt like write a poem about the ocean, the model will use that as a basis for generating the poem. And next we have image generation. So for image generation, for example, in DALI or GANs, the input might be a textual description of what the image should look like what image, what kind of image you want to generate. For example, it could be something like a sunset over the mountains with a clear sky. So in GANs, the input could also be a random noise vector, which the generator uses to create a detailed image. And then we have music generation like MuseNet, where the input might be a short melody or a genre specific, like write a jazz song, and the AI will then produce a full musical composition in that style. So once the input is given to the model for data generation, the next step is the transformation of input to output. So after receiving the input, the AI's job is to transform it into an output that aligns with the patterns and the structures it learned during the training phase. So the model uses its internal learned parameters to guide this transformation. So for example, in text generation, the model processes the input, sentence or prompt and generates subsequent words one after another. So based on probabilities it has learned, it predicts the next word in the sequence, considering the words before it. For example, we gave input once upon a time. So the model might predict the next word could be there. For example, once upon a time there was, like that, leading to a coherent sentence. So for example, it would produce something like once upon a time there was a dragon. So it continues this process until the text is complete. And then for image generation, if the input is a description, the AI will generate an image that fits that description. The generator uses what it has learned from textures, shapes, colors, and other image features from the training data. So for example, if the description was a cat wearing a top hat, the AI would combine the learned features of cats and hats to create an image that matches the description. Then for music generation, the model processes the given input, such as a short melody or a genre specification, and uses patterns learned from training on music data to create a complete musical piece. It may follow certain patterns like rhyme, melody, and chord progression that are typical for that genre. It's just use of randomness. So one interesting aspect of generative AI is the use of randomness. In many cases, the model starts with a random noise vector or some random elements as the starting point. In GANs, for example, the generator begins by producing random content like a random image and refines it through feedback from the discriminator, as already discussed before. So over time, as the generator improves, the output becomes more coherent and realistic. So in text generation models like GPT, randomness is often introduced through a sampling mechanism. The model doesn't always generate the same output for the same input, right? As you might have seen in GPT, like using ChatGPT, whenever you ask the same question multiple times, it provides a slightly different answer. So the model doesn't always generate the same output for the same input. There's a degree of randomness in choosing the next word, which leads to more varied and creative responses. And then comes iteration and refinement. So in some cases, especially with models like GANs, the data generation process is iterative. The generator produces an initial version of the content and then it is refined over multiple cycles. So each cycle uses feedback from other components of the model to improve the output. So over time, the generated content becomes closer to what humans would expect in terms of quality and realism. So once the training phase and the data generation phase is over, the next phase is of course the evaluation phase, which is assessing and improving the generated content. So once the content has been generated, we have to evaluate it. So this phase involves checking whether the generated content meets certain criteria such as realism, relevance, coherence, and creativity. So the evaluation phase can be done through both automated and human-driven processes, and it can occur in real time or in a post-generation step. So first we'll discuss about automated evaluation. So in many generative AI systems, evaluation is built directly into the model, and this is particularly common in systems like GANs, where the discriminator serves as an evaluator. So here's how it works. First is the discriminator in GAN. So after the generator produces content, for example an image, the discriminator evaluates whether the generated content is real or fake. It does this by comparing the generated content to the real examples from the training dataset that we had provided during the training phase. Now the discriminator gives feedback to the generator, guiding it to improve its content. So over time, as the generator gets better, the discriminator gets better at detecting fake content also. So this creates a feedback loop where both the generator and discriminator improve in tandem. So eventually, the generator creates content that is highly realistic and difficult for the discriminator to distinguish from real data. And then we have the self-assessment in transformers. So in models like GPT, for example, evaluation often happens internally through a process called self-attention. So the model checks how well each part of the generated output fits with the surrounding context. So if the model detects inconsistencies like strange word choices or unnatural phrasing, it will adjust its output to improve coherence. So after the automated evaluation, we have the human evaluation. So while automated evaluation is crucial, human evaluation is often needed to ensure that the generated content meets higher level expectations, right? Especially when it is a complex or creative task. So for example, it's basically used for quality control. So when generative AI is used to create marketing content or writing, human editors may review the AI generated text for things like tone, accuracy, and creativity. So even if the AI creates grammatically correct data or a correct content, a human might evaluate whether the text fits the brand's voice or whether it resonates with the target audience. And also it has to be checked for bias and ethics. So humans also play an important role in assessing whether the generated content is biased or unethical. So for instance, if an AI model is generating text or images based on biased data, human reviewers can catch these issues and make adjustments. So after the human evaluation comes fine-tuning. So once the content is evaluated, the AI model may undergo fine-tuning to further improve its output. So fine-tuning involves making small adjustments to the model based on feedback from the evaluation process. So for example, if a text generation model is consistently producing relevant or off-topic content, fine-tuning can involve retraining the model on more relevant data or adjusting the model's parameters to make it focus on most important aspects of the prompt. So for example, in the case of GANs, the feedback from the discriminator helps refine the generator's output. So the model can be trained for additional iterations to produce more realistic and high quality content. And then we have the real world testing. So once the model is generated content that meets evaluation standards, the real world testing is important. So this could involve testing the generated content in the context it's meant for, such as seeing how AI generated music fits with a film or how AI generated product descriptions perform in marketing campaigns. So real world testing helps validate whether the AI generated content truly works in its intended use case or not. So now that we have a complete idea about how generative AI works and what are the steps involved, let's see some of the GenAI applications. So generative AI has found applications in a wide range of fields, transforming industries and creating new possibilities across different domains. Its ability to generate novel content, simulate scenarios, and automate creative tasks is reshaping many areas of work. So let's explore the various categories of generative AI applications and dive deeper into each of them. So the first one is, of course, content creation. So generative AI is revolutionizing content creation, enabling the generation of articles, videos, images, music, and even entire books. So let's see how. The first one is text generation. One of the most popular applications of GenAI is in text generation, where models like GPT are used to create human-like text. So AI tools such as ChatGPT, Jasper, and Copy AI help in creating or writing blog posts, social media content, advertising copy, and even books. These tools can assist writers by suggesting ideas, creating outlines, or generating full paragraphs based on a given prompt. They also help reduce time and effort in content creation by automating repetitive or less creative tasks. Next, we have image generation. So models like DALL-E and Midjourney are used to generate images based on textual descriptions. So for example, you could type a futuristic city with flying cars and the AI would generate a detailed image based on that description. So this has wide applications in graphic design, advertising, and video game development, where unique visual content is often needed. So these models are also used to create synthetic images for training other AI models or to generate art that would otherwise require a professional artist. And then we have video creation. So generative AI can also create videos from entire animations to deepfake videos. AI tools like Runway ML and Synsia are used to generate video content by creating realistic avatars that can speak in any language and even simulate real-world applications. So this has applications in marketing, customer support, and education. And then we have music generation or audio generation. So AI can compose original music tracks or generate audio effects. Tools like MuseNet, which is from OpenAI, and Ample Music can create entire music compositions based on genre, mood, or specific instrument preferences. So this is especially useful for advertisements, film scoring, or even background music in apps and video games. So AI is also being used to generate realistic voices and sound effects, for example, in virtual assistants or audiobooks. So after content creation, the next we have is healthcare. So GenAI is providing or is being a game changer in the field of healthcare. For example, in drug discovery and design, one of the most promising applications of GenAI in healthcare is its ability to help design new molecules for drug discovery. So by analyzing known compounds and understanding their chemical structures, AI can generate new molecular structures that are likely to be effective against certain diseases. So for example, Atomwise and in silico medicine use generative models to propose new drug compounds, accelerating the traditionally slow and costly drug discovery process. And then in healthcare, we have the medical imaging. So GenAI is also being used in medical imaging to enhance the quality of images, detect abnormalities, or even generate synthetic images for training purposes. So models like DeepMind's AlphaFold have revolutionized the understanding of protein folding, which is crucial for drug design. AI tools can also assist in generating synthetic MRI scans, CT scans, or X-ray images, helping researchers and doctors have more data for analyzing without the need for new scans. And then we have the personalized healthcare, which is very popular nowadays. So in personalized healthcare, GenAI can help create personalized treatment plans based on a patient's unique health data. It can also predict how patients might respond to different treatments, enabling doctors to make more informed decisions about care. And then we have the field of entertainment and media, where we have the film and animation. So Gen AI is used in film production to create visual effects, generate character designs, and even script writing. So AI-powered animation tools can generate facial expressions, voices, and movements for characters. So for example, deepfake technology has been used to create realistic simulations of actors' performance, which we see nowadays on social media, allowing filmmakers to reuse older footage or generate entirely new scenes with minimal resources. And then in entertainment and media, we have game development. So for example, in video games, generative AI helps in generating vast dynamic environments and creating new characters, plots, or levels. So, for example, games like No Man's Sky have used procedural generation powered by AI to create millions or unique planets, each with different ecosystems and environments. And then again, already as discussed before, we have music and soundtracks. So beyond just generating individual songs, AI can also create soundtracks for movies and video games. And then we have business and marketing. So Gen AI is enhancing business operations. For example, a Gen AI can be used in creating highly personalized marketing content for specific customer segments. It can automatically generate email campaigns, blog posts, social media content, and even custom advertisements tailored to a customer's preference. And then there are chatbots and virtual assistants. So AI-powered chatbots such as ChatGPT or Dialogflow are becoming more intelligent in handling customer queries. So these systems are not only used for answering frequently asked questions, but also for generating contextually appropriate responses, assisting with lead generation, and even crafting sales pitches tailored to specific outcomes. And then we have the product and service design. So in product development, GenAI can help design new products or services by analyzing consumer feedback, market trends, and existing products. And then we have education and training. So Gen AI is transforming the education sector nowadays, where we have personalized training. So AI can create customized learning paths based on a student's progress, strengths, and weaknesses. So for example, a Gen AI system could adapt lessons, quizzes, or explanations based on learners' pace and understanding. And then we have content creation for learning. So Gen AI can automatically create educational materials such as worksheets, flashcards, quizzes, and even study guides based on existing content. And finally, we have the synthetic data generation. So in many fields, generating synthetic data is a crucial application of GenAI, especially when real data is difficult to obtain or too costly to generate. So by creating realistic artificial data sets, AI can simulate real-world scenarios for research, training, or development processes. So the first one is data augmentation for AI models. GenAI is used to generate synthetic data that augments real-world data sets, especially in computer vision or natural language processing. So for example, AI can generate images of objects or scenes that are underrepresented in existing data sets, helping improve the performance of machine learning models. And then we have the privacy preserving data. So for example, in sectors like healthcare or finance, Generating synthetic data can help create datasets that protect the personal privacy of the patients. So these datasets can be used to train AI models without exposing the sensitive information such as medical records or financial transactions. So now that you've got a clear picture of what is generative AI and how it works, now let's go into a deeper understanding how generative AI creates content. Hi, also in this chapter, we'll see how generative AI creates content. So AI models, particularly those in the domain of NLP, learn and generate text by using deep learning techniques, primarily through the use of neural networks. So let's explore the technical details of how AI models like GPT and similar architectures learn and generate text. So the first step is pre-processing and tokenization. So before an AI model can start learning from text data, the data that we give, must be first pre-processed and tokenized. So here's how it works. First, we have the text pre-processing step. So here, the text data is typically cleaned and formatted to remove noise like punctuation, special characters, or irrelevant words. So text may be normalized by converting everything to lowercase, removing stop words, example the, and, or correcting spelling errors. So the goal is to prepare the data for efficient processing by the AI model. And then comes tokenization. So tokenization is a process of converting text into smaller units called tokens. So tokens can be words, subwords, or even characters. So for example, the sentence AI model learn and generate text might be tokenized into words, like separate words as tokens, like AI models learn as separate tokens. So for example, here you can see this is a sample text. So here they have tokenized each word, but can also tokenize each, letters or a group of letters. So for example, if it's generating, the word is generating, it can also tokenize it as gen, one token, ER, one token, and ating is another token. So this allows the model to understand and generate less common or compound words that isn't seen before. So the next step comes training the AI model. So the learning process of AI models is typically based on deep learning, a subfield of machine learning where models are trained using neural networks. So here's how it works. First, let's talk about neural networks. So these networks consist of layers of interconnected nodes called neurons that mimic the structure of the human brain. So the most common neural network for NLP tasks are feed-forward networks, RRNs, and transformers. So transformer-based models such as GPT have become the state-of-art architecture for NLP due to their superior performance in handling sequential data like text. Then we have training with large data sets. So to train the model, vast amounts of text data are used. So these data sets are typically scrapped from books, websites, articles, and other written content. So the model learns by analyzing the context in which words appear, understanding the relationships between them, and developing a general understanding of language. And then we have the objective of training. So the core objective of training a text generation model is to minimize loss function, which measures how far off the model's predictions are from the actual data. So the most common loss function for text generation tasks is cross entropy loss, which evaluates how accurately the model predicts the next word in a sequence of words. So during this training process, the model is given a sequence of words or tokens and is asked to predict the next word in that sequence. So for instance, in the sentence, the cat is on the dash, the model would be trained to predict words like mat, roof, or similar words based on the context. So the model adjusts internal parameters through a process called backpropagation, which allows it to learn from its mistakes and improve over time. So next comes transformers and attention mechanism. So the transformer architecture is particularly important in modern text generation models. It relies heavily on a mechanism called self-attention. We have already discussed about it slightly before. Now we'll see it in more detail. So we'll just see how it works. So the first step is self-attention. So in a sequence of words, not all words are equally important for understanding the meaning of other words. So the attention mechanism allows the model to weigh each word's importance in relation to others. So for instance, in the sentence, if there's a sentence, the quick brown fox jumps over the lazy dog. So the model needs to focus on fox and jumps when predicting the next word after the quick brown fox. Then comes the attention score. So the attention scores are basically calculated using a mathematical operation that compares each word or each tokens in the sequence to other words. So the result is a set of attention weights that tells the model which part of the sentence to attend to when making predictions. And then we have the multi-head attention. So the transformer models use multi-head attention, which involves running the attention mechanism in parallel over different parts of the input, allowing the model to focus on different relationships between words simultaneously. So these help the model capture a variety of linguistic patterns such as long-range dependencies. And then there is position encoding. So unlike traditional sequential models like RNNs, transformers don't process words in order, meaning they don't inherently capture the sequential nature of language. So to account for word order, transformers use positional encoding, which adds information about the position of each word in the sequence. So this ensures that the model understands the relative positions of words in a sequence, which is crucial for tasks like generating coherent sentences. Now the next step is generating the text. So once a model is trained, it can be used to generate text. So here's the process. The first one is of course input prompt. So text generation begins with an input that we give, which is a seed or a starting point for the model. So this could be anything from a simple as a single word or a short phrase. Next is the prediction process. So the model generates text token by token. So it predicts the most probable word, the most probable next token based on the context provided by the input and the previous tokens it has already generated. And then there are sampling methods. So there are different methods to sample the next token. So one of it is greedy search. So the simplest approach is to always pick the most likely next word. So this can produce fluent text but may lack creativity or variation. And then we have samplings like top K sampling, where instead of picking the single most likely word, the model samples from the top K most likely word. And then there is also temperature sampling, where this method adjusts the probability distribution of the next word based on a temperature parameter. So higher temperature leads to most random selections, while a lower temperature makes the model more deterministic and focused on most likely words. And then there is contextual understanding in generating text. So as a model generates text, it uses the context of the previously generated tokens to inform the next predictions. So this is especially important for maintaining consistency and logic in the generated text. So for instance, the model might need to keep track of a specific character's name or a story setting to ensure that the output, the tone of the output or the style of the output remains relevant. So once the text is generated, we have fine-tuning and transfer learning as the next steps. So first, let's talk about fine-tuning. So after the model has been pre-trained on a large data set, it can be fine-tuned on more specific data to improve its performance on particular tasks. So for example, if a model is trained to generate general text, it can be fine-tuned on a data set of legal documents, medical literature, or product reviews to make it more specialized. And then we have transfer learning. So transfer learning means it's a key feature, especially in modern NLP models. So a model trained on one task or domain, for example, let's take general text generation. It can be fine-tuned and adapted to perform well on different tasks with less data. So this helps make generative AI models more adaptable and efficient. So now that you have seen how generative AI creates content, let's talk about LLMs or large language models. So LLMs have become one of the most powerful and transformative technologies in the field of AI. They leverage mass amounts of text data and deep learning techniques to generate, understand, and process human language. So let's explore the technical details behind the power of LLMs and understand why they are so influential in the AI world. So first, let's see what is LLM. So a large language model is a type of neural network based model designed to process and generate human language. So LLMs are built using deep learning techniques that are typically trained on enormous datasets containing billions or even trillions of words. They consist of billions of parameters, which are the weights of connections in the neural networks, which makes them extremely powerful at understanding and generating language. So the core idea of LLM is to use statistical patterns in text to predict the likelihood of a word or phrase given its context, enabling them to generate contextually relevant and human-like responses. So for example, models like GPT-3 by OpenAI or BERT by Google can be fine-tuned to perform specific tasks like answering questions, translating languages, or summarizing text. So let's look at the architecture behind the LLMs, which are transformers. So the architecture behind LLMs are the transformers. We have already discussed about transformers in detail in the previous chapter. So first is the self-attention mechanism. So the self-attention mechanism, as already discussed, is central to transformers, and it allows the model to weigh the importance of each word in a sentence relative to every other. So for example, in the sentence "the cat sat on the mat," the word cat is most likely related to sat than to mat, right? So the self-attention mechanism helps the model capture these relationships, allowing it to understand the context better. So the model also calculates attention scores by comparing each word with every other word in the input sequence. Next, we have multi-head attention. This also we had discussed before. So transformers use multi-head attention, where the attention mechanism runs in parallel across multiple sets of attention heads. So each head learns to focus on different aspects of the input sequence, which helps the model capture diverse relationships and patterns within the data. And then we have the positional encoding. So since transformers do not process data sequentially, they use positional encoding to ensure that the model knows the position of each word in the sequence. So this encoding is added to the input embeddings, allowing the model to understand the order of words and how context is built throughout a sentence or a paragraph. And the next step is training large language models, where we have pre-training, where the model is first pre-trained on vast text data, which is a process known as unsupervised learning. So in this phase, the model learns to predict the next word in a sentence. So during pre-training, the model develops a deep understanding of how language works by looking at the relationships between words, phrases, and sentences. And then we have fine-tuning. So after pre-training, the model is fine-tuned using supervised learning on more specific data sets for specialized tasks such as question answering, text classification, or summarization. So in this phase, the model learns how to apply its language understanding to specific use cases. Next, let's see the key features of LLMs. So there are several features which contribute to the remarkable performance of large language model. So let's see one by one. The first one is the scale of parameters. So LLMs are called large because they have an enormous number of parameters, right? The learnable weights within the model. So for instance, GPT-3 has 175 billion parameters, while some newer models like GPT-4 or PaLM, which stands for Pathways Language Model, have trillions of parameters. So the larger the number of parameters, the more data the model can process, and the more complex language patterns it can learn. So the performance of LLMs improves significantly as the number of parameters increases, and this is known as scaling. For example, parameter scaling. So larger models can better capture linguistic nuances, understand longer texts, and generate more human-like text. And then the next parameter, the next we have zero shot, few shot, and many shot learning. So LLMs are capable of performing tasks without needing extensive task-specific training. These models are, the first one is zero shot learning. This means basically performs tasks without any examples. So for example, a well-trained LLM can answer a question it has never been explicitly trained to answer. Then we have few shot learning, which performs tasks with just a few examples to guide the model. So for instance, if given a few examples of how to summarize articles, the model can generalize and apply this to new articles. And then we have many shot learning, which performs tasks with many examples, which is the typical case for fine-tuning on a specific dataset. So this flexibility allows LLMs to handle a wide range of applications without needing extensive retraining for each task. And then we have contextual understanding. So LLMs have a deep understanding of context. They can maintain coherent long-term dependencies, making it possible to generate text that is not only grammatically correct, but also contextually appropriate. So for example, GPT-3 can generate long paragraphs of text that make sense logically and follow the prompt closely, showing a remarkable understanding of the relationships between concepts, facts, and reasoning. So now let's see some of the applications of LLMs. It can be used in text generation. So LLMs can generate high quality, human-like text for a variety of purposes, such as article writing, creative writing, and advertising. It can be used in machine translation. So LLMs like GPT-3 and BERT are used in automatic translation systems, providing accurate translations between languages without requiring a direct mapping. Then it is also used in summarization. LLMs are used to generate summaries of long documents, articles, or books. Then it's also used in question answering. So by understanding and processing the context of a question, LLMs can provide precise, relevant answers to a wide range of queries. So this application is mainly useful for virtual assistants like Siri, Alexa, and customer service bots. Then it's used in sentiment analysis. So LLMs can be trained to classify and interpret the emotional tone of a piece of text, such as detecting whether a tweet or a review is positive, negative, or neutral. So this is widely used in social media analysis and market research. And it can also be used, as told before, in chatbots and conversational agents. So LLMs are widely used in chatbots, virtual assistants, and customer service applications. So now let's see some of the challenges and limitations of LLMs. So while LLMs are incredibly powerful, of course, they are not without their challenges and limitations. So the first one being bias and fairness. Now LLMs can inherit biases present in the training data. which can result in unfair or unethical outputs such as gender or racial bias in text generation. So this is a major concern in AI ethics. Then comes the computational cost. So training LLMs requires vast computational resources, which can be expensive and environmentally costly. And then comes the problem of interpretability. So LLMs are often considered the black box models, meaning it can be difficult to understand exactly how they make decisions. So this lack of transparency can be problematic in high stakes applications like in healthcare or law. And then we have the data privacy concerns. So LLMs, as you know, are trained on publicly available data, and it may inadvertently memorize and reveal sensitive or private information, raising concerns about data privacy and security. So next, let's see when does AI generated content works well and when it doesn't work well. So first, let's see when does AI generated content works well. So the first one is in repetitive and structured tasks. So AI excels in generating content for tasks that follow a predictable structured pattern. So this includes tasks like product descriptions. So AI can generate bulk product description, particularly when the format is consistent. For example, tools like Copy AI or Jasper can automate the creation of thousands of product descriptions in no time, and that can be used in reports and data-driven content. So AI can generate data-driven reports based on structured data, for example, financial results, sports scores, or weather reports. And it can also be used in email and marketing campaigns. So AI can generate personalized marketing emails or social media posts quickly and efficiently. Next, it can be used in content personalization. So AI can analyze vast amounts of data to create highly personalized content, and this is beneficial in areas like email marketing. So AI can write personalized subject lines, content, and calls to action based on a customer's browsing history, purchase behavior, and preferences. So, for example, AI-driven tools like Posado are already helping brands personalize their marketing materials at scale, at large scale. And then we have recommendation systems. So, as we all know, in platforms like Netflix, Spotify, or Amazon, AI generated content recommendations. It can be like movies, songs, or podcasts are highly effective at suggesting items users are likely to enjoy based on their past behavior. Then we have areas of creative and experimental work, which includes art and design. So AI models like DALI 2 and Midjourney are incredibly effective in creating visual art illustrations or design concepts from text prompts. So designers use AI to quickly generate design options and explore creative possibilities. And then comes the storytelling. So AI generated stories or scripts can help authors, screenwriters, or content creators generate ideas or overcome writer's block. So tools like ChatGPT can draft stories or plot lines based on simple inputs, helping authors develop initial drafts or experiment with different narrative structures. And then it can be used in music composition also. Next, it can be used in large-scale content production. So for large-scale content production, where speed is critical, AI can generate vast quantities of content rapidly. So for example, content for SEO. AI can generate blog posts, articles, or web copy optimized for SEO, helping businesses keep their websites up to date with fresh, keyword rich content. And then in content creation or content curation. So AI can help with curating content from various sources such as news aggregation by pulling relevant articles and data. And then it can also be used in language translation. So AI models, particularly those based on transformers like Google Translate and DeepLearn, are highly effective at translating text between languages. So these systems can handle vast amounts of text and provide real-time translations. So now that we have seen when AI generated content works well, next let's see when it doesn't work well. So the first one is in creative nuance and context. So while AI can generate creative content, it often struggles with deep emotional nuance. So AI often lacks a true understanding of human emotions and struggles to generate content that truly resonates on a deep emotional level. So, for instance, a piece of content that's meant to evoke compassion, humor, or grief might fall flat because the AI doesn't genuinely feel those emotions. And then there is cultural sensitivity issue. So, AI models trained on large data sets can inadvertently produce content that is culturally insensitive or inappropriate. Next is originality and intellectual property concerns. First one is lack of true originality. So AI is capable of producing content that appears original, but is fundamentally based on patterns it has learned, right? So this means AI generated content can sometimes lack true originality, which you might have faced while generating content, and can unintentionally replicate the existing ideas or phrases. And then there is a risk of plagiarism. So AI tools trained on large data sets may generate content that's too similar to existing work, leading to plagiarism concerns. The next, there is complex tasks requiring expertise, where highly technical writing comes. So while AI can generate content on a variety of topics, it struggles with complex specialized subjects like advanced scientific research, intricate legal analysis, or deep medical knowledge. So for instance, in areas like legal documentation, the precision and the attention to detail required often go beyond AI's current capabilities. And then there is subjective judgment. So AI lacks the ability to make subjective or qualitative judgments that are often needed in areas like art, criticism, literature analysis, or evaluating ethical dilemmas. And then there is bias and ethical concerns, which we have already discussed in the limitations. And then there is quality control and inconsistent output. So although AI has made significant strides in content generation, it often still struggles with maintaining quality, consistency, and coherence. And then there is legal and compliance issues. So in fields like healthcare or finance, AI generated content needs to follow strict guidelines. So for instance, an AI generated financial report or medical advice might inadvertently violate legal regulations or industry standards. And then there is also an issue of copyright. So AI generated content, especially art and writing, may raise questions regarding ownership. Who owns the rights to content generated by an AI? Is it the creator who prompted the AI or the company that developed the model? So these legal gray areas can create complications in industries where intellectual property rights are crucial. So now in the next chapter, we'll see how generative AI is used in businesses. How does companies use generative AI? So AI is increasingly being adopted by businesses across various industries to improve productivity, save time, and streamline operations. So here's a detailed breakdown of how businesses are leveraging AI to achieve these goals. So the first one is AI-powered chatbots for customer support. So one of the most common uses of AI in business is through AI-powered chatbots, which are transforming customer service by providing instant round-the-clock support. So here's how it works. First is instant customer interaction. So AI-powered chatbots are available 24/7 and can handle multiple customer queries simultaneously. So they can answer frequently asked questions like FAQs, provide information about products or services, and process simple transactions and resolve common issues. So for example, LivePerson, a company offering AI chatbots, powers brands like Vodafone and HSBC. So these bots can handle inquiries about account balances, service status, and more, significantly reducing the wait times for customers. Then there is cost efficiency. So with AI chatbots handling routine inquiries, businesses reduce the need for a large human customer support team. This leads to cost savings on staffing and training while maintaining a high level of customer satisfaction. So for example, Sephora, the cosmetics retailer, uses an AI-powered chatbot named Sephora Virtual Artist to assist customers in finding makeup products based on their preferences, giving personalized recommendations and beauty advice. And then it leads to improved customer satisfaction. So AI chatbots provide quick and consistent responses, reducing customer frustration. They also have the ability to analyze customer sentiment and escalate the complex issues to human agents when necessary. So for example, Mitsubishi Electric uses AI chatbots to quickly address technical inquiries from their customers, streamlining the support process and ensuring faster response time. So next, it is used in AI generated marketing content and business reports. So AI is a powerful tool for automating content generation, as we have discussed multiple times in this course. So the first is marketing content creation. So AI tools like Jasper AI and Copy AI are used to generate blog posts, email newsletters, social media posts, and product descriptions. So these tools can produce large volumes of high quality SEO optimized content quickly. So for example, Airbnb uses AI powered tools to create localized and content and personalized promotions for users. So by automating much of the content creation process, Airbnb can run personalized campaigns more efficiently. Next, there is automating business reports. So AI is widely used for generating automated business reports, including sales, financial, and operational reports. AI models can pull data from various sources, analyze it, and create comprehensive reports with actionable insights. So for example, Tableau, which is a data visualization company, integrates AI with its platform to generate automated reports and business intelligent insights. So this allows businesses to make data-driven decisions more quickly without needing a dedicated data analyst. And then there is personalized marketing campaigns. So AI can analyze customer data, including preferences, browsing history, and purchase behavior to create personalized marketing campaigns. So for example, Netflix uses AI algorithms to generate personalized recommendations for each user based on their viewing history. So this approach has contributed significantly to customer retention and engagement. Next, it is used in automating repetitive tasks with AI. So as you know, AI is a game changer when it comes to automating repetitive tasks that takes up significant amounts of employee time. So first, it can be used in data entry and processing. So AI systems can automate data entry, reducing human errors and saving employees time. So for example, AI can extract relevant information from documents and automatically input it into the correct fields in a database or enterprise resource planning ERP system. So for example, UiPath, a leading automation company, offers AI-powered robotic process automation or RPA tools that automate repetitive business tasks such as invoice processing, payroll management, and customer account updates. Next, it can be used in customer relationship management, CRM. So AI is often integrated into CRM systems to automate the tasks like lead generation, follow-up emails, and customer segmentation. So for example, HubSpot and Salesforce offer AI-powered CRM tools that automate lead scoring, email follow-ups, and sales pipeline management. And then it can be used in document management and legal work. So AI can automatically organize and categorize documents, which saves legal teams and other departments a great deal of time. So for example, Kira Systems uses AI to analyze contracts and legal documents quickly, identifying relevant clauses and potential risks. So this speeds up the contract review process, allowing legal teams to focus on high-level strategy. Next, it is used for predictive analytics. So businesses are increasingly using AI for predictive analytics, which helps forecast future trends and customer behavior. So for example, it's used in sales forecasting, where AI can analyze historical sales data, seasonal trends, customer behavior, and external factors like economic conditions to predict future sales. So this helps businesses plan production, inventory, and marketing strategies accordingly. So for example, Amazon uses AI to predict customer demand and optimize its inventory management. The AI models anticipate what products will be in demand based on historical data, time of year, and even social media trends, ensuring products are available when customers need them. Then it is used for supply chain optimization. So AI can optimize supply chain management by predicting demand fluctuations, identifying bottlenecks, and automating procurement processes. So for example, Walmart uses AI to forecast demand and optimize stock levels across its global supply chain, reducing waste and ensuring stores are stocked with the right products. Next, AI is also bulkily used in hiring and talent management. For example, it is used in automated recruiting where AI tools can analyze resumes, screen candidates, and even conduct initial interviews. So these tools help HR teams save time by identifying the best candidates based on qualifications, experience, and even cultural fit, often with less human bias. So for example, HireVue uses AI to analyze video interviews, assessing candidates' responses, tone, and body language to recommend the most suitable candidates. This speeds up the hiring process and helps eliminate bias. Also, it can be used in employee performance and retention. So AI can analyze employee performance, monitor engagement, and predict when employees might leave, helping businesses take action to retain talent. So for example, Workday integrates AI with its human resource management system to predict employee turnover and identify at-risk employees, allowing businesses to take proactive steps to improve retention. Then AI is also widely used for customer insights and market research. So AI tools can process and analyze vast amounts of customer data, providing business with insights that were previously difficult to gather. First, it can be used in sentiment analysis. So AI can analyze social media, reviews, and customer feedback to gauge customer sentiment toward products, services, or brands. So this helps businesses understand the public opinion about them. So for example, the Brandwatch uses AI to perform sentiment analysis on social media mentions, enabling companies to track customer opinions and identify emerging trends. And then there is market research. So AI-powered tools can also automate market research by analyzing industry data, competitor activity, and customer preferences. So for example, Crimson Hexagon uses AI to analyze millions of social media posts, blogs, and news articles to provide businesses with insights on consumer behavior and emerging market trends. So now that we have seen that how businesses use AI in different scenarios or different purposes, now in the next chapter we'll see how are these AI models built and being customized for these purposes. I also in this chapter we'll see how are these AI models built for customization. So basically we are fine-tuning the AI models. But what is fine-tuning? So fine-tuning is a critical concept in machine learning, particularly in the context of transfer learning, where a pre-trained model is adapted for a specific task or application by further training on a smaller specialized dataset. So the idea behind fine-tuning is to take advantage of the general knowledge a model has already learned from a large dataset and adjust it to perform better on a more specific problem without having to start from scratch. So in simpler terms, fine-tuning is a process of taking a model that has been already trained on a general task, such as it can be language modeling or image recognition, and then it is retrained with more specific data that reflects the nuances of the new task. So this process allows the model to apply its pre-existing knowledge to a more focused, specialized area, enhancing its performance for a particular use case. So that's how it is fine-tuned. A AI model which is, trained for general tasks are fine-tuned for a specific task, and then it is used for specific business use cases, as we saw before, which were the use cases. So now let's see why is fine-tuning important. So the first one is efficiency. So training a machine learning model from scratch can be computationally expensive and time-consuming, especially for complex models with millions or billions of parameters. So fine-tuning allows you to save time and computational resources by leveraging a model that has already learned general features. So the model only needs to be trained on the task's specific data for a short time to adapt to the new domain. Next is generalization. So pre-trained models, especially large models, have often been trained on vast datasets containing diverse information. So as a result, they have a rich understanding of the broader structure and relationships within the data. So fine-tuning helps the model take this broad knowledge and apply it to a specific context, improving the model's ability to generalize to real-world data related to that task. Next is performance boost. So fine-tuning typically leads to a significant improvement in the model's performance for a specific task. This is because the pre-trained model has already learned useful features such as patterns in language or objects in images or sentiments in text. And fine-tuning helps the model specialize in the exact problem you need to solve. And the next importance is of customizability. So fine-tuning allows businesses or researchers to customize pre-trained models to their specific needs or use cases without requiring deep expertise in training large-scale models. So whether it's adapting a model for sentiment analysis, customer service, or medical diagnosis, fine-tuning ensures that the model performs well in the intended context. So now let's see some of the areas or cases where fine-tuning works. So fine-tuning works by taking a pre-trained model and updating its parameters, right? So here's a detailed explanation of how the process typically works. So now let's see how does fine-tuning work. So the first step is starting with a pre-trained model. So fine-tuning usually starts with a pre-trained model. These models have been trained on vast datasets containing a variety of information. So for instance, GPT-3, which is a large language model, has been trained on large amounts of text from books, websites, and other sources to understand language broadly. Similarly, ImageNet models for computer vision are trained on millions of labeled images across various categories. So these pre-trained models have learned general representations like identifying objects or understanding sentence structures. The next step is selecting the fine-tuning dataset. So after choosing a pre-trained model, the next step is to gather a specific dataset related to the task or domain. So for example, if fine-tuning a language model for customer service, the dataset might include customer interactions, support tickets, or chat logs. Or if fine-tuning an image recognition model for medical imaging, the dataset might consist of X-rays or MRIs labeled with specific diagnosis. So once the fine-tuning dataset is selected, the next is freezing the initial layers. So in many fine-tuning processes, some layers of the pre-trained model, typically the early layers, are frozen, meaning that their weights are not updated during the training. So these early layers capture basic features, which are useful for many tasks. But freezing these layers, the model can retain its general understanding and only fine-tune the layers which are only responsible for more complex or domain-specific representations. So once that is done, the next step is training on the new task. So fine-tuning involves training the model on the new task-specific dataset, but unlike initial training, this step requires much less data and computational power. So the model is trained with a lower learning rate, so the adjustments to the weights are subtle, allowing the model to retain the broad knowledge it gained from the pre-training phase while becoming more specialized in the task at hand. So during this process, the model gradually adjusts its weight to minimize the error or loss when performing the task. So for example, if fine-tuning a text classification model, the model will adjust its internal parameters to predict the correct category for new text samples. So once the training on the new task is done, the next step is for evaluating and fine-tuning it further. So after fine-tuning, the model is typically evaluated on a separate validation dataset that wasn't part of the fine-tuning process. So this helps assess how well the model generalizes to new data and whether it has learned the task effectively. So if the model doesn't perform as expected, further adjustments may be made, such as tweaking the dataset, training parameters, or model architecture. And finally, we'll be deploying the fine-tune model. So once the fine-tuning process is complete and the model is performing well, it can be deployed for its specific task. So the fine-tuned model is now capable of handling tasks within its specialized domain, which can be examples such as answering customer queries or diagnosing medical images or providing accurate sentiment analysis and so on. So now let's see some of the examples of fine-tuning in practice, in real-life practice. So we'll take an example of fine-tuning a language model for sentiment analysis. So the first step would be to start with a pre-trained language model, which has been trained on a large, diverse text corpus. And then the step 2 would be to collect a task-specific dataset for sentiment analysis, such as a collection of customer reviews which are labeled as positive, negative, or neutral. The next step will consist of fine-tuning the model on this dataset by adjusting the model's weights so that it becomes better at classifying the sentiment of reviews. Step 4 would be evaluating the fine-tuned model on a test set of customer reviews to ensure it can correctly classify the sentiment. And finally, to deploy the model to analyze the sentiment of new customer reviews or social media comments automatically. So these are the steps to be followed while fine-tuning for a specific use case. So now let's see, when do these businesses need to train their own AI models? So businesses may need to train their own AI models in certain situations where pre-trained models or third-party solutions are insufficient for their unique requirements. So training custom AI models can provide a more tailored solution, allowing businesses to better address specific problems and use cases. So the first scenario would be for unique or specialized use cases. So for example, if a business operates in a niche industry or needs a solution for a highly specific task, pre-trained models may not perform well because they have been trained on a general data and might not be optimized for specialized requirements. So in such cases, training a custom model allows businesses to focus on their particular needs. So for example, a healthcare company may need an AI model that can analyze medical images for rare diseases or conditions that are not well represented in existing public dataset. So off-the-shelf models trained on general medical images might not be effective in detecting these rare conditions. So the company would need to train its own model on specialized medical image data. Next is, for example, a legal firm might need an AI model that can understand the nuances of specific legal terminology or interpret complex legal documents, requiring training on a dataset composed of case law, legal contracts, or regulations. Next, it can be used in the scenario of proprietary or private data. So businesses that deal with proprietary, private, or when they deal with sensitive data, it might prefer to train their own models to maintain control over their data and ensure privacy. So using pre-trained models from third parties could expose sensitive business data to external entities or compromise data security. So for example, an e-commerce platform may want to build a recommendation engine using data from its own users, such as browsing behavior, purchase history, and preferences. Since this data is proprietary, using third-party models may expose private customer information, prompting the business to train its own model. Next is, for example, a financial institution might want to develop fraud detection algorithms using their internal transaction data, customer profiles, and historical fraud patterns. So by training their own AI models, they can ensure that sensitive financial data remains within the organization. Next is the case of improving accuracy for domain-specific tasks. So pre-trained models can be good starting points, but they may not always deliver the level of accuracy required for high-stakes application. So when accuracy is crucial, especially for specialized tasks, training a custom model can help businesses improve performance significantly. So for example, a customer service chatbot using a pre-trained language model might be good at handling general inquiries, but struggle with understanding complex domain-specific queries. So training a custom model with a dataset of specific customer interactions, FAQs, and industry-specific jargon can make the chatbot more accurate in resolving issues. Next is the example of autonomous driving. A company may want to train its own model to recognize specific road signs, obstacles, or driving conditions that are unique to certain regions or environments. So pre-trained models might not be sensitive enough to these specific use cases, requiring the business to train a model with localized data. Next comes the performance and efficiency requirements. So pre-trained models are often large and computationally expensive, which might not be suitable for businesses with limited resources or those requiring real-time performance. So for example, a company building a mobile app for real-time image recognition might not want to rely on a large pre-trained model due to the constraints of mobile devices. So instead, they may train a smaller and more efficient model that can run locally on the device. Also, for an industrial application where AI is used for equipment monitoring in real time, a business may need to train custom models to process sensor data quickly and accurately. So pre-trained models could be too slow or not optimized for the specific types of data the business collects. Next, it can be used for areas in custom features or interactions. So sometimes businesses need to train models to incorporate custom features or understand unique patterns of interaction that pre-trained models cannot capture effectively. So for example, a retail business may want to build a model that recommends products based on a combination of historical sales data, inventory levels, and real-time customer behavior. So generic recommendation model may not take up all these features into account. Also, financial service provider may want to develop a credit scoring model that takes into account non-traditional data sources. In these cases, the business would need to train a custom model that processes and interprets this unique type of data. Next, it can be used in cases for regulatory and compliance requirements. So certain industries are highly regulated and require AI systems that meet strict legal and ethical standards. So as you know, pre-trained models may not comply with these regulations, and businesses may need to build their own models. So for example, in a healthcare company, it might need an AI system for diagnostic purposes that complies with medical standards. So pre-trained models that might not meet these standards. So training a custom model ensures compliance with these legal frameworks. Also, a company in the financial industry might need to ensure that its AI models used for risk assessments are transparent, explainable, and fair to meet certain regulations. So training models internally ensures that they can be adjusted to meet these legal requirements. And finally, it can be used for ethical considerations and bias control. So businesses aiming to ensure fairness and minimize bias in AI models may prefer to train their own models to have more control over data and algorithms. So for example, a company developing an AI tool for hiring might need to train their own model to ensure that it minimizes gender, racial, and other biases in recruitment. Also, an organization working in social service may want to train a custom model to assess eligibility for benefits, ensuring that the model is free from biases. So now that you know how the AI models are fine-tuned and trained for one specific use case, next let's see how we can make AI smarter with external knowledge by using RAG. Hi all, in this chapter we'll deal with how to make AI smarter with external knowledge. So for that, first we have to know what is RAG, or Retrieval Augmented Generation. So RAG, or Retrieval Augmented Generation, is a method in NLP that combines the capabilities of retrieved-based models and generation-based models to improve the quality of generated text. So the core idea behind RAG is to enhance the language model's output by retrieving relevant external information from a knowledge base or a database during the text generation process. So this allows the model to incorporate more accurate and up-to-date information that it might not have learned during training, particularly when dealing with specialized or complex queries. So this is how basically RAG works. So RAG is composed of two main components, which is retrieval and generation. So first let's see the retrieval part. So in the retrieval phase, the model receives a query or input, and it retrieves relevant documents or pieces of information from an external knowledge source. So this knowledge source could be anything from a large corpus of text like books, articles, or research papers to a structured database. So the retrieval component is responsible for identifying which pieces of information are most pertinent to the input and bringing them into the process. So for example, suppose the input is a question, what is the capital of France? The retrieval component searches a knowledge base of geographical facts and retrieves documents or passages that mention the capital of France, which would typically return the information about Paris. Now the next part is a generation part. So after the relevant documents or data have been retrieved, the generation component takes part. So this part of the model uses a generative language model. It can be anything like GPT-3, T5, or BART to generate a response, incorporating both the input query and the retrieved information. So the model generates text based on the context provided by the input and the newly retrieved data. So the key benefit of this approach is that the generation model doesn't have to rely solely on its pre-trained knowledge. So instead it can augment its understanding with external real-time information retrieved from the knowledge base. So basically there's a knowledge base given from where it retrieves the data or retrieves the knowledge. So this is particularly useful for answering factual or knowledge-intensive queries where the model's internal knowledge might be incomplete or outdated. So for example, what is the capital of France? The generation component uses the retrieved information that Paris is the capital of France to generate a more complete answer. So the capital of France is Paris, which is located in the northern part of the country, would be its reply or would be its output. So here are the key features of RAG. The first one being retrieval augmented. So by augmenting the generation process with retrieved data, RAG enables the model to access external knowledge sources in real time, making it more adaptable and capable of handling more specialized tasks. Then comes end-to-end model. So RAG models are typically trained end-to-end, meaning the retrieval and generation components are trained together as part of a single model. So this allows the model to learn how to retrieve the most relevant documents and generate the most appropriate output from them, creating a unified and efficient system. And then comes real-time access to information. So unlike the traditional models, which can only generate content based on what they have learned during training, RAG models can use up-to-date and domain-specific knowledge retrieved during the generation process. So this allows the model to provide more relevant and accurate responses to specialized queries. So now let's see why is RAG useful. So RAG addresses several key challenges faced by traditional language models. So RAG addresses several key challenges which are faced by the traditional language models. The first being handling specialized queries. So pre-trained generative models may struggle with specialized or domain-specific queries because their training data is broad and generalized. So RAG helps by retrieving relevant information from specialized sources, allowing the model to answer questions about niche topics more effectively. Then it also helps greatly in reducing hallucinations. So generative models sometimes produce hallucinated information, responses that sound plausible but are incorrect or fabricated. So by retrieving the facts, contextually relevant data, RAG reduces the likelihood of hallucination or wrong replies or wrong outputs and ensures the response is grounded in real-world knowledge. And it also greatly helps in improving accuracy. So because the model has access to a more diverse set of information, RAG models can generate more accurate, detailed, and relevant answers. So this is particularly important in applications like question answering, fact-based summarization, and knowledge extraction. So now let's see some of the real-world applications of RAG. So RAG has several real-world applications in businesses, particularly in areas where high-quality, fact-based, and contextually accurate information is essential. RAG combines the strengths of both the retrieval-based models, which fetch relevant information, and generation-based models, which generate human-like responses to provide more accurate and informative results. So let's see the applications. In customer support and chatbots, so RAG improves chatbots by retrieving relevant information from knowledge bases and generating detailed, contextually accurate responses. So for example, a telecom company uses RAG to retrieve up-to-date plans and pricing, providing personalized customer support. Then it's used in content generation. RAG helps create SEO-optimized content by retrieving data from internal sources, customer reviews, and trends. For example, an e-commerce platform generates unique product descriptions based on product features and customer feedback. Then it's used in knowledge management. RAG enhances internal document retrieval and automates report generation for businesses. So for example, a law firm uses RAG to retrieve and summarize legal cases for quick access to relevant information. It's also used in question answering systems. So RAG, as mentioned, improves search engines and customer-facing knowledge bases by generating direct answers to complex queries. So for example, a medical company uses RAG to generate up-to-date answers on treatments for doctors. Then it can be used in areas such as product e-commerce by generating personalized product suggestions based on customer data. It can be used in healthcare and medical applications where RAG supports clinical decision-making by retrieving relevant medical data and generating treatment recommendations. And it can also be used in areas of research and development, where RAG aids in scientific, literature search, and technical documentation retrieval, generating summaries and reports for faster decision making. So now that we have studied the applications, what is RAG, how we can make AI smarter, and also the real world applications of RAG, now let's move on to see what are the costs of using AI. Hi, also in this chapter, we'll see the costs of using AI. So AI is revolutionizing industries and offering businesses ways to increase efficiency, but it's important to understand the costs involved in using AI, particularly how AI models charge for usage, how much it costs to generate content, the comparison between AI and human labor, and when to use AI versus hiring a human expert. So let's break down each of these concepts in this chapter. So basically, how AI models charge for usage. So AI models typically charge based on the amount of usage, which is often measured in tokens or compute resources. So the two most common ways AI models, especially language models like GPT or Claude, charge for using are: number one is for tokens. So in the context of AI language models, a token refers to a unit of text, which could be as short as one character or as long as one word. So pricing for models like GPT is usually based on the number of tokens processed, including both the input tokens, which is the text that we provide as queries or prompts, and the output tokens, which is the text generated by the model. So for example, OpenAI's GPT-3 charges based on the number of tokens. A single token typically represents about 4 characters of English text. So that's the count. Now, depending on the model and the amount of text processed, you may be charged for the input tokens, that is the prompt you give the model, and the output tokens, the generated response. So pricing varies depending on the model size. Example, Ada, Babbage, Curie, DaVinci for OpenAI's models, and the total number of tokens used per interaction. So let's say, for example, if you send a prompt with 100 tokens and receive a response that generates 200 tokens. So the total cost is based on 100 input tokens plus 200 output tokens, which is 300 tokens. So prices can range from fractions of a cent per 1,000 tokens to a few dollars for larger models or complex tasks. Next, it is also charged on the basis of compute resources. So some AI models, especially for more complex tasks like image generation or video processing, charge based on compute resources they require. So this could be measured in terms of CPU or GPU hours, the storage space used, or the bandwidth consumed. So for example, Google Cloud AI, AWS, or Microsoft Azure charge businesses based on how much GPU or TPU time is consumed when running tasks, like training a custom model or generating content. So costs vary depending on factors such as the power of the infrastructure used, how long it runs, and the specific service tier chosen. So let's see how much it costs to generate content with AI. So the cost of generating content with AI depends on several factors, including the complexity of the content, the type of model used, and the pricing structure. So here's an overview. So first, let's see content generation costs for text. So basic text like short form. For simple tasks like generating short paragraphs, product descriptions, or emails, AI models may cost only a few cents per output. So for example, generating 100 to 200 words using a model like GPT-3 could cost you a few cents. Then comes long form content. So generating long articles, reports, or complex stories involves more tokens and could be more expensive. So for instance, generating a 1,000-word article could cost anywhere between $1 to $10, depending on the number of tokens processed and the model used. Next comes custom training. So if businesses are using AI to generate highly specialized content, they may need to fine-tune or train a model on domain-specific data, which can incur additional costs apart from this. Next are the content generation costs for images or videos. So in image generation, AI image generators like DALL-E 2 or Midjourney typically charge per image generated. So a single image might cost anywhere between $0.5 to $5 depending on the platform and resolution. And AI video generation is generally more resource intensive, especially for high quality content. So the cost can vary widely based on factors like video length, resolution, and complexity. So for example, platforms like Runway ML or Cincia might charge hundreds of dollars per minute of high quality video. So let's say an example, if an e-commerce site uses an AI model to generate 500 product descriptions. So it might cost $20 to $100 depending on the model and the length of description. The model might process hundreds of tokens per product description, leading to more substantial costs for large-scale content generation. So having known the costs of AI, let's see an AI versus human labor, whether AI is really cheap. So one of the key benefits businesses look for in AI is its potential to replace human labor, right? particularly for repetitive or low-skill tasks. So, however, when evaluating whether AI is really cheaper than hiring a human expert, there are several factors to consider. First is for repetitive low-skill tasks. So, AI can be significantly cheaper and more efficient compared to human labor. For instance, AI-powered chatbots for customer support, automated data entry, or content generation for marketing can perform these tasks much faster than humans without the need for breaks, vacations, or training, and often at a fraction of cost. So, for example, a human customer service agent might cost a business $15 to $30 per hour, while an AI-powered chatbot might cost $0.01 to $0.05 per transaction. So, for high volumes of customer inquiries, AI becomes vastly more cost effective than in areas where high skill creative or specialized tasks are needed. So, AI still faces limitations in tasks that require high level expertise, nuanced decision making, or creativity. Human experts bring a wealth of contextual understanding, emotional intelligence, and domain specific knowledge that AI models currently cannot replicate. So, for example, legal analysis, strategic business decision making, and highly creative content production often require human input. So, for example, while AI can generate basic copy for blogs or advertisements, creating a marketing campaign with a unique voice, cultural relevance, and deep understanding of customer psychology would likely still require a human marketer. Next are some of the hidden costs of implementing AI. So, while AI can appear cheaper in short term, businesses must also consider the hidden costs, such as model training, data acquisition, maintenance, and compute resources. So, additionally, fine tuning and customizing AI models for specific tasks can incur significant costs. So now let's see when to use AI versus when to hire a human expert. So choosing whether to use AI or hire a human expert depends on task's complexity, the need for creativity, and the budget constraints. So here are some guidelines. First, let's see when to use AI. So when the task is repetitive and data driven, examples including automating customer service, generating basic marketing content, processing large data sets, and creating reports or summaries. Also, AI can process vast amounts of data in seconds, whereas human work may take much longer. So, this is ideal for tasks like real-time recommendation, 24/7 customer support, and content generation at scale. Also, cost efficiency is key. So, for tasks like generating large volumes of standard content, AI is often much cheaper than hiring multiple human workers. Also, where standardization is required. So, AI is perfect for tasks that require uniformity, like generating standard emails, filling out forms, or processing invoices. So, now let's see where we should hire a human expert. So, first is, of course, where creativity and critical thinking are required. So, human experts excel in generating creative content, crafting strategies, and handling complex tasks that involve interpretation, judgment, and problem solving. So, AI still lacks true creativity and the ability to understand deep context, also in tasks which are highly specialized. So, for instance, a human expert in law, medicine, or engineering brings a level of domain expertise and nuanced understanding that AI cannot yet replicate. Also, where emotional intelligence or relationship management is required. So, human experts are essential in tasks like therapy, sales, and consulting, where empathy, understanding, and interpersonal skills are required. So now that you've got a clear understanding of where we have to use AI, Gen AI, and where we have to use a human expert, now in the next chapter, which is our last chapter, we'll see what is the future of generative AI. How does the future of generative AI look like? So in this last chapter, we will have a quick glance of how the future of Gen AI would look like. So generative AI is advancing quickly and is expected to transform numerous industries in the near future. So here's an overview of how Gen AI will evolve and its potential impact. First one is advancements in model capabilities. So the future of Gen AI will bring enhanced performance and flexibility. First is improved coherence and context understanding. So GenAI models will become better at understanding long-term context and maintaining coherence across industries. So this means more natural conversations and better continuity in content creation. Then comes multimodal ability. So GenAI will move beyond just text and images to handle a variety of modalities, including video, audio, and like more improvised and perfect video and audio creation. So this will allow the generation of not only written content, but also, better at visuals and voiceovers. Also in hyper personalization, AI will become more adept at generating tailored content based on real-time data. So businesses will be able to deliver highly personalized experiences in marketing, customer service, and other areas adapting to individual use preferences. Next is expert across various industries. Like healthcare, where GenAI can help diagnose diseases, recommend treatments, and also with drug discovery. It can be used in education, where GenAI will generate customized learning materials, adaptive quizzes and explanations. Also, it will be more widely used in entertainment, generate unique video game narratives, movie scripts, entirely fresh content, and even entire songs. So it may also be used to create interactive and dynamic content in gaming, where the storylines evolve based on player choices. Also, it can be used in creative industries. GenAI will assist artists, designers, and writers for creation. Next is increased accessibility. So first comes low-code or no-code platforms. So with the rise of low-code and no-code tools, businesses and individuals with little technical expertise will be able to learn generation, customer interaction, and more. Also user-friendly interfaces. So future GenAI systems will likely feature voice or gesture-based interfaces. The AI in intuitive ways, making it more accessible for everyone, not just developers. So that was it, guys. Congratulations on completing the course. You have now gained a solid understanding of generative AI and its transformative impact across industries. So from content creation to automation and personalized experiences, Gen AI is revolutionizing how we work and innovate.
Are you feeling like every other video, article, or tweet you see these days is about generative AI? You're not wrong. It's the tech world's current obsession. But instead of just nodding along, wondering what it all means, what if we could actually master it? In this video, we are cutting through the hype, giving you a practical step you need to truly understand. I will be breaking down the entire journey into manageable phases from fundamental knowledge to building your own Gen AI projects. Before we begin, let me tell you what generative AI or Gen AI means. As the name suggests, it is generating data. It's a technology where it uses existing data for creating new ones. It might be in the form of text, images, audio, video, code, or even 3D models. For better understanding, I will be dividing the entire roadmap into 4 phases plus one additional phase as a bonus phase for you to excel in this field. Phase 1 is all about laying the foundation, which includes the basics of AI and machine learning. Think of artificial intelligence as making computers smart enough to do things which people can do. Machine learning is just one of the way to do it, allowing computers to learn from example instead of being told exactly what to do. It's a learning by seeing and doing it, not just by a rule book. There are 3 main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is where the computers learn with correct answers, whereas unsupervised learning involves finding patterns on its own, and reinforcement learning is about learning through rewards. You will need Python too. Key tools include NumPy for numerical operations, Pandas for organizing data, and Matplotlib and Seaborn for data visualization. These help you to work with and understand data. You need to understand data preparation, which involves cleaning and organizing data. Also, learn about the feature engineering, which is the process of selecting important parts of the data of the model. Gen AI uses deep learning. You can think of deep learning as a computer network with many layers. Understand the basic idea of how these networks learn from data. This is the key for understanding more complex Gen AI models. Moving on to phase 2, where you can start exploring the Gen AI models. Some of Gen AI models include GANs, which are 2 networks competing, one making fake data and other tries to spot it. This model works well for creating realistic outputs. The second model is VAEs. This model learns a hidden representation of data to create new or similar data. The next model is transformers, which are excellent at understanding context in sequence like text, audio, and even images using attention. The last model is diffusion model, which can create high quality data by reversing a noising process. This model is very popular for images. Apart from Gen AI models, you need to cover text generation model, which falls under natural language processing, which is NLP. These models power text creation from writing articles to translating languages. And lastly, you will cover image generation using GANs and diffusion models. In phase 3, we will focus on developing our practical skills. You can start with small projects such as generating basic images or text with small datasets. Do experiment and learn the workflow. Join platforms like Hugging Face, Reddit, Stack Overflow, and Kaggle forums to ask questions and learn from others. To showcase your work, you can use GitHub to share your projects and code. Phase 4 is truly about staying ahead. Gen AI is always changing, so you need to be aware of it. New architectures are constantly being built, so briefly be aware that more advanced models are continuously being developed beyond the basics that we have covered. I would also recommend learning about deploying models on cloud platforms like AWS, Google Cloud, or Azure, which will be useful for larger projects. Additionally, you can read research papers, follow tech experts online, whether on Twitter or LinkedIn, and stay curious about this field. Continuous learning is the key in this field. Now that you have built a strong foundation in generative AI, Phase 5 is all about mastering the future of technology. A certification course provides formal validation of specialized knowledge and skills, making individuals stand out to employees and demonstrating a commitment to professional development. This recognition often leads to enhanced credibility that improves career opportunities with specific field. Wondering which certification to go with? Don't worry, I've got you covered here as well. There are so many certificate courses available, but I would strongly suggest you to check on Applied Generative AI Specialization course by Simplilearn in partnership with Purdue University and Microsoft. This will be 16-week course which will give you hands-on learning experience on building AI and agentic AI apps through hands-on industry-relevant projects. You will also learn popular Gen AI tools which includes gaining in exposure to Copilot, LangChain, Hugging Face, Azure AI, Studio, OpenAI, and other tools. Additionally to this, you will provide a certificate from Purdue University and course completion certificate from Microsoft. Hurry and enroll now. Find the course link in the description box and pinned comments. That's your roadmap to understanding generative AI. Start with the basics and get practical experience and never stop learning. The power of Gen AI is within your reach.
Hey everyone, welcome to the Simplilearn's YouTube channel. In this tutorial, we will learn about the MCP. Anthropic's MCP, or also known as the Multi-Agent Collaboration Protocol, is a groundbreaking framework designed to enable seamless cooperation and collaboration between multiple AI agents. Unlike traditional single-agent ecosystems, MCP allows agents to specialize, communicate, and coordinate effectively to solve complex tasks. This leads to a faster decision-making, enhanced problem-solving, and more scalable AI systems. One of its key strengths is structured communication, where agents can negotiate rules, share knowledge, and adapt dynamically. With MCP, developers can now build AI ecosystems that behave like more intelligent teams than isolated tools. It marks a significant leap towards building truly autonomous collaborative AI applications. Now, in today's session, we will actually try to work on one, and we will be building a web scraping AI agent using MCP protocols. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Now, we will begin with the agenda for MCP tutorial for beginners. So firstly, we will have a quick briefing of what exactly is an MCP, or as it is called, Multi-Agent Collaboration Protocol. Followed by that, we will understand some basic protocols and standards in communication. Next, we will try to relate MCP to the understanding of protocols and standards. Followed by that, we will get started with our demonstration on developing a web scraper agent using MCP. And for that, we will be needing Node.js, Cursor AI, and Firecrawl API. So I will be walking you through those demonstration steps one after the other, and this will be a very beginner-friendly tutorial and practical demonstration on MCP. Now that I've made myself clear with the agenda, let's get started with MCP. So what exactly is MCP? As MCP on their webpage says, MCP is a Model Context Protocol, or Multi-Agent Collaboration Protocol is an open source protocol that standardizes how applications supply context to large language models. Similar to how USB-C unifies hardware connections, MCP offers a consistent way to integrate AI models with various data sources and tools. Now let's go to the official documentation of MCP to have a broader overview. So, as they say, MCP is one such tool, if you remember N8N and all the AI tools and data sources that you used. For example, if you wanted an AI travel agent, as we have an already existing tutorial on our channel, you can go through it for a brief overview. So you might be needing an email writing agent, and you might be needing an airport code searching AI agent, hotel searching AI agent, flight booking AI agent, and a lot of agents connected to one another through a complex network using an ATN platform, right? Now, in this particular MCP, that will be minimized. So you will have a standardized approach where you just eliminate all those boilerplate coding, agents, manual searching for databases, manual search for knowledge bases, manual search for agents, which are specifically designed for the purpose. You just explain your initiative, attach the API keys, and MCP takes over and gives you a fully furnished and finished product within no time. That's the main approach of MCP. So here you can see an overview image where we have the parts MCP host, clients, servers, local data sources, remote services, and local data sources. If you wanted to go ahead with local data sources or local knowledge base, you can go ahead with that. But in case if you wanted some open source, then you can also go ahead with that. So here we have all the quick starts and guides and example and tutorials to how to begin with that one, and all the explore pages that you want to go ahead with if you wanted to have a deep dive into core architecture, the resources available, prompts, tools, transport samplings, and a lot more. And in case if you wanted to contribute your dedicated resources for the community, you can also go ahead with that, and you can also have some support and feedback for MCP. Now that we have a brief understanding of MCP and still clueless about what exactly is MCP, then let's go ahead with some standards and protocols so that you can get a template and you can relate MCP to that template and understand what's the role or importance of MCP in AI agent development. Now, understanding the standards and protocols. Now, let us imagine that you get a team of people to work on a project, and you are the manager that leads and directs this particular team for a purpose, right? Now, the complex problem. No one is friend of anyone. Everyone is new to everyone on the team. And each and every person in this team belongs to a different country and doesn't have a common language in between. For example, person A speaks Mandarin, person B speaks Hindi, person C speaks French, so on. There is no common language between any one of those. Now imagine each and every one of these team members as an AI agent or a tool working for the purpose. In this scenario, you might have to hard code the ports of communication, instructions on how to do, and you need to go on to each and every single AI agent and explain the stuff in a very dedicated and a specific way. This could take a very long time. In the same way, if you relate this to a person, then you might have to reach to every single person and speak to them in their own tongue and explain them the procedures and the steps to be taken to finish the task. Now, how would you do that? It would be a lot complex. Mandarin, you might not even know French or a different language. And in that particular scenario, you might be stuck. What if there was one single language that everyone knew? For example, English. Now you can get all of them together and explain the stuff in one single call and close it. And what might be so wonderful is that you'll not even waste a lot of time and there is no hard coding, there is no manual effort there, right? In the same way, if you relate this to a web server, then you are the client, you have the server, and you just, let's say you're working on Facebook or Instagram, you try to post something, you try to write a comment, you try to like something, right? That is the activity. And these particular activities will go through 4 different types of requests. One is the get request, put request, post request, and last is the delete request, right? Now, if you are connected to a single server, this might not be as tough as possible. But if you are getting connected to multiple servers, then you might be requiring different protocols every single time. Now, this can be a combination of 2 parts, HTTP and the URL that you're trying to get connected to, right? Now, to eliminate the efforts between multiple servers and multiple requests at one go, you have one single tool called as API. And the most popular API is the REST API, which has a standard way of communicating. So here, the REST API works as the language English that we discussed before. In the same way, it has maintained a standard where each and every web client can have his communication to his dedicated server or multiple servers in one go using one single language or medium or standard, that is REST API. Without REST API and the standards and protocols, it might be very confusing and you might end up in a complex situation which might not yield in the type of result you're expecting. Now, if you can relate the development of multiple AI agents for a single purpose to the web communication and a meeting, you also expect if there were a template for development of AI agents which could make the process less complex, just like REST API did in a web service and just like English did in a team meeting, then MCP comes into the picture. MCP is your template for it, right? So just like your REST API and the meetings, you have a MCP. Earlier, without MCP, we used to have one tool called NA10, where you had all the tools connected to it and all the LLMs programmed to it, and you had to do this hard code coding for each and every tool that you have included in the network and each and every agent that you have related to it. You had to specifically instruct, write down steps, develop a persona to your AI agent, right? There was a lot of stuff. But if you eliminate this particular complexity with one tool, then that would be your MCP. You just had to include MCP and tell your purpose, and your job would be done. Now that you have a brief understanding or a general overview of what exactly is MCP, now let's go ahead and build one. Now, the steps would include the following. For the project that we are building, which is a web crawler or web scraper, we might need the help of Node.js. So firstly, we will install and set the environment for Node.js. Followed by that, we will be needing an editor. So for that, we will be choosing the Cursor AI editor. And next, we will use an API. So for that, we will be using the Firecrawl API. And lastly, we can get started with building one once we have all the required resources. So let's get started. So as we discussed before, we will get started by installing Node.js into our operating system. So we're working on Windows operating system. So we might have to go ahead with Windows. So I'll choose Windows and the architecture will be the one which I'm working with. So that would be x64. But in case if you are working with a different operating system, say Mac OS, then you might have to select ARM or any suitable architecture that you can be compatible with. For Linux, you'll have to choose with the same and so on. So since we're working with Windows, so Windows it is and x64 architecture, and click on that Windows installer MSI file. So it will be getting started to install, and you'll have to click on that Windows installer.msi file and it'll get downloaded. While it is getting downloaded, let's go to the next web page and download and install the Cursor AI that we will be needing for this demonstration today. You'll have to log in, create an account and log in, and automatically it will give you the version that suits our operating system. Since we are in Windows, it gave me a Windows operating system. Just sign up or log in. So since you've already an account, just log into your account and confirm it's that you, and followed by that, you'll have installed your Cursor AI. Choose your theme. I'll go with the Cursor Dark theme. And here you make sure that you have Cursor tab, Control K agent, and you can also choose the data sharing option. I'll go with the privacy mode in case if you want the other one, go ahead with that. And here you have a few review settings, and there you go. Now you're on the new window for Cursor AI. And meanwhile, let's check on the Node.js installation. I think the wizard has already started installing the Node.js setup. So this is the window. Let's quickly go through each and every instance that we have gone through so far in this particular window from the beginning. So it started off with some packages that we would be needing. So yeah, chocolatey and KB299. Yeah, further we have, and the last one is Python 13, right? Version 3.13.3 is approved. So far, so good. I think we can now get started with the next step. So here we are on the Cursor AI. So we might have to get started going through the Cursor AI settings to create our new MCP. So there are quite a few methods that you can try out to reach to settings. One is you can go to the file, and there you may have to choose the preferences, and then you have the cursor settings. You just can use that particular step, or you can go ahead with the search options as well. So you can use that step, or you can also use the other step where you can just go to the search window and search for the settings. Here you can see MCP on the left window. So let me also walk you through a few other steps. So go to the search window and type down cursor AI or cursor settings. I think there has been a discrepancy, but not to worry. We'll go with the regular approach where we go to the file, preferences, and cursor settings. And there you have the options on the left hand side. Go to MCP, and so far you don't have any MCP service because this is the first time you've logged into Cursor AI. So you just have to add new global MCP server, which is available on the blue color button. Just click on that. And now you'll have a mcp.json file which is completely empty. You'll have to write down a few hard-coded codes here, which are not too complex related to the earlier ones that you have worked on in A10. So you might need a few more tools here. So go to the Firecrawl website. Before that, let's go through some awesome MCP servers GitHub link. So here we have almost all information related to the MCP. So let's open a new window and open all these links. What is MCP, clients, tutorials, community, legend, server implementations, framework, tips and tricks, right? For further information, you can go through all these web pages individually. So back to the home page, here you have everything you needed, the basic information of what exactly is MCP, and further you have some server implementations. Like if you scroll down, so you have awesome MCP services. This is where the beginning is. And next you have server implementations, aggregators, art and culture, coding execution, right? Customer data platforms. So here you have aggregators, art and culture, dedicated web spaces. So, and you have also cloud platforms that you can work along with. And moving further, you have code executions, coding agents, command lines as well, and communication related stuff. So you can go along and perform your operations, customer data or platforms, data platforms, and much more. Let's close all these windows and get started with the next stage where we need an API, right? So for that, the project that we're working on, which is web crawler, we will be needing an API from one of the providers, which is Firecrawl API. Okay, that's the one, Firecrawl MCP. So that's the one. Click on that particular link. Here, to generate an API, first you might have to sign up with Firecrawl. So before we sign up, let's go through the website of Firecrawl from the beginning. So that's the template code that you'll be working on. And also here we have a wide variety of crawl options, media parsing options, smart weight actions, right? Reliability first and all those things. And also we have the pricing details. For now, we'll go ahead with the free plan. And yeah, let me add down my details, my email address, and you might also have to add a password. So let me type down something. Yeah, so the password is not too strong enough. That's a good thing. They have a really strong website. So that's a sign you need to have strong passwords, and also make sure that you don't share your passwords and the API keys that you generate using Firecrawl. Now that my password is a little too longer, I think it should be access. Yeah, it's accessible and it is a successful account generation. Now you need to check your email and confirm that login credentials are right and everything. So once you are signed up, let's go through another website for generating our API keys. So Firecrawl API, scroll a little bit. So API documentation. So here you'll find some documentation related to Firecrawl and all the details that you need to go through for API key generation. So Firecrawl MCP server. Yeah, that's the website that we're looking for. Firecrawl MCP server. That's the one. And here you have overview, content, tools, and other resources that you're looking for. Now, this is the template server configuration that you'll be needing. So make sure that you have an eye on it. And now you will also have the details that you might have to go through. Like basically, it'll have the steps that you need to follow in the content page. Click on content. There you go. So it has all the features and details that you need to go ahead with. And tools, you have the crawling, extraction, scraping tools that you can work along with Firecrawl, and a few comments here. Now, yeah, the email has not been confirmed yet. Let's try to resend and reconfirm the email so that we just sign up or log in and create our API keys as soon as possible. So there you go. I have verified my email in my phone. So I'll just enter the credentials and sign in. Successful, you are signed in. On the left hand side, you can see the overview, playground, extract, activity logs, usage, API keys, and all the settings. So here you can see my API key has been by default hidden, so I'll not visualize it now. So you have two options, either view or copy. So we will be copying it for the first time to be on the safe side. So since we are new to this particular website, so we don't have any activities registered on this particular web page. So now we have the API keys. Now let's go to the content page to verify the steps that we need to follow. So we need to install npm and we need to go to the Cursor AI settings and add a new MCP server, which we already did. So we just need to copy the template code and we just need to place it there. And also, don't worry about where exactly to place your API keys in the template. We have that place. So we are back on the Cursor AI. Now we will replace this template code with the code that we just copied. And remember, if you're using Windows, try cmd/c. Okay. If you're not on Windows, you can eliminate that cmd/c. But if you are working in Windows, then you definitely need that cmd/c. Okay, let's erase this and replace that. So I'll name my tool as Firecrawl. And I'll go to the new line where I'll write down my command, and the command will be the code that I just copied from the Firecrawl window. So let me type down the command in double quotes in the new line, and I'll paste the command here, which is the code that we copied from the Firecrawl window. Control V. There you go. So the white stuff, which is in cmd/c, so that's the one you need to focus on. If you are working on Windows, that you definitely need it. If you're not working on Windows, then you can just omit it. Now, there might be some concerns with the codes, don't worry. Now, to cross-verify, you can just go back to the Firecrawl homepage and cross-verify it with the template for configuration that they have made us available. Let's go back to the Firecrawl window, and at the same time, you can see your API key here. So that's where you need to place your API key. So here we are on the Firecrawl window. You need to copy the API key and place it in the place where they have mentioned your API key. So if you have cross-verified with the configuration code, that's fine. And now you can just check the double quotes. So that's the one you need to focus on. Let me if there is a way to zoom it in, let me try to zoom in. Yeah, that's the one, cmd/c. If you're on Windows, you definitely need this. If you're not on Windows, you can just choose to omit it. Now let me just do one last final check. I think I missed a double quote somewhere. Yeah, I need to remove it from this place and add it to the end. Just a second. Okay, remove the double quote at that place. Now it should be after MCP. And once everything is done, you can just quickly choose to save and close this particular window. Check the distance between the API key and the double ampersand places. That's fine. And saving is really simple. Choose those three dots, close, save. And once that is clicked, it's all done. You get to choose to close this particular mcp.json file and get back to your agent. So once you have closed it, you will have your new server that you've just created in the cursor settings. But in a few times you get no tool connected, no server connected, or there might be some errors. So in that case, you just need to cross-verify the npm installation, Node.js installation, and check all the files that are there or not. But even if everything is installed and you can see the versions available, and if you're still seeing this or watching that particular error, then don't worry, just close the Cursor AI and restart it, or you can also choose the refresh option, which is right available there. So I've closed and restarted it, and the same procedure, go to File, Preferences, Cursor Settings, and there you'll see the MCP models, and there you'll find it right there. Correct? Now close it and go to the window where you will find the server. Yeah, that's the one. And here you choose the agent. Make sure that you choose the agent instead of anything else. Not manual, not ask. I choose the agent. And now I'll write down a simple prompt. Search for Simplilearn on Google. Now it should give me results which it finds on Google. Maybe it's a home page, maybe it's a social media handle like LinkedIn or YouTube or Instagram, anything that it finds related to Simplilearn. Only the term Simplilearn. So here you can see it has given me 3 different results. First one is Simplilearn website. Second one is Simplilearn YouTube channel. And the third one is LinkedIn page. So let's get started with the official web page. So click on the simplilearn.com. Now, it's asking me permission, open. Now we are on Simplilearn homepage. Similarly, let's go back and select for the YouTube page. So that's the one. Open again, get permissions. So you're on the Simplilearn YouTube page. Now I think it might ask for a login for LinkedIn. But anyways, let's try to check if it can open without logging in to LinkedIn or not. So yeah, you can see I've logged in to the YouTube. Yeah, it is asking me to log in. So let's quickly log in. It might take a couple of seconds. So there you go. I've logged into LinkedIn. Now open. So I can see Simplilearn's homepage getting loaded in a second. Yeah, there you go. On LinkedIn, we have opened the Simplilearn's homepage successfully.
OpenAI just dropped something huge. It's called Codex. If you're writing code or just love tech, this is about to blow your mind. This AI is not just smart, it rewrites how we write code like for real. But here's the thing, is all this hype actually worth it? That's what we are diving into today. We'll break down what Codex is, how it works, the cool features that make it special, how safe and reliable it really is, and how it stacks up against other AI coding tools out there. So if you're curious whether Codex is a game changer or just a fancy buzz, stick with me and let's get into it. Alright, so what exactly is Codex? Imagine having a supercharged AI developer in the cloud. It's like a team of experts who can juggle writing new features, fixing bugs, answering questions about your code, all at the same time. Codex runs in these safe, isolated sandboxes loaded with your exact code base. So it's working with your code just like a real teammate would. But what powers Codex? A special AI model called Codex 1, trained on tons of real coding projects to produce code that looks just like a human wrote it. It follows instructions carefully, keeps testing until everything works perfectly, and even adapts to your coding style. Oh, and there's a cool fact. In OpenAI's own coding benchmark test called SWE Bench, Codex nailed up to 85% accuracy solving real world coding problems. That's a massive jump over other AI models. So it's not just a good looking code, it's a trustworthy code. Now you might be wondering, how do I actually use Codex? Now if you have got ChatGPT Pro, Team or Enterprise, Codex is right there in the sidebar. You just type what you want, maybe write me a login feature or fix this bug in the payment system and hit the code button easy. Want to ask questions about your code? Hit ask and get answers right away. Each task Codex handles run in its own secure cloud workspace. It reads your file, edits them, runs tests, linters and checks type, basically everything a human dev does. Tasks take anywhere from a minute to half an hour depending on how tricky they are, and you can watch the whole process live. When it's done, Codex commits the changes and gives you all the receipt, terminal logs, and the results, citations, and so you can easily see what it did. You can review the work, ask for changes, create GitHub pull requests, or merge directly. You can even set up a Codex environment to match your real development setup for smoother results. Want Codex to work even better? Just add agents.md file to your repository, like kind of a guidebook telling Codex how your project works, what commands to run for testing, and your coding standards. Think of it like onboarding a new developer, giving clear instructions, and Codex becomes smarter and more helpful. But even without that, Codex is already rocking in OpenAI's internal test. Talking about is Codex safe or not? Look, handing over code to AI can feel scary, right? But OpenAI built Codex with safety first. It runs in locked down cloud containers with zero internet access, so it can't browse random sites or grab sketchy stuff. And Codex shows you everything it does. Log, test results, even when things go wrong, you can always stay in control. No surprise, just transparency. Now, who's already using Codex? This isn't just theory. OpenAI engineers live with Codex. They offload boring stuff like renaming, refactoring, writing tests, and fixing bugs so they can focus on the cool creative part. Cisco uses it to speed up features and untangle huge code bases. Superhuman speeds up testing and test product managers to small code tweaks without bugging engineers. Codex helps team work smarter and faster, cutting down distractions and keeping projects moving. Let's talk about the updates to Codex CLI and development experience. If you love working with the terminal, OpenAI launched Codex CLI, a lightweight open source assistant that brings Codex powers to your local workflow. They also made a smaller, faster version called Codex Mini for quick QA and editing. Perfect when you want instant help. Signing is in a breeze now. Just use your ChatGPT account, pick up your API organization, and boom, you're all set. Plus and Pro users even get free credits to start. Right now, Codex is rolling out globally to ChatGPT Pro, Team, and Enterprise users. Plus and education users, you are next in line. For API users, Codex Mini costs around 1.50 per million input tokens and $6 per million output tokens, with discounts if you reuse prompts a lot. Heads up, Codex is still in early days. It can't yet process images or change course mid-task, and remote task delegation takes longer than quick edits, but it's evolving fast and will soon handle more complex work. What's next? The future. OpenAI vision. Developers own the work they love and delegate the rest to AI agents, boosting productivity like never before. Soon you'll chat with Codex mid-task, guide it, get progress updates, and assign jobs from your IDE, GitHub, or issue tracker. Imagine a smooth, unified workflow where AI is your teammate across all your tools. Now, how does Codex stacks up against other AI coding assistants? GitHub Copilot is amazing for real-time code suggestions while you type, like a buddy sitting next to you. Codex works more like a remote teammate that handles entire coding tasks asynchronously, writing features, fixing bugs, running tests, and submitting pull requests, freeing you up for bigger picture stuff. And GPT-4, it's great at code snippets and explanation, but Codex is trained specifically for software engineering, producing cleaner, more reliable code tailored to real projects. Together, these tools form an unstoppable AI coding dream team. But Codex's ability to multitask safely and transparently is pushing the limits of what AI coding can do. So, whether you're a solo developer or a part at a team, Codex is here to change the way you build software. It's available now for ChatGPT Pro, Team, and Enterprise, with Plus and Education coming soon. Try it out, play with different tasks, and see how it speeds up with your workflow, cuts headaches, and makes coding way more fun.
Welcome to the short course on Generative AI Models for Beginners by Simplilearn. So in this course, we will learn about the basic understanding of Generative AI. Then we will move on to the C applications of the many GenAI tools. And thirdly, we will understand the GenAI models, and then we will create our first GenAI model. And then we will move on and see the real world impact of the generative AI models. And then we will create a chatbot using the GenAI model. And then we will conclude the course with the limitations of the GenAI models, and finally we will see the future of GenAI models. Now, let us begin with the first chapter, that is basic understanding of generative AI. So, let us begin with what is generative AI. So generative AI is a type of artificial intelligence that creates new content such as text, images, music, or even code from scratch based on what it has learned. So unlike the traditional AI, which just analyzes or classifies data, like recognizing faces or recommending products, generative AI creates. It's like the difference between a judge and an artist. One evaluates and the other one imagines and produces. So let's break it down with a simple real world examples. The first one is ChatGPT, that is a text generation. So what it does? So ChatGPT, like the one you are talking to right now, generates human-like conversations and answers. So you can ask it to write stories, emails, explain difficult topics, or even debug a code. For example, you say, write me a bedtime story about a robot and a unicorn. The ChatGPT creates an entire story for you on that particular spot. So let's move on and see DALL-E, that is for the image generation. So DALL-E creates pictures from words, that is the text prompts. Then artists and marketers use it to generate logos, illustrations, or more without hiring a designer. For example, you type a cat wearing a spacesuit on Mars, and DALL-E draws it instantly. Now moving on to GPT-3, that is text plus logic task. So what it does? So GPT-3 is a powerful language model that can create and write essays, summary books, translate languages, and even write computer code. So developers use it in apps to create smart features like the AI writing assistant. So then you give GPT-3 a blog title and it writes the full article with an intro, subheadings, and conclusion. So after knowing all this, let's move on and see why are generative models. So generative models are changing the way we create content across multiple fields. So under the text field, we are writing books, articles, reports, or even poetry. And then we are assisting in the customer support with the chatbots. And then under the images section, we are helping the artists generate concepts and visuals. And then we are even handling the speeding up design and marketing content creation. And then under the music part, we are composing the background scores for videos or games. And then we are helping musicians brainstorm the melodies or the lyrics. And then finally, we write the boilerplate code under this coding section, debugging, or even creating full web apps. So now moving on, we'll see traditional AI versus generative AI. So let's compare both side by side with the simple explanations. So the main goal of traditional AI is to analyze and make decisions. And the main goal of generative AI is create new content. For example, under traditional AI, predicting stock prices or recommending books on movies. And the generative AI, we are writing stories, generating images, and so on. So traditional AI handles data. It uses data to classify or forecast, and generative AI learns from data to generate something new. The traditional AI, it labels, scores, and categories as output, and generative AI, the text, images, music videos, and so on. For example, traditional AI is face recognition, fraud detection, spam filters, and generative AI is ChatGPT, DALL-E, Music LM, and so on. So down the line in the next chapter, we will see the applications of some generative AI tools like the ChatGPT, DALL-E, and GPT-3. So imagine this. You are working on a college project. It's late at night and the deadlines is tomorrow. You need a well-written report and a poster design and a clear presentation. So total chaos, right? But what if I tell you that there's an AI assistant that can help you with all of this in just minutes? So welcome to the world of generative AI. Today we'll explore how tools like ChatGPT, DALL-E, and GPT-3 are being used by the students, content creators, and professionals to do amazing things faster, easier, and smarter. So let's break down each tool and see how you can actually use them in real life. So This is ChatGPT 4.0. If you're not aware of what ChatGPT is, so ChatGPT is an AI chatbot that can create, write essays, summaries, articles, explain topics, solve coding problems, and even conduct mock interviews all through one single chat. So let's look at real ways you can use it. So, ChatGPT model, it uses this GPT-4, the latest in the generative AI pre-trained transformer that is a GPT family. So, GPT-4 is designed for more nuanced and human-like conversation. So, have a look at the real ways we can use it. So, the first prompt we are going to try is explain the greenhouse effect like I am in class 12. So basically this prompt is asking for the greenhouse effect explanation, and it is asking the ChatGPT to behave that it is explaining to a class 12 person. So we will give this. So you can basically see a human-like generation. Just like, sure, the greenhouse effect is a natural process that warms the Earth's surface. It happens when certain gases in the Earth's atmosphere trap the heat. Here's how it works. It will have a detailed explanation on the solar energy, Earth's surface absorption, greenhouse gases, heat trapping, and all. So after all this 4 points, it has also given without the greenhouse effect, the earth would be too cold to sustain life. However, human activities like as burning fossil fuels, deforestation, and industrial processes. So you can basically think it has given one nutshell, and if you just understand this, you have a clear vision of what a greenhouse effect is. So the first point we can see over here is that it is like a own tutor. So the first point, we have just been to ChatGPT, that is founded by chat.openai.com. We have typed a question and we have got a simple and easy to understand answer. And even you can have a follow-up question, like if I ask, is solar energy related to greenhouse effect? You can even have a follow-up question. Yes, solar energy is related to the greenhouse effect. So it's almost like its own tutor. So great for the late night cramming or the quick concept clarity. So this is it. And now moving on to the second thing that it can help with, that writing assignments or essays in just minutes. So we will ask ChatGPT, write a 350-word essay on climate change for college purpose. And you can see I have provided conditions. You can even customize it by saying make it simple and yet engaging and awesome. So it will basically create, it has even created a own title, a growing concern for our future. Climate change, it has created paragraphs, and basically you can even customize this word count and topic, then review the generated draft. You can even personalize it. Do you like this personality? And done and dusted. You can just have this. Now writing feels less stressful and it would be more fun. It can even give you an interview experience. For example, just imagine you are having your interview on the next Monday and you are preparing and you're very confused about what to prepare and what not. Then you can basically ask ChatGPT to behave like an interviewer for a particular job. I can even paste your job description from that particular company, and you can ask that what are the probable questions I can have. So let's have a demo. Ask me 3 HR questions for a software development internship and suggest improvements. And You can even post this. And in no time, it has started generating. Here are the 3 HR questions for a software development internship. The first one, can you walk me through a recent coding project you have worked on and explain how you approach solving the problem? And you know what? This is a very, very common question. And it has given one tip also, suggestion. This question evaluates your problem solving skills, your technical ability, and how you approach development tasks. It gives the interviewer insight into your practical experience and thought process. So how do you manage the deadlines when working on the multiple projects or the tasks simultaneously? So this question assesses your time management skills and ability to prioritize the task. So the software development often involves juggling multiple assignments. So this gives the interviewer an idea of your organization skills. So this is very important. It has also written, how do you keep yourself updated with the latest programming languages and technologies? So basically this question looks after your own learning ability. So the self-improvement part. So it has even created one answer over it. And it is also suggestions for the improvement, provide specific examples, highlight the soft skills, prepare for the problem-solving questions, and so on. And for example, if I write, customize it with a data analyst fresher role, having no experience, what all the interviewer can ask me in the technical round, and it will give you answer in no time. HR questions for a data analyst fresher. Why are you interested in pursuing a career as a data analyst, and what are the steps you have taken to prepare yourself for this role? Can you describe a situation where you had to analyze data or solve a problem using numbers or data in your studies or personal projects? How do you approach learning new tools or technologies, especially when it comes to data analysis software? And then we have this technical question. What is the difference between the structured and unstructured data? What is data normalization? How comfortable are you with the data visualization tools? Can you describe a visualization you would use to represent sales data over time? Can you explain what a pivot table is when it is used in data analysis? And there are suggestions that showcase your learning journey, focus on the problem solving skills, prepare for the basic technical questions. Since you are a fresher, the technical questions may focus on the fundamentals like the Excel, Python, that is the libraries, pandas, and so on. So in no time, it can even have a mock interview over here. So you can even create ideas over here. It can brainstorm you with the ideas available. For example, you have a group project and you want an idea. I'll type over here, give 5 creative ideas for a group project on sustainability. And if you post this, in no time it has created this 5 ideas. Sustainable packaging design challenge. Objectives, design a sustainable. It has created one objective, it has given one approach for you and one outcome. Then it has created community-based urban garden, and for each topic if you see, for each idea if you see, it has created the objective, the approach and the outcome. So these projects can not only be educational but also impactful. So you never run out of inspiration from ChatGPT. So ChatGPT is a lot. And here if you can actually see, it has various search, deep search and create image, and you can basically do everything you want from ChatGPT. Let's now move on to DALL-E. The next we would be seeing is DALL-E. So DALL-E is an AI that creates images from text. You tell it what to draw and it generates the artwork, logos and visuals. So you would be getting DALL-E from this ChatGPT only, and in the Explore GPTs in the sidebar, you have to just mention DALL-E 2. So there are various versions of DALL-E and we'll start chatting. And now if you close this sidebar, you can basically see DALL-E 2. So DALL-E is an AI that creates the images, and DALL-E, this model, uses a version of the CLIP model, that is a contrastive language image pre-training, combined with the VQ-VA2 or other generative image models. So DALL-E creates images from the text descriptions, generating highly creative visuals based on the natural language input. So let's see how you can use it. So for example, you're going to design the college poster design. So instantly it would be done. So we would write create a poster for a college fest with DJs, neon lights and a crazy crowd, okay? And you can basically give the prompt. And in no time, it will create one great image for you. You can write and you can see it has created a great image. You can basically download this image and do anything. Here's the poster for your college fest featuring a vibrant DJ scene with the neon lights and the energetic crowd. So forget Photoshop, let AI do the heavy lifting. So then you can create presentations over here, adding better visuals. So I'll write, draw a cartoon showing water pollution in a river. And you can basically see this. Now you can insert it into the PowerPoint or Canva and design it on your own. It acts as a vector, it acts as an icon, and anything you want to act. Then you can instantly create club logos and branding. So you can even generate a logo for over here through DALL-E 2. Logo for a coffee club with books and steaming mugs. And you can see it has created a drastic logo and it feels like real. So you had just given one prompt and get 4 to 5 variations of logo. You can even ask it for a different version. So great for the student clubs or college events. Then you can even have it for the costume design or any ideas again. So we'll write futuristic costume design for a sky-fi play with glowing elements. And even you can see here, it has created a futuristic costume design for a scientific fiction play with the glowing elements. And it is very amazing. The qualities of the images are of high quality. And use vivid descriptions, use more detailed prompts, and you will get a great output from DALL-E 2. So art students and theater class, this is your new secret weapon. So let's move on to GPT-3. Our next GenAI tool is GPT-3. So GPT-3 is the powerhouse engine behind the tools like ChatGPT. So it doesn't just chat, it can write full code, research summary papers, business emails, and more. So GPT-3 is a predecessor of GPT-4 based on the same GPT architecture but with a 175 billion parameters. It was one of the most advanced language models when it was released. So let's explore how it helps in the real world task. So initially, we can use ChatGPT because it is a ChatGPT 4 version. There is a GPT-3 is basically a predecessor of GPT-4. So I'm using ChatGPT over here. You can also use ChatGPT 4 to understand the GPT-3. So the first one is building websites without coding. So you can even write a HTML for personal portfolio with my name, bio, and contact form. And in no time, it has generated this. You can just copy it, paste it in VS Code or any of the code editors you like, and you can definitely get a proper output of this. Perfect for the beginners or the design students. Then you can even summarize a lengthy research paper. You can have to just upload the paper, and if you see this plus section, you can just click on this. You can just upload from your computer and summarize it in 2 seconds. It can even brainstorm you with the project and the startup ideas, like suggest 5 unique app ideas for college students. Now you can see the first one is Study Buddy Finder. Helps students find partners based on their courses, schedules, and many preferences. And you can even see Campus Event Hub, Course Material Exchange, Mental Wellness Check-in, Foodie Finder, and so on. It has even created bullet points for better understanding. So it is a noise-free study timer. Use it to kickstart your next hackathon or competition or anything. So I'm not dragging it more because as I have already showed you the use of ChatGPT. So that's it. Moving on to the next lesson of understanding the generative AI models. Imagine you are teaching a computer to be creative, like painting a picture, writing a poetry, or designing a dress. That's exactly what generative AI models aim to do. So learn from the data and generate new content that looks, sound, or feels real. But how do this pull off? Let's break it down into the 3 major families of models. The first one is GANs, that is the Generative Adversarial Networks. Then the second one we have is VAEs, that is the Variational Autoencoders. And the third one, the final one, is transformers like the GPT. So let's understand this in a detailed one. The first one is Generative Adversarial Networks, GANs, the artist versus the critic game. So how it works? Think of GANs like a competition between the 2 neural networks. The generator is like a rookie artist trying to create a fake art. The discriminator is the tough critic trying to tell the real art from the fake. So the artist creates random images. The critic says fake or real, and the artist learns to get better. So over the time, the fake images become indistinguishable from the real ones. So there's a real world analogy. It's like a student, that is a generator, forging a signature and a teacher, discriminator, spotting it. As both improve, the forgeries become nearly perfect. So there are certain applications. The first application is creating realistic human faces. Then style, the transfer in the art. And then we have fashion design prototypes. And then finally we have deep fakes, that is controversial but technically fascinating. And then let's move on to the challenges. So training instability. The second one is it requires a lot of data and computing. So moving on, we'll understand variational autoencoders, that is the VAEs, the data compressor with creativity. So VAEs are like the compress and the rebuild systems. They take input data like an image, compress it into a low dimensional space that is called a latent space, and then reconstruct it. But here's the twist. The VAs don't just remember, they imagine. So by sampling different points in the latent space, they can generate new similar looking content. So let's move on and see the applications. First application is anomaly detection. So what doesn't fit in the normal data? Then the second one is generating handwritten digits and faces. And then we have data compression. And then finally we can see drug discovery, that is generating molecular structures. So now let's move on to the strengths. So more stable than the GANs, and it gives a well-structured latent space for the interpolation. So now moving on to the third model, we have transformer models, that is a master of the sequences. So unlike the GANs or the VAEs, which focus more on images, transformers shine in handling sequences, especially the text. The core data idea is attention mechanism, a way to let the model focus on the different words when generating a sentence. So for example, when GPT generates a sentence, I like ice cream because it's sweet. It pays attention to the context, understanding how because relates to the ice cream and sweet. So let's now move on to the applications. The first one is chatbots, like the ChatGPT. And then we have code generation, that is the GitHub Copilot. And then thirdly, we have language translation. And finally, we have summarization and content creation. And then let's move on and see why transformers stand out. So the first one is they scale data well. The second one is they can be fine-tuned on specific tasks like the medical summarization or legal drafting. Then finally we have they handle the long-range dependencies better than the older models like the RNNs or the LSTMs. Then we have a comparison and the use cases. So the first one is GANs, and it is best at image generation. And then we have an example use, that is the face synthesis. And the associated strength is high realism, and the weakness is it is hard to train. Then we are seeing the VAEs, and it is best at data compression, plus it is also good in anomaly detection. So it is used as a latent space exploration. And then coming to the strength, it is very stable training, and then coming to weakness, it has a less sharp outputs. So then coming to the model type, that is the transformers, and it is best at text and language. And then we have an example use, that is a ChatGPT and summarization. And then we have strength, that is powerful with the large data. And then we have certain weakness, that is expensive to train. Now moving on, let's clear something, which to use and when. So if you don't know which generative model to use for what, it can mess things up fast. So let's say you are building an app that needs to write emails, make pictures, answer questions, and turn speech into text. If you use the wrong model for the wrong job, your results will be poor, things will be slow, and you will waste time. So let's understand which models performs what. So for a sharp realistic images, we are using GANs. And then coming to the next, for variation and latent space analysis, we are using VAEs. And then finally, for the language or the text-based task, we are using transformers. So finally, how do these models actually work? So the GAN training process is, the first process is generator makes the fake data. Then the step 2 is the discriminator tries to classify the real versus fake. Then the third step is both get better at their jobs with each round. So the final goal is to fool the discriminator with the realistic outputs. So the transformers under the hood pays attention mechanism. So it helps model understand which words matter more. Then we have self-attention, that is allows the model to look at all the words in a sentence at once. And then we have positional, that is encoding, and it helps track the orders of the words as transformers don't read left to right like humans. So this is why models like GPT-4 can summarize, translate and generate in text so well. So understanding the differences between these generative models is like knowing which tool to use for which creative job. So GANs are your digital painters, VAs are the smart compressors with imagination, and transformers are your text wizards. So down the line we'll see how to create our first generative AI model. In this chapter, we will be creating our first generative AI model. So the objective of this lesson is breaking down the steps of building a generative AI model using a pre-trained model. So we are here not training a model from the scratch. So instead, we will fine-tune or directly use a pre-trained model. So this makes it fast and beginner-friendly. So if I tell the steps, in nutshell, we will be first choosing a pre-trained model. For example, GPT-2 because it is lightweight and good for beginners. The source from which we will getting the model is Hugging Face's Model Hub, and then we will be setting up the environment in Google Colab as you can see. Then we will be installing the libraries, the transformers, torch, and then loading the pre-trained model and the tokenizer. Then we will be writing a prompt and generating a text. So here we will be using the pipeline API for simplicity and parameters like max length and temperature. So let's begin. So here I am inside this Google Colab and I have chosen a new notebook to begin with, and then I'll just insert exclamation pip install transformers and shift enter. And it may take some time, and you can see it has actually installing all the required transformers. So pip install means install this package in Colab, and transformers is a library by the Hugging Face. So it gives us access to the powerful AI models like GPT-2, BERT and more. And then we will install from transformers import pipeline, and then we will be using the loading generator GPT-2 text generator. So generator equal to, and you can see pipeline text generation and tab. So we'll execute this, and basically this pipeline is a shortcut tool. It hides all the complex code needed to run the AI models. So here the text generation tells like, hey, I want a model that can write text for me, and GPT-2 is the actual model name. It was trained by the OpenAI to predict what word comes next in a sentence. And then basically you can see that it has model 7 tensors, 100%, has loaded everything, and the storage is also enabled for this repository. And then we'll begin with the prompt. Okay, so let's give the prompt and let's keep it very simple. Prompt equal to once upon a time in a world full of AI, comma, and then in the next line I will be writing result is equal to generator, and we will be passing the prompt inside it, and then we will be giving the max length, one parameter, and I will be specifying it as 100, and I will be giving the number return sequence number return sentence is equal to 1, and I don't require this, so I will be directly printing the result. The first one, the first doc will print, and then we will be passing the generated text, and I will run this. And so the prompt I have given, this is a starting sentence you give to the AI, like saying, hey, start a story with this and this and this. So max length is equal to 100. So this particularly means generate up to 100 words or characters after the prompt. And then you can even see I have given this num return sequence is equal to 1. This is asking for just one version of the result. So you can basically ask for 2-3 versions. I have just asked for only one. And then the result you can see. And in the third bracket, I have given a 0 and the generated text. It extracts the generated text from the result. So you will see the AI write a continuation of your prompt basically. So that's your first generative AI output. You can basically see, once upon a time in the world of AI, your only limit was when you could kill monsters, but now you can for the first time ever. The new monsters are in the battle in the blood of elves now, not the usual black and white battles that you have experienced with the past couple of years, and it has created a great one. So you can even see the power of generative AI. It has that power of completing your text, your prompt. So then let's write result equal to generator and if I want to write prompt comma enter, then max length I will again mention equal to 100, then enter. I want the num return sequence equal to 1, and have to put a comma over here, okay, so don't forget this guys. And then temperature is equal to 0.7 comma top k. Don't worry, I'll explain one by one as I write. Equal to 50, then top p equal to 0.95 comma, then I'll write do samples equal to true, basically a boolean value. So then after this I'll print the result, print result, and in third brackets will be the first one, and then again third brackets will give in generated text, and then we're basically gonna shift enter. So here basically we have parameters like temperature. So temperature, what it does, it controls the creativity. This is lower is equal to safe and higher is the wild, and creative is 0.7 medium. So this top underscore k is equal to 50. So pick from the top 50 likely next words instead of just the top one. Then we have this top underscore p is equal to 0. It is the nuclear sampling, that is a more natural randomness. Then we have do sample is equal to true, that is enables the randomness. So without this the output is too predictable. So once you run this code, you will see something like once upon a time In a world full of AI and with every advancement in AI machines, there has been a change in the way we think about the world. And we need to make sure that we can make sure, and it has repeated it so many times. So every time you run it, you might get a slightly different result. So over here, you have used the Hugging Faces Transformers library to load the GPT-2. Then you wrote a prompt and then the AI continued it using its training. So you did it without any complex machine learning setup inside the Google Colab. So this is your very first generative AI model. In the next chapter, we will be seeing the real world of impact of generative AI models. So generative AI is not just about another buzzword. It's fundamentally changing how businesses operate, solve problems, and serve customers. From generating product descriptions to designing aircraft parts, generating AI is stepping into roles that once required human creativity and intelligence. So in this session, we will explore how industries across the board are using generative AI in meaningful and practical ways. The first one is healthcare, that is a faster diagnosis and drug discovery. So in healthcare, generative AI is helping doctors and scientists make faster decisions. The first one is medical imaging. So AI can analyze medical images like the X-rays or MRIs and create reports to help doctors quickly identify the problems. For example, a hospital uses AI to write reports for doctors, cutting down the time spent on each patient. Then we have drug discovery. So AI helps scientists discover new medicines faster by predicting how proteins fold, which is important for the creating drugs. For example, a company used AI to discover a new drug in just 18 months, which usually takes much longer time. Then moving on to the next one, we have finance, that is a smarter risk management and report generation. So in finance, AI is making it easier to analyze data and detect the problems. The first one is automated financial reports. So AI can create financial reports based on data, saving time for analysts. For example, a hedge fund uses AI to write the market reports in minutes. Then we have fraud detection. So AI helps banks detect fraud by generating the fake transaction data to test their security systems, making them more reliable. So for instance, MasterCard uses AI to create realistic transaction data to improve their fraud detection system. So now moving on to the third, we have retail, and that is the personalized shopping experience. So retailers use AI to create personalized shopping experiences for customers. The first one we have is product descriptions. So AI writes product descriptions that are customized for different customer groups, such as casual descriptions for young buyers and formal ones for the professionals. For example, a clothing brand uses AI to automatically write descriptions for thousands of products. And then we have virtual try-ons. So AI lets customers try on clothes or makeup virtually to see how it would look on them before buying. So for instance, Sephora's app uses AI to suggest makeup and lets users see how it looks on their face using their phone camera. So now moving on to the fourth one, we have manufacturing. There is a faster design and maintenance. So AI is also making manufacturing more efficient. The first one is AI generated designs. AI helps create lighter, stronger parts for products, reducing waste and material costs. For example, an airplane company used AI to design parts that were 50% lighter but just as strong as the traditional designs. Then moving on, we have predictive maintenance. So AI helps factories predict when machines will need maintenance, reducing downtime and improving efficiency. For example, a factory uses AI to automatically create maintenance schedules for machines based on their performance data. So now moving on to the fifth one, we have education. that is a personalized learning for students. So AI is making education more personalized and accessible. The first one is AI tutors. So AI-powered tutors can help students with the homework by guiding them step by step through problems. For example, a student stuck on a math problem can get hints and explanations from an AI tutor available at any time. Then we have automated feedback. So teachers use AI to create quizzes and provide feedback on assignments, saving them hours each week. For instance, a teacher uses AI to review essays and provide comments in just minutes instead of hours. So now moving on, we have sixth one is entertainment, that is creating content at a scale. So in entertainment, AI is being used to create content faster and cheaper. First one is script writing. AI can help writers come up with ideas, generate dialogues, and even create storyboards before filming. For example, a filmmaker uses AI to plan scenes and create visuals before they start shooting, save time in the pre-production. So then we have virtual characters. So AI can create virtual characters that speak and act, which is useful for movies, games, and social media content. For instance, AI is used to create virtual influencers who interact with their followers on social media. So now moving on down the line, we will see how to create a chatbot in Google Colab. So before we dive into the code, let's first understand what the Hugging Face Transformers library is. So the Hugging Face Transformers library is one of the most popular libraries for the natural language processing, and it provides the pre-trained models that can perform a variety of tasks like the text generation, text classification, named entity recognition, and more. So here in the code, we will be using a model called DialogGPT Small, which is a variant of GPT-2 designed for conversation generation. So the DialogGPT was trained on the large conversational datasets, making it a perfect fit for building the chatbots. So let's now build the setting up the environment. So for this, we will install pip install transformers. So this line basically installs the transformers library. You need this to work with the pre-trained models provided by the Hugging Face. So this will allow you to load the models like the DialogGPT we will be using here, a conversational AI model, and use it to generate the chat responses. And here we will begin with importing the necessary libraries. From transformers, import the auto model. For the casual LM auto tokenizer, import torch, and then we will run this. So here we are importing the necessary components like the auto model ID for the casual LM. So this class basically loads a pre-trained model for the casual language modeling, which is used for the text generation task. So we will use it to load the DialogGPT model. And the auto tokenizer, the tokenizer converts the text into tokens which are known as numbers, that the model can process and then converts the model's output back into the human readable text. So the torch is then, PyTorch is the deep learning framework used by the model. It's used for the tensor manipulations as models rely on these tensors for the input and output. So let's begin. Then we will begin with the loading the model and the tokenizer. So here this converts the raw text, that is the user input, into tokens. Into that model understands. So each word or phrase is mapped into the unique ID, making it easier for the model to process and generate a response. So then model is that pre-trained DialogGPT small model is loaded over here. So this model has been trained on a large corpus of dialogues, which enables it to generate the relevant responses in a conversational manner. So then we will begin with the chat initialization. And before beginning with the chat initialization, we will see that the tokenizer config JSON is 100% complete, and the best part of Collab is it will give you all the status of how it is complete and for which particular merges.text.vocab.json which is completing and what problem is there. So let's just run this and let me explain. So chat history IDs. So this is a variable where we store the history of the conversation. So this helps the model maintain the context across multiple user inputs. Then we have having a print statement that start chatting with your AI, type quit to exit. So this provides a welcoming message to the user to start chatting and gives the exit command. So then we will begin with the chat loop, that is the main logic of the chatbot. So then we'll begin with this chat loop logic. So we have written for step in range 5, user input is equal to input and then u and then semicolon and then a space. And then we have written if user input dot lower is equal to quit, then I have to break it. Break the loop. Break. So then I'll run this. And this section of the code basically uses input to get the user's message and exit condition. If the user types quit, the loop will break and the chat ends. So let's see. And here basically you can see I have written hey and still it doesn't break. So let's write quit over here and let's see what happens. So you can see that it has stopped generating, means it has got out of the logic. So here we have this encoding user input. So encoding, the user input is converted into token IDs using the tokenizer dot encode. So the EOS token, that is the end of sequence token, is added at the end of the user input. This tells the model that the input has ended and it prepares for generating a response. Then tensors. So this is the return underscore tensors equal to PT. That part ensures that the encoded input is returned as a PyTorch tensor. This is the format that the model expects. So we will run this. And then we will be moving on to managing the conversation in history. So here we are having this managing conversation history and it is up to maintaining the context. So we want to keep the track of the conversation history so that the model can respond in context. So if there's previous chat history, that is the chat history IDs, it is concatenated with the new input, allowing the model to consider the entire conversation so far. So if there is no previous history, that is the first user input, the new input IDs are used directly. So then we will be moving on to generating a response. So here we are concentrating on generating a response. Chat history IDs is equal to model generated bot input IDs, max length equal to 1000 and pat token ID is equal to tokenizer dot EOS token ID. So model response, so this part sends the concatenated input to the model, that is model.generate, and generates a response. The maximum length specifies the maximum length of the generated text. So in this case, it is set to 1000 tokens. Then we have pad token ID, that is ensures the padding tokens are handed correctly. That is the model needs to know which tokens are just padding. Then we will be moving on to the decoding the response. And here we are seeing response is equal to tokenizer dot decode chat history IDs, that is the bot input IDs dot shape and everything. So basically decoding this generated token IDs are converted back into the human readable text using the tokenizer dot decode. Then we have skip the special tokens. The skip special tokens is equal to true. It ensures that any special tokens like the EOS are not included in the final output. So we will run this. And then finally, we are actually printing the response, that is displaying the response. So the print, this generating the response is displayed to the user. So we'll run this. And you can see bot, I'm so sorry. So what happens when you run this code? You initiate the chat and the bot welcomes you to start chatting. So every time you input something, the bot takes your message, encodes it, and sends it to the model along with the conversation history. The model generates a response considering the entire conversation so far, and the bot outputs that response. So this loop continues until you type quit, ending the conversation. So, building a chatbot is essential because it enhances the user engagement by providing the real time, personalized interactions, making it more dynamic and the user friendly compared to the static content. So, chatbots are available 24 by 7, ensuring the users can get immediate responses at any time. So, by automating the repetitive tasks like answering common questions, processing orders, or providing basic customer support, chatbots free up valuable resources, allowing human employees to focus on more complex tasks. So then, additionally, chatbots can improve customer satisfaction by quickly resolving the inquiries, reducing the wait times, and enhancing the overall user experience. So, implementing the context management allows the bot to remember the previous interactions, ensuring a continuous and more personalized experience for the user. So, finally, enabling the multi turn conversation handling means the chatbot can engage in back and forth dialogues rather than only answering the isolated questions, so making it feel more conversational and human like. So these features collectively help create an intelligent, efficient, and engaging chatbot that can significantly improve user interactions and streamline the business operations. So you can even fine tune your own model. So this could be your own data set to make it more specific to a particular domain or a use case. You can even make it worth handling the longer conversations so that it remembers the chat history for a long time. So guys, you have made your first chatbot and down the line, let's get improved. So in this lesson, we will understand about the limitations of generative AI models. So the first one is lack of understanding. So AI models generate content by predicting what comes next based on the patterns in data, but they don't truly understand the content. For example, when an AI creates an article or a code, it doesn't know what it's writing. It's just mixing patterns based on the past data. Then moving on to the dependence on the data quality. So the AI's performance is only as good as the data it's trained on. So if it has biased or incomplete data, it can generate biased or inaccurate results. Think about biased hiring algorithms or flawed healthcare recommendations, real issues caused by the bad training data. So now moving on to the third one, we have creativity limitations. So AI can produce impressive creative outputs like artwork or music. So however, it struggles to innovate or produce truly original ideas like a human artist would. It's more about remixing the existing content rather than inventing something groundbreaking. Now moving on to the next, we have ethical concerns. So AI models can sometimes generate harmful content, from offensive language to deep fakes that are hard to distinguish from the real footage. So, this poses risk for misinformation and ethical dilemmas, especially in media and entertainment. So, now moving on to the next, we have context and nuance. So, generative AI can miss the subtle nuance in conservations or emotions. For instance, if you asked a model to help with the sensitive topics like mental health, it might offer advice that's generic and more tailored to the individual's emotional needs. Next, we have cost and resource intensive. So, training a generative AI model requires huge amounts of computing power, time, and energy. So, these models often run on the powerful servers, consuming a lot of resources, which raises concerns about the sustainability and the environmental impact. So now moving on to the next one, we have limited problem solving capabilities. While generative AI is great at tasks like writing essays or summarizing text, it's not well suited for the task requiring the deeper reasoning or the complex problem solving. It can simulate problem solving, but it doesn't truly understand the solution in the way humans do. Now, moving on to the next one, we have risk of over reliance. So, with AI generating more and more content, there's a risk of becoming too dependent on the technology. So, people might rely on AI for the tasks that require human expertise or critical thinking, which could hinder the personal creativity or decision making. So, now moving on, we have data privacy issues. So AI models can sometimes generate content based on the personal data, raising concerns about privacy. So this is especially problematic in the areas like healthcare, where sensitive data can be inadvertently shared or misused. So now moving on to the next one, we have generalization challenges. So generative models are great at specific tasks, but struggle with the broader generalization. For instance, a model trained to generate images of the cats may struggle to create the convincing images of a completely different animal, showing that AI is limited in its flexibility. Now, moving on down the line, we will understand the future of Gen AI models. The first one is improved understanding and comprehension. So, that the future of generative AI will likely see models that can understand the context more deeply, providing more relevant and meaningful outputs. So, we might see AI models that can truly comprehend the meaning behind the responses rather than just spitting out the data. So next, we'll move on to the enhanced creativity. So as AI models evolve, we can expect them to push boundaries and become more innovative. So with advancements in the techniques like the reinforcement learning and neural architecture search, we could see AI producing truly original content, potentially revolutionizing fields like the art, music, and literature. So now moving on, we have more ethical AI. So in the future, we will likely see more regulations around AI usage to prevent the harmful outcomes. So AI companies are already working on improving the transparency, reducing bias, and making their models more ethical and responsible. So now moving on, we have better personalization. So the future holds AI that can offer more tailored, personalized experience. So imagine an AI that truly understands your needs and preferences. So providing you with the content, products or services that feel personalized and relevant. Now moving on to the next one, we have energy efficiency. So as the demand for the generative AI grows, researchers are focusing on creating more energy efficient models. We may see smaller, more powerful models that can run on less computational power, reducing the environmental impact. So next we have human AI collaboration. So rather than replacing humans, the future of generative AI models is likely to be centered on collaboration. So we will see AI helping people be more productive, augmenting creativity and providing insights that humans can use to make better decisions. So now moving on to the next, we have integration with the new technologies. So generative AI will continue to integrate with the new technologies like augmented reality, that is the AR, then the virtual reality, that is the VR, the blockchain, and opening up new possibilities for the immersive experiences and the decentralized applications. So now moving on, we have solving complex real world problems. So in the near future, we could see AI models working alongside scientists to tackle the big challenges like climate change, pandemics, and global food security. So AI could help analyze data, predict trends, and offer innovative solutions to these pressing problems. So now we'll see the next one, we have more accessible AI. So as technology advances, AI will become more accessible. Tools will be easier to use, and people from all the walks of life, not just the technical experts, will be able to harness the power of AI to create and innovate. So, while generative AI models are still evolving, their potential to transform the industries, enhance creativity, and solve the complex problems is undeniable. But it's important to address their limitations and work towards creating more ethical, efficient, and responsible AI systems. So the future is exciting and we are just getting started. So guys, congratulations on completing the Gen AI Models for Beginners course by Simplilearn. You have now built a strong foundation on the generative AI models by learning what generative AI was, how it impacted the real world, then creating chatbots, creating your first Gen AI model, and then finally closing it with the future of Gen AI models. So, as you move forward, continue experimenting with your own data sets and refining your own pipeline to unlock the full potential of Gen AI and creating smarter, context aware Gen AI systems and models.
So guys, let us start with first understanding what exactly is LLM. LLM stands for Large Language Model, which is a type of artificial intelligence trained on vast amount of text data to understand and generate human-like language. These models, such as OpenAI's GPT or Meta's Llama, use deep learning techniques to analyze context, predict the next word in a sentence, and also provide intelligent responses to text inputs. Unlike traditional rule-based systems, LLM learns patterns, grammar, facts, and even reasoning skills from the data they trained on. In simple terms, LLM can read and write text almost like humans, making them incredibly powerful tools for building intelligent applications. Now, let us move ahead and try to understand some of the real-world applications of LLM. So, the first one are chatbots and virtual assistants. Apps use LLMs to power smart conversation with users, whether it's customer support, booking assistance, or mental health guidance. LLM help deliver human-like, helpful interactions. The next one we have all over here is content generation. From blog intros to product descriptions, LLM can generate content at scale, making them valuable for marketing apps and writing tools. Next, we have summarizations and insights. Apps like News Aggregator or legal tools use LLMs to summarize long documents into digestible insights. Next one, we have code generation. Developers focus tools use LLMs to auto-generate code snippets, help debug errors, or explain programming concepts. And finally, we have language translation and correction. Language apps leverage LLMs to provide real-time translation, grammar correction, and learning suggestions. Overall, LLMs enable apps to understand and respond to user inputs with remarkable fluency, making them central to next-gen user experiences. Now, let us discuss about some of tools and framework from where LLMs can be made. So guys, depending on your preferred programming language and project type, here are some of the key tools. If I talk about Python guys, it is widely used for quick prototyping with LLMs. Libraries like LangChain, Transformers, and OpenAI make it easy to connect with LLM APIs. If we talk about Node.js guys, it is ideal for web-based apps and backend services. We can use packages like OpenAI, Axios, or LangChain. Now let us discuss something about LangChain. So LangChain is actually a popular framework which simplifies working with LLMs. It handles prompt templates, chaining multiple steps, memory management, and even data retrieval. And you could easily integrate with the front-end frameworks like React, Vue, or Flutter for building the user interface that interacts with LLM via APIs. So guys, now let us set up our environment. But before that, you need to make sure that you have Python installed on the system. So I'm basically using Windows operating system and I'm at command prompt. So I will just type Python V, check the version of Python. So guys, as you can see, I have already installed Python in my system. But if you don't have Python on your system, then you need to install it. You can watch our Simplilearn's video where we have installed Python on Windows operating system. Now, after that, what you need to do is, guys, you need to run this bash script. Now, guys, let us create our virtual environment. So for creating our virtual environment, you can type python /m vnv llm env. This is the name of our virtual machine. Just right click on this. Okay. Now let us activate our virtual machine. Now after that, what you need to type is llm env, the name of your virtual environment, /script /activate. Now this will enable your virtual machine, which is llm env. Now after this, what we have to do is we have to download one of the important libraries. So let us download it. So guys, I'll tell you one of the most secure way. So you'll be using API keys of ChatGPT all over here. So I'm not using .env, but still I would suggest for security reason to always create a .env file. So for the same purpose, what we are going to do, I'm going to install OpenAI python.env. So this package will help you manage your APIs key very smoothly. Just right click on this and it is going to install the .env package. Now after that, let us set our API key. So guys, go all over here. So create a new secret key. Let us give it as name as LM test. So you have to go on platform.openai/API/keys. So this is the link where you will create your secret key. Now you create your secret key all over here. Copy this, okay, and just add in your .env file in your project structure. So guys, after copying that, what you need to do is you need to set your API key. So there are two ways to do it. One is very simple way, which I would not suggest it. Like just create a variable and paste your secret key. The next is using .env. So by creating a .env file and setting your variables and then pasting your given API key. That is one of the good things. Now let us go all over here. Just copy this. Now guys, after creating this variable, just paste your given API key. Right click on this and our API key is set. Now guys, what you need to do is open a notepad, and this is just for simple demonstration. You just type this code. Now let us discuss about this code for a minute to understand what is going on all over here. So guys, as you can see all over here, I have imported OpenAI and I have also imported operating system. Okay, so this OS module OpenAI repeat. So guys, this OpenAI Python library, you can use it with the OpenAI's API. Then we are also importing OS module to interact with the environment variables on our system. Now finally, what we are doing is OpenAPI.API key equals to os.getEnv and OpenAPI key. So this line gets your OpenAPI key from an environment variable called OpenAPI key. Okay, and it also sets it to the library who knows how to authenticate your request. You need to have this key set up in your system environment variables before running the code. Now next, we have response equals to openai.chat.completions.create, and here I have added my model. So if you are not having paid account, then it will be bit troublesome for you because there are different kind of models, and like 4.0 basically comes at a charged prices. So get your plan upgraded and your billing plans. So because based on that, the number of tokens are there. In that way, your API call is going to happen. Now, here you could see I have written the messages as role, system, content, your helpful assistant, role, user, content. Hello, can you assist me using GPT 4.0 mini model? So basically what we are doing all over here is I'm calling the OpenAI chat completion API to create a method. First of all, I specified my model, which is basically optimized for faster responses, 4.0 mini. And then there is a message parameter which simulates a chat conversation. The system message sets the assistant's behavior, like you are a helpful assistant, And there is a user message which is asking the model, hello, can you assist me using the GPT-4 mini model? So basically this prints out the content of the first response message generated by model, and the API returns a list of choices, usually just one, and you can access the message text from the first choice. Now this script basically sends a chat message to the OpenAI GPT-4 mini model and prints the model's reply. It uses your API key stored in the environment to authenticate and perform the request. So this is how basically this is happening. I hope so guys you would have got a brief idea regarding this code. Okay. Now after this you need to go to your designated folder. Okay. So I have saved my given file in C users SLP13089. Now going to documents. Okay. So inside this I have this folder called app.py. Now I'm going to run the given file. Now just right click on this and let's see what happens. You can see we are getting some error. Okay, you can see the message here is code is 429 and my quota is exceeded. Okay, I need to upgrade my plan, and this is generally going to happen if you have not upgraded your plan because the number of API calls are already set. But this is something very much feasible. Now let me tell you what will be the output of this program. So you could see all over here that in the user it's asking the content as hello, can you assist me using GPT-4 mini model. Now the answer would be yes, I can definitely assist you using the GPT-4 mini model. How can I help you today? So that is a kind of a simulated reply that we are going to see in our given output. And this is a very simple way of integrating LLM model. So in this way, you are going to get the output. Okay. I hope so. You would have got a brief idea how you could integrate LLM models into your given project. So that is one of the way. Now let us move ahead and discuss about some of the more key concepts all over here. Now let us discuss about designing effective prompts. Crafting a strong prompt is key to unlocking accurate, relevant, and context-aware responses from large language models. And here are some essential guidelines to help you write better prompts. First of all, be clear and specific. Vague instructions often lead to generic or confusing answers. So instead of asking explain AI, a clearer version would be explain artificial intelligence in simpler terms for a high school student. This not only narrows down the scope but also defines the complexity level and target audience, helping the model tailor its response accordingly. Next one we have define the role or tone. LLMs can adopt different styles or personas based on your prompt. For instance, saying you are a career coach, give advice to a fresher looking to enter data science will lead to more structured and empathetic guidance. You can also adjust tone, formal, casual, humorous, or technical tone based on your app's use case. Next one we have is called providing context. If your prompt depends on previous information or has multiple parts, provide that background clearly. For example, given this resume summary and job description, write a tailored cover letter in 100 words. This example helps the model understand relationship between inputs and generate more relevant output. So guys, keep this in mind while you are designing an effective prompt. Now let us discuss some of the effective prompting techniques. First one we have is zero-shot prompting. Now here you give only one instruction with no examples. Like for example here you will say translate the sentence to French. How are you? Okay. This is great for simple or well-known tasks. So that is called zero-shot prompting. Now, let me tell you one more prompting technique which is called as few-shot prompting. Now, here you have to provide 1 to 3 examples to set the format or tone. Like for example, English hello to Spanish hola, then good night to buenas noches. Basically you say hello and then in Spanish you add hola. So this helps guide the model and also it improves the consistency. Now, the final one that we are going to discuss, that is called chain of thoughts. Now, prompt the model to think step by step. So this is all about chain of thought. For example, if you say like if a train leaves at 3 p.m. and travels for 2 hours, what time will it arrive? So let's think step by step. This is ideal for reasoning, heavy tasks like math, logic puzzles, or multi-step questions. So guys, mastering these techniques will make your LLM based app more intelligent, reliable, and it will be tailored to user needs. Now let us discuss about future scope and advanced topics. So as you grow more confident with building LLMs, there are several advanced techniques and future-ready capabilities you can explore to build smarter, more specialized applications. These methods help overcome limitations of generic LLMs, making them more accurate, efficient, and customized for your specific needs. Now, let us discuss about these parameters because these are the future scope which could help you improve your LLM. The first one we'll talk about fine-tuning versus prompt tuning. So fine-tuning basically involves retraining base model on your own dataset. This is useful when you want the model to understand industry-specific language or behave in a certain way consistently. However, it's resource intensive and usually requires large datasets and GPU support. If I talk about prompt tuning, guys, on the other hand, it's kind of lightweight. It focuses on crafting or learning optimal prompts, often called soft prompts, without changing the underlying model. It's faster, cheaper, and works well for specific tasks like classification, summarization, or form filling. Use fine tuning when you need deep domain adaptation. Use prompt tuning for faster task specific improvements. Now, next thing what you could include is RAG. So, if I talk about RAG, so RAG stands for Retrieval Augmented Generation. This basically combines the power of LM with a knowledge retrieval. So instead just relying solely on the model's internal knowledge, RAG, what it does, it pulls the real-time external data like PDF, websites, or databases, okay, to provide grounded and up-to-date answer. For example, let's say if you are saying to ChatGPT, like summarize the latest policy from this PDF. Okay, so if you give a government generated PDF and you want to know what is the latest policy with certain regards, so the retriever fetches the relevant text and the LLM is going to summarize that. So this is how RAG actually is very useful, and this is one of the future scopes of LLM. The third thing, how to improve it, is by connecting to the external data. One of the most exciting advancements in LLM app development is the ability to connect the model to external data sources. So by most default, LLMs like GPT-4 generate responses based on static pre-trained knowledge. But real-world applications often need to access up-to-date, domain-specific or user-generated data, which is where this integration becomes essential. So instead of relying only on what the LLM knows, you can dynamically feed it information from various data systems, making your app smarter, more relevant, and context-aware. Examples of external data sources can be you could connect to databases like SQL or MongoDB, retrieve customer records, inventory data, transaction histories, etc., and let the LLM analyze or summarize them. The next one is cloud storage. So you could use Google Drive, Dropbox, AWS S3. Read documents, PDF, or spreadsheet and answer questions about their contents. Third one, if we talk about, is knowledge bases. Notion, Confluence, SharePoint are those things. Pull the internal wiki pages or team documentation into the LLM for better organizational support. Third one will be APIs and web scraping. Bring in live weather data, stock prices, policy updates, or even product listings from e-commerce sites. Then you have search indexes like RAG. It uses tools like Llama Index, LangChain, or Haystack to retrieve and inject relevant information into the prompt before LLM generates a response. Now guys, why does it matter? Because these are the future scope or where our LLM advancement is heading up to. And these capability will turn your app into live knowledge connected assistant, capable of answering user queries with real-time accuracy and deep customization. And this becomes very much useful in scenarios like customer support bots, enterprise dashboards, research tools, or intelligent CRMs. So guys, by building LLM powered application, it's just not a trend. It's a transformative shift in how we design intelligent, user-centric software. From setting up a basic prompt response interface to mastering prompt engineering and exploring advanced techniques like RAG, external data integration, you now can understand how LLMs can unlock powerful capabilities in your application. So, guys, whether you are creating a chatbot, research tool, or an internal assistant, you are no longer just encoding. You are designing intelligent conversation. Keep exploring and keep fine tuning. And let the power of language model elevate your ideas into smart and dynamic experience.
OpenAI Gen AI agents. So, first, let's get started with the agenda for today's session. We will have a brief introduction to generative AI agents. Followed by that, we will understand the core components of Gen AI agents, then how generative AI agents work, architectures and deployment, enhancing AI agents with external tools, challenges and limitations of Gen AI agents, future trends and advancements in AI agents will be the last one. So I hope I made myself clear with the agenda. Now let's get started with the first part, which is Introduction to Generative AI Agents. So basically, what exactly do you mean by the term generative AI agents? So an AI agent is just an LLM that can take actions, and it can do so autonomously without any human supervision, and now also reason about the tasks. An AI agent is software entity that autonomously interact with environments, make decisions and execute tasks. Generative AI agents extend by leveraging large language models like OpenAI GPT to generate intelligent responses and perform tasks beyond rule based automation. Now, we will also look into the evolution of AI agents. Traditional rule based AI agents had limited to predefined rules. Like if you define a process and give the steps, it will just perform them and complete it. It will not take a step beyond it. And machine learning based AI agents can learn from data but need structured inputs. And then comes the generative AI agents, which are capable of understanding, reasoning, and generating human like responses autonomously. Like they understand the environment and learn through it and take their steps based on the principle they have been trained for. And also, they will provide the reason for which they have taken a certain step. Now, moving ahead, why generative AI agents matter a lot? So there are three key points to consider. Firstly, efficiency. They automate repetitive tasks with minimal human intervention. Next is high scalability. They handle large volumes of work, example customer support, content generation, and many more. And finally, intelligence. They can adapt to different use cases dynamically. Nobody has to write rules for them. Now let's focus on OpenAI and its latest release of agents. So OpenAI just released two new groundbreaking agents, the Operator Agent and Deep Research Agent. These two releases are absolutely massive for all AI agent developers. So Operator is the first AI agent released by OpenAI, and what it does is it mimics human actions on your browser. So it means it can scroll, type, click, and navigate Google web pages for you just like any other human would. But more importantly, and what many people have missed out is this agent is actually based on a completely new model called CUA, which stands for Computer Using Agent. So, this agent, unlike standard GPT models, wasn't trained to just output text. You like write a prompt and expect an output in the text format. Instead of that, it can go beyond it. This agent was actually trained to output mouse and keyboard clicks, which is exactly what makes this agent so powerful in your browser. But not only that, it can also reason about every single action. This is also something that we haven't seen before. This agent doesn't just perform actions in your browser, it actually reasons about every single step and what it should do next. Just like we discussed before about the generic overview of generative AI agents, same as the OpenAI operator here. It takes the step based on the environment, and also it will give you a particular reason for which or based on which it took a certain action, and it also asks you what to do next. Let's say if you want to book a ticket, it'll navigate to all the websites. It can go through some better flight options for you. Let's say the low cost ones, the low hours of flight ones, and best timings, and then finally selects the best one for you based on your recommendations, and asks you if it should proceed with booking or not. So that's how it works. Now, of course, there are some limitations as well. The first limitation is it has still a lower bit of accuracy. It's really high compared to other projects that we have seen in the past where people just prompt GPT models to perform actions in the browser that can browse web using GPT-4o vision capabilities, but it often struggles with other models. So whenever there was a model on a web page, like some other random model available working readily on a web page, it would just accidentally pop up and it would not be able to do anything because it would just get confused. It would not be able to close it, and then basically you would have to get involved yourself and close this model manually. And the second limitation is high cost. Right now, this particular operator agent is only available on $200 plus plan. So we can probably guess it's going to be pretty expensive in the API. Also, I do think that if you are focusing on the right thing, then costs are not going to be an issue. Now, let's talk about the second agent that OpenAI deployed. Now, the second agent which was deployed by OpenAI is called as Deep Research. So, this second agent released by OpenAI was trained to perform comprehensive research. It can search the web, it can pull up the necessary resources, and then it can compile all that information into a really comprehensive document or maybe a report as well. The groundbreaking thing about this agent is it's powered by the new O3 model. So again, similar to the operator agent, but it doesn't just search the web and provide you with the results. It actually reasons about every single source and then it thinks about what other information it needs to find out next, and it's really incredibly powerful. Deep research doesn't just output the most average thing on the internet just like some other standard GPT models. It would compile novel insights. Now, let's move on to the real world applications. There are a wide variety of real world applications. First one is customer support AI agents, which helps you in automating help desk responses. Next, powerful AI assistants like copilots for professionals. Third one is research and analysis agents for data summarization, literature reviews, and many more. Fourth one is creative writing and content generation, automating social media posts, emails, etc. And lastly, AI-driven code assistants like GitHub Copilot, OpenAI Codex, and many more. Now, let's go through the next part, which is core components of these generative AI agents. Let's begin with the foundation models. So the foundation models are GPT-4, Dolly, and Whisper. GPT-4 for natural language processing, Dolly for image generation, and Whisper for speech to text conversion. The next one would be prompt engineering and context handling. So here, designing effective prompts for AI agents to generate relevant responses, using few shot and zero shot learning for adaptability, and lastly, implementing context-aware AI agents that remember past interactions from the user. Now, next would be the memory and long-term context storage. AI agents typically process short-term prompts, but memory-based approaches, for example, LangChain's memory module, enable long-term reasoning as well. Now, storing and retrieving user-specific data for personal responses is also one of the priority. Next will be the tool use and API integrations. Using external API to fetch real-time data, for example, weather, stock prices, news, etc., and integrating databases for structured information retrieval. And proceeding further, we have autonomous decision making. AI agents evaluate multiple options before making a decision. Planning and reasoning techniques to enhance responses is a priority for them. Proceeding ahead, we will discuss how generative AI agents work. Starting with the first step, input processing and context awareness. AI agents analyze user input, detect intent, and extract entities. For example, in a travel booking AI agent, it identifies destination, date, and budget from user queries. Just like the example we discussed before, right? You provide the point A and point B, the best time for you to fly, and the best number of hours that you focus on flying, and lastly, the destination, right? All these things will be evaluated in real time. The cost, the number of hours, the flight, the options provided, the amenities provided on the flight, and all those things, and also budget as well. And based on that, they take a decision. Now proceeding ahead, generating intelligent responses. So here, RAG, or also known as Retrieval Augmented Generation. AI searches external databases for responding. Next, we have chain of thoughts reasoning, or also known as COT reasoning, and AI breaks down problems into fine steps. And last step is fine-tuning the models, custom trained AI for specific industries. For example, if you're preparing an AI agent for a dedicated sector like healthcare, legal, customer support, based on that, you will fine-tune your AI agent or model. Now, next is decision trees and multi-step reasoning. AI can simulate a thought process, breaking down complex questions into manageable steps. For example, whenever you open DeepSeek or whenever you open OpenAI ChatGPT for the most premium version, you will write a prompt and there will be an option called think, right? If you just click on that, it will explain you the thought process it is going through and how is it planning on giving a reason for you, right? And followed by that, we have handling uncertainty and error correction. AI self corrects through confidence scoring and human feedback loops. Last step in this particular stage is fine tuning and reinforcement learning, or also known as RLHF. Human in the loop training to improve responses, and AI learns from real world interactions and adapts over time. So it's basically called overtime learning, where it adapts to the real world environment and learns things and provides the best feasible solution. Now, the next stage is architecture and deployment of AI agents. So, in the first one, we have standalone versus multi agent systems. So, firstly, the standalone AI agents. They perform tasks independently. For example, ChatGPT. Multi agent systems, on the other hand, work together to achieve complex tasks. For example, one agent for summarization, another for execution. Now, next in this particular stage is agent orchestrator model. A central AI agent coordinates multiple AI sub agents. For example, in an AI powered research assistant, one agent gathers all the data that is required, the second agent summarizes all the information collected, and the third agent formats the output. Followed by that, we have cloud based AI agents and edge based AI agents. Cloud based AI agents compute, for example, OpenAI API, Azure AI, and edge based AI agents run on local devices for faster processing, for example, Tesla's AI in self driving cars. Followed by that, we have using APIs to build AI agents. OpenAI's API for GPT-4 powered by AI agents, LangChain framework for AI agent orchestration, and Llama Index for document-based AI agents. The next stage, we will discuss about enhancing AI agents with external tools. In that, the first step is integrating with databases. AI agents can query SQL and non-SQL query databases for structured data retrieval. Proceeding ahead, we have connecting with web scrapers and APIs. AI agents can fetch real-time data using tools like Beautiful Soup, Scrappy, and OpenAI plugins. Next ahead, using vector databases for context recall. FAISS ChromaDB store long-term memory for AI agents. For example, legal AI agents retrieve case law from vector embeddings. Lastly, we have autonomous agents and workflows. AutoGPT and Baby AGI are best examples. These AI agents that self-improve by learning from previous tasks, and True AI, which is a set of multiple AI agents collaborating to solve a complex problem. Now, the main part, challenges and limitations of generative AI agents. In that, the first one will be the ethical considerations. AI bias and fairness concerns are the primary ones. Addressing AI hallucinations, which is false information generation, and then we have computational cost and efficiency, which is a major concern amongst all the industries. Large AI models require significant computational power. Strategies to optimize AI agent efficiency will also considered to be expensive to hire many training models or also human programmers. Followed by that, we have security risks and data privacy. Risk of data leaks or data breaches and AI jailbreaking is one of the highest security threat. Implementing secure AI architecture is one of the primary solutions that you need to focus on. And lastly, we have legal and compliance issues. This would majorly be concerned from the enterprise level. GDPR, HIPAA, and AI regulations compliance is mandatory, And AI liability in decision making is also important. And now, the last stage of today's discussion, which is future trends and advancements in AI agents. Starting with the first one, AI agents with emotional intelligence are also known as affective AI. AI is capable of detecting emotions and adapting responses accordingly. For example, if you have designed a therapeutic AI chatbot for mental health. Now, the next one, self improving AI systems. So, meta learning and auto ML are a few examples. AI agents that learn from new data autonomously, for example, AI adjusting marketing campaigns based on customer responses. And now the next one, AGI and roadmap to superintelligence. Well, this always ends up with question. Will AI agents evolve into AGI, or also known as artificial general intelligence? And are the implications of self-learning AI real? This is the major question. And lastly, the role of AI agents in the future of work. Now we can see there are a lot of AI agents like Copilot, which will assist humans in their day to day tasks, whether it is business, healthcare, or education. And also, you have a lot of automation and transformation happening in the IT industry, which will reduce the work hours and stress on the employees by automating all those mundane tasks by the help of Copilots, also the generative AI agents.
So, what is deep learning? Deep learning is a subset of machine learning, which itself is a branch of artificial intelligence. Unlike traditional machine learning models, which require manual feature extraction, deep learning models automatically discovers representation from raw data. So, this is made possible through neural networks, particularly deep neural networks, which consist of multiple layers of interconnected nodes. So, these neural networks are inspired by the structure and the function of human brain. Each layer in the network transforms the input data into more abstract and composite representation. For instance, in image recognition, the initial layer might detect simple features like edges and textures, while the deeper layer recognizes more complex structure like shapes and objects. So one of the key advantage of deep learning is its ability to handle large amount of unstructured data, such as images, audios, and text, making it extremely powerful for various applications. So stay tuned as we delve deeper into how these neural networks are trained, the types of deep learning models, and some exciting applications that are shaping our future. Types of deep learning. Deep learning AI can be applied supervised, unsupervised, and reinforcement machine learning using various methods for each. The first one, supervised machine learning. In supervised learning, the neural network learns to make prediction or classify that data using labeled datasets. Both input features and target variables are provided, and the network learns by minimizing the error between its prediction and the actual targets. A process called backpropagation. CNN and RNN are the common deep learning algorithms used for tasks like image classification, sentiment analysis, and language translation. The second one, unsupervised machine learning. In unsupervised machine learning, the neural network discovers patterns or clusters in unlabeled datasets without target variables. It identifies hidden pattern or relationship within the data. Algorithms like autoencoders and generative models are used for tasks such as clustering, dimensionality reduction, and anomaly detection. The third one, reinforcement machine learning. In this, an agent learns to make decisions in an environment to maximize a reward signal. The agent takes action, observes the records, and learns policies to maximize cumulative rewards over time. Deep reinforcement learning algorithms like deep Q networks and deep deterministic polygradient are used for tasks such as robotics and gameplay. Moving forward, let's see what are the artificial neural networks. Artificial neural networks, ANNs inspired by the structure and the function of human neurons, consist of interconnected layers of artificial neurals or units. The input layer receives data from the external resources and it passes to one or more hidden layers. Each neuron in these layers computes a weighted sum of inputs and transfers the result to the next layer. During training, the weight of these connections are adjusted to optimize the network's performance. A fully connected artificial neural network includes an input layer or more hidden layers and an output layer. Each neuron in a hidden layer receives input from the previous layer and sends its output to the next layer. So this process continues until the final output layer produces a network response. So moving forward, let's see types of neural networks. So deep learning models can automatically learn features from data, making them ideal to tasks like image recognition, speech recognition, and natural language processing. So the most common architecture in deep learnings are the first one, feed-forward neural network, FNNs. So these are the simplest type of neural network where information flows linearly from the input to the output. They are widely used for tasks such as image classification, speech recognition, and natural language processing, NLP. The second one, convolutional neural network, designed specifically for image and video recognition. CNNs automatically learn feature from images, making them ideal for image classification, object detection, and image segmentation. The third one, recurrent neural networks, RNNs, are specialized for processing sequential data time series and natural language. They maintain an internal state to capture information from previous input, making them suitable for tasks such as speech recognition, NLP, and language translation. So now let's move forward and see some deep learning application. The first one is autonomous vehicle. Deep learning is changing the development of self-driving car. Algorithms like CNNs process data from sensors and cameras to detect objects, recognize traffic signs, and make driving decisions in real time, enhancing safety and efficiency on the road. The second one is healthcare diagnostic. Deep learning models are being used to analyze medical images such as X-rays, MRIs, and CT scans with high accuracy. They help in early detection and diagnosis of diseases like cancer, improving treatment outcomes and saving lives. The third one is NLP. Recent advancement in NLP powered by deep learning models like Transformer, ChatGPT have led to more sophisticated and human-like text generation, translation, and sentiment analysis. So applications include virtual assistant, chatbots, and automated customer service. The fourth one, deepfake technology. So deep learning techniques are used to create highly realistic synthetic media known as deepfakes. While this technology has entertainment and creative application, it also raises ethical concern regarding misinformation and digital manipulation. The fifth one, predictive maintenance. In industries like manufacturing and aviation, deep learning models predict equipment failures before they occur by analyzing sensor data. Their proactive approach reduces downtime, lowers maintenance costs, and improves operational efficiency. So now let's move forward and see some advantages and disadvantages of deep learning. So first one is high computational requirements. So deep learning requires significant data and computational resources for training. Whereas advantage is high accuracy, achieves state-of-the-art performance in tasks like image recognition and natural language processing. Whereas deep learning needs large labeled datasets, often require extensive labeled dataset for training, which can be costly and time-consuming together. So second advantage of deep learning is automated feature engineering. Automatically discovers and learn relevant features from data without manual intervention. The third disadvantage is overfitting. So deep learning can overfit to training data, leading to poor performance on new unseen data. Whereas the third deep learning advantage is scalability. So deep learning can handle large complex dataset and learn from massive amount of data. So in conclusion, deep learning is a transformative leap in AI, mimicking human neural networks. It has changed healthcare, finance, autonomous vehicles, and NLP, LLMs. If you ever wondered how machine learning can now understand and generate human-like text, you are in the right place. From chatbots like ChatGPT to AI assistant that powers search engines, LLMs are transforming how we interact with technology. One of the most exciting advancements in this space is Google's Gemini or OpenAI ChatGPT, a cutting-edge large language model designed to push the boundaries of what AI can achieve. In this video, we will explore what LLMs are, how they work, and why models like Gemini are critical for the future of AI. Google Gemini is part of a new wave of AI models that are smarter, faster, and more efficient. It is designed to understand context better, offer more accurate responses, and integrate deeply into services like Google Search and Google Assistant, providing more human-like interactions. So we will break down the science behind LLMs, including their massive training datasets, transformer architecture, and how models like Gemini use deep learning innovation to change industries. Plus, we will compare Google Gemini to other popular LLMs such as OpenAI ChatGPT models, showing how each of these technologies is used to power chatbots, virtual assistants, and other AI-driven applications. By the end of this video, you will have a clear understanding of how large language models like Gemini work, their key features, and what they mean for their future AI. Don't forget to like, subscribe, and hit the bell icon to never miss any update from Simplilearn. So, what are the large language models? Large language models like ChatGPT 4, Generative Pre-trained Transformer 4, O, and Google Gemini are sophisticated AI systems designed to comprehend and generate human-like text. These models are built using deep learning techniques and are trained on vast datasets collected from the internet. They leverage self-attention mechanism to analyze relationship between words or tokens, allowing them to capture context and produce coherent, relevant responses. LLMs have significant application, including powering virtual assistant, chatbots, content creation, language translation, and supporting research and decision making. Their ability to generate fluent and contextually appropriate text has advanced natural language processing and improved human-computer interaction. So now let's see what are large language model used for. Large language models are utilized in scenarios with limited or no domain-specific data available for training. These scenarios include both few-shot and zero-shot training approaches, which rely on the model's strong inductive bias and its capability to derive meaningful representation from a small amount of data or even no data at all. So now let's see how are large language models trained. Large language models typically undergo pre-training on a board, all-encompassing dataset that shares statistical similarities with the dataset specific to the target task. The objective of pre-training is to enable the model to acquire high-level features that can later be applied during the fine-tuning phase for specific tasks. So there are some training processes of LLM which involve several steps. The first one is text pre-processing. The textual data is transformed into a numerical representation that the LLM model can effectively process. This conversion may be involve techniques like tokenization, encoding, and creating input sequences. The second one is random parameter initialization. The model's parameters are initialized randomly before the training process begins. The third one is input numerical data. The numerical representation of the text data is fed into the model of processing. The model's architecture, typically based on transformers, allows it to capture the contextual relationship between the words or tokens in the next. The fourth one is loss function calculation. A loss function calculation measures the discrepancy between the model's prediction and the actual next word or token in a sentence. The LLM model aims to minimize this loss during training. The fifth one is parameter optimization. The model's parameters are adjusted through optimization technique. This involves calculating gradient and updating the parameters accordingly, gradually improving the model's performance. The last one is iterative training. The training process is repeated over multiple iterations or epochs until the model's output achieve a satisfactory level of accuracy on that given task or dataset. By following this training process, large language models learn to capture linguistic patterns, understand context, and generate coherent responses, enabling them to excel at various language-related tasks. The next topic is how do large language models work? So large language models leverage deep neural network to generate output based on patterns learned from the training data. Typically, a large language model adopts a transformer architecture which enables the model to identify relationship between words in a sentence irrespective of their position in the sequence. In contrast to RNNs that rely on recurrence to capture token relationship, transformer neural network employs self-attention as their primary mechanism. Self-attention calculates attention scores that determine the importance of each token with respect to the other token in the text sequence, facilitating the modeling of intricate relationships within the data. Next, let's see application of large language models. Large language models have a wide range of application across various domains. So here are some notable applications. The first one is natural language processing, NLP. Large language models are used to improve natural language understanding tasks such as sentiment analysis, named entity recognition, text classification, and language modeling. The second one is chatbot and virtual assistant. Large language models power conversational agents, chatbots, and virtual assistant, providing more interactive and human-like user interaction. The third one is machine translation. Large language models have been used for automatic language translation, enabling text translation between different languages with improved accuracy. The fourth one is sentiment analysis. LLMs can analyze and classify the sentiment or emotion expressed in a piece of text, which is valuable for market research, brand monitoring, and social media analysis. The fifth one is content recommendation. These models can be employed to provide personalized content recommendations, enhancing user experience and engagement on platforms such as news website or streaming services. So these applications highlight the potential impact of large language models in various domains for improving language understanding automation.
Welcome to Math Refresher, Linear Algebra. In this lesson, we are going to explain the concepts of linear algebra, solve a linear system of equations, describe matrix, forms of matrix and matrix operations, and define vectors and list down its properties. Introduction to linear algebra. Linear algebra. Linear algebra refers to study of linear combinations. For linear transformations to be carried out, a study of vector spaces, lines, and planes, as well as some mappings is necessary. It contains linear functions, vectors, and matrices. It is an examination of characteristic of linear set transformations. Linear equations. Linear algebra's major goal is to establish systematic techniques for solving systems of linear equations. A linear equation with n variables can be represented as a1x1 plus a2x2 plus a3x3 and so on till an xn equals to b, where x1, x2, x3 and so on till xn are the unknown quantities that are to be found, while a1, a2, a3 and so on until an are the coefficients. B here is a constant term. A linear equation with two variables, x and y, is a linear connection between x and y. The value of one variable, often y, is determined by the value of the other, that is x. The independent variable in this situation is x, while the term dependent variable refers to y. Since it depends on x, let's consider some examples for linear equations. Linear equations in one variable can be written as 3x plus 5 equals 0, or 3 by 2 of x plus 7 equals to 0, or 98x equals to 49. Linear equations in two variables. Examples can include y plus 7x equals to 3, or 3a plus 2b equals to 5, 6x plus 9, y minus 12 equals to 0. Linear equations can also be written with three variables as x plus y plus z equals to 0, a minus 3b equals to c, 3x plus 12 y equals to half of z. Identifying linear and nonlinear equations. Linear equations present themselves as a straight line on a graph. However, nonlinear equations represent themselves as a non-straight line on the graph. Here, equations like y equals to 8x minus 9 or y plus 3x minus 1 equals to 0 are examples of linear equations. However, y equals to x squared minus 7 is a nonlinear equation because x is raised to the power 2. Hence, denoting a nonlinear relationship or a non-straight line relationship between x and y. Similarly, square root of y plus x equals to 6 or y raised to the power 2 minus x equals to 9 are examples of nonlinear equations, as y is raised to the power half and 2 respectively. Forms of linear equation. Linear equations can be represented in three forms: a standard form, a slope-intercept form, or a point-slope form. Linear equation in standard form. A linear equation in standard form for a single variable can be represented as a x plus b equals to 0, where a and b are real integers and x is the variable. While a linear equation in standard form for two variable can be represented as ax plus by equals 2c, where a, b, and c are real integers, while x and y are the variables. To summarize, a linear equation for variables can be written as ax plus by equals to c, where x and y are the variables. C is the constant and a and b are the coefficients of x and y respectively. Linear equation in the slope-intercept form. A linear equation slope can be calculated to see how one variable varies in response to a unit change in another variable. It is represented as y equals to mx plus b, where m is the slope, b is the intercept on the y-axis and x, and y are the line's distance from the x and the y-axis respectively. Consider this example. The lines point x, y represents the distance from the x and the y-axis respectively, while the line intercept on the y-axis is at point 0, b. Linear equation slope. The slope indicates how steep a line is with respect to y-axis. When seen from left to right, it indicates whether the line goes up or down. The slope describes how independent variable has been changed, while the dependent variable is changing. Types of slope. There are 4 types of slopes based on the relationship between the two variables x and y. The first is the positive slope here as x increases. Y is also increasing in a negative slope as x increases. Y decreases. If a line is parallel to x-axis, it is a 0 slope. On the other hand, if the line is parallel to y-axis, then the slope is undefined. Linear equation in point-slope form. A straight line is represented in point-slope form by its slope, and a point on the line. It is represented as y minus y1 equals to m of x minus x1, where x1 and y1 are the coordinates of the point. Linear equation forms, some examples. Consider solving the linear equation given as 2x minus 10 divided by 2 equals to 3x minus 1. First, we will clear the fraction. In this example, we can see only left-hand side we have 2x minus 10 divided by 2. If from the numerator we take 2 as common, we will be left with 2 times x minus 5 divided by 2, hence x minus 5 on the left-hand side. On the right-hand side, we still have 3 times x minus 1. Now, as a part of next step, we simplify both sides of the equation, that is, open up the brackets. When we do that on the right side, we end up getting 3x minus 3 by multiplying 3 to x minus 1. Solving further, we can write as x equals to 3x plus 2. Finally, we try to clear the fraction to solve for x. We can rearrange the equation as x minus 3x equals to 2. Solving it further, we get minus 2x equals to 2. And then we solve for x as minus 1. System of linear equation. A system of linear equations is a finite collection of linear equations, usually involving the same variables. It can be represented as a11x1 plus a12x2, and so on equals to b1, a21x1 plus a22x2, so on equals to b2, and so on. Here this example is for n variables. A system of m equations. A linear system can have unlimited number of solutions. One solution or no solution at all. In case of a single linear equation, a consistent linear system has a solution, while an inconsistent linear system has no solution. Solving a linear equation. Solving linear system of equations. Various methods can be used to solve linear system of equations, which include graphic method, substitution method, linear combination or elimination method, or a matrix method. Graphing method. Let's try and solve these two linear equations using the graphic method. The first equation is defined as y equals 0.5x plus 2, and the second equation is y equals to minus 2x minus 3. The two equations, as we can see, are in the slope-intercept form. The first line has a slope of 0.5 and a y-intercept of positive 2, while the second line has a slope of negative 2 and a y-intercept of negative 3. Let's have a look at these lines through a plot. Here, the blue line is the first line represented by y equals 2.5x plus 2. and the red line is represented by y equals to -2x -3. These two lines intersect at a point at -2, 1. Hence we can say that x equals to -2 and y equals to 1. Solving systems of linear equation using substitution. For substitution, we start by putting one of the equations in the form of variable equals to. We then substitute that variable in the other equation in its place. Take the other equation to solve. If there are more than 2 variables involved, we repeat the process from steps 1 through 3. Let's consider an example. Let's consider the equation 3x plus 2 y equals to 19 and x plus y equals to 8. We could begin with any equation and variable. In this case, let's look at the second equation with variable y. We start with subtracting x from both sides of x plus y equals to 8. And we end up getting y equals to 8 minus x. The first equation still retains its form. Now we take the value of y, that is 8 minus x, and substitute in the first equation in place of y. We end up getting the equation 3x plus 2 times 8 minus x equals to 19. We further simplify and solve this equation using algebra method to get 3x plus 16 minus 2x equals 290. We solve this equation further, and we end up getting x plus 16 equals to 19, and finally x equals to 3. Now we take the value of x and substitute in the new reformed second equation as y equals to 8 minus x. That gives us y equals to 8 minus 3, hence y equals to 5. The final answer remains x equals to 3 and y equals to 5. Solving systems of linear equation using elimination. In this case, we start by multiplying an equation by a constant anything other than 0. We then add or subtract an equation onto the other equation. Let's consider the same example of 3x plus 2, y equals to 19 and x plus y equals 8. We first start by multiplying the second equation by 2, and we get 2x plus 2, y equals 216. Now we subtract the second equation from the first equation. That is 3x minus 2x, 2y minus 2y, and 19 minus 60. On solving this, we end up getting x equals to 3. Now using these steps of substitution, we put the value of x in the original second equation, that is x plus y equals to 8, and achieve a value of y equals to 5. Hence the answer remains x equals to 3 and y equals to 5. We can verify the solution by using the graph. Here again, the blue line represents the point at which 3x plus 2, y equals to 19 is true, while the red line represents the point where x plus y equals to 8 is true. The solution is found at the point where x equals to 3 and y equals to 5. This is the point where both lines intersect. Introduction to matrices. Matrix. A matrix is rectangular array or table with rows and columns of numbers, symbols, expressions used to represent a mathematical object or an attribute. For example, here A is a matrix of 2 rows and 3 columns, as 2, 1, 3, minus 1, 2, and 4. Well, B is a squared matrix with 2 rows and 2 columns given as 2, 1, 3, 4. Matrix size. The matrix size is expressed as m cross n, where m is the number of rows, and n is the number of columns. A matrix with 2 rows and 3 columns can be referred to as 2 by 3 matrix or a 2 cross 3 matrix, or a matrix of dimension 2 cross 3. Notation of a matrix. A matrix with m rows and n columns can be presented as this. Here each element will be identified by its row number and column number. For example, the element over here is in the 3rd row and the 1st column. Hence, it is identified as a 3-1. Forms of matrix. The matrix is termed as a squared matrix. If n equals to m, that is, the number of rows and number of columns are equal. An element's entry in the matrix of from A, I is located on the diagonal. Hay is called a diagonal matrix if Hay ij equals to 0, when I is not equals to j, that is in a square matrix. Apart from diagonal at all places, we have 0 as a value. Matrix operations. Addition. Addition of 2 matrices is adding their corresponding elements, as in A11 plus B11, A12 plus B12, A21 plus B21, A22 plus B22, and so on. Consider the example over here. We have a matrix A as 22, 32, 11, 16, and matrix B as 13, 8, 13, and 16. Matrix A is of the order 2 cross 2, and matrix B is also of the same order, 2 cross 2. Hence, the corresponding elements can be quickly added as 22 plus 13, 32 plus 8, 11 plus 13, and 16 plus 16, giving us the result in matrix of 35, 40, 24, and 32. Addition rules. Only matrices with the same size can be added. That is, the 2 matrices should have same number of rows and same number of columns. Matrix addition follows commutative property. That means A plus B is equals to B plus A. Subtraction. Matrix subtraction is same as matrix addition. It is subtracting the corresponding values. Let's consider the same example of matrix A and B. The result of A minus B can be given as 22 minus 13. That is A11 minus B11. 32 minus 8. That is A12 minus B12. 11 minus 13. A21 minus B21. And 16 minus 16. That is A22 minus B22. Giving us result as 9, 24, -2, and 0. Subtraction rules. Only matrices with the same number of rows and columns can be subtracted. Matrix subtraction does not follow commutative property. That means A minus B is not equals to B minus A. Multiplication. Matrix multiplication results in what is called as a product matrix. In matrix multiplication, each row of the first matrix is multiplied to each column of the second matrix. To compute each of these elements in the matrix, the values are then added. For example, consider the matrix A and B. To get the first element, we will multiply the first row of matrix A to the first column of matrix B, and then add the individual elements, that is 22, multiplied to 13, and 32, multiplied to 13, and then add them up to get this particular element. For the second element, we multiply the first row of A to the second column of B, hence getting 22 multiplied to 8 plus 32 multiplied to 16. Similarly, we compute all the remaining elements, that is the second row multiplied to the first column, and added 11 multiplied to 13 plus 16 multiplied to 13. And the second row now multiplied to the second column, that is 11 multiplied to 8 plus 16 multiplied to 16. This gives us the resulting matrix as 702, 688, 351, and 344 multiplication rules. Let us say C equals to AB. Here, C is our product matrix, which can be computed as summation over A at ij dot bjk. For a matrix of size ij, matrix B of size jk, to calculate the value of each member in the I cross K matrix of C. The matrix product AB is defined only when the number of columns in A equals to the number of rows in B. The matrix product of BA is defined only when the number of columns in B is equals to the number of rows in A. Dot B is not always equals to B dot A. Transpose. A transpose is a matrix form by turning all the rows of a given matrix into the columns and vice versa. The transpose of a matrix A is denoted as AT. For example, if the matrix A is 22, 32, 11, and 16, the transpose of A would be 22, 11, 32, and 16. Here we can see the row has been converted to column. Inverse. If it is a non-singular square matrix, there exists n cross n matrix, a minus one known as A's inverse, that satisfies A dot A inverse equals to A inverse dot A equals to I, where I is the identity matrix. And identity matrix is characterized as a diagonals 1 and all other elements are 0. Also, AB equals to B dot A equals to IN, where IN denotes the n cross n identity matrix. Special matrix types. Symmetric matrix. A matrix A is set to be symmetric. If A is equals to transpose of A, diagonal matrix, A matrix D is diagonal only if Dij equals to 0. For all I not equals to J. Identity matrix. Identity matrix is denoted as IN, where AIN equals to IN dot A equals to A. Tensors. Tensors are arrays with more than 2 axes. A tensor can have n dimensions. Aijk is the value in the tensor A at coordinates ij and k. The principal component analysis PCA, which is a statistical technique used to reduce the number of dimensions in a given data set while we preserve its variability. So there are different use cases of PCA in real-time scenarios. One of the major use cases is in the healthcare domain, so technically known as the spike-triggered covariance analysis. It uses the principle of PCA in neuroscience to identify the specific properties of a stimulus that increase a neuron's probability of generating an action potential. So it is using reduction techniques, which is going to be really helpful in detecting the coordinated activities of large neuronal ensembles. So it is basically used for identifying a neuron from the shape of its action potential. Then in terms of quantitative finance. So PCA help us in reducing the dimensionality of a complex problem. Let's say a fund manager has 200 stocks in his portfolio. Now to analyze these stocks quantitatively, a stock manager will require a correlational metric of a size 200 by 200, which makes the problem very complex. However, if he has to extract 10 principal components, which best represents the variance in the stock price, this will reduce the complexity of the problem while still explaining the movement of all 200 stocks. So we use it for analyzing the shape of the yield curve in terms of forecasting the portfolio returns, developing the asset allocation algorithms, and so on. And it is also widely used in image compression. So PCA is also used for image compression. So if we go ahead and use any of the PyCharm IDE, so here we can work with Matplotlib, ImagePyPlot, and the NumPy as NP. And here we can also import from sklearn. And we can import the PCA. So basically we are trying to print the shape of the image by reading the image. This is a sample logo.png, which has been placed in the same directory. We are trying to print the image. So if we run this particular code, then we will be able to see the shape of the image. Return to us first the current shape based on the image which has been deducted, which is 156, 94, and 3. So what does this mean? This means image is in the form of 156 rows, and each row containing 194 pixels, and then having 3 channels, which is red, green, and blue. So we had to resize the image so that it is in a format required for PCA input, which is 196 by 3, which is going to be 582. So here we can see we have performed a simple operation as image_r, where we are using the NumPy library for reshaping the image. And then we are printing the shape of the image again. So here we can see 156 and 582 has been returned as a response. Now running the PCA with 32 principal components, we can use this fit for the image that has been reshaped, and then we are trying to train the transform image. So with these 32 components, we are able to express 98.7% of the variance. So inverse transforming the PC output and reshaping the visualization can also be done forward. And that's how PCA is widely used as a part of the medical and the other sciences. For example, is used for object detection model for the healthcare domain for the transportation, aviation, and location-based services. Introduction to vectors. Objects with both magnitude and direction are called as vectors. The magnitude of the vector determines its size. It is represented as a line with an arrow, where the length of the line indicates the vector's magnitude, and the arrow points in the desired direction. Other names for it include Euclidean vector, geometric vector, spatial vector, or simply vector. Its length is indicated by the symbol $v", and it begins at the original 0, 0. Notation of a vector. A vector can be represented in a standard form as A equals to AI cap plus BJ cap plus CK cap, where A, B, and C are numeric values. The unit vectors along the x, y, z axis are I, j, and k cap respectively.
Now, let us start with understanding first the first wave of artificial intelligence, which was predictive analytics, or we could say data analytics and forecasting. What exactly happened? Predictive AI focused more on analyzing the historical data, identifying the patterns, and making forecasts about the future events. And these models do not generate any new content, but instead it was predicting outcomes based on the statistical models and machine learning. Now, technically how it used to work? So basically what we had, we used to take, suppose this is the ML model, okay? So this is taking a structured data, which could be suppose any past user activity, or it could be a transaction record, or any sensor reading. For example, you can consider, say, Netflix users' watch history, okay? It could be any movie genre, watch time, and the user rating. So now, after this, what we were basically doing is, we were doing the feature engineering or pre-processing, okay? Now, in the feature engineering process, we were extracting key features like user watch time trends, preferred genres, and watch frequency. And we could also apply scaling, normalization, and encoding techniques to basically make data more usable for the ML model. Then we were using the ML models. Suppose it could be a time series forecasting models like ARIMA, LSTM, and all those given algorithms, which was basically predicting the future movie preferences based on the historical data. And in the output, guys, Netflix AI recommends new shows or movie based on the similar user patterns. So this is how exactly the Netflix model was working, incorporating the machine learning model. So this was exactly the first wave of AI. Now, let us discuss about the second wave of AI. Now, if I discuss about the second wave, which was basically content creation and use of conversational AI. So, LLM models like ChatGPT became very much popular during the second wave of artificial intelligence. So what exactly was happening? Like generative AI was taking input data and it was producing new content such as text, images, videos, or even code. And these models learn from patterns in large data sets and it was generating human-like outputs. Now, let us understand how exactly this technology was working. So basically, first there was a data input. Okay, so basically any prompt from the user. So suppose in the GPT, okay, so I'll just open GPT all over here and say we are, suppose we are giving any new prompt, say such as write an article on AI. Okay, so this was our given prompt. And after this, what exactly was happening was tokenization and pre-processing. So the input text, suppose which I have written all over here, write an article on AI. So this text was basically split into smaller parts. For example, like you could consider certain thing like this. So here you have write as one, and as next. And similarly, you could carry on, for the other words. Then what exactly used to happen that these words were, converted into word embeddings, means the numerical vectors representing words like in a higher dimensional space. And then we used to perform neural network processing. So here the LLM processes input such as attention mechanisms, okay, or using these models like GPT-4, BERT, and Llama. And with the help of self-attention layers, they were understanding the context and they were predicting the next word. Okay. Now, as a result, you are getting output certain thing like this. So, which was basically a generative AI phase. So this was, guys, our second evolution of AI. Now, if I talk about our third wave, so it is basically agentic AI or autonomous AI agent. Now, what is this, guys? So the agentic AI actually goes beyond text generation. So it integrates decision making, action execution, and autonomous learning. These AI systems don't just respond to prompts, but they also independently plan, execute, and optimize the processes. So you could understand something like this. So here the first step was the user input or receiving any goal. So user provides any high level instruction. For example, it could be like, say, optimize warehouse shipments for maximum efficiency. It could something be like that. And unlike generative AI, which would generate text, agentic AI executes real world actions. After this, suppose the prompt that we have given, like optimize warehouse shipments for maximum efficiency, then the next step would have been querying the databases. The AI would pull the real-time data from multiple sources. So it could be traditional database like SQL or NoSQL, where we are fetching inventory levels or shipment history. Then it could be a vector database from where it is receiving some unstructured data like past customer complaints and all those things. Then with the help of external APIs, it is connecting to like forecasting services or fuel price APIs or supplier ERP systems. And these things are like present with this respect. Then the third step was the LLM decision making. Now, after querying the database, the AI agent processes data through the LLM based reasoning engine. Example like decision rules applied, like suppose if inventory is low, then it could automate supplier restocking orders. Like if shipment cost is increasing, then it is rerouting shipments through cheaper vendors. And suppose also if weather condition impacts the route, then it is adjusting the delivery schedules. Now you can understand how agentic AI is behaving all over here in the decision-making process. Now, next step would be action execution via APIs. So AI is executing tasks without human intervention. It is triggering an API call to reorder a stock from a supplier or update the warehouse robot workflows to prioritize fast moving products or even send emails and notifications to logistic partners and about the changes, what is going to be happen. And after this, finally, it is continuously learning, which is a data flywheel all over here. Okay, the AI is monitoring the effectiveness of its action, like it was restocking efficient or did routing shipments, reduce the cost and all. So it is monitoring the effectiveness of the action it has taken, and the data flywheel is continuously improving the future decisions. So basically, it is using reinforcement learning and fine tuning to optimize its logic. Okay. Now let's have a just quick recap about the comparison of all these three waves of AI. So basically, predictive AI's main focus was on forecasting the trends, okay, while generative AI was creating the content, and agentic AI on the other hand, which is at the final step right now, is making decision and taking action. So you could see how the evolution happened of AI in all these stages. And if you understand about the learning approach, then predictive AI was basically analyzing the historical data, while generative AI was learning from the patterns, like using text, image generation, okay? But agentic AI is basically using the reinforcement learning or the self-learning to improve its learning approach. Now, if we just look at the user involvement in predictive AI, so human is asking for the forecast and all. Here, human is giving the prompts, but in the agentic AI, the prompts or the intervention of human input has become very much minimal. If you could understand the technology, like basically predictive AI was using machine learning, time series analytics, so these kind of algorithms they were using. Generative AI was using transformers like GPT, Llama, BERT, and all those things. Now, agentic AI is doing what, guys? It is using LLM plus APIs plus autonomous execution. So we have discussed how this workflow is, in a short way, how it is working. And moving ahead, we are also going to discuss through an example how exactly all these steps like agentic AI is working. So based on the example, you could understand like predictive AI, Netflix recommendation model which they have on their system. And similarly, if we talk about generative AI, then you could understand about ChatGPT, writing articles and all those things. And agentic AI, we could imagine like how AI, if incorporated in supply chains, how things are working out. So guys, I hope so you would have got a brief idea regarding the three waves of AI. Now let us move ahead and bit understand about what is the exact difference between generative AI and agentic AI. Now guys, let us understand the difference between generative AI and agentic AI. So let us first deep dive into what exactly is a generative AI. Okay. So as you can see all over here that generative AI models generally are taking input query, okay, and they are processing it using LLM or large language model and basically returning a static response without taking any further action. So in this case, for example, a chatbot like ChatGPT, it is taking the input from the user. So as I've shown you earlier that suppose I've given an input like write a blog post on AI in healthcare. So when I have written this given user input or given the query, so when it goes to the large language model, these model is actually tokenizing all these input query, and it is retrieving the relevant knowledge from its training data, and it generates text based on the patterns. Now we give the prompt, then LLM processes it, okay, and then we are getting the given output. So now this is basically how generative AI is working. So you could see all over here we have GPT model, we have DALI, we have Codex. So these are some of the amazing generative AI models. Okay. Now let us discuss a bit about DALI, which is actually a realistic image generation Gen AI. So like DALI is described as the realistic image generation model by the OpenAI, and this actually is a part of generative AI category alongside with GPT, which is basically for human-like language creation purposes. This model was created, and you could have also Codex for like it could be used for advanced code generation purposes. So let us discuss a bit about DALI. So DALI is like a deep learning model basically, which is designed to generate realistic images from the text prompt. and it can create highly detailed and creative visuals based on descriptions provided by the users. So some of the aspects of DALI, like you could have all over here, like text to image generation, where users can input text prompts and DALI can generate unique images based on those description. The images generated by DALI are highly realistic and creative. Okay, and it can generate photorealistic images, artistic illustration, and even surreal or imaginative visuals. You will also have customization and variability, where it is allowing variation of an image edits based on text instruction and multiple styles. So this is also part of a generative AI model, and this tool is actually playing a very amazing role. So I will show you one example, like how generative AI is actually working in image generation purposes. So guys, as you can see all over here, I have opened this generative AI tool called DALI. Let us give a prompt to DALI and let's see how the image is generated. So let's say we want a futuristic city at sunset filled with neon skyscraper. Say have flying cars and holographic billboards. The streets are bustling with humanoid robots, and we can have people wearing let's just say high-tech, let's include some technology. Okay, now let us see how DALI is trying to create an image. So this is how actually generative AI is working. So let us wait for a few seconds as the output comes up. Now you can see all over here that this image which is generated, basically this is generated by AI, and you could see based on our prompt, it has given like the kind of the input we gave, and we got the output based on this. Now, so this is one of the amazing GenAI tool. We could explore this, guys. Okay. Now, guys, let us discuss about agentic AI, or autonomous decision making and action execution. So you can see this diagram all over here. So agentic AI, like unlike the generative AI, it is not generating responses, but it is also executing a task autonomously based on the given query. For example, like if we take AI in managing a warehouse inventory. Okay. Suppose we want to optimize the warehouse shipment for the next quarter. So here what is going to happen? So first the agent is going to receive its goal all over here. Okay. And this AI agent is going to query the external data sources. So it could for example, it could be your inventory databases or logistics API, and then it retrieves real-time inventory levels and it demands the given forecast. Okay, now at here it is going to make the autonomous discussions, and the kind of output we are going to get will be kept in observation by this agent. Okay, so basically it is going to analyze the current warehouse stock, predict demand for the next quarter, check the supplier's availability, and automate the restocking if inventory is below the given threshold. So for example, you could imagine suppose based on the output what we are going to get all over here. So based on this output we could get certain thing like this, like say current inventory level, like say 75% capacity. Okay, then it could have also other thing like say demand forecasts, say 30% increase in expected in quarter 2, and also it is going to go say reordering initiated. So this is the output what we are going to get based on the supply chain management example what we are trying to get. So as we have seen in generative AI, user is giving the input, okay, prompt, then it is using a LLM model to generate the given output. But agentic AI is doing what, guys? it is going to take an action, beyond just generating a text. So in this scenario, it is querying the inventory databases, it is automating the purchase order, it is going to select the optimal shipping providers, which could be, suitable for the given company. It is going to continuously refine the strategies based on the real-time feedback. So guys, let's recap once more. So if we talk about the function base, then GenAI is more concerned with producing a written content or a visual content, okay? And even it can code from the pre-existing input. But if we talk about agentic AI, guys, it is actually, it's all about decision making, taking actions towards a specific goal, and it is focused on achieving the objectives by interacting with the environment and making the autonomous decision. GenAI is exactly relying on the existing data to predict and generate content based on, say, patterns it has learned during its training phase, but it does not adapt or evolve from its experiences. Whereas if I talk about agentic AI, it is adaptive. So it is learning from its actions and experiences. It is improving over time by analyzing the feedback, adjusting its behavior to meet objectives more effectively. With the help of GenAI, human input is essential to the prompt, so that, basically with the help of that, it could go into the LLM model and it could generate the given, output based on your prompt. Once you set up the agentic AI, it requires like minimum human involvement. It operates autonomously, making decisions and adapting to changes like without continuous human guidance. And it can even learn in real time. So that's what the beauty of agentic AI is. So we have given one example of Gen AI, like basically giving prompt to the ChatGPT or DALI. Okay. And agentic AI, one example could be your supply chain management system. Now, let us bit deep dive into understanding the technical aspects of how agentic AI is exactly working. Now, guys, let us try to understand how agentic AI is exactly working. So there is actually a four-step process of how agentic AI exactly works. So the first step is perceiving, where basically what we are doing is we are gathering and processing information from databases, sensors, and digital environments. And also the next step is reasoning. So with the help of large language model as a decision-making engine, it is generating the solutions. If we talk about the third step, which is acting, so it is integrating with external tools and softwares to autonomously execute the given task. And finally, it is learning continuously to improve through the feedback loop, which is also known as the data flywheel. Okay. Now, let us explore each of the steps one by one and let us try to understand. So if we talk about perceiving, okay, so this is actually the first step where agentic AI is actually stepping up. So it is doing the perception, where what exactly is happening, guys, that AI is collecting data from multiple sources. So this data could be from database, okay, like your traditional and vector databases, okay. So it could be GraphQL, like vector database means the same. And if we talk about other from data, it could be from APIs, like it is fetching real-time information from external systems. It is basically taking data from the IoT sensors, like for real-world applications like robotics and logistics. And also it could take data from the user inputs also, like it could be text command, voice commands, or a chatbot interaction. Now, how it is exactly working, guys? So basically, let us recollect everything technically and let us see how this is happening. So the first step, which is going in perceiving, is the data extraction, where exactly the AI agent queries the structured databases like SQL or NoSQL for relevant records. It is also using vector databases to retrieve any semantic data for context-aware responses, like it could be any complaints written, it is trying to find out. Okay, so next, after it has got the data extraction, it goes for feature extraction and pre-processing, where AI is filtering the relevant features from the raw data. For example, like a fraud detection AI is scanning the transaction log for anomalies. The third thing, it is entity recognition and object detection. So AI uses basically computer vision to detect objects and images, and then it is applying the named entity recognition. This is a technique, okay, to extract the critical terms from the given text also. So we have three step-by-step process which is happening in perceiving. The first one is data extraction. Second one is feature extraction and pre-processing. The third one is like entity recognition and object detection. So let us take a very simple example like AI-based customer support system. So if we consider an agentic AI assistance like for a customer service, so say a customer is asking, where is my order? So the AI queries multiple databases all over here. Suppose it is going to query the e-commerce order database to retrieve the order status, or it could go to the logistics API to track the real-time shipment location. Also, it could go for customer interaction history to provide personalized response. The result, what we get all over here, is that the AI is fetching the tracking details, identifying any delays if it is happening, and suggesting the best course of action. Now, the next step is reasoning. Okay. Now, AI's understanding and decision making and problem solving is making agentic AI way greater. So here, what is exactly happening? Like once the AI has perceived the data, now it should start reasoning it. Okay, so the LLM model acts as a reasoning engine, orchestrating AI processes and integrating with specialized models for various functions. So if we talk about the key components like here used in the reasoning, it could be LLM based decision making. So AI agents could use models like LLMs like GPT-4, Cloud, Llama to interpret a user intent and generate a response. It is basically coordinating with smaller AI models for domain-specific tasks, like it could be like financial prediction or medical diagnostics. So these could be, the given example. Then it is using retrieval augmented generation or RAG model, okay, to with the help of which AI is enhancing the accuracy, by retrieving any proprietary data from the company's databases. For example, like instead of relying on GPT-4's knowledge, the AI can fetch company-specific policies to generate the accurate answers. So this could be the one. And in the reasoning, the final step is AI workflow and planning. So it is a multi-step reasoning where AI is breaking down complex tasks into logical steps. For example, like if asked to automate a financial report, AI is retrieving the transaction data, analyzing the trend, and it is formatting the results. Also, for example, you could use this in supply chain management. So suppose, consider there is a logistics company which is using the agentic AI to optimize what could be the shipping routes. So a supply chain manager requesting the AI agent to find the best shipping route to reduce the delivery cost. So the AI processes real-time fuel prices, traffic conditions, and weather report. So using LLM plus data retrieval, it finds out the optimized routes and selects the cheapest carrier. Result you get is that AI chooses the best delivery option. So here the cost is reduced and improving efficiency. So this is one of the use cases, guys. So after perceiving, you get is reasoning. Okay. Now let us move ahead and discuss about the third step, which is act. So in this step, basically what is happening, like AI is taking autonomous actions. So unlike generative AI, which stops at generating content, so agentic AI takes the real world action. Okay. How AI is executing tasks autonomously, guys? So basically first step is like here the integration with APIs and software could be happen, where AI can send automated API calls to the business systems. For example, like reordering the stock from the supplier's API. So suppose any inventory level is going down, so it could reorder that particular stock from the supplier's API. So it is interacting with the given API. Now it could also automate the workflows, like AI executes multi-step workflows without human supervision. So here like AI can handle like insurance claims by verifying the documents, checking policies, and approving the payouts. And finally, AI could operate within predefined business rules, okay, to prevent any unauthorized actions also. So ethical AI is basically being worked in this direction. For example, like AI can automatically process claims up to say 10,000 US dollars, but it is requiring the human approval for the higher amounts. So based on insurance and policy making stuff, so agentic AI could be really helpful in this scenario. One example, like let's consider. So let's say we have this agentic AI managing an IT support system. So suppose a user says my email server is down. So the AI can diagnose the issue, restart the server, and confirms the given resolution. Now, if it is unresolved, then AI escalates to a human technician. Then it results into AI is fixing the issues autonomously, reducing the downtime. Okay, so this is where your action or act is coming up into the picture. Now, if we go on to the next and the final step, which is learning. So, learning basically with the help of data flywheel, it is continuously learning. Okay, so this is the feedback loop all over here, which is the data flywheel. So, how AI learns over the time? If we ask this question, so what is exactly happening that it is interacting with the data collection? Suppose AI logs successful and failed actions. For example, like if users correct AI generated responses, the AI is learning from those corrections. Second thing, what you could do is you could you could fine tune the model and do reinforcement learning. So AI adjusts its decision making models, basically to improve future accuracy. It uses reinforcement learning basically to optimize workflows based on past performance. Okay. Now, third step could be automated data labeling and self-correction. So here, what is happening that AI is labeling and categorizing past interactions to refine its knowledge base. Example like AI autonomously is updating frequently asked answers based on the recurring user queries. So in this way, AI is learning over the time. Example one you could consider. So say we have this AI is optimizing any financial fraud detection. So say this is consider that this is a bank which is AI powered, which has this AI powered fraud detection system. So AI is analyzing these financial transaction and it is detecting any suspicious activity. And if flagged, the transactions are false, and AI is learning to reduce these false alerts. So over the time, AI is improving the fraud detection accuracy, like minimizing disruptions for the customer. So in this way, AI is getting smarter over the time, like reducing the false alerts and also the financial fraud. So let's have a just quick recap of what we studied right now. So agentic AI works in 4 steps. The first step is perceiving, where AI is gathering data from databases, sensors, and APIs. The next step is reasoning. So it is using LLM to interpret task, applies logic, and generating the solution. The third step is acting. So here AI is integrating with external systems and automating the task. And finally, it is learning. So AI is improving over the time, via feedback loop, or which is basically called as data flywheel. So guys, now let us see this diagram and try to understand what this diagram is trying to say. So the first thing, you could see an AI agent all over here. So this is an AI agent, which is basically an autonomous system. So which has the capability of perceiving its environment, making decisions, and executing actions without any human intervention. Now, AI agent is acting as the central intelligence, okay, in this given diagram, and it interacts with the user, okay, and various other data sources. It processes input, queries databases, makes decision using a large language model, and it is executing action and it is learning from the given feedback. Now, the next step, you could see the LLM model. So if we talk about LLMs, these are the large language model, which is kind of an advanced AI model trained on massive amount of text data to understand, generate, and reason over natural language. Now, if I talk about this LLM, so this is actually acting as the reasoning engine all over here. And it is interpreting the user inputs and making informed decision. It is also retrieving relevant data from the databases, generating responses. It can also coordinate with multiple AI models for different tasks, like it could be content generation, okay, predictions, or decision making. Now, when the user is asking a chatbot, like for example, let's say, what is my account balance? So the LLM processes the query, retrieves the relevant data, and responds the given bank balance accordingly. Now, if you look at the kind of database the LLM is interacting, so we have the traditional database and the vector database. So here, if I say the database, like AI agent basically is querying the structured database. So suppose structured database, like it could be a customer records or inventory data, or it could be any transactional log also. So traditional databases basically store well-defined, structured information. Okay. So for example, like when a bank AI assistant is processing a query like show my last 5 transactions, so it is basically fetching the information from a traditional SQL-based database. Next, we have this vector database also, guys. So vector database is a specialized kind of a database for storing unstructured data, which could be like text embeddings, images, or audio representations. So guys, like unlike traditional databases that store exact values, vector databases store in a high dimensional mathematical space. It allows AI models to search semantically similar data instead of like exact matches. Now, AI is retrieving the contextual information from the vector databases, which is actually enhancing the decision making. It is improving the AI memory by allowing the system also to search for conceptually similar past interaction. Let's take an example to understand this. For example, we have discussed about a customer support chatbot. So suppose if it queries a vector database to find out similar past tickets, like when responding to a customer query. So a recommendation engine could use a vector database to find out similar products on a user's past preferences. So this could be done in that scenario. Also, some of the popular vector databases could be like Facebook's AI similarity search, Pinecone, or VV8. These are the certain amazing vector databases. Then you could see the next step is, after it has worked on these given data, it is performing the action. So the action component is referring where AI's agent has this ability to now execute tasks autonomously after the reasoning is done. So AI is integrating with external tools, APIs, or automation software to complete the given task. It does not provide only information, but it is actually, performing the given action. So for example, like in a customer support, the AI can automatically reset a user's password after verifying their identity. If we talk about in finance, then AI can approve a loan also, like based on the predefined eligibility criteria. Now, finally, we have the data flywheel. So data flywheel is a continuous feedback loop where AI is learning from the past interactions, refining its models, and it is always improving over the time. Now, every time like the AI is interacting with the data or taking an action or receiving a feedback, that information is fed into this model. So this is creating a self-improving AI system that is becoming smarter over the time. So the data flywheel is allowing AI to learn from every interaction, and AI is becoming more efficient by continuously optimizing responses and refining strategies. Best thing could be used in fraud detection. So in this, the AI is going to learn from the past fraud cases and it is going to detect new fraudulent patterns and more effectively. Chatbots also can learn from user feedback and improve the responses. And finally, you have the model customization, which is basically you are trying to fine tune the AI models on specific business need or any industry requirement. So AI models are not static, like they can be adapted and optimized for a specific task. So custom fine tuning is actually improving the accuracy and domain specific application, like it could be finance, healthcare, or cybersecurity. So a financial institution, say, fine-tuning an LLM to generate an investment advice, okay, on the historical market trends. That could be one use case. Or in healthcare, if we discuss like the healthcare provider is fine-tuning then AI model to interpret the medical reports and recommend the treatments. So guys, based on the given diagram, you would have got a brief idea like how, agentic AI is working. Now, if we discuss about the future of agentic AI, then guys, I would say it looks very much promising because it is keep improving itself and it is finding new ways to be useful. Like with better machine learning algorithms and smarter decision making, these AI systems will be more independent, handling complex tasks on their own. And believe me, in industries like healthcare, finance, customer service, they have already started to see how AI agents can make more impact and it could be more efficient from a personalization perspective, managing resources and many more other things. So as this system continue to learn and adapt, I think so they will be opening up even more possibilities, helping businesses grow, improving how we live and work. Now, I would say that in conclusion that agentic AI is actually paving the way for new opportunities like unlike the older versions of AI, which was assisting with generating content or predicting the data, or responding to any queries. But agentic AI can perform techniques independently with minimal human effort. And agentic AI has become self-reliant in decision-making way, and it is making very big differences in industry like healthcare, logistics, customer services, which is enabling companies to be more efficient. As a result, it is providing better services to their clients.
We've looked at a lot of examples of machine learning, so let's see if we can give a little bit more of a concrete definition. What is machine learning? Machine learning is the science of making computers learn and act like humans by feeding data and information without being explicitly programmed. And we see here we have a nice little diagram where we have our ordinary system. Your computer, nowadays you can even run a lot of this stuff on a cell phone because cell phones have advanced so much. And then with artificial intelligence and machine learning, it now takes the data and it learns from what happened before. And then it predicts what's going to come next. And then really the biggest part right now in machine learning that's going on is it improves on that. How do we find a new solution? So we go from descriptive, where it's learning about stuff and understanding how it fits together, to predicting what it's going to do, to post-scripting, coming up with a new solution. And when we're working on machine learning, there's a number of different diagrams that people have posted for what steps to go through. A lot of it might be very domain specific. So if you're working on photo identification versus language versus medical or physics, some of these are switched around a little bit or new things are put in. They're very specific to the domain. This is kind of a very general diagram. First, you want to define your objective. Very important to know what it is you're wanting to predict. Then you're going to be collecting the data. So once you've defined an objective, you need to collect the data that matches. You spend a lot of time in data science collecting data, and the next step, preparing the data. You got to make sure that your data is clean going in. There's the old saying, bad data in, bad answer out, or bad data out. And then once you've gone through and we've cleaned all this stuff coming in, then you're going to select the algorithm. Which algorithm are you going to use? You're going to train that algorithm. In this case, I think we're going to be working with SVM, the support vector machine. Then you have to test the model. Does this model work? Is this a valid model for what we're doing? And then once you've tested it, you want to run your prediction. You want to run your prediction or your choice or whatever output it's going to come up with. And then once everything is set and you've done lots of testing, then you want to go ahead and deploy the model. And remember I said domain specific. This is very general as far as the scope of doing something. A lot of models, you get halfway through and you realize that your data is missing something and you have to go collect new data because you've run a test in here someplace along the line. You're saying, hey, I'm not really getting the answers I need. So there's a lot of things that are domain specific that become part of this model. This is a very general model, but it's a very good model to start with. And we do have some basic divisions of what machine learning does that's important to know. For instance, do you want to predict a category? Well, if you're categorizing things, that's classification. For instance, whether the stock price will increase or decrease. So in other words, I'm looking for a yes-no answer. Is it going up or is it going down? And in that case, we'd actually say, is it going up? True. If it's not going up, it's false, meaning it's going down. This way, it's a yes-no, 0, 1. Do you want to predict a quantity? That's regression. So remember, we just did classification. Now we're looking at regression. These are the two major divisions in what data is doing. For instance, predicting the age of a person based on the height, weight, health, and other factors. So based on these different factors, you might guess how old a person is. And then there are a lot of domain-specific things, like do you want to detect an anomaly? That's anomaly detection. And this is actually very popular right now. For instance, you want to detect money withdrawal anomalies. You want to know when someone's making a withdrawal that might not be their own account. We've actually brought this up because this is really big right now. If you're predicting the stock, whether to buy stock or not, you want to be able to know if what's going on in the stock market is an anomaly. Use a different prediction model because something else is going on. You got to pull out new information in there. Or is this just the norm? I'm going to get my normal return on my money invested. So being able to detect anomalies is very big in data science these days. Another question that comes up, which is on what we call untrained data, is do you want to discover structure in unexplored data? And that's called clustering. For instance, finding groups of customers with similar behavior given a large database of customer data containing their demographics and past buying records. And in this case, we might notice that anybody who's wearing a certain set of shoes goes shopping at certain stores, or whatever it is, they're going to make certain purchases. By having that information, it helps us to market or group people together so that we can now explore that group and find out what it is that we want to market to them if you're in the marketing world. And that might also work in just about any arena. You might want to group people together, whether they're based on their different areas and investments and financial background, whether you're going to give them a loan or not. Before you even start looking at whether they're a valid customer for the bank, you might want to look at all these different areas and group them together based on unknown data. So you don't know what the data is going to tell you, but you want to cluster people together that come together. Let's take a quick detour for quiz time. Oh, my favorite. So we're going to have a couple questions here under our quiz time, and we'll be posting the answers in the part 2 of this tutorial. So let's go ahead and take a look at these quiz times questions, and hopefully you'll get them all right, and it'll get you thinking about how to process data and what's going on. Can you tell what's happening in the following cases? Of course, you're sitting there with your cup of coffee and you have your checkbox and your pen trying to figure out what's your next step in your data science analysis. So the first one is grouping documents into different categories based on the topic and content of each document. Very big these days. You have legal documents, you have maybe it's a sports group documents, maybe you're analyzing newspaper postings, but certainly having that automated is a huge thing in today's world. B, identifying handwritten digits in images correctly. So we want to know whether they're writing an A or capital A, B, C. What are they writing out in their handwriting? C, behavior of a website indicating that the site is not working as designed. D, predicting salary of an individual based on his or her years of experience. Boy, HR hiring set up there. So stay tuned for part 2. We'll go ahead and answer these questions when we get to the part 2 of this tutorial. Or you can just simply write at the bottom and send a note to Simplilearn, and they'll follow up with you on it. Back to our regular content. And these last few bring us into the next topic, which is another way of dividing our types of machine learning, and that is with supervised, unsupervised, and reinforcement learning. Supervised learning is a method used to enable machines to classify, predict objects, problems, or situations based on labeled data fed to the machine. And in here you see we have a jumble of data with circles, triangles, and squares, and we label them. We have what's a circle, what's a triangle, what's a square, and we have our model training, and it trains it so we know the answer. Very important, when you're doing supervised learning, you already know the answer to a lot of your information coming in. So you have a huge group of data coming in, and then you have new data coming in. So we've trained our model. The model now knows the difference between a circle, a square, a triangle. And now that we've trained it, we can send in this case, a square and a circle goes in, and it predicts that the top one's a square and the next one's a circle. And you can see that this is being able to predict whether someone's going to default on a loan, because I was talking about banks earlier. Supervised learning on stock market, whether you're going to make money or not. That's always important. And if you are looking to make a fortune in the stock market, keep in mind it is very difficult to get all the data correct on the stock market. It is it fluctuates in ways really hard to predict. So it's quite a roller coaster ride. If you're running machine learning on the stock market, you start realizing you really have to dig for new data. So we have supervised learning. And if you have supervised, we should need unsupervised learning. In unsupervised learning, machine learning model finds the hidden pattern in an unlabeled data. So in this case, instead of telling it what the circle is and what a triangle is and what a square is, it goes in there and looks at them and says, for whatever reason, it groups them together. Maybe it'll group it by the number of corners. And it notices that a number of them all have 3 corners, a number of them all have 4 corners, and a number of them all have no corners. And it's able to filter those through and group them together. We talked about that earlier with looking at a group of people who are out shopping. We want to group them together to find out what they have in common. And of course, once you understand what people have in common, maybe you have one of them who's a customer at your store, or you have 5 of them are customer at your store, and they have a lot in common with 5 others who are not customers at your store. How do you market to those 5 who aren't customers at your store yet? They fit the demographics of who's going to shop there, and you'd like them to shop at your store, not the one next door. Of course, this is a simplified version. You can see very easily the difference between a triangle and a circle, which might not be so easy in marketing. Reinforcement learning. Reinforcement learning is an important type of machine learning where an agent learns how to behave in an environment by performing actions and seeing the result. And we have here where in this case, a baby. It's actually great that they used an infant for this slide because the reinforcement learning is very much in its infant stages. But it's also probably the biggest machine learning demand out there right now, or in the future, it's going to be coming up over the next few years, is reinforcement learning and how to make that work for us. And you can see here where we have our action. In the action in this one, it goes into the fire. Hopefully the baby it was just a little candle, not a giant fire pit like it looks like here. When the baby comes out, and the new state is the baby is sad and crying because they got burned on the fire. And then maybe they take another action. The baby's called the agent because it's the one taking the actions. And in this case, they didn't go into the fire. They went a different direction, and now the baby's happy and laughing and playing. Reinforcement learning is very easy to understand because that's how, as humans, that's one of the ways we learn. We learn whether it is, you burn yourself on the stove, don't do that anymore. Don't touch the stove. In the big picture, being able to have a machine learning program or an AI be able to do this is huge because now we're starting to learn how to learn. That's a big jump in the world of computer and machine learning. And we're going to go back and just kind of go back over supervised versus unsupervised learning. Understanding this is huge because this is going to come up in any project you're working on. We have in supervised learning, we have labeled data. We have direct feedback, so someone's already gone in there and said, yes, that's a triangle. No, that's not a triangle. And then you predict an outcome. So you have a nice prediction. This new set of data is coming in and we know what it's going to be. And then with unsupervised training, it's not labeled. So we really don't know what it is. There's no feedback. So we're not telling it whether it's right or wrong. We're not telling it whether it's a triangle or a square. We're not telling it to go left or right. All we do is we're finding hidden structure in the data. Grouping the data together to find out what connects to each other. And then you can use these together. So imagine you have an image and you're not sure what you're looking for. So you go in and you have the unstructured data, find all these things that are connected together. And then somebody looks at those and labels them. Now you can take that labeled data and program something to predict what's in the picture. So you can see how they go back and forth and you can start connecting all these different tools together to make a bigger picture. There are many interesting machine learning algorithms. Let's have a look at a few of them. Hopefully this gives you a little flavor of what's out there. And these are some of the most important ones that are currently being used. We'll take a look at linear regression, decision tree, and the support vector machine. Let's start with a closer look at linear regression. Linear regression is perhaps one of the most well-known and well-understood algorithms in statistics and machine learning. Linear regression is a linear model. For example, a model that assumes a linear relationship between the input variables x and the single output variable y. And you'll see this if you remember from your algebra classes, y equals mx plus c. Imagine we are predicting distance traveled y from speed x. Our linear regression model representation for this problem would be y equals m times x plus c, or distance equals m times speed plus c, where m is the coefficient and c is the y-intercept. And we're going to look at two different variations of this. First, we're going to start with time is constant. And you can see we have a bicyclist. He's got his safety gear on, thank goodness. Speed equals 10 meters per second. And so over a certain amount of time, his distance equals 36 kilometers. We have a second bicyclist who's going twice the speed, or 20 meters per second. And you can guess if he's going twice the speed and time is a constant, then he's going to go twice the distance. And that's easily to compute. 36 times 2, you get 72 kilometers. And so if you had the question of how fast would somebody who's going 3 times that speed, or 30 meters per second is, you can easily compute the distance in our head. We can do that without needing a computer. But we want to do this for more complicated data. So it's kind of nice to compare the two. But let's just take a look at that and what that looks like in a graph. So in a linear regression model, we have our distance to the speed, and we have our m equals the VE slope of the line. And we'll notice that the line has a plus slope. And as the speed increases, distance also increases, hence the variables have a positive relationship. And so your speed of the person, which equals y equals mx plus c, distance traveled in a fixed interval of time, and we could very easily compute, either following the line or just knowing it's 3 times 10 meters per second, that this is roughly 102 kilometers distance that this third bicyclist has traveled. One of the key definitions on here is positive relationship. So the slope of the line is positive. As distance increase, so does speed increase. Let's take a look at our second example where we put distance is a constant. So we have speed equals 10 meters per second. They have a certain distance to go, and it takes them 100 seconds to travel that distance. And we have our second bicyclist who's still doing 20 meters per second. Since he's going twice the speed, we can guess that he'll cover the distance in about half the time, 50 seconds. And of course you could probably guess on the third one, 100 divided by 30, since he's going 3 times the speed, you could easily guess that this is 33.333 seconds time. When we put that into a linear regression model or a graph, If the distance is assumed to be constant, let's see the relationship between speed and time. And as time goes up, the amount of speed to go that same distance goes down. So now your m equals a minus VE slope of the line. As the speed increases, time decreases, hence the variable has a negative relationship. Again, there's our definition, positive relationship and negative relationship dependent on the slope of the line. And with a simple formula like this, and even a significant amount of data, let's see with the mathematical implementation of linear regression. And we'll take this data. So suppose we have this data set where we have x, y, x equals 1, 2, 3, 4, 5, standard series, and the y value is 3, 2, 2, 4, 3. When we take that and we go ahead and plot these points on a graph, you can see there's kind of a nice scattering, and you could probably eyeball a line through the middle of it. But we're going to calculate that exact line for linear regression. And the first thing we do is we come up here and we have the mean of xi. And remember, mean is basically the average. So we added 5 plus 4 plus 3 plus 2 plus 1 and divide by 5. And that simply comes out as 3. And then we'll do the same for y. We'll go ahead and add up all those numbers and divide by 5. And we end up with the mean value of y of I equals 2.8. Where the xi references it's an average or means value, and the yi also equals a means value of y. And when we plot that, you'll see that we can put in the y equals 2.8 and the x equals 3 in there on our graph. And we kind of gave it a little different color so you could sort it out with the dashed lines on it. And it's important to note that when we do the linear regression model should go through that dot. Now let's find our regression equation to find the best fit line. Remember, we go ahead and take our y equals mx plus c, so we're looking for m and c. So to find this equation for our data, we need to find our slope of m and our coefficient of c. And we have y equals mx plus c, where m equals the sum of x minus x average times y minus y average, or y means and x means, over the sum of x minus x means squared. That's how we get the slope of the value of the line. And we can easily do that by creating some columns here where we have x, y. Computers are really good about iterating through data, and so we can easily compute this and fill in a graph of data. And in our graph, you can easily see that if we have our x value of 1, and if you remember the xi, or the means value, is 3, 1 minus 3 equals a negative 2, and 2 minus 3 equals a negative 1, so on and so forth. And we can easily fill in the column of x minus xi, y minus yi, and then from those we can compute x minus xi squared and x minus xi times y minus yi. And you can guess it that the next step is to go ahead and sum the different columns for the answers we need. So we get a total of 10 for our x minus xi squared, and a total of 2 for x minus xi times y minus yi. And we plug those in, we get 2/10, which equals 0.2. So now we know the slope of our line equals 0.2. So we can calculate the value of c. That'd be the next step, is we need to know where it crosses the y-axis. And if you remember, I mentioned earlier that the linear regression line has to pass through the means value, the one that we showed earlier. We can just flip back up there to that graph, and you can see right here there's our means value, which is 3, x equals 3 and y equals 2.8. And since we know that value, we can simply plug that into our formula, y equals 0.2x plus c. So we plug that in, we get 2.8 equals 0.2 times 3 plus c, and you can just solve for c. So now we know that our coefficient equals 2.2. And once we have all that, we can go ahead and plot our regression line. Y equals 0.2 times x plus 2.2. And then from this equation, we can compute new values. So let's predict the values of y using x equals 1, 2, 3, 4, 5 and plot the points. Remember, the 1, 2, 3, 4, 5 was our original x values. So now we're going to see what y thinks they are, not what they actually are. And when we plug those in, we get y of designated with y of p. You can see that x equals 1 equals 2.4, x equals 2 equals 2.6, and so on and so on. So we have our y predicted values of what we think it's going to be when we plug those numbers in. And when we plot the predicted values along with the actual values, we can see the difference. And this is one of the things that's very important with linear regression in any of these models, is to understand the error. And so we can calculate the error on all of our different values. And you can see over here we plotted x and y predict. And we draw in a little line so you can sort of see what the error looks like there between the different points. So our goal is to reduce this error. We want to minimize that error value on our linear regression model. Minimizing the distance. There are lots of ways to minimize the distance between the line and the data points, like sum of squared errors, sum of absolute errors, root mean square error, etc. We keep moving this line through the data points to make sure the best fit line has the least square distance between the data points and the regression line. So to recap with a very simple linear regression model, we first figure out the formula of our line through the middle, and then we slowly adjust the line to minimize the error. Keep in mind this is a very simple formula. The math gets, even though the math is very much the same, it gets much more complex as we add in different dimensions. So this is only 2 dimensions, y equals mx plus c, but you can take that out to x, z, ijq, all the different features in there, and they can plot a linear regression model on all of those using the different formulas to minimize the error. Let's go ahead and take a look at decision trees, a very different way to solve problems in the linear regression model. Decision tree is a tree-shaped algorithm used to determine a course of action. Each branch of a tree represents a possible decision, occurrence, or reaction. We have data which tells us if it is a good day to play golf. And if we were to open this data up in a general spreadsheet, you can see we have the outlook, whether it's rainy, overcast, sunny, temperature, hot, mild, cool, humidity, windy, and did I like to play golf that day, yes or no? So we're taking a census. And certainly I wouldn't want a computer telling me when I should go play golf or not. But you could imagine if you got up in the night before, you're trying to plan your day, and it comes up and says tomorrow would be a good day for golf for you in the morning and not a good day in the afternoon or something like that. This becomes very beneficial, and we see this in a lot of applications coming out now where it gives you suggestions and lets you know what would fit the match for you for the next day or the next purchase or the next whatever, next meal out. In this case, is tomorrow a good day for playing golf based on the weather coming in? And so we come up and let's determine if you should play golf when the day is sunny and windy. So we found out the forecast tomorrow is going to be sunny and windy. And suppose we draw our tree like this. We're going to have our humidity, and then we have our normal, which is if you have a normal humidity, you're going to go play golf. And if the humidity is really high, then we look at the outlook. And if the outlook is sunny, overcast, or rainy, it's going to change what you choose to do. So if you know that it's a very high humidity and it's sunny, you're probably not going to play golf because you're going to be out there miserable, fighting off the mosquitoes that are out joining you to play golf with you. Maybe if it's rainy, you probably don't want to play in the rain. But if it's slightly overcast and you get just the right shadow, that's a good day to play golf and be outside, out on the green. Now in this example, you can probably make your own tree pretty easily because it's a very simple set of data going in. But the question is, how do you know what to split? Where do you split your data? What if this is much more complicated data where it's not something that you would particularly understand? Like studying cancer, they take about 36 measurements of the cancerous cells, and then each one of those measurements represents how bulbous it is, how extended it is, how sharp the edges are. Something that as a human we would have no understanding of. So how do we decide how to split that data up? And is that the right decision tree? So that's a question that's going to come up. Is this the right decision tree? For that, we should calculate entropy and information gain. 2 important vocabulary words there are the entropy and the information gain. Entropy. Entropy is a measure of randomness or impurity in the data set. Entropy should be low. So we want the chaos to be as low as possible. We don't want to look at it and be confused by the images or what's going on there with mixed data. And the information gain. It is a measure of decrease in entropy after the data set is split, also known as entropy reduction. Information gain should be high, so we want our information that we get out of the split to be as high as possible. Let's take a look at entropy from the mathematical side. In this case, we're going to denote entropy as I of P of and N, where P is the probability that you're going to play a game of golf, and N is the probability where you're not going to play the game of golf. Now, you don't really have to memorize these formulas. There's a few of them out there depending on what you're working with. But it's important to note that this is where this formula is coming from, so when you see it, you're not lost when you're running your programming, unless you're building your own decision tree code in the back. And we simply have a log squared of P over P plus N minus N over P plus N times the log squared of N of P plus N. But let's break that down and see what it actually looks like when we're computing that from the computer script side. Entropy of a target class of the dataset is the whole entropy. So we have entropy play golf. And when we look at this, if we go back to the data, you can simply count how many yeses and no in our complete data set for playing golf days. In our complete set, we find we have 5 days we did play golf and 9 days we did not play golf. And so our I equals, if you add those together, 9 plus 5 is 14. And so our I equals 5 over 14 and 9 over 14. That's our P and N values that we plug into that formula. And you can go 5 over 14 equals 0.36, 9 over 14 equals 0.64. And when you do the whole equation, you get the minus 0.36 log root squared of 0.36 minus 0.64 log squared root of 0.64. And we get a set value. We get 0.94. So we now have a full entropy value for the whole set of data that we're working with. And we want to make that entropy go down. And just like we calculated the entropy out for the whole set, we can also calculate entropy for playing golf and the outlook. Is it going to be overcast or rainy or sunny? And so when we look at the entropy, we have P of sunny times E of 3 of 2. And that just comes out how many sunny days yes and how many sunny days no over the total, which is 5. Don't forget to put we'll divide that 5 out later on. Equals P overcast equals 4 comma 0 plus rainy equals 2 comma 3. And then when you do the whole setup, we have 5 over 14. Remember I said there was a total of 5? 5 over 14 times the I of 3 of 2 plus 4 over 14 times the 4 comma 0 and 514 over I of 2, 3. And so we can now compute the entropy of just the part that has to do with the forecast. And we get 0.693. Similarly, we can calculate the entropy of other predictors like temperature, humidity, and wind. And so we look at the gain outlook. How much are we going to gain from this? Entropy play golf minus entropy play golf outlook. And we can take the original 0.94 for the whole set minus the entropy of just the rainy day and temperature, and we end up with a gain of 0.247. So this is our information gain. Remember, we define entropy and we define information gain. The higher the information gain, the lower the entropy, the better. The information gain of the other 3 attributes can be calculated in the same way. So we have our gain for temperature equals 0.029. We have our gain for humidity equals 0.152, and our gain for a windy day equals 0.048. And if you do a quick comparison, you'll see the 0.247 is the greatest gain of information, so that's the split we want. Now let's build the decision tree. So we have the outlook. Is it going to be sunny, overcast, or rainy? That's our first split because that gives us the most information gain. And we can continue to go down the tree using the different information gains with the largest information. We can continue down the nodes of the tree where we choose the attribute with the largest information gain as the root node and then continue to split each subnode with the largest information gain that we can compute. And although it's a little bit of a tongue twister to say all that, you can see that it's a very easy to view visual model. We have our outlook, we split it 3 different directions. If the outlook is overcast, we're going to play. And then we can split those further down if we want. So if the outlook is sunny, but then it's also windy, if it's windy, we're not going to play. If it's not windy, we'll play. So we can easily build a nice decision tree to guess what we would like to do tomorrow and give us a nice recommendation for the day. So we want to know if it's a good day to play golf when it's sunny and windy. Remember the original question that came out? Tomorrow's weather report is sunny and windy. You can see by going down the tree, we go outlook sunny, outlook windy. We're not going to play golf tomorrow. So our little smartwatch pops up and says, I'm sorry, tomorrow's not a good day for golf. It's going to be sunny and windy. And if you're a huge golf fan, you might go, uh-oh, it's not a good day to play golf. We can go in and watch a golf game at home. So we'll sit in front of the TV instead of being out playing golf in the wind. Now that we looked at our decision tree, let's look at the third one of our algorithms we're investigating. Support vector machine. Support vector machine is a widely used classification algorithm. The idea of support vector machine is simple. The algorithm creates a separation line which divides the classes in the best possible manner. For example, dog or cat, disease or no disease. Suppose we have a labeled sample data which tells height and weight of males and females. A new data point arrives and we want to know whether it's going to be a male or a female. So we start by drawing a line. We draw decision lines, but if we consider decision line 1, then we will classify the individual as a male. And if we consider decision line 2, then it will be a female. So you can see this person kind of lies in the middle of the two groups, so it's a little confusing trying to figure out which line they should be under. We need to know which line divides the classes correctly, but how? The goal is to choose a hyperplane, and that is one of the key words they use when we talk about support vector machines. Choose a hyperplane with the greatest possible margin between the decision line and the nearest point within the training set. So you can see here we have our support vector, we have the two nearest points to it, and we draw a line between those 2 points. And the distance margin is the distance between the hyperplane and the nearest data point from either set. So we actually have a value, and it should be equally distant between the two points that we're comparing it to. When we draw the hyperplanes, we observe that line 1 has a maximum distance. So we observe that line 1 has a maximum distance margin, so we'll classify the new data point correctly. And our result on this one is going to be that the new data point is Mel. One of the reasons we call it a hyperplane versus a line is that a lot of times we're not looking at just weight and height. We might be looking at 36 different features or dimensions. And so when we cut it with a hyperplane, it's more of a three-dimensional cut in the data, or multi-dimensional. It cuts the data a certain way. And each plane continues to cut it down until we get the best fit or match. Let's understand this with the help of an example. Problem statement. I always start with a problem statement when you're going to put some code together. We're going to do some coding now. Classifying muffin and cupcake recipes using support vector machines. So the cupcake versus the muffin. Let's have a look at our data set. And we have the different recipes here. We have a muffin recipe that has so much flour. I'm not sure what measurement 55 is in, but it has 55, maybe it's ounces? But it has a certain amount of flour, a certain amount of milk, sugar, butter, egg, baking powder, vanilla, and salt. And so based on these measurements, we want to guess whether we're making a muffin or a cupcake. And you can see in this one, we don't have just two features. We don't just have height and weight as we did before between the male and female. In here, we have a number of features. In fact, in this, we're looking at 8 different features to guess whether it's a muffin or a cupcake. What's the difference between a muffin and a cupcake? Turns out muffins have more flour, while cupcakes have more butter and sugar. So basically the cupcake's a little bit more of a dessert, where the muffin's a little bit more of a fancy bread. But how do we do that in Python? How do we code that to go through recipes and figure out what the recipe is? And I really just want to say cupcakes versus muffins, like some big professional wrestling thing. Before we start in our cupcakes versus muffins, we are going to be working in Python. There's many versions of Python, many different editors. That is one of the strengths and weaknesses of Python, is it just has so much stuff attached to it, and it's one of the more popular data science programming packages you can use. In this case, we're going to go ahead and use Anaconda and Jupyter Notebook. The Anaconda Navigator has all kinds of fun tools. Once you're into the Anaconda Navigator, you can change environments. I actually have a number of environments on here. We'll be using Python 3.6 environment. So this is in Python version 3.6. Although it doesn't matter too much which version you use. I usually try to stay with the 3x because they're current, unless you have a project that's very specifically in version 2x. 2.7 I think is usually what most people use in the version 2. And then once we're in our Jupyter Notebook editor, I can go up and create a new file. And we'll just jump in here. In this case, we're doing SVM muffin versus cupcake. And then let's start with our packages for data analysis. And we almost always use there's a few very standard packages we use. We use import numpy. That's for number Python. And they usually denote it as NP. That's very common. And then we're going to import pandas as PD. And numpy deals with number arrays. There's a lot of cool things you can do with the numpy setup as far as multiplying all the values in an array, in a numpy array, data array. Pandas, I can't remember if we're using it actually in this data set. I think we do as an import. It makes a nice data frame. And the difference between a data frame and a numpy array is that a data frame is more like your Excel spreadsheet. You have columns, you have indexes, so you have different ways of referencing it, easily viewing it, and there's additional features you can run on a data frame. And Pandas kind of sits on numpy, so you need them both in there. And then finally, we're working with the support vector machine. So from sklearn. We're going to use the sklearn model. Import SVM, support vector machine. And then, as a data scientist, you should always try to visualize your data. Some data obviously is too complicated or doesn't make any sense to the human. But if it's possible, it's good to take a second look at it so that you can actually see what you're doing. Now for that, we're going to use two packages. We're going to import matplotlibary.pyplot as PLT. Again, very common. And we're going to import Seaborn as SNS. And we'll go ahead and set the font scale in the SNS right in our import line. That's what this semicolon followed by a line of data. We're going to set the SNS. And these are great because the Seaborn sits on top of matplotlibary, just like Pandas sits on NumPy. So it adds a lot more features and uses and control. We're obviously not going to get into matplotlibary and Seaborn. That'd be its own tutorial. We're really just focusing on the SVM, the support vector machine from sklearn. And since we're in Jupyter Notebook, we have to add a special line in here for our matplotlibary. And that's your percentage sign or ampersand matplotlibary in line. Now, if you're doing this in just a straight code project, a lot of times I use like Notepad++, and I'll run it from there. You don't have to have that line in there because it'll just pop up as its own window on your computer, depending on how your computer's set up. Because we're running this in the Jupyter Notebook as a browser setup, this tells it to display all of our graphics right below on the page. So that's what that line is for. I remember the first time I ran this, I didn't know that, and I had to go look that up years ago. It was quite a headache. So matplotlibary inline is just because we're running this on the web setup. And we can go ahead and run this, make sure all our modules are in. They're all imported, which is great. If you don't have them import, you'll need to go ahead and pip, use the PIP or however you do it. There's a lot of other install packages out there, although pip is the most common. And you have to make sure these are all installed on your Python setup. The next step, of course, is we got to look at the data. You can't run a model for predicting data if you don't have actual data. So to do that, let me go ahead and open this up and take a look. And we have our cupcakes versus muffins. And it's a CSV file, or .csv, meaning that it's comma-separated variable. And it's going to open it up in a nice spreadsheet for me. And you can see up here we have the type. We have muffin, 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 cupcake, cupcake, cupcake. And then it's broken up into flour, milk, sugar, butter, egg, baking powder, vanilla, and salt. So what we can do is we can go ahead and look at this data also in our Python. Let us create a variable recipes equals, we're going to use our pandas module, .read CSV. Remember, it's a comma-separated variable. And the file name happened to be cupcakes versus muffins. Oops, I got double brackets there. Do it this way. There we go. Cupcakes versus muffins. Because the program I loaded, or the place I saved this particular Python program is in the same folder, we can get by with just the file name. But remember, if you're storing it in a different location, you have to also put down the full path on there. And then because we're in pandas, we're going to go ahead and you can actually, inline you can do this, but let me do the full print. You can just type in recipes.head in the Jupyter Notebook. But if you're running in code in a different script, you need to go ahead and type out the whole print recipes.head. And pandas knows that that's going to do the first 5 lines of data. And if we flip back on over to the spreadsheet where we opened up our CSV file, you can see where it starts on line 2. This one calls it 0, and then 2, 3, 4, 5, 6 is going to match. Go and close that out because we don't need that anymore. And it always starts at 0. And it automatically indexes it since we didn't tell it to use an index in here. So that's the index number for the left-hand side. And it automatically took the top row as labels. So pandas using it to read a CSV is just really slick and fast. One of the reasons we love our pandas. Not just because they're cute and cuddly teddy bears. And let's go ahead and plot our data. And I'm not going to plot all of it. I'm just going to plot the sugar and flour. Now, obviously, you can see where they get really complicated if we have tons of different features. And so you'll break them up and maybe look at just 2 of them at a time to see how they connect. And to plot them, we're going to go ahead and use Seaborn. So that's our SNS. And the command for that is sns.lmplot. And then the 2 different variables I'm going to plot is flour and sugar. Data equals recipes. The hue equals type. And this is a lot of fun because it knows that this is pandas coming in. So this is one of the powerful things about pandas mixed with Seaborn and doing graphing. And then we're going to use a palette set 1. There's a lot of different sets in there. You can go look them up for Seaborn. We'll do a fit regular equals false, so we're not really trying to fit anything. And it's a scatter, KWS. A lot of these settings you can look up in Seaborn. Half of these you could probably leave off when you run them. Somebody played with this and found out that these were the best settings for doing a Seaborn plot. And let's go ahead and run that. And because it does it inline, it just puts it right on the page. And you can see right here that just based on sugar and flour alone, there's a definite split. And we use these models because you can actually look at it and say, hey, if I drew a line right between the middle of the blue dots and the red dots, we'd be able to do an SVM and a hyperplane right there in the middle. Then the next step is to format or pre-process our data. And we're going to break that up into 2 parts. We need a type label. And remember, we're going to decide whether it's a muffin or a cupcake. Well, a computer doesn't know muffin or cupcake. It knows 0 and 1. So what we're going to do is we're going to create a type label. And from this, we'll create a numpy array np where, and this is where we can do some logic. We take our recipes from our panda, and wherever type equals muffin, it's going to be 0. And then if it doesn't equal muffin, which is cupcakes, it's going to be 1. So we create our type label. This is the answer. So when we're doing our training model, remember we have to have a training data. This is what we're going to train it with, is that it's 0 or 1. It's a muffin or it's not. And then we're going to create our recipe features. And if you remember correctly from right up here, the first column is type. So we really don't need the type column because that's our muffin or cupcake. And in pandas, we can easily sort that out. We take our value recipes dot columns. That's a pandas function built into pandas. Dot values, converting them to values. So it's just the column titles going across the top. And we don't want the first one. So what we do is, since it always starts at 0, we want 1 colon till the end. And then we want to go ahead and make this a list. And this converts it to a list of strings. And then we can go ahead and just take a look and see what we're looking at for the features. Make sure it looks right. Let me go ahead and run that. And I forgot the S on recipes, so we'll go ahead and add the S in there and then run that. And we can see we have flour, milk, sugar, butter, egg, baking powder, vanilla, and salt. And that matches what we have up here, right where we printed out everything but the type. So we have our features and we have our label. Now, the recipe features is just the titles of the columns, and we actually need the ingredients. And at this point, we have a couple options. One, we could run it over all the ingredients. And when you're doing this, usually you do. But for our example, we want to limit it so you can easily see what's going on. Because if we did all the ingredients, we have, that's what, 7, 8 different hyperplanes that would be built into it. We only want to look at one so you can see what the SVM is doing. And so we'll take our recipes and we'll do just flour and sugar. Again, you can replace that with your recipe features and do all of them. But we're going to do just flour and sugar, and we're going to convert that to values. We don't need to make a list out of it because it's not string values. These are actual values on there. And we can go ahead and just print ingredients, and you can see what that looks like. And so we have just the amount of flour and sugar, just the 2 sets of plots. And just for fun, let's go ahead and take this over here and take our recipe features. And so if we decided to use all the recipe features, you'll see that it makes a nice column of different data. So it just strips out all the labels and everything, and we just have just the values. But because we want to be able to view this easily in a plot later on, we'll go ahead and take that and just do flour and sugar. And we'll run that and you'll see it's just the 2 columns. So the next step is to go ahead and fit our model. We'll go ahead and just call it model. And it's a SVM. We're using a package called SVC. And in this case, we're going to go ahead and set the kernel equals linear. So it's using a specific setup on there. And if we go to the reference on their website for the SVM, you'll see that there's 8 of them here. 3 of them are for regression. 3 are for classification. The SVC, support vector classification, is probably one of the most commonly used. And then there's also one for detecting outliers, and another one that has to do with something a little bit more specific on the model. But SVC and SVR are the 2 most commonly used, standing for support vector classifier and support vector regression. Remember, regression is an actual value, a float value or whatever you're trying to work on. And SVC is a classifier, so it's a yes, no, true, false. But for this, we want to know 0, 1, muffin, cupcake. We go ahead and create our model. And once we have our model created, we're going to do model.fit. And this is very common, especially in the sklearn. All their models are followed with the fit command. And what we put into the fit, what we're training with it, is we're putting in the ingredients, which in this case we limited to just flour and sugar. And the type label, is it a muffin or a cupcake? Now, in more complicated data science series, you'd want to split into, we won't get into that today, we split it into training data and test data. And they even do something where they split it into thirds, where a third is used for, where you switch between which one's training and test. There's all kinds of things that go into that, and it gets very complicated when you get to the higher end. Not overly complicated, just an extra step which we're not going to do today because this is a very simple set of data. And let's go ahead and run this, and now we have our model fit. And I got an error here, so let me fix that real quick. It's capital SVC, it turns out. I did it lowercase. Support vector classifier. There we go. Let's go ahead and run that. And you'll see it comes up with all this information that it prints out automatically. These are the defaults of the model. You notice that we changed the kernel to linear, and there's our kernel linear on the printout. And there's other different settings you can mess with. We're going to just leave that alone for right now. For this, we don't really need to mess with any of those. So next, we're going to dig a little bit into our newly trained model. And we're going to do this so we can show you on a graph. And let's go ahead and get the separating. And we're going to say we're going to use a W for our variable on here. And we're going to do model.coefficient _0. So what the heck is that? Again, we're digging into the model. So we've already got a prediction and a train. This is the math behind it that we're looking at right now. And so the W is going to represent 2 different coefficients. And if you remember, we had y equals mx plus c. So these coefficients are connected to that, but in 2-dimensional. It's a plane. We don't want to spend too much time on this because you can get lost in the confusion of the math. So if you're a math whiz, this is great. You can go through here and you'll see that we have a equals minus w of 0 over w of 1. Remember, there's 2 different values there. And that's basically the slope that we're generating. And then we're going to build an XX. What is XX? We're going to set it up to a numpy array. There's our np dot line space. So we're creating a line of values between 30 and 60. So it just creates a set of numbers for x. And then if you remember correctly, we have our formula, y equals the slope times x plus the intercept. Well, to make this work, we can do this as yy equals the slope times each value in that array. That's the neat thing about NumPy. So when I do a times xx, which is a whole NumPy array of values, it multiplies a across all of them. And then it takes those same values and we subtract the model intercept. That's your, remember we had mx plus c, so that'd be the c from the formula, y equals mx plus c. And that's where all these numbers come from. A little bit confusing because it's digging out of these different arrays. And then what we want to do is we're going to take this and we're going to go ahead and plot it. So plot the parallels to separating hyperplane that pass through the support vectors. And so we're going to create B equals a model support vectors, pulling our support vectors out there. Here's our YY, which we now know is a set of data. And we have we're going to create YY down equals A times XX plus B1 minus A times B0. And then model support vector B is going to be set that to a new value, the -1 setup. And YY up equals A times XX plus B1 minus A times B0. And we can go ahead and just run this to load these variables up. If you wanted to understand a little bit more of what's going on, you can see if we print YY, we just run that, you can see it's an array. This is a line. It's going to have, in this case, between 30 and 60, so there's going to be 30 variables in here. And the same thing with YY up, YY down. And we'll plot those in just a minute on a graph so you can see what those look like. You just go ahead and delete that out of here and run that so it loads up the variables. Nice clean slate. I'm just going to copy this from before. Remember this, our SNS, our seaborn plot, LM plot, flour, sugar. And I'll just go ahead and run that real quick so you can see remember what that looks like. It's just a straight graph on there. And then one of the neat things is because seaborn sits on top of pyplot, we can do the pyplot for the line going through. And that is simply plt.plot. And that's our XX and YY, our two corresponding values, XY. And then somebody played with this to figure out that the line width equals 2 and the color black would look nice. So let's go ahead and run this whole thing with the pyplot on there. And you can see when we do this, it's just doing flour and sugar on here. Corresponding line between the sugar and the flour and the muffin versus cupcake. And then we generated the support vectors, the YY down and YY up. So let's take a look and see what that looks like. So we'll do our PL plot. And again, this is all against XX, our X value. But this time we have YY down. And let's do something a little fun with this. We can put in a K dash dash. That just tells it to make it a dotted line. And if we're going to do the down one, we also want to do the up one. So here's our YY up. And when we run that, it adds both sets of line. And so here's our support, and this is what you expect. You expect these two lines to go through the nearest data point. So the dashed lines go through the nearest muffin and the nearest cupcake when it's plotting it. And then your SVM goes right down the middle. So it gives it a nice split in our data, and you can see how easy it is to see, based just on sugar and flour, which one's a muffin or a cupcake. Let's go ahead and create a function to predict muffin or cupcake. I've got my recipes I pulled off the internet, and I want to see the difference between a muffin or a cupcake. And so we need a function to push that through. And we'll create a function with def. And let's call it muffin or cupcake. And remember, we're just doing flour and sugar today. We're not doing all the ingredients. And that actually is a pretty good split. You really don't need all the ingredients to know it's flour and sugar. And let's go ahead and do an if-else statement. So if model predict is of flour and sugar equals 0. So we take our model and we run a predict. It's very common in sklearn where you have a dot predict. You put the data in and it's going to return a value. In this case, if it equals 0, then print you're looking at a muffin recipe. Else, if it's not 0, that means it's 1, then you're looking at a cupcake recipe. That's pretty straightforward for a function, or def for definition. DEF is how you do that in Python. And of course, if you're going to create a function, you should run something in it. And so let's run a cupcake, and we're going to send it values 50 and 20, a muffin or a cupcake. I don't know what it is. And let's run this and just see what it gives us. And it says, oh, it's a muffin. You're looking at a muffin recipe. So it very easily predicts whether we're looking at a muffin or a cupcake recipe. Let's plot this. There we go. Plot this on the graph so we can see what that actually looks like. And I'm just going to copy it and paste it from below where we're plotting all the points in there. So this is nothing different than what we did before. If I run it, you'll see it has all the points and the lines on there. And what we want to do is we want to add another point. And we'll do PLT plot. And if you remember correctly, we did, for our test, we did 50 and 20. And then somebody went in here and decided we'll do YO for yellow, or it's kind of an orangish yellow color is going to come up. Marker size 9. Those are settings you can play with. Somebody else played with them to come up with the right setup so it looks good. And you can see there it is graphed, clearly a muffin. In this case, in cupcakes versus muffins, the muffin has won. And if you'd like to do your own muffin cupcake contender series, you certainly can send a note down below, and the team at Simplilearn will send you over the data they use for the muffin and cupcake. And that's true of any of the data. We didn't actually run a plot on it earlier. We had men versus women. You can also request that information to run it on your data setup so you can test that out. So to go back over our setup, we went ahead for our support vector machine code. We did a predict 40 parts flour, 20 parts sugar. I think it was different than the one we did, whether it's a muffin or a cupcake. Hence, we have built a classifier using SVM, which is able to classify if a recipe is of a cupcake or a muffin, which wraps up our cupcake versus muffin. What's in it for you? We're going to cover clustering. What is clustering? K-means clustering, which is one of the most common used clustering tools out there, including a flowchart to understand K-means clustering and how it functions. And then we'll do an actual Python live demo on clustering of cars based on brands. Then we're going to cover logistic regression. What is logistic regression? Logistic regression curve and sigmoid function. And then we'll do another Python code demo to classify a tumor as malignant or benign based on features. And let's start with clustering. Suppose we have a pile of books of different genres. Now we divide them into different groups like fiction, horror, education, and as we can see from this young lady, she definitely is into heavy horror. You can just tell by those eyes and the maple Canadian leaf on her shirt. But we have fiction, horror, and education, and we want to go ahead and divide our books up. Well, organizing objects into groups based on similarity is clustering. And in this case, as we're looking at the books, we're talking about clustering things with known categories. But you can also use it to explore data. So you might not know the categories, you just know that you need to divide it up in some way to conquer the data and to organize it better. But in this case, we're going to be looking at clustering in specific categories. And let's just take a deeper look at that. We're going to use K-means clustering. K-means clustering is probably the most commonly used clustering tool in the machine learning library. K-means clustering is an example of unsupervised learning. If you remember from our previous thing, it is used when you have unlabeled data. So we don't know the answer yet. We have a bunch of data that we want to cluster into different groups. Define clusters in the data based on feature similarity. So we've introduced a couple terms here. We've already talked about unsupervised learning and unlabeled data. So we don't know the answer yet. We're just going to group stuff together and see if we can find an answer of how things connect. We've also introduced feature similarity. Features being different features of the data. Now with books, we can easily see fiction and horror and history books. But a lot of times with data, some of that information isn't so easy to see right when we first look at it. And so K-means is one of those tools where we can start finding things that connect, that match with each other. Suppose we have these data points and want to assign them into a cluster. Now when I look at these data points, I would probably group them into two clusters just by looking at them. I'd say two of these group of data kind of come together. But in K-means, we pick K clusters and assign random centroids to clusters, where the K clusters represents two different clusters. We pick K clusters and assign random centroids to the clusters, then we compute distance from objects to the centroids. Now we form new clusters based on minimum distances and calculate the centroids. So we figure out what the best distance is for the centroid, then we move the centroid and recalculate those distances. Repeat previous two steps iteratively till the cluster centroids stop changing their positions and become static. Repeat previous two steps iteratively till the cluster centroids stop changing and the positions become static. Once the clusters become static, then k-means clustering algorithm is said to be converged. And there's another term we see throughout machine learning is converged. That means whatever math we're using to figure out the answer has come to a solution, or it's converged on an answer. Shall we see the flow chart to understand? Make a little bit more sense by putting it into a nice, easy step-by-step. So we start, we choose K, we'll look at the elbow method in just a moment. We assign random centroids to clusters, and sometimes you pick the centroids, because you might look at the data in a graph and say, oh, these are probably the central points. Then we compute the distance from the objects to the centroids. We take that and we form new clusters based on minimum distance and calculate their centroids. Then we compute the distance from objects to the new centroids. And then we go back and repeat those last two steps. We calculate the distances. So as we're doing it, it brings into the new centroid, and then we move the centroid around and we figure out which objects are closest to each centroid. So the objects can switch from one centroid to the other as the centroids are moved around. And we continue that until it is converged. Let's see an example of this. Suppose we have this data set of 7 individuals and their score on 2 topics, A and B. So here's our subject, in this case referring to the person taking the test. And then we have subject A, where we see what they've scored on their first subject, and we have subject B, and we can see what they score on the second subject. Now let's take 2 farthest apart points as initial cluster centroids. Now remember, we talked about selecting them randomly, or we can also just put them in different points and pick the furthest one apart so they move together. Either one works okay, depending on what kind of data you're working on and what you know about it. So we took the 2 furthest points, 1 and 1, and 5 and 7. And now let's take the 2 farthest apart points as initial cluster centroids. Each point is then assigned to the closest cluster with respect to the distance from the centroids. So we take each one of these points in there, we measure that distance, and you can see that if we measured each of those distances, and you use the Pythagorean theorem for a triangle in this case, because you know the x and the y, and you can figure out the diagonal line from that. Or you can just take a ruler and put it on your monitor. That'd be kind of silly, but it would work if you're just eyeballing it. You can see how they naturally come together in certain areas. Now we again calculate the centroids of each cluster. So cluster 1 and then cluster 2, and we look at each individual dot. There's 1, 2, 3, we're in one cluster. The centroid then moves over. It becomes 1.8, 2.3. So remember, it was at 1 and 1. Well, the very center of the data we're looking at would put it at the roughly 2, 2, but 1.8 and 2.3. And the second one, if we wanted to make the overall mean vector, the average vector of all the different distances to that centroid, we come up with 4, 1 and 5, 4. So we've now moved the centroids. We compare each individual's distance to its own cluster, mean, and to that of the opposite cluster, and we find, we can build a nice chart on here, that as we move that centroid around, we now have a new different kind of clustering of groups, and using Euclidean distance between the points and the mean, we get the same formula. You see new formulas coming up. So we have our individual dots, distance to the mean centroid of the cluster, and distance to the mean centroid of the cluster. Only individual 3 is nearer to the mean of the opposite cluster, cluster 2, than its own cluster 1. And you can see here in the diagram where we've kind of circled that 1 in the middle. So when we've moved the centroids of the clusters over, one of the points shifted to the other cluster because it's closer to that group of individuals. Thus, individual 3 is relocated to cluster 2, resulting in a new partition. And we regenerate all those numbers of how close they are to the different clusters. For the new clusters, we will find the actual cluster centroids. So now we move the centroids over, and you can see that we've now formed 2 very distinct clusters on here. On comparing the distance of each individual's distance to its own cluster mean and to that of the opposite cluster, we find that the data points are stable. Hence, we have our final clusters. Now, if you remember, I brought up a concept earlier, k-mean on the k-means algorithm. Choosing the right value of k will help in less number of iterations. And to find the appropriate number of clusters in a data set, we use the elbow method. And within sum of squares, WSS, is defined as the sum of the squared distance between each member of the cluster and its centroid. And so you see what we've done here is we have the number of clusters. And as you do the same k-means algorithm over the different clusters, and you calculate what that centroid looks like, and you find the optimal, you can actually find the optimal number of clusters using the elbow of the graph, is called as the elbow method. And on this, we guessed at 2 just by looking at the data. But as you can see, the slope, you actually just look for right there where the elbow is in the slope, and you have a clear answer that we want 2 different, to start with k-means equals 2. A lot of times people end up computing k-means equals 2, 3, 4, 5 until they find the value which fits on the elbow joint. Sometimes you can just look at the data, and if you're really good with that specific domain, remember domain, I mentioned that last time, you'll know that where to pick those numbers or where to start guessing at what that k value is. So let's take this, and we're going to use a use case using k-means clustering to cluster cars into brands using parameters such as horsepower, cubic inches, make, year, etc. So we're going to use the dataset cars data, having information about 3 brands of cars: Toyota, Honda, and Nissan. We'll go back to my favorite tool, the Anaconda Navigator with the Jupyter Notebook. And let's go ahead and flip over to our Jupyter Notebook. And in our Jupyter Notebook, I'm going to go ahead and just paste the basic code that we usually start a lot of these off with. We're not going to go too much into this code because we've already discussed NumPy, we've already discussed Matplot library, and pandas. NumPy being the number array, pandas being the pandas data frame, and Matplot for the graphing. And don't forget, since if you're using the Jupyter Notebook, you do need the Matplot library inline so that it plots everything on the screen. If you're using a different Python editor, then you probably don't need that because it'll have a pop-up window on your computer. And we'll go ahead and run this just to load our libraries and our setup into here. The next step is, of course, to look at our data, which I've already opened up in a spreadsheet. And you can see here we have the miles per gallon, cylinders, cubic inches, horsepower, weight pounds, how heavy it is, time it takes to get to 60. My card is probably on this one at about 80 or 90. What year it is. So this is, you can actually see this is kind of older cars, and then the brand, Toyota, Honda, Nissan. So the different cars are coming from all the way from 1971, if we scroll down, to the 80s. We have between the 70s and 80s a number of cars that they've put out. And let's, when we come back here, we're going to do importing the data. So we'll go ahead and do dataset equals, and we'll use pandas to read this in, and it's from a CSV file. Remember, you can always post this in the comments and request the data files for these, either in the comments here on the YouTube video or go to Simplilearn.com and request that. The cars CSV, I put it in the same folder as the code that I've stored. So my Python code is stored in the same folder, so I don't have to put the full path. If you store them in different folders, you do have to change this and double check your name variables. And we'll go ahead and run this, and we've chosen dataset arbitrarily because it's a dataset we're importing. And we've now imported our cars CSV into the dataset. As you know, you have to prep the data, so we're going to create the X data. This is the one that we're going to try to figure out what's going on with. And then there's a number of ways to do this, but we'll do it in a simple loop so you can actually see what's going on. So we'll do for I in x.columns. So we're going to go through each of the columns, and a lot of times it's important. I'll make lists of the columns and do this because I might remove certain columns, or there might be columns that I want to be processed differently. But for this, we can go ahead and take x of I, and we want to go fill NA, and that's a pandas command. But the question is, what are we going to fill the missing data with? We definitely don't want to just put in a number that doesn't actually mean something. And so one of the tricks you can do with this is we can take x of I, and then in addition to that, we want to go ahead and turn this into an integer, because a lot of these are integers. So we'll go ahead and keep it integers. And we add the bracket here. And a lot of editors will do this. They'll think that you're closing one bracket. Make sure you get that second bracket in there if it's a double bracket. That's always something that happens regularly. So once we have our integer of x of I, this is going to fill in any missing data with the average. And I was so busy closing one set of brackets, I forgot that the mean also has brackets in there for the pandas. So we can see here we're going to fill in all the data with the average value for that column. So if there's missing data, it's in the average of the data it does have. And then once we've done that, we'll go ahead and loop through it again and just check and see to make sure everything is filled in correctly. And we'll print, and then we take x is null, and this returns a set of the null value, or the how many lines are null, and we'll just sum that up to see what that looks like. And so when I run this, And so with the X, what we want to do is we want to remove the last column because that had the models. That's what we're trying to see, if we can cluster these things and figure out the models. There is so many different ways to sort the X out. For one, we could take the X and we could go data set, our variable we're using, and use the iLocation, one of the features that's in pandas. And we could take that and then take all the rows and all but the last column of the data set. And at this time we could do values. We just convert it to values. So that's one way to do this. And if let me just put this down here and print X, it's a capital X we chose, and I run this, you can see it's just the values. We could also take out the values and it's not going to return anything because there's no values connected to it. What I like to do with this is, instead of doing the iLocation, which does integers, more common is to come in here and we have our data set, and we're going to do dataset dot columns. And remember, that lists all the columns. So if I come in here, let me just mark that as red, and I print dataset dot columns, you can see that I have my index here. I have my MPG, cylinders, everything, including the brand, which we don't want. So the way to get rid of the brand would be to do data columns of everything but the last one, -1. So now if I print this, you'll see the brand disappears. And so I can actually just take dataset columns -1, and I'll put it right in here for the columns we're going to look at. And let's unmark this and unmark this. And now if I do an x.head, I now have a new data frame, and you can see right here we have all the different columns except for the brand at the end of the year. And it turns out when you start playing with the data set, you're going to get an error later on, and it'll say cannot convert string to float value. And that's because for some reason these things, the way they recorded them, must have been recorded as strings. So we have a neat feature in here on pandas to convert. And it is simply convert objects. And for this we're going to do convert underscore numeric equals true. And yes, I did have to go look that up. I don't have it memorized, the convert numeric in there. If I'm working with a lot of these things, I remember them, but depending on where I'm at, what I'm doing, I usually have to look it up. And we run that. Oops, I must have missed something in here. Let me double check my spelling. And when I double check my spelling, you'll see I missed the first underscore in the convert objects. And when I run this, it now has everything converted into a numeric value, because that's what we're going to be working with, is numeric values down here. And the next part is that we need to go through the data and eliminate null values. Most people, when they're doing small amounts, working with small data pools, discover afterwards that they have a null value and they have to go back and do this. So, be aware, whenever we're formatting this data, things are going to pop up, and sometimes you go backwards to fix it. And that's fine. That's just part of exploring the data and understanding what you have. And I should have done this earlier, but let me go ahead and increase the size of my window 1 notch. There we go. Easier to see. So we'll do for I in working with x dot columns. We'll page through all the columns. And we want to take x of I, and we're going to change that, and we're going to alter it. And so with this, we want to go ahead and fill in x of I. Pandas has the fill in a, and that just fills in any non-existent missing data. And we'll put my brackets up, and there's a lot of different ways to fill this data. If you have a really large data set, some people just void out that data and then look at it later in a separate exploration of data. One of the tricks we can do is we can take our column and we can find the means. And the means is in our quotation marks. So when we take the columns, we're going to fill in the non-existing one with the means. The problem is that returns a decimal float. So some of these aren't decimals. Certainly, we need to be a little careful of doing this, but for this example, we're just going to fill it in with the integer version of this. It keeps it on par with the other data that isn't a decimal point. And then what we also want to do is we want to double check. A lot of times you do this first part first to double check, then you do the fill, and then you do it again just to make sure you did it right. So we're going to go through and test for missing data. And one of the ways you can do that is simply go in here and take our x of I column. So it's going to go through the x of I column. It says is null. So it's going to return any place there's a null value. It actually goes through all the rows of each column is null, and then we want to go ahead and sum that. So we take that and we add the sum value, and these are all pandas. So is null is a panda command, and so is sum. And if we go through that and we go ahead and run it, and we go ahead and take and run that, you'll see that all the columns have 0 null values. So we've now tested and double checked, and our data is nice and clean. We have no null values. Everything is now a number value. We turned it into numeric. And we've removed the last column in our data. And at this point, we're actually going to start using the elbow method to find the optimal number of clusters. So we're now actually getting into the sklearn part, the k-means clustering on here. I guess we'll go ahead and zoom it up one more notch so you can see what I'm typing in here. And then from sklearn, we're going to, or sklearn cluster, we're going to import k-means. I always forget to capitalize the K and the M when I do this. So it's capital K, capital M, k-means. And we'll go ahead and create a array, WCSS equals, we'll make it an empty array. If you remember from the elbow method from our slide, within the sum of squares, WSS is defined as the sum of square distance between each member of the cluster and its centroid. So we're looking at that change in differences as far as a square distance. And we're going to run this over a number of k-mean values. In fact, let's go for I in range, we'll do 11 of them. Range 0 of 11. And the first thing we're going to do is we're going to create the actual, we'll do it all lowercase. And so we're going to create this object from the k-means that we just imported. And the variable that we want to put into this is in clusters. And we're going to set that equals to I. That's the most important one because we're looking at how increasing the number of clusters changes our answer. There are a lot of settings to the k-means. Our guys in the back did a great job just kind of playing with some of them. The most common ones that you see in a lot of stuff is how you init your k-means. So we have k-means plus plus. This is just a tool to let the model itself be smart how it picks its centroids to start with, its initial centroids. We only want to iterate no more than 300 times. We have a max iteration we put in there. We have the nth init, the random state equals 0. You really don't need to worry too much about these when you're first learning this. As you start digging in deeper, you start finding that these are shortcuts that will speed up the process as far as the setup. But the big one that we're working with is the in clusters equals I. So we're going to literally train our k-means 11 times. We're going to do this process 11 times. And if you're working with big data, you know the first thing you do is you run a small sample of the data so you can test all your stuff on it. And you can already see the problem that if I'm going to iterate through a terabyte of data 11 times, and then the k-means itself is iterating through the data multiple times, that's a heck of a process. So you got to be a little careful with this. A lot of times, though, you can find your elbow, using the elbow method, find your optimal number on a sample of data, especially if you're working with larger data sources. So we want to go ahead and take our k-means and we're just going to fit it. If you're looking at any of the sklearn, very common, you fit your model. And if you remember correctly, our variable we're using is the capital X. And once we fit this value, we go back to the array we made, and we want to go ahead and just append that value on the end. And it's not the actual fit we're pinning in there, it's when it generates the value you're looking for is inertia. So k-means.inertia will pull that specific value out that we need. And let's get a visual on this. We'll do our PLT plot, and what we're plotting here is first the x-axis, which is range 0, 11, so that will generate a nice little plot there, and the WCSS for our y-axis. It's always nice to give our plot a title. And let's see, we'll just give it the elbow method for the title. And let's get some labels. So let's go ahead and do PLT X label. And what we'll do number of clusters for that. And PLT Y label. And for that we can do, oops, there we go, WCSS, since that's what we're doing on the plot on there. And finally we want to go ahead and display our graph, which is simply PLT dot show. There we go. And because we have it set to inline, it'll appear inline. Hopefully I didn't make a type error on there. And you can see we get a very nice graph. You can see a very nice elbow joint there at 2, and again right around 3 and 4, and then after that there's not very much. Now, as a data scientist, if I was looking at this, I would do either 3 or 4, and I'd actually try both of them to see what the output looked like. And they've already tried this in the back, so we're just going to use 3 as a setup on here. And let's go ahead and see what that looks like when we actually use this to show the different kinds of cars. And so let's go ahead and apply the k-means to the cars data set. And basically we're going to copy the code that we looped through up above, where k-means equals k-means number of clusters, and we're just going to set the number of clusters to 3, since that's what we're going to look for. And you could do 3 and 4 on this and graph them just to see how they come up differently. It'd be kind of curious to look at that. But for this, we're just going to set it to 3. Go ahead and create our own variable, y k-means, for our answers. And we're going to set that equal to, whoops, a double equal there, to k-means. But we're not going to do a fit. We're going to do a fit predict is the setup you want to use. And when you're using untrained models, you'll see a slightly different, because usually you see fit and then you see just the predict. But we want to both fit and predict the k-means on this. And that's fit underscore predict, and then our capital X is the data we're working with. And before we plot this data, we're going to do a little pandas trick. We're going to take our X value and we're going to set X as matrix. So we're converting this into a nice rows and columns kind of setup, but we're going to have columns equals none, so it's just going to be a matrix of data in here. And let's go ahead and run that. A little warning. You'll see these warnings pop up because things are always being updated. So there's like minor changes in the versions and future versions. Instead of matrix, now it's more common to set it dot values instead of doing as matrix. But as matrix works just fine for right now. And you'll want to update that later on. But let's go ahead and dive in and plot this and see what that looks like. And before we dive into plotting this data, I always like to take a look and see what I am plotting. So let's take a look at y k-means. I'm just going to print that out down here. And we see we have an array of answers. We have 2, 1, 0, 2, 1, 2. So it's clustering these different rows of data based on the 3 different spaces it thinks it's going to be. And then let's go ahead and print X and see what we have for X. And we'll see that X is an array, it's a matrix, so we have our different values in the array. And what we're going to do, it's very hard to plot all the different values in the array. So we're only going to be looking at the first 2, or positions 0 and 1. And if you were doing a full presentation in front of the board meeting, you might actually do a little different and dig a little deeper into the different aspects, because this is all the different columns we looked at. But we'll only look at columns 1 and 2 for this to make it easy. So let's go ahead and clear this data out of here, and let's bring up our plot. And we're going to do a scatter plot here. So PLT scatter, and this looks a little complicated, so let's explain what's going on with this. We're going to take the X values, and we're only interested in y of k-means equals 0, the first cluster. Okay? And then we're going to take value 0 for the x-axis, and then we're going to do the same thing here. We're only interested in k-means equals 0, but we're going to take the second column. So we're only looking at the first 2 columns in our answer, or in the data. And then the guys in the back played with this a little bit to make it pretty. And they discovered that it looks good if it has a size equals 100. That's the size of the dots. We're going to use red for this one. And when they were looking at the data and what came out, it was definitely the Toyota on this. We're just going to go ahead and label it Toyota. Again, that's something you really have to explore in here as far as playing with those numbers and see what looks good. We'll go ahead and hit enter in there, and I'm just going to paste in the next 2 lines, which is the next 2 cars. And this is our Nissan and Honda. And you'll see with our scatter plot, we're now looking at where y underscore k means equals 1. And we want the 0 column and yk means equals 2. Again, we're looking at just the first 2 columns, 0 and 1. And each of these rows then corresponds to Nissan and Honda. And I'll go ahead and hit enter on there. And finally, let's take a look and put the centroids on there. Again, we're going to do a scatter plot. And on the centroids, you can just pull that from our k-means, the model we created, dot cluster centers, and we're going to just do all of them in the first number and all of them in the second number, which is 0, 1, because you always start with 0 and 1. And then they were playing with the size and everything to make it look good. We'll do a size of 300. We're going to make the color yellow, and we'll label them. It's always good to have some good labels, centroids. And then we do want to do a title, PLT title, and pop up there. PLT title, because you always want to make your graphs look pretty, and we'll call it clusters of car make. And one of the features of the plot library is you can add a legend. It'll automatically bring in it since we've already labeled the different aspects of the legend with Toyota, Nissan, and Honda. And finally, we want to go ahead and show, so we can actually see it. And remember, it's inline, so if you're using a different editor that's not the Jupyter Notebook, you'll get a pop-up of this. And you should have a nice set of clusters here. So we can look at this, and we have clusters of Honda in green, Toyota in red, Nissan in purple. And you can see where they put the centroids to separate them. Now, when we're looking at this, we can also plot a lot of other different data on here, because we only looked at the first 2 columns. This is just column 1 and 2. Or 0, 1 as you label them in computer scripting. But you can see here we have nice clusters of car make, and we were able to pull out the data, and you can see how just these 2 columns form very distinct clusters of data. So if you were exploring new data, you might take a look and say, well, what makes these different? Almost going in reverse, you start looking at the data and pulling apart the columns to find out why is the first group set up the way it is. Maybe you're doing loans and you want to go, well, why is this group not defaulting on their loans? And why is the last group defaulting on their loans? And why is the middle group 50% defaulting on their bank loans? And you start finding ways to manipulate the data and pull out the answers you want. So now that you've seen how to use k-mean for clustering, let's move on to the next topic. Now let's look into logistic regression. The logistic regression algorithm is the simplest classification algorithm used for binary or multi-classification problems. And we can see we have our little girl from Canada who's into horror books is back. That's actually really scary when you think about that with those big eyes. In the previous tutorial, we learned about linear regression, dependent and independent variables. So, to brush up, y equals mx plus c. A very basic algebraic function of y and x. The dependent variable is the target class variable we are going to predict. The independent variables, x1 all the way up to xn, are the features or attributes we're going to use to predict the target class. We know what a linear regression looks like, but using the graph we cannot divide the outcome into categories. It's really hard to categorize 1.5, 3.6, 9.8. For example, a linear regression graph can tell us that with increase in number of hours studied, the marks of a student will increase, but it will not tell us whether the student will pass or not. In such cases where we need the output as categorical value, we will use logistic regression. And for that we're going to use the sigmoid function. So you can see here we have our marks, 0 to 100, number of hours studied. That's going to be what they're comparing it to in this example. And we usually form a line that says y equals mx plus c. And when we use the sigmoid function, we have p equals 1 over 1 plus e to the minus y. It generates a sigmoid curve. And so you can see right here when you take the ln, which is the natural logarithm. I always thought it should be nl, not ln. That's just the inverse of e, or e to the minus y. And so when we do this, we get ln of p over 1 minus p equals m times x plus c. That's the sigmoid curve function we're looking for. Now we can zoom in on the function, and you'll see that the function as it derives goes to 1 or to 0, depending on what your x value is. And the probability, if it's greater than 0.5, the value is automatically rounded off to 1, indicating that the student will pass. So if they're doing a certain amount of studying, they will probably pass. Then you have a threshold value at the 0.5. It automatically puts that right in the middle usually. And your probability, if it's less than 0.5, the value rounded off to 0, indicating the student will fail. So if they're not studying very hard, they're probably going to fail. This, of course, is ignoring the outliers of that one student who's just a natural genius and doesn't need any studying to memorize everything. That's not me, unfortunately. I have to study hard to learn new stuff. Problem statement: to classify whether a tumor is malignant or benign. And this is actually one of my favorite data sets to play with because it has so many features, and when you look at them, you really are hard to understand. You can't just look at them and know the answer. So it gives you a chance to kind of dive into what data looks like when you aren't able to understand the specific domain of the data. But I also want you to remind you that in the domain of medicine, if I told you that my probability was really good at classified things at, say, 90% or 95%, and I'm classifying whether you're going to have a malignant or a benign tumor, I'm guessing that you're going to go get it tested anyways. So you got to remember the domain we're working with. So why would you want to do that if you know you're just going to go get a biopsy because, you know, it's that serious? This is like an all or nothing. Just referencing the domain, it's important. It might help the doctor know where to look just by understanding what kind of tumor it is. So it might help them or aid them in something they missed from before. So let's go ahead and dive into the code, and I'll come back to the domain part of it in just a minute. So use case, and we're going to do our normal imports here, where we're importing NumPy, Pandas, Seaborn, the Matplot library, and we're going to do Matplot library inline since I'm going to switch over to Anaconda. So let's go ahead and flip over there and get this started. So I've opened up a new window in my Anaconda Jupyter Notebook. And by the way, Jupyter Notebook, you don't have to use Anaconda for the Jupyter Notebook. I just love the interface and all the tools that Anaconda brings. So we got our import NumPy as in P for our NumPy number array. We have our Pandas PD. We're going to bring in Seaborn to help us with our graphs as SNS. So many really nice tools in both Seaborn and Matplot library. Then we'll do our Matplot library.pyplot as PLT. And then, of course, we want to let it know to do it in line. And let's go ahead and just run that so it's all set up. And we're just going to call our data, not creative today, equals PD. And this happens to be in a CSV file. So we'll use the pd.read_CSV. And I happen to name the file, I renamed it, data for p2.csv. You can, of course, write in the comments below the YouTube and request for the data set itself, or go to the Simplilearn website, and we'll be happy to supply that for you. And let's just open up the data before we go any further, and let's just see what it looks like in a spreadsheet. So when I pop it open in a local spreadsheet, and this is just a CSV file, comma separated variables, we have an ID, so I guess they categorize this for reference, or what ID, which test was done. The diagnosis, M for malignant, B for benign, so there's two different options on there. And that's what we're going to try to predict, is the M and B, and test it. And then we have like the radius mean or average, the texture average, perimeter mean, area mean, smoothness. I don't know about you, but unless you're a doctor in the field, most of the stuff, I mean, you can guess what concave means just by the term concave, but I really wouldn't know what that means in the measurements they're taking. So they have all kinds of stuff like how smooth it is, the symmetry, and these are all float values. We can just page through them real quick, and you'll see there's, I believe, 36 if I remember correctly in this one. So there's a lot of different values they take and all these measurements they take when they go in there and they take a look at the different growth, the tumorous growth. So back in our data, and I put this in the same folder as the code. So I saved this code in that folder. Obviously, if you have it in a different location, you want to put the full path in there. And we'll just do pandas first 5 lines of data with the data.head. When we run that, we can see that we have pretty much what we just looked at. We have an ID, we have a diagnosis. If we go all the way across, you'll see all the different columns coming across displayed nicely for our data. And while we're exploring the data, our Seaborn, which we referenced as SNS, makes it very easy to go in here and do a joint plot. You'll notice very similar to, because it is sitting on top of the plot library, so the joint plot does a lot of work for us. And we're just going to look at the first two columns that we're interested in, the radius mean and the texture mean. We'll just look at those two columns. And data equals data. So that tells it which two columns we're plotting and that we're going to use the data that we pulled in. And let's just run that. And it generates a really nice graph on here. And there's all kinds of cool things on this graph to look at. I mean, we have the texture mean and the radius mean, obviously the axes. You can also see, and one of the cool things on here is you can also see the histogram. They show that for the radius mean. Where is the most common radius mean come up and where the most common texture is. So we're looking at on each growth its average texture, and on each radius its average radius on there. It gets a little confusing because we're talking about the individual objects average, and then we can also look over here and see the histogram showing us the median, or how common each measurement is. And that's only two columns, so let's dig a little deeper into Seaborn. They also have a heat map. And if you're not familiar with heat maps, a heat map just means it's in color. That's all that means. Heat map. I guess the original ones were plotting heat density on something, and so ever since then it's just called a heat map. And we're going to take our data and get our corresponding numbers to put that into the heat map. And that's simply data.corr for that. That's a pandas expression. So remember, we're working in a pandas data frame, so that's one of the cool tools in pandas for our data. And let's just pull that information into a heat map and see what that looks like. And you'll see that we're now looking at all the different features. We have our ID, we have our texture, we have our area, our compactness, concave points. And if you look down the middle of this chart, diagonal, going from the upper left to bottom right, it's all white. That's because when you compare texture to texture, they're identical. So they're 100%, or in this case, a perfect 1 in their correspondence. And you'll see that when you look at, say, area, or right below it, it has almost a black on there when you compare it to texture. So these have almost no corresponding data. They don't really form a linear graph or something that you can look at and say how connected they are. They're very scattered data. This is really just a really nice graph to get a quick look at your data. It doesn't so much change what you do, but it changes verifying. So when you get an answer or something like that, or you start looking at some of these individual pieces, you might go, hey, that doesn't match. According to showing our heat map, this should not correlate with each other. And if it is, you're going to have to start asking, well, why? What's going on? What else is coming in there? But it does show some really cool information on here. I mean, we can see from the ID, there's no real one feature that just says, if you go across the top line, that lights up. There's no one feature that says, hey, if the area is a certain size, then it's going to be benign or malignant. It says there's some that sort of add up. And that's a big hint in the data that we're trying to ID this, whether it's malignant or benign. That's a big hint to us as data scientists to go, okay, we can't solve this with any one feature. It's going to be something that includes all the features, or many of the different features, to come up with a solution for it. And while we're exploring the data, let's explore one more area, and let's look at data.isNull. We want to check for null values in our data. If you remember from earlier in this tutorial, we did it a little differently where we added stuff up and summed them up. You can actually, with pandas, do it really quickly, data.isNull, and sum it, and it's going to go across all the columns. So when I run this, you're going to see all the columns come up with no null data. So we've just to rehash these last few steps, we've done a lot of exploration. We have looked at the first two columns and seen how they plot with the Seaborn, with a joint plot, which shows both the histogram and the data plotted on the XY coordinates. And obviously, you can do that more in detail with different columns and see how they plot together. And then we took and did the Seaborn heat map, the SNS heat map of the data. And you can see right here where it did a nice job showing us some bright spots where stuff correlates with each other and forms a very nice combination or points of scattering points. And you can also see areas that don't. And then finally, we went ahead and checked the data. Is the data null value? Do we have any missing data in there? Very important step because it'll crash later on. If you forget to do this step, it will remind you when you get that nice error code that says null values. Okay, so not a big deal if you miss it, but it's no fun having to go back when you're in a huge process and you've missed this step, and now you're 10 steps later and you got to go remember where you were pulling the data in. So we need to go ahead and pull out our x and our y. So we just put that down here, and we'll set the x equal to, and there's a lot of different options here. Certainly we could do x equals all the columns except for the first two, because if you remember, the first two is the ID and the diagnosis. So that certainly would be an option. But what we're going to do is we're actually going to focus on the worst radius, the worst texture, parameter, area, smoothness, compactness, and so on. One of the reasons to start dividing your data up when you're looking at this information is sometimes the data will be the same data coming in. So if I have two measurements coming into my model, it might overweigh them. It might overpower the other measurements because it's basically taking that information in twice. That's a little bit past the scope of this tutorial. What I want you to take away from this, though, is that we are dividing the data up into pieces, and our team in the back went ahead and said, hey, let's just look at the worst. So I'm going to create an array, and you'll see this array: radius worst, texture worst, perimeter worst. We've just taken the worst of the worst, and I'm just going to put that in my X. So this X is still a pandas data frame, but it's just those columns. And our Y, if you remember correctly, is going to be, oops, hold on one second. It's not X, it's data. There we go. So X equals data, and then it's a list of the different columns, the worst of the worst. And if we're going to take that, then we have to have our answer for our Y, for the stuff we know. And if you remember correctly, we're just going to be looking at the diagnosis. That's all we care about, is what is it diagnosed? Is it benign or malignant? And since it's a single column, we can just do diagnosis. Oh, I forgot to put the brackets. There we go. Okay. So it's just diagnosis on there. And we can also real quickly do like x.head if you want to see what that looks like, and y.head, and run this. And you'll see it only does the last one. I forgot about that if you don't do print. You can see that the y.head is just MMM because the first ones are all malignant. And if I run this, the x.head is just the first 5 values of radius worst, texture worst, parameter worst, area worst, and so on. I'll go ahead and take that out. So moving down to the next step, we've built our two data sets, our answer and then the features we want to look at. In data science, it's very important to test your model. So we do that by splitting the data. And from sklearn model selection, we're going to import train test split. So we're going to split it into 2 groups. There are so many ways to do this. I noticed in one of the more modern ways, they actually split it into 3 groups, and then you model each group and test it against the other groups. So you have all kinds of, and there's reasons for that, which is past the scope of this, and for this particular example isn't necessary. For this, we're just going to split it into 2 groups, one to train our data and one to test our data. And the sklearn model selection, we have train test split. You could write your own quick code to do this, where you just randomly divide the data up into 2 groups, but they do it for us nicely. And we can actually do it in one statement with this, where we're going to generate 4 variables: capital X train, capital X test. So we have our training data we're going to use to fit the model, and then we need something to test it. And then we have our Y train, so we're going to train the answer, and then we have our test. So this is the stuff we want to see how good it did on our model. And we'll go ahead and take our train test split that we just imported, and we're going to do X and our Y, our 2 different data that's going in for our split. And then the guys in the back came up and wanted us to go ahead and use a test size equals 0.3. That's test underscore size. Random state, it's always nice to kind of switch your random state around, but not that important. What this means is that the test size is we're going to take 30% of the data and we're going to put that into our test variables, our Y test and our X test. And we're going to do 70% into the X train and the Y train. So we're going to use 70% of the data to train our model and 30% to test it. Let's go ahead and run that and load those up. So now we have all our stuff split up and all our data ready to go. And now we get to the actual logistics part. We're actually going to create our model. So let's go ahead and bring that in from sklearn. We're going to bring in our linear model, and we're going to import logistic regression. That's the actual model we're using. And this, we'll call it log model. Oops, there we go, model. And let's just set this equal to our logistic regression that we just imported. So now we have a variable log model set to that class for us to use. And with most of the models in the sklearn, we just need to go ahead and do a fit on there. And we use our X train that we separated out with our Y train. Now let's go ahead and run this. So once we've run this, we'll have a model that fits this data, that 70% of our training data. And of course it prints this out that tells us all the different variables that you can set on there. There's a lot of different choices you can make. But for what we're doing, we're just going to let all the defaults sit. We don't really need to mess with those on this particular example. And there's nothing in here that really stands out as super important until you start fine-tuning it. But for what we're doing, the basics will work just fine. And then we need to go ahead and test out our model. Is it working? So let's create a variable yPredict. And this is going to be equal to our log model. And we want to do a predict. Again, very standard format for the sklearn library is taking your model and doing a predict on it. And we're going to test yPredict against the yTest. So we want to know what the model thinks it's going to be. That's what our yPredict is. And with that, we want the capital X test. So we have our train set and our test set. And now we're going to do our yPredict. And let's go ahead and run that. And if we print yPredict, let me go ahead and run that. You'll see it comes up and it prints a nice array of B and M for benign and malignant for all the different test data we put in there. So it does pretty good. We're not sure exactly how good it does, but we can see that it actually works and is functional. It was very easy to create. You'll always discover with our data science that as you explore this, you spend a significant amount of time prepping your data and making sure your data coming in is good. There's a saying, good data in, good answers out. Bad data in, bad answers out. That's only half the thing. That's only half of it. Selecting your models becomes the next part as far as how good your models are. And then, of course, fine-tuning it depending on what model you're using. So we come in here, we want to know how good this came out. So we have our yPredict here, logModel.predictXTest. So for deciding how good our model is, we're going to go from the sklearn.metrics, we're going to import classification report. And that just reports how good our model is doing. And then we're going to feed it the model data. And let's just print this out. And we'll take our classification report. And we're going to put into there our test, our actual data. So this is what we actually know is true. And our prediction, what our model predicted for that data on the test side. And let's run that and see what that does. So we pull that up, you'll see that we have a precision for benign and malignant, B and M. And we have a precision of 93 and 91, a total of 92. So it's kind of the average between these two of 92. There's all kinds of different information on here. Your F1 score, your recall, your support coming through on this. And for this, I'll go ahead and just flip back to our slides that they put together for describing it. And so here we're going to look at the precision using the classification report. And you see this is the same printout I had up above. Some of the numbers might be different because it does randomly pick out which data we're using. So this model is able to predict the type of tumor with 91% accuracy. So we look back here, you'll see where we have benign and malignant. It actually is 92 coming up here. But we're looking at about a 92, 91% precision. And remember, I reminded you about domains. So when we're talking about the domain of a medical domain with a very catastrophic outcome, at 91 or 92% precision, you're still going to go in there and have somebody do a biopsy on it. Very different than if you're investing money and there's a 92% chance you're going to earn 10% and 8% chance you're going to lose 8%. You're probably going to bet the money because at that odds, it's pretty good that you'll make some money. And in the long run, you do that enough, you definitely will make money. And also with this domain, I've actually seen them use this to identify different forms of cancer. That's one of the things that they're starting to use these models for, because then it helps the doctor know what to investigate. So that wraps up this section. We're going to go in there and let's discuss the answer to the quiz asked in Machine Learning Tutorial Part 1. Can you tell what's happening in the following cases? Grouping documents into different categories based on the topic and content of each document. This is an example of clustering where k-means clustering can be used to group the documents by topics using bag of words approach. So if you've gotten in there that you're looking for clustering, and hopefully you had at least one or two examples like k-means that are used for clustering different things, then give yourself a 2 thumbs up. B. Identifying handwritten digits in images correctly. This is an example of classification. The traditional approach to solving this would be to extract digit-dependent features like curvature of different digits, etc., and then use a classifier like SVM to distinguish between images. Again, if you got the fact that it's a classification example, give yourself a thumb up, and if you're able to go, hey, let's use SVM or another model for this, give yourself those 2 thumbs up on it. C. Behavior of a website indicating that the site is not working as designed. This is an example of anomaly detection. In this case, the algorithm learns what is normal and what is not normal, usually by observing the logs of the website. Give yourself a thumbs up if you got that one. And just for a bonus, can you think of another example of anomaly detection? One of the ones I use it for in my own business is detecting anomalies in stock markets. Stock markets are very fickle and they behave very erratic. So finding those erratic areas and then finding ways to track down why they're erratic. Was something released in social media? Was something released? You can see where knowing where that anomaly is can help you to figure out what the answer is to it in another area. D. Predicting salary of an individual based on his or her years of experience. This is an example of regression. This problem can be mathematically defined as a function between independent, years of experience, and dependent variables, salary of an individual. And if you guessed that this was a regression model, give yourself a thumbs up. And if you're able to remember that it is between independent and dependent variables and that terms, give yourself 2 thumbs up. Summary. So to wrap it up, we went over what is k-means. And we went through also the chart of choosing your elbow method and assigning a random centroid to the clusters, computing the distance, and then going in there and figuring out what the minimum centroids is and computing the distance and going through that loop until it gets the perfect centroid. And we looked into the elbow method to choose k based on running our clusters across a number of variables and finding the best location for that. We did a nice example of clustering cars with k-means, even though we only looked at the first 2 columns to make it simple and easy to graph. You can easily extrapolate that and look at all the different columns and see how they all fit together. And we looked at what is logistic regression. We discussed the sigmoid function, what is logistic regression, and then we went into an example of classifying tumors with logistics. I hope you enjoyed part 2 of machine learning.
In this video, we are going to learn how to automate Google Sheets using NA10. It is a very powerful workflow automation tool. We will start by setting up a webhook trigger to receive data from external sources, then connect it to Google Sheets to automatically store and update data in real time. By the end of this tutorial, guys, you will be able to capture form submissions, automate data entry without manual work, or set up live workflow that runs seamlessly. So whether you are a beginner or an automation pro, this tutorial is must-see for you. First, understanding what exactly is NA10. So I'm at the official website of NA10, and NA10 is an open source workflow automation tool that allows you to connect various applications like APIs and databases without writing extensive code. It provides a visual editor where you can create workflows by linking different nodes. Think of it an alternative to Zapier and Apache Airflow. But this tool has more control and flexibility, and also it has self-hosting capabilities. Now if you see, the key features of NA10 are as follows. It has this amazing visual editor where you can drag and drop nodes to create workflows. No complex coding is required. It has over 350 plus integrations, and it supports APIs, databases, messaging apps, AI tools, and cloud services. For example, you can think of like Google Sheets, Slack, Telegram, OpenAI, AWS, GitHub, MySQL. So it has integration to these tools. And apart from that, it has self-hosting and cloud options. You can run it on your own server for data privacy, also available as cloud service. It has also conditional logic and data transformation. It supports if condition loops, branching. You could also modify API responses, filter data, and perform calculations. And guys, this feature is very amazing. For real-time automation, it has webhooks. So n8n can receive data from webhooks to trigger instant actions. For example, when a form is submitted in Typeform and send an email via Gmail. So it can automate in real time. Now you'll be wondering, how does n8n works? Now let us try to understand how n8n works exactly. So you can think of n8n as a digital assistant that automates your task without requiring you to write complex codes. It basically works by connecting different applications, services, and database into a sequence of steps called workflow. So if you go and log in to the creators.n8n.io.dashboard, if you register for this n8n, you're going to get a workflow template. Okay, you can go all over here. And you can share your template with the template name and give a description about it. And this could be your template code, whether it is free or paid. You can just click on this. And after that, I have reviewed my submission guidelines of n8n terms and services. And then you can click this workflow. Now, let us try to understand what exactly is a workflow. But before that, let us try to understand nodes. Okay, so nodes are tiny workers that do specific tasks. You can consider this something like that. And workflows are a sequence of nodes working together to complete a job. Like for example, let us say we are sending an email when you get a new form submission. Imagine you have a Google form where people can contact you. So every time someone builds the form, you want to automatically send them an email. So in n8n, you can create a workflow like this. So a Google Forms node collects the new response and Gmail node sends an automatic email to the person who submits the form. So this is something like this. We'll be doing a one hands-on tutorial also to elaborate more about it. So this is one of the way how it works. Next, there is a concept of triggers. So there are trigger-based execution mode also, how to start your workflow. So you have to also understand, guys, that n8n workflows don't run all the time. They only start when something happens. So there are three ways to trigger a workflow. So the first one is trigger-based execution, okay, which is basically called as an event-driven. The workflow automatically starts when a specific event occurs. For example, let's say a new row is added to the Google Sheets. Now the workflow starts to run. Or you can think about it something like that. When a customer fills out a type form survey, the workflow runs. Think of it like a doorbell. When someone rings a bell, like for example submits a form or updates a database, the workflow wakes up and does its jobs. Next one, we have the schedule execution, or we call it as cron jobs. Now here the workflow run on schedule, like daily, weekly, monthly. For example, every Monday at 9 a.m., a report is generated and sent via email. Or every hour, n8n checks for new tweets and saves them. Think of this like an alarm clock. You set it once and it automatically rings at the right time. Now let us discuss about the workflow components, which are like the brains of the system. So every n8n workflow is made up of different types of nodes. And each node has a special role, just like team members working on a project. So whenever we trigger the node or start the workflow, so what happens exactly? First, there is a webhook node, which starts someone when, like for example, someone is sending a data to your API. Then there is a scheduler node, which starts at a specific time, like every morning at around 8 a.m. And then there is a type form trigger node, which starts when someone fills out a type form survey. So we'll try to cover all these things in this today's tutorial. Now, there are some also nodes, like we call them as action nodes, which basically perform tasks. So these nodes do not actually work in your workflow. For example, let's say send an email node or send an email via Gmail or Outlook. Or there is a HTTP request node, which fetches the data from an API like a weather update or something. Then there is a Google Sheet node, which like adds a new data to a spreadsheet.
So these are called as action nodes, which basically performs task. Then you could also understand a bit about, let's say, logic nodes, which adds intelligence. So these nodes allow you to add conditions and decision in your workflow. For example, let's say if node checks a condition is met, like for example is an email from a VIP customer. You can imagine something like this. Then there is a switch node which routes the workflow based on different cases. Like for example, the payment example is the best one. Like if the payment is failed, send a reminder. Otherwise, if it's successful, send a confirmation. And then you could also find out the loop node, which repeats an action multiple times, like sending a follow-up email every 3 days. So guys, these were some of the logics nodes which basically adds intelligence. And finally, we have the data nodes, which store and retrieves the information. These nodes basically help you save and manage data. For example, like Google Sheet node, which helps you to read and write data from my spreadsheet, or MySQL node, which stores customer data in a database, or Airtable node, which basically updates information in a table. Think of it like filing cabinet. It organizes and stores important documents or data for future use. So putting up all together, let's say you run an online store and you want to notify your team on Slack when a new order is placed in Shopify. So here is how your init and workflow would look like. There is a trigger node, like Shopify will trigger, like it is going to detect a new order. Then the action node is going to come up, which is going to fetch order details from Shopify. Then there is a logic node. If the order is above $1,000, it marks it as a high priority. An action node which basically sends a Slack message to your sales team. So this is like the entire process which runs automatically, saving your time and effort. Now guys, you would be wondering, why should you use n8n? See guys, there is no need for coding skills. You can just drag and drop nodes. It saves a lot of time by automating repetitive tasks. And it works with hundreds of apps and APIs like Google, Slack, Shopify, ChatGPT, etc. It also has self-hosting option which ensures privacy and full control. And finally, it is free and open source, unlike some other tools which have some strict limits. Now we are going to move forward and do a small hands-on to make you more understand about this platform. So guys, now let us create an automation using n8n. So first click on the first step. And let's say we want to use a trigger, let's say on a webhook call. So basically when we will be sending any HTTP request like get, post, put or delete, it is going to trigger our webhook on n8n. So just click on this and you could see our method is, let's say, post, and we want to post a data on using this post request. And after selecting this, guys, just click for listen for test event. Let's test our webhook API. Copy this and then you can go to this online tool which is called as Recubin. Okay. And it is just a very simple tool where you could just do one thing. You could paste the same URL which you have copied it from here. Okay. Now, after going all from here, what are you going to do? Just click on the send request. Now, you could see we have got a successful message that the workflow has started. But how to be sure of that this thing is working? Because in the output section, you will be seeing these kind of output. Okay. So our webhook API is working very much fine. Now, what next thing you could do? So the next thing, let's say, let us add a node all over here. So for example, let's add a Google Sheet. Okay. And let us trigger an API. Okay. Let us say append a row in a sheet, or we want to update a row. So now you could see all over here, we have this option called append or update a row from this list. And let's say we have this document called monthly expense. And you could also choose it, let's say, from expense. And we want to add these properties, what values to send. Suppose name, we could say the name as Neil, and all over here, that's one thing. Okay. Then what we could do, we could add another option, like what would be the cell format. And we could add the next property, let's say as email, let's say .com. Okay. Now we could test these steps. Okay. Now you could also say, let's add a column, okay, to name. Okay. And let's say we could add just one value. Then we could add another column, let's say email. Okay. Okay, we could write the name of another column. Okay, so we had only two columns that I have actually created all over here, name and email. So that's why our workflow is showing the same. And also, guys, there is one point to note. You have to also connect to your given applications. Okay, so I'll just show you how you could do it. But first, let us try to test this step. Okay, so okay, fine. We can choose it, match each column manually. And let's test the given step. Let's wait for the output. And if I open my Google Sheet, you could see, we can see, the name, email, and it's already mentioned here. So this is like how you are basically creating your workflow. So if you go back to your canvas, you could see our workflow has been created using the webhook call. Similarly, you can trigger a lot of, in a very different way. Suppose you could add a next node, like you could add AI and all those things, and you can create this automation using N8N. Guys, this is a very amazing tool, and this automation tool is definitely going to save a lot of time for you.
Introduction to agentic workflow from Simplilearn. So before moving on to creating the agentic workflow, let's first understand what is AWS Bedrock. So AWS Bedrock is a fully managed AI service that helps developers build and use AI-powered applications without needing to worry about setting up or managing complex infrastructure. So it gives access to pre-trained AI models from top providers like Amazon, Anthropic, Claude, Meta, Mistral AI, etc. So with Bedrock, you can create chatbots, text generators, summarization tools, and other AI-driven features without needing to train models from scratch. It also lets you customize AI models using your own data, add guardrails to ensure your safe and appropriate responses, and connect knowledge bases so the AI can provide more accurate answers. So since Bedrock is part of AWS, it also works smoothly with other AWS services, making it easy to integrate AI into your existing applications. So whether you're working to automate customer support, generate content, or enhance decision making, Bedrock provides a simple and scalable way to bring AI into your business. So now let's talk about serverless agentic workflows. So as AI-driven automation continues to evolve, businesses require intelligent agents that can understand user queries, retrieve relevant information, and take meaningful actions. So Amazon Bedrock introduces serverless agentic workflows, enabling organizations to build AI-powered assistants that interact with users, fetch real-time data, and execute business tasks, all without managing infrastructure. So in a traditional AI chatbot, the system typically responds to queries based on predefined answers or static knowledge. However, with serverless agentic workflows in Amazon Bedrock, AI agents can dynamically retrieve information and trigger actions, making them significantly more powerful than basic chatbots. So now let's explore how these workflows function, their key components, and their real-world applications. So when a user interacts with an Amazon Bedrock agent, the following steps takes place. First one is user input processing. So the agent receives a query from the user, such as, I need to return a laptop I purchased last week, can you help me? And the foundation model processes the input, extracts key information, and decides the next step. And the next step is information retrieval from a knowledge base. So if additional details are needed, the agent queries a knowledge base to pull relevant information. And the third step is action execution via AWS Lambda. So if the agent needs to perform an action, it calls an AWS Lambda function to interact with backend systems. So the function retrieves the order details, verifies eligibility, and processes the return request, for example. And number 4 is generating and sending a response. So the agent gathers the information and constructs a natural language response for the user. And finally, the session continuity and follow-up. So if the user asks another question, the agent continues the conversation while maintaining context. So the entire workflow runs on AWS infrastructure, allowing businesses to deploy AI-powered assistants without worrying about managing servers, scaling resources, or handling background execution. So here are some of the key components of serverless agentic workflows. So number 1 is Amazon Bedrock Agent. So the core AI assistant that interacts with users, understands their queries, and determines the best course of action. So it basically uses pre-trained foundation models from providers like Amazon, Mistral, etc. to process and generate response. And then it has foundation models. So these are large language models that power the agent's natural language processing capabilities. So the model helps the agent to understand questions, retrieve information, and generate responses. And then there are action groups. So action group define what the agent can do beyond answering questions. They allow the agent to execute functions, fetch data, and interact with APIs. So for example, retrieving customer orders from a database, processing refunds using an e-commerce system, or creating support tickets in a help desk platform. So each action group is mapped to an AWS Lambda function which handles the actual task execution. And then we have AWS Lambda for business logic execution. So since Bedrock agents are serverless, AWS Lambda is used to execute backend logic without managing infrastructure. So for example, a Lambda function can look up order history, verify eligibility, and initiate a return process. And another Lambda function can check support ticket statuses and provide updates. And fifth, we have knowledge bases for data retrieval. So a knowledge base helps an agent retrieve factual information from structured databases, FAQs, or documents. And then finally, we have guardrails for AI safety and compliance. So guardrails ensure the agent's responses remain safe, ethical, and appropriate by filtering out harmful, sensitive, or restricted content. So here are some of the real-world use cases of agentic workflows. So number one is for customer support automation. So a company can deploy a Bedrock-powered AI agent to handle customer service tasks like answering FAQs using a knowledge base, retrieving order details via an action group plus Lambda function, and initiating return requests and processing refunds automatically. It can also be used in IT help desk support. So an internal AI assistant can help employees troubleshoot technical issues such as checking server uptime using AWS Lambda, resetting passwords via an action group request, or submitting IT tickets automatically in support system. And it can also be used in HR virtual assistant. Like for example, a Bedrock agent can be used to assist employers with HR-related queries like fetching leave balances, processing leave requests, or providing company policy details. So basically, serverless agentic workflows in Amazon Bedrock unlock a powerful, scalable, and cost-effective way to build AI-driven automation. So these workflows represent a significant step forward in AI-driven automation, like allowing organizations to deploy intelligent, action-oriented AI assistants that go beyond simple conversation. So now in the coming chapters, we will see how to create agent with Amazon Bedrock, how to connect with CRM and perform calculations, and how to read an FAQ manual and a short Amazon Bedrock console walkthrough. So let's get started. Okay, but before we start, in this course, we have used the Claude 3 Haiku model. This is one of the latest AI models, and here is a quick look at its pricing. For Claude 3 Haiku, the cost is $0.25 per 1 million input tokens and $1.25 per 1 million output tokens. So throughout this course, we'll be using Claude 3 Haiku as a primary AI model. So alright, let's proceed with the course. Hello all, welcome to our first chapter. So in this chapter, we are diving into Amazon Bedrock to build a simple cloud-based agent. You'll also learn how to invoke the agent and trace its workflow through traces, giving you a clear view of how it happens. So let's get started. The first step, just like in every chapter, is importing the Bottle3 library. So this is basically AWS official SDK for Python, which we'll be using throughout the chapters. But before we start, we have to set up an environment to run the code. So first, let's set up the environment. Import OS. I'll be explaining you everything shortly. ARM is equal to OS dot environ Bedrock agent role. So basically, this code will reset the environment and prepare the resources. So let's just run this. Okay, sorry, there is a syntax error. Let's fix that. Yes, as you can see, it is resetting the environment. So the agent reset process is completed, Lambda reset process is completed, guardrail reset process is completed. We had discussed all these in the introduction chapter. So the environment is set. So now let's start working on it. As I already mentioned before, let's import the Bottle3. Import Bottle3. Now the next step is we have to create a client object. So basically we create a client object to interact with the different AWS services. So let's do that. So Bedrock agent is equal to 3 dot client service name is Bedrock agent, and we'll also provide the region name. So region name is US West 2. Now next we'll use this client to connect to the AWS and set up our agent there. So for your information, this code is configuring in a cloud-based agent that operates at production scale, so it won't be running in our notebook right now. So let's get started. So let's start by creating the agent. So this is actually pretty straightforward. We'll be using the Bedrock agent client and calling the create agent function. So let's write the code. So first, we'll be using the Bedrock agent client and calling the create agent function. So now let's, pass the parameters. Let's set up the parameters. So the first thing is we need to give our agent a name. We should call it something. So one thing to keep in mind is this name isn't something that the agent itself will recognize. It's just for our reference. So for example, I will name this one as laptop customer support agent. So now let's move on to the other parameters. First things first, we need to give our agent a foundation model. So basically this means selecting a specific large language model from Amazon Bedrock, which will handle the language understanding for how agent operates. So we'll paste the model ID over here. So the foundation model is Anthropic Cloud 3 Haiku. So now there are multiple models available, and you can find the full list in the AWS documentation, which I'll be showing in further chapters. So here we have set up with Anthropic's Cloud 3 Haiku. This is very small, fast and highly capable model. So the next step is we need to define the agent's behavior by providing it with instructions. Now these are also known as system prompts. So let's give the instruction. So we have given it the instruction that you are an advanced AI agent acting as a frontline customer support agent. So in this case, the agent is acting as an advanced AI assistant for the frontline customer support, especially for laptop businesses. Now that we have set up the model and instructions, there's just one more thing left for the configuration, that is the resource code. So predefined IAM role has already been created for us in this environment, and we are pulling in its ARN. ARN means Amazon resource name from an environment available. So basically this role defines the security permissions for our agent. Basically dictates which services the agent can access. So in this case, we are keeping the thing secure and minimal, following the principles of least privilege, meaning the agent only has access to necessary language model and nothing else. So let's set up that. And yes, we are good to go. As you can see, we have loaded this into a variable create agent response. Let's just check it. Yes. So as you can see, our agent is ready, it is created. So now you might have noticed that we haven't assigned any tools yet. So in Amazon Bedrock, these are called actions and they belong to action groups. So for now, we have built a basic AI-powered laptop support agent, and the next step is learning how to invoke and interact with it. So let's see how to do that. So as you can see, our agent status right now is in creating state. We have the agent ID, we have the agent name. So basically what happens next is the agent moves to a state called not prepared. So basically this is the full process the agent goes through. First state is creating, where the agent is being set up, which is happening right now. Then the second state is not prepared, where it exists but isn't ready yet. And the third one is prepared, where it's ready to use. So once it's prepared, we can create an alias for it. Alias is like a stable version of the agent that we can use in production. So because it lets us control updates, instead of changing the agent directly, we can manage different versions and keep things stable. But before doing anything else, we need to wait until the agent reaches the not prepared state, and that's when we can move forward. So now let's go ahead and store the agent ID in a variable. So basically I'm going to pull it from the response we created earlier, from the agent field where the agent ID is located. So let's do that. So agent ID, this is the variable. Create agent response agent ID. So this is really going to be very useful for us. Now we have to set up a few helper functions here. So for example, they'll help us wait for certain processes like transitioning to the prepared state, so we don't have to handle everything manually. And since we are working on laptop customer support, these functions will make it easier to manage tasks like checking the laptop's warranty status, troubleshooting hardware issues, and guiding customers through software fixes. So first, let's import the helper function. So from helper, let's first write the helper function and then I will explain the code to you. So wait for agent status agent ID is equal to agent ID. A target status is not prepared. So as you can see that the agent has reached the not prepared state, which is actually a good thing. That's exactly what we wanted. So it has basically transitioned from creating state to not prepared state. So now the next step is to prepare the code so it's ready to go. So let's do that. We want it to be in prepared state. So as you can see now the agent is preparing, agent stated is preparing. So we have used the Bedrock agent, which is the client, if you remember we set up earlier, and we have called the prepare agent function. So basically we need to tell it which agent we are working with. So we'll pass in the agent ID also. We have passed the agent ID, which we had already stored in a variable. And thus it has reached in the preparing state. Now our target is for prepared state. So let's just take this code and our target status is prepared. Let's see. So as you can see, the agent has reached the prepared state. But if you have noticed, as I showed you, it did briefly show preparing before it switched to prepared state. Now, as I mentioned earlier, the next step is to create an alias. And that is because we want to invoke the agent and have a conversation with it. So since the agent that we created is now prepared, we can go ahead and set up the alias. So let's do that. So let's move on to creating an agent alias using our Bedrock agent. Let's do that. Create agent alias. Response Bedrock agent. Create agent alias. Yeah. So to do this, we need to provide a few key details. So first, we have to specify the agent ID so that the system knows which agent we are working with. Along with that, we need to assign a name to the alias. So this name can be anything. For simplicity, we'll just call it my agent alias. So let's do that. First, let's specify the agent ID. Then let's set the agent alias name. Which is my agent So now once we have these details, we'll store the response from this operation in a variable, right? So this basically allows us to reference it later when we need it. So the process involves calling the create agent alias function, passing it both the agent ID and the alias name. So let's do that. For that, agent, alias ID is equal to create agent alias response. We have given the, we have passed on the agent alias and agent alias ID. So now before executing this, there's an additional step to ensure that everything runs smoothly. So we need to extract the agent alias ID from the response and store it in a variable. So this is important because we'll use it to track the alias status. So to make sure that the alias is properly set up, we'll use a helper function that waits for the alias status to transition to prepared. So let's write the helper function also. Let's include the helper function also. So yes, this is the helper function. So we have already talked about helper functions earlier. So now let's execute the code and see what happens. So as you can see, everything is working as expected. The alias transitions into the prepared state, which is exactly what we were waiting for. Now that the alias is ready, we can actually start using the agent. So with prepared alias, the agent is now in a functional state, meaning that we can interact with it. So let's move on and see how to put it into use. So now to interact with the agent, we need to create a new client specifically for this purpose. So we'll be using bot23 to initialize it. So let's create a new client as we have done earlier. As you can see, we have, specified the service name and we have specified the region. Then we have stored this client in a variable. So let's run this. Now that we are ready to move forward and actually invoke the agent. So for that, we have to write a few lines of code. So first you have to import UUID. So we'll be calling the invoke agent method for our Bedrock agent runtime client, which is essentially all that's needed to start a conversation with the agent. So let's write the code first and then I'll explain it to you. So as you can see, this is the message that I've given as a customer that, hello, I bought a laptop from your store yesterday. There is an issue with the display and I want to return it. So as you can see, we have specified which agent it is by giving the agent ID. Similarly, we also passed the agent alias ID, which we had saved earlier in the process. And finally, we gave the message also. So at this stage, the agent doesn't have any actions configured, meaning it won't actually be able to troubleshoot the issue. However, it should still generate a response based on whatever logic it has available. So in addition to the message that we have given, we also have given a session ID. We have to establish a session ID to maintain the conversation, right? So you might have experience chatting with a, customer support agent, and you might have noticed that, there's a session ID and there's a session for each and every conversation. So once you end the conversation, when you're starting a new conversation, it's separately a new session. So similarly here also, we need to establish a session ID to maintain the conversation. So we have generated a unique ID using Python's UUID module, and that's why we have imported UUID first. So basically this ensures that each session is uniquely identifiable and the conversation history will be stored in the cloud, so we don't have to manage it ourselves. So here we have kept end session false, which means this keeps the conversation active instead of losing it after one exchange. And enable trace is true, which means this, and enable trace for now, let's keep it as false. Yeah, which means this disables request tracing for now, but we can explore it later. So let's just run this. Agent response. So as you can see, we have run the code over here. And as we print the response, you'll see that it doesn't display like a normal text response. And that's because it comes back as an event stream instead of a simple message. So since we can't just print it directly, we need to extract the actual response from the stream. So to do that, we'll pull the relevant data from the event stream, which will allow us to see what the agent actually said. So let's do that. Let's write a piece of code. Event stream is equal to invoke agent response completion. Put event I. Event string, just print event. So as you can see, when we do this, we'll see that there's only one main event returned, and this event is called chunk. And inside it, we have some data, specifically bytes and a response from the agent. So basically, the agent has responded that I'm sorry, but I'm unable to assist you with the return process for your laptop at this time. Please contact our customer support team directly and they will be able to help you with it. So this message makes sense because right now the agent doesn't have any actions set up. It knows it's supposed to have some functions, but since we haven't defined any, it simply acknowledges its limitations. But how does the agent figure this out? And how does it do the necessary action? So for that, to get a clear picture, we have to enable the trace mode. So earlier we have disabled the trace mode by keeping it false. So we have to enable it by making it true. So this will start a new session. It will reset everything and allow us to have another conversation with the agent. And this time with more insights into how it generates its response. So let's go ahead and do that. So as you can see here, I have enabled the trace and I've printed it. Here, as you can see, we can find some familiar details like they have given the agent ID, the session ID. They have given so many details. And I'm just finding the final response over here. As you can see, it has given a final response. To initiate the return process for your laptop with the display issue, please gather the following information: date of purchase, order number of receipt, description of issue. So as you can see, first it said that, I am unable to help and please contact, some customer support agent, like, some human customer support. But as you can see now, it actually, gave us an answer that I want, some details like date of purchase, order number or receipt, etc., so that we can initiate the return process. So with this in place, we are now ready for the next step, which is adding actions to the agent so that it can actually perform some useful tasks. So we'll see that in the next chapter. So now that we have a basic agent set up and running, it's time to take things a step further. So in this chapter, we'll connect the agent to external services, allowing it to interact with the outside world. We'll simulate integrating it with a CRM system where it can retrieve customer details, log support tickets. So this will make our customer support agent more functional and bring it closer to real world use case. So let's see how it works. So first things first, let's set up the environment. Do that. So as you can see, the environment is being set up. This will take some time. Now next we need to import the required libraries. We'll start with module 3 to interact with AWS services. Import module 3. We also bring in UUID, which we discussed in the earlier chapter, which helps us create unique session IDs. And also we'll import some helper functions. So let's do that. Import UUID from helper. Import all. So since our environment variables are already set up, we're all set to go. So the agent from the last chapter, from the last environment, is still running. So we can continue using it. And this time we'll give more detailed instructions because we have added a few extra components. So now let's start testing and see how it works. So firstly, I'll generate a new session ID and set up another message similar to what we used in the previous chapter. Let's set up the session ID first. Session ID equal to and let's give a new message. For example, let's give my name as Leah. My laptop has display issue and I want a refund. So once that's defined, we'll use a helper function to check the responses and see what happens. So we'll call invoke agent and use a print helper function to send a message and check responses. So let's do that. Invoke agent and print. Again, we have to specify our agent ID. Input text is the message. That is one more thing. Agent alias ID is equal to agent alias ID session ID. So as you can see, this is what our response is. This actually looks like a chat format. We said that my name is Leah, my laptop has display issues and I want a refund, and the agent has responded by saying that it's sorry, but it doesn't have enough information to process our request for a refund at this time, and all the details. So now what we need to do is we need to connect our agent to some other tools to make it more useful. And in Amazon Bedrock agents, these tools are called actions and action groups. These allow the agent to perform tasks beyond just responding with text. So the logic behind these actions is handled through AWS Lambda functions. So basically the Lambda function serves as the invocation point where the agent sends requests when an action needs to be performed. So when the agent calls this function, passes an event that contains key details like agent's name, action group name, specific function, and any parameters. So let's do that now. Let's write the code first and then we'll explain. So to connect our agent with tools, we need to define an action group using the Bedrock agent client. So this action group will allow the agent to perform tasks by interacting with an AWS Lambda function. So first let's create the client like before. So we have done that. The service name is Bedrock agent, region name. We're not specifying the region right now. Now next step is to set up the action group. So yeah, now let's see what the code is. So we have started by naming the action group. The action group name is customer support actions, and this is just for our reference. Now the next thing is we link it to our agent by providing the agent ID from our environment variables, and we specify the Lambda function that will handle the logic using the ARN. Now after that, we have defined the actions. Like for example, inside the action group, we define functions the agent can call. For example, the first one is customer ID lookup. So this function retrieves a customer ID based on details like email, name, or phone number, and the agent must send at least one of these details to proceed. Now the parameters are described in natural language so that the agent understands their purpose. Now the next function, the second function is send to support. So basically this function escalates the issue to a human support team. Like for example, if the agent that we created is not able to respond, so it will escalate the issue to a human support team. It requires both a customer ID and a support summary, and if the agent doesn't have a customer ID, it will first fetch it using the customer ID lookup function. So this is what these two functions does. Now before sending the request, we have specified the agent version as draft. It means that it applies to the current agent setup. So once everything is set up, we have created the create agent action group response. This is a variable, create agent action group response, and we have stored the response in this variable. So let's look at the output. Create agent action group response. So as you can see, we have executed the request and we have our response. So this includes an action group ID, it has the action group state, which is enabled. And before we proceed further, we need to ensure that the action group is fully enabled. So although it's already enabled, as you can see in this case, we'll add a helper function to wait for the state. So this will ensure that, if we run the entire script from top to bottom, everything works smoothly without any timing issues. So let's add that helper code. Let's do that. So first we need to extract the action group ID. That's what we have done here. We have to extract the action group ID from the response, which will allow us to reference it later. Next, we'll give our helper function, like how we have given helper functions before. As you can see, the target status that we want is enabled. So now that we have made a change to the agent, we also need to prepare the agent again to apply the updates and update the alias so it reflects the latest version. So let's do that. Again, we'll be using helper functions for that. It's enabled. Now we want it in the prepared state. Agent is prepared, and next is we have to update the alias. So let's do that. So the agent alias has also reached the prepared state. So basically we have, as you can see here, we have used the prepare agent function. So now the alias is fully updated and the agent is ready to use. So now, we can start performing tasks and we can just test it by giving a message. So again, first, before giving the message, we are going to reset the session ID. So let's reset the session ID and let's give a different message, including an email address. So my name is Leah, and we'll just give a dummy email ID like Leah at leah.com. My laptop has display issues. And I want a refund. So this time I've also included, as you can see, the email address. Now the thing is, with this email, the agent can confidently match it to the customer ID. So in this case, it will just be a random number, of course. So this helps simulate a real customer support interaction. So now let's run and see what happens. So first I'll give a helper function and call invoke agent to send the message and print the response. So firstly, we'll just write the helper function, invoke agent and print. We'll pass on the agent ID. Agent alias ID. Just copy paste it because we have already used this function before. And right now we have kept the enable trace as false. So as you can see, it has given the chat, the user, a query and the agent response. So it has said, hello Leah, I'm sorry to hear you are having issues with your laptop display. So to better assist you, could you please provide some more details about the specific problem you're experiencing? So right now, as we gave the email, it might have already got the customer ID. So now it's asking about more issues. Like what's the specific problem you are finding and what is the, purchase date and everything. And also at the end, it has asked that please let me know and I'll help you to escalate this to our customer support team if needed. So this is what our agent has responded with. Now let's just keep the enable trace as true and see what happens. So as you can see here, you can, see the user query, the final response, and the thing is you can also see the agent's thought process. So this is basically thought process that's going on with the agent, which means, okay, let me review the details we have so far. It has taken the customer name, customer email, the issue, the request. Issue is that the laptop has display issues. The request is that, we want a refund. And it has processed that it still misses some key details to fully process the refund, such as order number or purchase data of the laptop. So without these details, I won't be able to properly escalate this to the support team. So let me ask the user about it, and that's what it has done over here. So as you can see, so far we have built an agent that responds effectively and uses tools to process customer support cases. It can retrieve a customer ID and log a support request, making it much more functional. This chapter will be seeing what are guardrails in AWS Bedrock. Hello, also in this chapter we will talk about what are guardrails in Amazon Bedrock. So what are guardrails? So basically, guardrails in Amazon Bedrock are a set of safety measures that help ensure AI-generated responses are safe, ethical, and appropriate. Act as filters and restrictions that prevent the AI agent from generating harmful, biased, or restricted content. So guardrails are essential for regulating AI behavior, especially in customer support, healthcare, finance, and other sensitive domains, where AI-generated responses must adhere to compliance standards. So now let's see how the guardrails work. So when an AI model generates a response, guardrails analyze the output before sending it to the user. If the response contains restricted, offensive, or policy-violating content, the guardrails block or modify the response. So the guardrails in Amazon Bedrock can be customized based on business requirements. So users can define content filters to block inappropriate language, deny topics that the AI cannot discuss, and harmful category filters to prevent responses related to violence, hate speech, self-harm, or explicit content. So these itself are some of the key features of guardrails. In content filters means it can filter and scan AI responses for profanity, hate speech, or offensive content and block them before they reach the user. In denied topics, predefined topics that the AI is not allowed to discuss. Example, political opinions, personal health advice, financial investment recommendations, etc. And then comes harmful categories, where adjustable safety settings for restricting responses related to hate speech, self-harm, violence, harassment, and adult content. And then it has custom word filtering, where users can define a list of restricted words or phrases that the AI should not generate in its responses. And then we have custom guardrails via AWS Lambda for advanced use cases. Custom logic can be implemented by using AWS Lambda to validate and modify AI responses dynamically. So now let's see how we can implement guardrails in Amazon Bedrock with some code examples. So there are basically 4 steps. So the first step is to create a guardrail. So this is the code for that. So to create a guardrail in Amazon Bedrock, you have to use the AWS SDK, which is Boto3 for Python, to define the content filtering, restricted topics, and sensitivity levels. So basically, this code creates a guardrail named Customer Support Guardrail, as you can see. And it filters harmful language, it blocks specific words, example, fraud, scam, illegal. It restricts discussions on specific topics like politics, religion, and investments, and it applies different safety levels to content categories. Now the next step is to associate guardrail with an AI agent. So once a guardrail is created, it needs to be attached to an Amazon Bedrock agent to enforce content filtering in AI responses. So this step ensures that the AI agent follows the guardrail rules and does not generate restricted content. And next we have testing guardrails by invoking the AI agent. So we can test if the guardrail works by sending a sample query to the agent and check its response. So as you can see in this code, if the guardrail is applied correctly, the AI agent will refuse to provide investment advice and respond with a safe and predefined answer, such as, I'm sorry, but I cannot provide financial investment advice. And finally, we have step 4, which is fine-tuning guardrails. So if the AI agent still provides undesired responses, you can adjust the guardrail by modifying the sensitivity levels or adding new denied topics. So in this code, the AI agent will not respond to financial or medical related queries, ensuring compliance with regulations. So now, why are guardrails so important? Number one, to prevent AI misuse. So guardrails restrict AI generated responses, preventing harmful, biased, or unethical replies. Next is to ensure regulatory compliance. So industries like finance, healthcare, and legal services must comply with strict rules. So guardrails help prevent AI from providing unauthorized advice. And then to enhance customer trust. So well-configured AI assistant maintains brand integrity by ensuring all the responses align with company policies and ethical guidelines. And finally, to reduce AI risks. So guardrails act as a safety net, reducing the risk of AI-generated misinformations, hate speech, or offensive content. So basically, guardrails in Amazon Bedrock are a critical feature for ensuring AI models generate safe, ethical, and policy-compliant responses. By implementing content filters, denied topics, and harmful category restrictions, businesses can control AI-generated output and protect user interactions. And by using AWS Lambda and customizable filters, developers can further fine-tune guardrails based on business needs, whether it's preventing AI from giving financial advisors, blocking offensive language, or ensuring customer support consistency. Guardrails help maintain AI reliability and trustworthiness in real-world applications. So that was it about guardrails. Now in the next chapter, we'll take it a step further by making the agent smarter. So instead of immediately forwarding requests to support, it will perform calculations before sending them. So let's get into it and enhance its decision making. All, welcome to the next chapter where we are going to give our agent a code interpreter. So this means the agent will be able to perform accurate calculations by writing and running temporary Python code to support its responses. So let's dive in and see how it works. And before that, as we mentioned in all the chapters, let's run the code to set up an environment. So let's do that first. Let's set up the environment. So first, I'll load all the necessary libraries. Same as before, we need the bottle 3. We need UUID. And we need to import the helper functions. So once that's done, the next step is to create a client, a Bedrock agent client. Same as before, so let's do that. Done. So right now the agent in our environment is the same that we used in the last chapter. So to enhance its capabilities, we'll update it and integrate the Amazon Bedrock agent with new features. So let's write the code. So let's see what this code is. So this code basically updates an existing action group in Amazon Bedrock by modifying its function schema and adding a new function. So first we have the function called update agent action group. So this function is called to modify the agent's action group. So this ensures the agent can execute the necessary actions when handling customer support requests. And then we have set up the code parameters. As you can see here, we have the action group name, which is customer support action. So this names the action group. We have kept it same as before. The action group state is enabled. So since we are modifying the action group, we explicitly set its state to enabled. So by default, an action group is enabled upon creation, but when updating, we must manually specify the state to keep it active. And then we have given the action ID group, the action agent ID. And as you can see, the agent version is in draft. So this update applies to the draft version of the agent because Bedrock allows multiple agent versions. So changes are first applied in the draft state before being finalized. After that, we have the Lambda function, ARN. So the agent will execute actions using a Lambda function. So the Lambda function ARN is stored in the Lambda function ARN variable. Now after that, we have defined the function schema. So inside the function, as you can see, inside the function, we have 3 other functions. The first function is customer ID function. So this function helps the agent identify a customer based on the available details. So as you can see, this is the description just given. Get a customer ID, given available details. At least one parameter must be sent to the function. This is private information and must not be given to the user. So what this means is that the agent can look up a customer ID but must not share it with the user. So at least one parameter is required. It can be email. These are the parameters. It can be email, name, or phone number. And then you have the send to support. So if the agent cannot resolve the issue, it can pass a request to your human agent. And then we have a new function, an updated function, which is called purchase search. So here they have given the description that search for and get details of a purchase made. Details can be used for raising support requests. You can confirm you have this data. Like for example, I found the purchase, or I can't find the purchase, so and so. So basically the agent can search for purchases and confirm whether it found the record. So however, private information like order numbers must not be shared. And as you can see, these are the parameters given over here. The first parameter is the customer ID. The second parameter is the product description. And the third parameter is the purchase date. As you can see, the purchase date, the date of purchase should be in this format: year, month, and date format. So basically, this function helps the agent verify past purchases before escalating the case. Before escalating the case, the agent must verify that, if the query is real or not. So for that, this helps. So now once everything is set, we have stored it to this variable, which is update agent action group response. So basically running this agent ensures that it retains previous functions, adds the new function. As you can see, these customer ID and send to support function we had already used in the previous chapter. So the new function that we have added is a purchase search function. So let's run this. Now next, let's extract the action group ID from the update response. So let's extract the action group ID. So here the variable update agent action group response contains a response from the update agent action group function, which we used before. So the response has a nested structure where the action group ID is inside the action group. So this line retrieves the action group ID from the response and stores it in an action group ID, which is for later use. So action group is enabled, action group status is enabled. So now let's give it a different message. We can give something like first we'll give the email, and then we'll say I bought a laptop 5 weeks back and now it has a display issue. I want a refund. So as you can see, the message has mentioned the date in weeks. So here we have already mentioned in the function that we need it in this format, year, month, and date format. But right now we have given it as 5 weeks back. So as you can see, we have to do something. So we got to update our agent. So next we have to add a code interpreter to deal with date. So let's do that. Okay. So this code enables the agent to execute Python code dynamically by creating a code interpreter action group. As you can see, this is the code interpreter action group. So the process involves 3 key steps. The first one is creating the code interpreter action group. So the function over here, create agent action group, is called to create a new action group named code interpreter action. So an action group defines a set of tasks that an agent can perform, and in this case, it enables the agent to execute Python code using the Amazon Bedrock's code interpreter feature. So now let's just move on to some key parameters over here. As you can see, again, we have the action group name, we have the action group status, agent ID, agent version, which is still in draft. And then we have the parent action group signature, which is Amazon code interpreter. So basically, this links this action group to Amazon Bedrock's pre-built code interpreter. This enables the agent to execute Python code dynamically, supporting use cases such as calculations, data analysis, and automation. So why this is important is because Amazon Bedrock provides built-in action groups like this, like for example, Amazon Code Interpreter to handle common AI tasks. So by referencing Amazon.code interpreter, the agent gains the ability to process and run Python code without needing custom Lambda functions. And after that, we are extracting the action group ID over here. So this ID uniquely identifies a newly created code interpreter action group, and it is stored in the code interpreter action group ID for later use. And then we have given a helper function, which is used to pause execution until the action group is fully ready. So the next step is to prepare agent and alias to add new action group. So let's do that. So first let's prepare the agent. Prepare agent response. Agent. Prepare agent. Agent ID equal to agent ID. Now let's just copy the function. The target state is prepared, and let's run this. Okay, there is some error over here. Let me just fix it. As you can see, it is waiting for first. It waited for agent status of prepared. Then finally, it has reached the prepared status. Now, once that's done, our next step is to update the alias. So let's do that. Bedrock agent update agent alias. We are going to update the alias. Agent ID is equal to agent ID. We have to give the agent alias ID. And we'll keep the agent alias name as test. And once that's done, wait, let me just format it. Yeah, once that's done, let's just paste our helper function. And let's run the code. So as you can see, our agent alias has also been updated and reached the prepared state. So now let's set a session ID and write our message again. So first let's set the session ID. Session ID strUID. Yes. And we'll rewrite our message. Oh, where was our message? Yeah, this is our message. So let's rewrite this. Let's run it. Now let's write a code which prints its response. I'll write the code first and then get into detail. Invoke agent and print. Again, here we have the agent ID, agent alias ID, input text, which is a message, and the session ID. And here we have given enable trace as true. So we have run it. So basically the invoke agent and print function, it sends a message to the agent and retrieves a response. Again, here we have kept the enable trace as true. So this is the response. We have the agent's thought process, invocation input, again agent's thought process, and finally here we have the final response where it has said that I have reviewed your request and found that you purchased a laptop approximately 5 weeks ago. Since this is within the typical refund period, I've routed your request for a refund to our support team. So they will review the details and get back to you shortly. You can also reference support case. They have also given an ID sort of thing for, our ticket or our case. So as you can see, what it has done is, let's see the agent's thought process. So the agent's thought process was that the purchase search tool found a purchase for this customer that matches the details provided. So now I need to calculate the purchase date to determine if it is within the refund period. So first, to know that, because we haven't given it the correct date, we have given it 5 weeks ago. So to determine if it is within the refund period, it has to, come up with the correct date. So what it has done is, it has actually used a Python REPL to calculate the purchase date from 5 weeks ago, and basically it has calculated the date over here, and then it has come up with the conclusion, the final response, that it is within the typical refund period. Now let's look at another code with another session ID. So we'll give it the same message. Where is the message? Yeah. Next, let's set up the client. Basically, now we want to retrieve the response in streaming format. So for that, first we have to invoke agent response. We have that over here. And next we have to create the event stream. So event stream, invoke agent response completion. So for event, in event stream, if the chunk is in the event, print this, else print this. So this kind of looks cluttered. Let me just format it a bit. So as you can see, what happens here is, you already know the invoke agent response and the invoke agent function. Here in this particular part of the code, the loop iterates over the event stream and checks for chunk responses. So if the event contains chunk, like for event contains chunk, the response data is stored in bytes. As you can see in this part, the response data is stored in bytes format, so it must be decoded into a readable string. And the decoded text is formatted as JSON and printed. And for other event types, any metadata or function related events are printed as it is for analysis. So tracing provides insights into how the agent processed the request, and the conversation remains open, allowing continued interaction. So now let's move on to the output. As you can see, this is a pretty big output, so you can take time and see what it is. I will just give you a gist about it. I'll just give you a gist about it. So basically the output represents a trace log of the Amazon Bedrock agent's orchestration process while handling this case. So as you can see, it has all the history, like the agent has been acting as a frontline customer support service, and it has taken requests from a customer named Leah who reported a display issue with a laptop 5 weeks ago. So basically the trace shows the agent's step-by-step reasoning and its function calls, beginning with retrieving customer ID using the provided email, then searching for purchase details using purchase search function which we used, and finally escalating the issue to the support team with the send to support function that we used. So the AI adheres to strict guidelines, ensuring accuracy and compliance by leveraging the Python REPL for date calculations and enforcing guardrails to prevent incorrect assumptions. So it also includes model invocation inputs, function calls, API responses, and trace logs, confirming that the request was successfully processed. And as you can see, finally, the agent has also given a final response. Like, I have reviewed Leah's purchase details and routed her refund request to our customer support team. The support team will be in touch with Leah shortly to assist her further with the display issue, so and so. And please let me know if you need any further assistance. So as you can see, the last portion of the output confirms that the response has been finalized and delivered, ensuring smooth AI-driven automation customer support workflows. That was it about this chapter. Now in the next chapter, we will see how to connect this agent to a repository of customer support documents. Hello all, welcome to the next chapter. So in this chapter, we will see how to connect the agent to a repository of customer support documents that discusses simple issues the agent can resolve. So once it is connected, the agent can resolve some issues directly and redirect others to human workflow. So let's start by importing the necessary basic codes and inputs. So the first step, of course, is to run the code to set up the environment. So let's do that. Next, let's import Auto3. Here we also need to import JSON. And let's import the help functions. Next, let's create the client. Rock agent is equal to auto3.client. The service name is Bedrock agent. Region name, we'll keep it as US West 2. Next, let's write the code to retrieve details about the existing agent in Amazon Bedrock. So for that, describe agent response is equal to Bedrock agent dot get agent. Inside, we'll give the agent ID. So basically the function getAgent is used to fetch metadata and configuration details about the specific Bedrock agent. So now let's run the code. For that, let's print the response. So print JSON dumps describe agent response. Agent is equal to 4. Default here that's string. So this is the response So basically, this code prints the agent details retrieved from the Amazon Bedrock in a structured and a human-readable format. The function JSON dumps over here is used to convert the dictionary stored in describe agent response into a JSON formatted string. So since API responses often return nested data structures, formatting them properly helps in analyzing and debugging the output basically. So the ident is equal to 4 parameter ensures that the JSON output is visually structured with proper spacing, making it easier to read. So without identation, the response would be printed as a single long line, which is difficult to parse manually. And additionally, default is equal to str is included to handle any non-serializable objects such as timestamps or special data types. So by converting them into strings before printing. So this prevents errors that may occur if the response contains complex data structures that cannot be directly serialized into JSON. So when executed, this command provides a clear view of the agent's configuration, including its name, as you can see, its status, version, associated action groups, and execution settings. So this output is valuable for verifying whether the agent is correctly set up, checking its state before making modifications, or troubleshooting issues related to its configuration. So by displaying all relevant details in an organized manner, this step simplifies debugging and ensures that the agent is functioning as expected. But as you can see here, they have all the informations, including the instructions. So what we can do is let's take that and print it separately. So for that, we'll write another piece of code, which is print describe agent response agent and in instruction. So as you can see, this line of code retrieves and prints the agent's instruction from the API response. So the describe agent response dictionary contains various metadata about the agent, and within it, the agent key holds the main details. The instructions field over here specifically stores the system prompt or predefined guidance that tells the agent how to behave and respond to queries. So as you can see, it has an instruction. First, it has an instruction over here. It has just printed an instruction from the previous output, which is you are a frontline customer support agent for a company and your role is to process customer messages and so and so. And also it has given guidelines for processing customer messages. So first you have to analyze the customer's message to understand their issue. Then you have to determine the appropriate action. You have to use appropriate tools. You have to provide a summary, a clear and concise summary of analysis. And then again, for handling issues based on complexity, there are two types. Like if it's complex issues or those requiring human intervention, or then there are simple issues or general product usage questions. So this is just the instruction printed. So if you go through the output, you'll realize there is lack of knowledge base. Okay, so like they have given the instruction, they have given the guidelines, but still there is a lack of knowledge base. So our next step is to add the knowledge base. So let's do that. Let's write that piece of code. So get knowledge base response agent get knowledge base. Sorry. Knowledge base ID is equal to knowledge base ID. So as you can see, this code retrieves information about a knowledge base linked to the Amazon Bedrock agent. So knowledge base is basically a collection of stored informations like FAQs or company guidelines that the agent can use to give better responses. So this function over here, get knowledge base of, is called with knowledge base ID, which ensures that the correct knowledge base is assessed. The response is then stored in the get knowledge based response, which contains details such as knowledge base name, status, description, and stored documents. So running this function helps check if the knowledge base exists Is it active and properly linked to the agent? So this is useful for troubleshooting cases where the agent is supposed to retrieve information but isn't responding quickly. So now let's just print this and see. Print JSON dumps. Get knowledge base response. Content is 4. So as you can see, we have printed and the response contains a lot of configuration. Now next, let's connect this knowledge base with our agent. So to do that, first let's type the code and then we'll see how it works. Associate agent. Base response is equal to agent associate agent knowledge base. We have to provide the agent ID, the knowledge base ID, the agent version, which is draft, and the description, which is my knowledge base. We'll give it as my KB. Just format this a bit. So as you can see, this code links a knowledge base to an Amazon Bedrock agent, allowing the agent to use stored information when generating responses. So the function over here, which is associate agent knowledge base, connects a specified knowledge base with knowledge base ID to the given agent ID. And here the agent version is draft, which ensures that the change applies to the agent's draft version before being finalized. And the description, we had given it as myKB, which provides a short reference name for the knowledge base association. So basically, this function allows the agent to access and reference information from the knowledge base when answering queries. And by running this, you ensure that the agent can retrieve stored knowledge, improving accuracy and response quality. And it is useful for customer support, FAQs, and structured document retrieval. Now let's just look at the output. Associate agent knowledge base response. So as you can see, the knowledge base is enabled and we are ready to go. Now next, let's prepare the agent and alias. So I will just take the code and paste it because we have done this multiple times by now. Now let's see the code. So basically, this code prepares the agent for use, updates its alias, and ensures everything is fully activated before proceeding. So it consists of 4 key steps. I'll explain it to you again. So the first function, which is prepare agent, is called with agent ID, instructing Amazon Bedrock to process and activate the latest changes made to the agent, such as updated actions on a newly linked knowledge base. Waiting for the agent to be ready. So since the preparation process takes time, wait for agent status function ensures that the agent reaches the prepared state before moving forward. And this prevents errors from calling an agent that isn't fully activated. And the next one is updating the agent alias. So since the preparation takes time, so the function update agent alias assigns a new alias, like my agent alias, to the agent. So an alias is a version reference that allows different agent versions to be accessed in a structured way. And this step ensures that the alias is correctly linked to the updated agent. And finally, waiting for the alias activation. So wait for agent alias status function ensures that the alias is fully prepared before use. And this guarantees that any request made to the agent will work correctly. So these steps finalize all updates and ensures that the agent is fully functional before invocation. And this approach prevents errors, incomplete updates, or unresponsive behavior making the agent reliable and ready to process queries. So let's just run this code. Let's wait for it to process. So once it's executed, you can see that we have a fully built customer support agent by now. So now let's just ask it some questions to see how it works. So first, let's give the session ID and our message. Again, we have given this multiple times by now. Creating a session ID. Message is leah@leah.com. I bought a laptop 5 weeks ago and now it has display issues. I want a refund. Now let's give the invoke agent function to print. Here we have disabled the trace. Let's print it. So it has actually given us a response saying that I've reviewed a request for a refund on the laptop you purchased about 5 weeks ago, and that is now having display issues. So I was able to look up the details of your purchase using the information. Based on my research, I've escalated your case to our customer support team for further assistance. So a support agent will get in touch. So you can, continue asking more questions. Like for example, let's try another message which says, let's ask, I am unable to connect my laptop Wi-Fi. What can I do? And let's print this. So we have enabled trace. So as you can see, this is the output, and the guardrail trace is none. It has given the agent's thought process like, okay, let me see how I can assist you with the issue of not being able to connect your laptop to Wi-Fi. And then it has gone to the knowledge base. And then it has come up with a final response, like to troubleshoot the issue of not being able to connect your laptop to Wi-Fi. Here are some steps you can try. And it is given 5 steps. So similarly, you can prompt more questions and see the response, how the agent responds to your queries. So basically, the agent is now designed to follow the conversation flow and use agentic reasoning to decide how to handle each customer request. And it doesn't just respond blindly, as you have seen. It analyzes the situation and figures out the best course of action. So what makes this agent powerful is its ability to take different paths depending on the problem. So if it's a simple issue, it can resolve it on its own, but when a situation requires human assistance, it knows when to escalate to a support agent. So the way it makes these decisions come down to 3 things. Number 1, the agentic workflow that guides its decision making. Number 2, the instructions we provide to shape its behavior. And the third one, the tools and actions it has access to, like knowledge bases and APIs that you have seen in this example. So together, these elements allow the agent to be efficient, adaptable, and capable of handling a variety of customer interactions smoothly. So that was it. In the next chapter, I will give you a quick walkthrough of the Amazon Bedrock console. So now that we have successfully built a customer support agent using code, it's important to explore how the Amazon Bedrock console provides a visual and interactive way to configure AI models, manage agents, and fine-tune various functionalities such as guardrails and knowledge bases. So while coding provides greater flexibility and control, the console simplifies the process by offering an intuitive interface that allows for quick modifications, testing, and troubleshooting. So Amazon Bedrock is a part of AWS serverless AI infrastructure, which means it can integrate seamlessly with other AWS services while giving users access to pre-trained AI models from multiple providers. So this makes it an ideal tool for companies and developers looking to build and deploy AI-powered solutions without the need for extensive machine learning expertise. So to access Amazon's Bedrock, you first need to log into your AWS account, and once logged in, you have to navigate to the search bar and search for Bedrock and select Amazon Bedrock from the search results. So as you can see on the left-hand menu, you'll see several options that allow you to explore the different components of Bedrock. So these options include model providers, agent management, guardrails, knowledge bases, and playgrounds for testing AI models interactively. So by providing a centralized dashboard, the Bedrock console allows users to easily manage AI-driven workflows, configure their AI assistant's behavior, and enhance their knowledge retrieval capabilities. So one of the most important aspects of Amazon Bedrock is a variety of AI models it provides access to. So Bedrock allows users to choose from models built by leading AI research organizations, offering a range of capabilities such as text generation, reasoning, summarization, and question answering. So as you can see inside the console, the providers section lists the various AI models available in Amazon Bedrock. So some of these include the Amazon AI, Anthropic, Claude models, AI21 Labs, Cohere, Meta, Mistral AI, Stability AI, etc. So as you can see, each of these providers offers different types of large language models which can be used depending on the specific requirements of a project. Like for example, Anthropic's Claude models are known for their safety-first approach, while Meta's Llama models are designed for high-efficiency reasoning tasks. So if you encounter errors when you are trying to use these certain models, it is likely because they have not been enabled for your AWS region or account. So the Bedrock console allows users to manually enable access to these models by navigating to the model access settings. So here users can agree to end user license agreements to enable specific models, modify access permissions to allow Bedrock to integrate with those models, and select or deselect models based on their respective project needs. So once a model is enabled, it becomes available for use within agents, knowledge bases, and other AI-driven applications. So first, let's have a look at agents for configuring and managing AI assistants. So one of the most powerful features of Amazon Bedrock is its ability to create AI-powered agents that can interact with users, process queries, and provide intelligent responses based on available data. So the agents section in the console provides tools for managing the assistants. So when you open the agent section, you will see a list of existing agents along with their current status. So these agents can be in different states, as we have already seen while coding. So it can be in the prepared state, which means it is ready to use and actively responding to queries. And it can also be in not prepared state, which means that the agent has been created, but it isn't fully configured yet. So to create a new agent, users can click the create agent, enter a name. You'll be having an option to enter a name, a description, and also select the large language model that will power the agent's response. So this step is crucial as the model selection determines the quality, response style, and processing capabilities of the agent. So basically, the agent builder provides a structured interface where users can define detailed agent instructions, choose best suited AI model, enable the code interpreter, which allows the agent to execute Python scripts when needed and customize its workflow and processing logic to suit business requirements. Now, a major part of setting up an agent involves configuring action groups, which define what the agent can actually do. So action groups allow the agent to connect with external tools, databases, and services to perform tasks beyond simple conversation. So within the console, users can link agents to external services using AWS Lambda functions. Amazon Bedrock simplifies the process by providing a quick create Lambda function option, which automatically generates sample Lambda code, configures the necessary AWS permissions for execution, and allows developers to customize Lambda functions for business-specific use cases. So for example, if a support agent needs to retrieve a customer order details, an action group can be set up to query a database through a Lambda function. So once the function is triggered, the response is processed by agent and delivered back to the user. And also after configuring an agent, the console provides an interactive test environment, allowing users to send sample queries, debug unexpected agent behavior, and ensure proper integration with external systems. Now next over here, we have the guardrails for controlling and filtering AI responses. So AI safety and compliance are critical when deploying automated assistance. So Amazon Bedrock offers guardrails, which we already saw while coding in a previous chapter, which allows users to filter and control an agent's responses to ensure it behaves within set guidelines. So as you can see, unlike action groups, which define what an agent can do, guardrails define what it shouldn't do. So these settings block inappropriate, harmful, or restricted content from being generated. So the console makes it easy to set up and manage guardrails through an intuitive interface, allowing users to specify denied topics that the agent should avoid, define content filters to block inappropriate responses, and adjust AI safety levels using interactive sliders. So, for example, if an organization wants to prevent an AI assistant from providing financial advice, a denied topic can be configured within the guardrail settings. And then there is knowledge bases, which is for expanding the agent's knowledge. So basically, knowledge base enhances an AI agent's ability to provide accurate and informed responses by allowing it to access structured data. So this is particularly useful for customer support, internal documentation, and FAQ systems. So the console simplifies knowledge base creation by guiding users through entering a name and description for the knowledge base, setting up access permissions, and choosing a data source such as Amazon S3, Salesforce, SharePoint, or a web crawler. So once a knowledge base is set up, the data needs to be indexed in a vector base to enable fast and efficient retrieval. So Amazon Bedrock supports multiple vector storage options like Amazon OpenSearch, Serverless, Aurora PostgreSQL, MongoDB, LTAS, and Pinecone. So when users queries the agent, the system retrieves relevant information from the knowledge base and integrates it into the agent's response. So the Amazon Bedrock console provides a comprehensive interface for managing AI agents, configuring workflows, and integrating data sources. While coding gives developers full control over implementation, the console simplifies deployment, testing, and fine-tuning, making it accessible for both technical as well as non-technical users. So by using all this AI model customization, guardrails for safety, and knowledge bases for enhanced understanding, Bedrock ensures that AI-powered solutions remain accurate, efficient, and aligned with the current business needs. So that was it. Congratulations on completing the Introduction to Agentic Workflow course from Simplilearn. Throughout this course, we explored key concepts of agentic workflows and how they can enhance automation. We learned how to create an agent using Amazon Bedrock connected with a CRM to perform calculations and read an FAQ manual for different information retrieval. We also walked through the Amazon Bedrock console, giving you a hands-on understanding of its features. So with these foundational skills, you are now equipped to build intelligent, automated workflows that streamline business processes.
In this video, we will learn about an important popular deep learning neural network called Generative Adversarial Networks. Yann LeCun, one of the pioneers in the field of machine learning and deep learning, described it as the most interesting idea in the last 10 years in machine learning. In this video, you will learn about what are generative adversarial networks and look in brief at generator and discriminator. Then we'll understand how GANs work and the different types of GANs. Finally, we'll look at some of the applications of GANs. So let's begin. So what are generative adversarial networks? Generative adversarial networks or GANs, introduced in 2014 by Ian J. Goodfellow and co-authors, became very popular in the field of machine learning. GAN is an unsupervised learning task in machine learning. It consists of two models that automatically discover and learn the patterns in input data. The two models, called generator and discriminator, compete with each other to analyze, capture, and copy the variations within a dataset. GANs can be used to generate new examples that possibly could have been drawn from the original dataset. In the image below, you can see that there is a database that has real 100 rupee notes. The generator, which is basically a neural network, generates fake 100 rupees notes. The discriminator network will identify if the notes are real or fake. Let us now understand in brief about what is a generator. A generator in GANs is a neural network that creates fake data to be trained on the discriminator. It learns to generate plausible data. The generated instances become negative training examples for the discriminator. It takes a fixed length random vector carrying noise as input and generates a sample. Now the main aim of the generator is to make the discriminator classify its output as real. The portion of the GAN that trains the generator includes a noisy input vector, the generator network, which transforms the random input into a data instance, a discriminator network which classifies the generated data, and a generator loss, which penalizes the generator for failing to dolt the discriminator. The backpropagation method is used to adjust each weight in the right direction by calculating the weight's impact on the output. The backpropagation method is used to obtain gradients, and these gradients can help change the generator weights. Now, let us understand in brief what a discriminator is. A discriminator is a neural network model that identifies real data from the fake data generated by the generator. The discriminator's training data comes from two sources. The real data instances such as real pictures of birds, humans, currency notes, etc. are used by the discriminator as positive samples during the training. The fake data instances created by the generator are used as negative examples during the training process. While training the discriminator, it connects with two loss functions. During discriminator training, the discriminator ignores the generator loss and just uses the discriminator loss. In the process of training the discriminator classifies both real data and fake data from the generator. The discriminator loss penalizes the discriminator for misclassifying a real data instance as fake or a fake data instance as real. Now moving ahead, let's understand how GANs work. Now GANs consists of two networks, a generator which is represented as G of X and a discriminator which is represented as D of X. They both play an adversarial game where the generator tries to fool the discriminator by generating data similar to those in the training set. The discriminator tries not to be fooled by identifying fake data from the real data. They both work simultaneously to learn and train complex data like audio, video, or image files. Now you are aware that GANs consists of two networks, a generator G of X and discriminator D of X. Now the generator network takes a sample and generates a fake sample of data. The generator is trained to increase the probability of the discriminator network to make mistakes. On the other hand, the discriminator network decides whether the data is generated or taken from the real sample using a binary classification problem with the help of a sigmoid function that gives the output in the range 0 and 1. Here is an example of a generative adversarial network trying to identify if the 100 rupee notes are real or fake. So first, a noise vector or the input vector is fed to the generator network. The generator creates fake 100 rupee notes. The real images of 100 rupee notes stored in a database are passed to the discriminator along with the fake notes. The discriminator then identifies the notes and classifies them as real or fake. We train the model, calculate the loss function at the end of the discriminator network, and backpropagate the loss into both discriminator and generator. Now the mathematical equation of training a GAN can be represented as, you can see here. Now this is the equation and these are the parameters. Here G represents generator, D represents the discriminator. Now P data of X is the probability distribution of real data, P of Z is the distribution of generator, X is the sample of probability data of X, Z is the sample size from P of Z, D of X is the discriminator network, and G of Z is the generator network. Now the discriminator focuses to maximize the objective function such that D of X is close to 1 and Z of Z is close to 0. It simply means that the discriminator should identify all the images from the training set as real, that is 1, and all the generated images as fake, that is 0. The generator wants to minimize the objective function such that D of Z of Z is 1. This means that the generator tries to generate images that are classified as real, that is 1, by the discriminator network. Next, let's see the steps for training a neural network. So we have to first define the problem and collect the data. Then we'll choose the architecture of GAN. Now depending on your problem, choose how your GAN should look like. Then we need to train the discriminator on real data. Now that will help us predict them as real for n number of times. Next, you need to generate fake inputs for the generator. After that, you need to train the discriminator on fake data to predict the generated data as fake. Finally, train the generator on the output of discriminator. With the discriminator predictions available, train the generator to fool the discriminator. Let us now look at the different types of GANs. So first we have vanilla GANs. Now vanilla GANs have min-max optimization formula that we saw earlier, where the discriminator is a binary classifier and is using sigmoid cross entropy loss during optimization. In vanilla GANs, the generator and the discriminator are simple multi-layer perceptrons. The algorithm tries to optimize the mathematical equation using stochastic gradient descent. Up next, we have deep convolutional GANs or DC GANs. Now DC GANs support convolutional neural networks instead of vanilla neural networks at both discriminator and generator. They are more stable and generate higher quality images. The generator is a set of convolutional layers with fractional strided convolutions or transpose convolutions, so it unsamples the input image at every convolutional layer. The discriminator is a set of convolutional layers with strided convolutions, so it downsamples the input image at every convolutional layer. Moving ahead, The third type we have is conditional GANs or CGANs. Vanilla GANs can be extended into conditional models by using an extra label information to generate better results. In CGAN, an additional parameter called Y is added to the generator for generating the corresponding data. Labels are fed as input to the discriminator to help distinguish the real data from fake data generated. Finally, we have super resolution GANs. Now, SR GANs use deep neural networks along with adversarial neural network to produce higher resolution images. Super resolution GANs generate a photorealistic high resolution image when given a low resolution image. Let's look at some of the important applications of GANs. So with the help of DC GANs, you can train images of cartoon characters for generating faces of anime characters and Pokemon characters as well. Next, GANs can be used on the images of humans to generate realistic faces. The faces that you see on your screens have been generated using GANs and do not exist in reality. Third application we have is GANs can be used to build realistic images from textual descriptions of objects like birds, humans, and other animals. We input a sentence and generate multiple images fitting the description. Here is an example of a text-to-image translation using GANs for a bird with a black head, yellow body, and a short beak. The final application we have is creating 3D objects. So GANs can generate 3D models using 2D pictures of objects from multiple perspectives. GANs are very popular in the gaming industry. GANs can help automate the task of creating 3D characters and backgrounds to give them a realistic feel.
So let's talk about what exactly are transformers. Transformers are an artificial intelligence model used to process and generate natural languages. They can read and understand huge amount of text and then use that knowledge to answer questions, translate languages, summarize information, and even create stories or write code. The magic behind transformers is their ability to focus on different text paths with attention mechanisms. This means that they can understand context better than older models, making their outputs more accurate and natural sounding. The basic structure of a transformer includes two main parts, the encoder and the decoder. Think of the encoder as a translator that understands and processes the input, and the decoder as the one that takes the processed information and turns it into the output. For example, if we are translating a sentence from English to French, the encoder reads the English sentence and converts it into a form that AI can understand. The decoder then takes this form and generates the French sentence. A great example of a transformer in action is ChatGPT. ChatGPT uses transformers to understand and generate human-like text. When you ask a question, it processes your input with its encoder and generates a response with its decoder. This lets it have conversations, write essays, and even tell jokes. For instance, if you ask ChatGPT what's the weather like today, it uses its transformer model to understand your question and respond it with it's sunny with a chance of rain in the afternoon. This ability to understand and generate text makes transformers incredibly powerful. So let's talk about how transformers work. Transformers are especially good at sequence-to-sequence learning tasks, like translating a sentence from one language to another. Here's how they work. First, there's the attention mechanism. This allows the transformer to focus on different parts of input data. For example, if it's translating the sentence, the cat sat on the mat, it can pay attention to each word's context to understand the meaning better. So it knows cat is related to sat and mat, helping it produce an accurate translation in another language. Transformers also use something called positional encoding. Since they process all words at once, they need a way to understand the order of the words. Positional encoding adds information about the position of each word to the input, helping the transformers understand the sequence. Another key feature is like parallel processing. Unlike older models like recurrent neural network, which is RNNs, the process text words by word. Transformers can process the entire sentence at once. This makes them much faster and more efficient. Let's compare transformers with recurrent neural networks. But first, let's understand what are RNNs. So RNNs is a type of neural network designed to handle sequential data. They process data one step at a time, maintaining a memory of previous steps. This makes them good for tasks where order matters, like speech recognition or time series prediction. However, RNNs have a problem called the vanishing gradient, which means that they can forget information from earlier in the sequence. Imagine trying to understand the sentence, Alice went to the park and then to the store. An RNN might struggle to remember Alice by the time it gets to the store, but a transformer can easily keep track of Alice throughout the sentence. So why are transformers better? Unlike RNNs, transformers process the entire sentence at once, keeping the context intact. This solves the vanishing gradient problem and makes transformers faster and more accurate to tasks like language translation and text generation. So let's talk about the applications of transformers. At first, we have language translation. They are used by services like Google Translate to convert text from one language to another. For example, translating hello, how are you to Spanish as hola. Then we have document summarization. They can take long articles and summarize them into shorter, more concise versions. For instance, summarizing a 10-page report into a few key points, making it easier to understand the main ideas without reading the whole document. Then we have content generation. Transformers can write articles, stories, and even code. They can create new content based on what they have learned. For example, you could ask a transformer to write a short story about a space adventure, and then it would come up with a unique narrative. Then we have game playing. Transformers can learn and play complex games like chess, making strategic decisions just like a human player. They analyze the entire board and make moves considering all possible outcomes. Let's talk about image processing. They are used in tasks like image classification and object detection, helping computers understand visual data. For example, identifying objects in a photo, like recognizing a cat, tree, or a car. Now let's understand the training process. The training transformers involves two main steps. Semi-supervised learning. They can learn from both labeled data where the answer is known and unlabeled data where the answer is not provided. This makes them very versatile. For example, a transformer could be trained on a mix of articles with and without summaries to learn how to summarize text effectively. Pre-training and fine-tuning. Transformers are pre-trained on a large dataset to learn general patterns. Then they are fine-tuned with specific tasks, making them highly versatile. For instance, a transformer might be pre-trained on a large collection of books to understand language and then fine-tuned to generate marketing copy for a specific brand. The future potential of transformers is huge. Researchers are continuously improving them, making them even more powerful. We can expect more advanced applications in areas like healthcare, finance, and more sophisticated AI systems that interact with humans in more natural ways. Imagine having an AI that can provide personalized medical advice or one that can help you write a novel. In conclusion, we can say that transformers are a revolutionary architecture in AI. They offer speed, efficiency, and versatility, changing how we interact with the technology. The future looks bright for transformers, and we can't wait to see what they'll do next.
So we will be discussing about what exactly is LangChain, Langgraph, Langflow, and Langsmith, and where can we use them, and what makes them different from others. So this is the major agenda for today's session. Let's begin with LangChain. So what exactly is LangChain? LangChain is an open source framework designed to help developers build applications powered by large language models by providing tools and abstractions to simplify the process of integrating LLMs with external data sources and workflows. Now, imagine you're building an AI application where an LLM model like GPT-4 is needed to generate an initial response to your query. Llama 3 or other versions to refine that response. A custom-built AI agent to decide whether it can answer the query without a hiccup or if it has to fetch external sources to generate a response. Most importantly, a solid memory to store all previous user interactions. Without LangChain, managing all these components manually would require extensive coding. You need to write a custom code snippet to handle API calls to your LLM like GPT, Llama, create and maintain a dedicated memory space, and most importantly, a fully customized decision-making capable AI agent. Yet in scenarios where you can see an opportunity to scale it up, the possibilities are questionable. This approach leads to a lot of boilerplate code and makes the system complex. LangChain simplifies this by providing an open source framework that helps developers build applications powered by large language models. It enables training prompts, interacting with external data, and adding memory for contextual understanding. Now, let's discuss some of the key features of LangChain. Firstly, LLM support. It works with both closed source GPT-4 and open source models like Llama 3 with simple API integrations. Prompt templates. It allows dynamic prompt customization instead of hard coding queries. Third one is chains. It helps connect multiple tasks like querying an LLM, retrieving data, and processing responses in a seamless workflow. Fourth one is indexes. Supports document loaders and vector databases to pull in external data. Fifth one is memory. It enables applications to retain past interactions, improving contextual awareness. And lastly, the agents. It uses LLMs as reasoning engines to dynamically decide the next step in the workflow. With LangChain, developers can efficiently build AI-powered applications without reinventing the wheel. You can have a detailed briefing on LangChain on the official website. Also, should you wish to try it out, take a quick look at Quick Start page to steps to follow to set up the environment and run LangChain in your local system. Now, let's proceed with the next one in this tutorial, which is Langgraph. So what exactly is Langgraph? By definition, Langgraph is a library within the LangChain's ecosystem. It is a framework for building and managing complex stateful multi-agent LLM applications by modeling workflows as graphs, where nodes represent tasks or states and edges represent a transition between them. Now, let us imagine this. You are in a situation where you need to work with not one, but multiple agents in parallel. But LangChain can just assist you with one. You need much more enhanced platform for this. That's where Langgraph comes into the picture. Langgraph is built upon the existing LangChain and designed for managing agents and multi-agent workflows. While LangChain is excellent for chaining prompts, Langgraph excels at handling structured interactions between multiple agents. If you are building a system where multiple agents collaborate, such as a research assistant or an automation workflow, Langgraph is a great choice. So let's discuss these core components of Langgraph. First one, state. A state is a shared data structure that stores user inputs, agent outcomes, and workflows history. Now, the next one is nodes. You can have one node or also multiple nodes. These nodes are individual components or actions that execute LLM calls, run functions, or interact with external tools. Now, let's go to the third part, which is edges. Edges are nothing but connections between nodes that define execution flow. Unlike traditional directed graphs, nodes in LangGraph can dynamically decide which node to call next. That means the control flow can go in both ways. LangGraph is ideal when you need agents to interact in cyclical workflows or collaborate on complex tasks. You can have a detailed briefing on LangGraph on the official website. Also, should you wish to try it out, take a quick look at the quick start. Using LangGraph is straightforward. You just need to install the package, import it onto your project, and then using the provided classes, you can straightly access LangGraph. Now, let's proceed to the next one, which is Langflow. Now, what is Langflow? Langflow is a visual, low-code framework built upon top of LangChain, enabling developers to easily design and test AI applications, especially those involving multi-agent systems and retrieval augmented generation or RAG. Now, imagine building AI-powered applications like chatbots or data processing tools without writing any code. Langflow makes this possible with the drag and drop interface. Langflow is built upon top of LangChain and provides a visual interface for designing LangChain workflows. It is perfect for prototyping LLM applications, allowing users to quickly design workflows, chains, and agents and test them. However, it is not intended for production use, but it is excellent for MVPs, which is minimum viable products. Langflow is designed to simplify AI-powered app development by providing a drag-and-drop interface. It enables developers to visually design, experiment with, and test LangChain-based workflows. Now, what makes Langflow different from LangChain and LangGraph? Why use Langflow? So, there are three major reasons. Firstly, no coding required. Perfect for prototyping AI applications without having to write any code. Second one, visual workflow builder. You can easily design chains, agents, and integrations. Thirdly, quick prototyping. Best suited for MVPs, experimentation, and non-production use cases. So there are two main ways to use Langflow. First one, via DataStax, a paid cloud-hosted option. Second one, self-hosted. Install locally or on your own cloud server. So once deployed, Langflow provides a UI where you can drag and connect various components, enabling you to build and test AI workflows seamlessly. You can have a detailed briefing on Langflow on the official website. Also, should you wish to try it out, take a quick look at Quick Start to work on setting up Langflow in your local environment. You just need to install the package, import it onto your project, and start using the provided classes. Now, let's move on to the last one, which is Langsmith. So what exactly is Langsmith? So Langsmith is a platform developed by LangChain, designed to streamline the development, testing, debugging, and monitoring of LLM applications, offering tools for observability, evaluation, and prompt engineering. The LLM, Gen AI agents, all the hype was a huge hit. Everybody is interested in developing a custom AI agent to automate and optimize all the redundant CRM tasks and much more. But building an LLM-based application or AI agent is just the beginning. Monitoring, testing, and optimizing are equally crucial. Langsmith is designed to help developers at every stage of an AI application's lifecycle, from prototyping to production. Now, why use Langsmith? So there are three important reasons. Firstly, performance monitoring. It tracks API calls, token usage, errors, and latency. Second one, debugging and evaluation. It ensures models return expected results and avoid unnecessary API costs. Lastly, independent framework. It works with any LLM framework, not just the LangChain based ones. If your application requires extensive monitoring, debugging, or optimization, Langsmith is a great tool. However, for simple applications without complex tracking needs, it might not be necessary. To integrate LangChain, install the package, set up the environment variables, and use traceable annotations in your code. The Langsmith dashboard provides insights into performance metrics, including token usage, call trends, and error rates. For more details on Langsmith, visit the official page of Langsmith. Also, should you wish to try it out, take a look at the quick start to work on setting up Langsmith in your local environment. You just need to install the package, import it into your project, and start using the provided classes.
Something big is happening in the world of AI, and it's shaking up the industry. No, it's not another ChatGPT update or a new release from OpenAI. This time, it's a brand new player on the scene. DeepSeek R1, an AI model that's already outperforming the best known models in ways that have experts seriously been talking. But why is this causing such a stir? Well, it's because DeepSeek R1 doesn't just answer questions like other AIs. It thinks. And I mean really thinks. It breaks down complex problems step by step, showing you exactly how it arrives at the solution. You just don't get an answer, you get the entire process from start to finish. That too in real time. This is the kind of AI that doesn't just solve problems, it solves the way we do. Now, here's the twist. DeepSeek R1 isn't from one of the usual AI giants like OpenAI or Anthropic. It was developed by High Flyer Capital Management, a hedge fund that's quietly been making waves in the AI world. In fact, their new DeepSeek R1 Lite review is already making headlines for its stunning performance on tasks like mathematical reasoning, logical inference, and real-time decision making. Areas where even the best of the OpenAI's models often fall short. But why is this model such a game changer? It's because in 2024, the world is demanding AIs that can think logically and reason through problems. DeepSeek's ability to show its work is what sets it apart. While other AIs give you answers, DeepSeek lets you watch its thought process unfold. Think of it as the AI that doesn't just solve problems, but teaches you how to think like it does. And if you think that's all just a hype, let me tell you, Forbes isn't the only one buzzing about it. Even experts across the industry are pointing out that DeepSeek is outperforming model from heavyweights like OpenAI and Anthropic on tests that measures complex reasoning. It's already winning in some major AI benchmarks and it's only going to get better.
So why is DeepSeek R1 such a big deal right now? And what does it mean for the future of AI in 2024 and beyond? Well, in this video, we will explore DeepSeek R1 starting with its unique capabilities and how it stands out from the other AI model. We'll also test its math reasoning and problem solving skills, comparing it with models like OpenAI. Then we will examine the real world application in fields like finance and tech. So let's dive in and see how it's shaping the future of AI. So at first, let us understand what is exactly DeepSeek R1 Live Preview. As you can see this tweet post, so DeepSeek R1 Live Preview is an AI tool which is similar to ChatGPT and is created by a Chinese company which is known as DeepSeek. The company announced this new model on X on November 20th and shared a few details. So I'll show you the documentation page over here. So this is a documentation page of DeepSeek API. And DeepSeek R1 Live Preview is meant to be really good at solving problem reasoning in maths, coding, and logic. It shows you how to think step by step so that you can understand how it comes up with answers and which help people to build trust more. So you can try out me on their website, and the website name I'm going to show you. So you just have to simply go to Google and type over here chat.deepseek.com. As soon as you enter this, you'll be redirected to DeepSeek's page. So simply I'll just log in with the Google account. And here you can see this is the interface of our DeepSeek R1 Lite model. And here we will enable this DeepThink preview, which is a new feature over here. And now let's start with our test and start testing whether DeepSeek, this model, is really that effective or worth the hype or not. So first we'll be doing the strawberry test, okay? So let's see what exactly is the strawberry test. So let's start with a very simple question, which is how many times does the letter R occur in the word strawberry? So this is our question over here, and let us just check what would be the answer. So I didn't expect such a long reasoning process for what seems like a straightforward task. I thought that after counting the letter R and identifying the position of the word, it would have stopped there. But what's interesting to me is that it didn't stop. It double-checked the counting a couple of times and even considered things like how people might pronounce or spell the word differently, which I think is a bit of redundant, especially the pronunciation part. But then that's how it does show how careful and thoughtful it is. So it just explained us every step by step and what process we can go through it. So let's move on to our second question, which would be a mathematical reasoning question. So our next question would be if a triangle has sides of 3, 4, 5, what would be its area? So let's just check. So as you can see here, the DeepSeek R1 model is getting our answers, and it performs the checks I predicted, although in a different order. But then it's using all the steps and all the formulas and what would be the best to go with this question. So both the explanation and the output are particularly clear and easy to follow, which makes me think that this would be a fantastic model to embed in math students' assistant. For example, this is a particular use case. Maybe the thought process could be shown first and the student could interact with acknowledging whether they understood it or not. So that's a pretty fast answer. Let's move on to our third question. So now let's ask a DeepSeek model a geometrical type of question, which is a bit tough, and let's see what answer would it generate for us and how it is taking the logic building and the process. So as you can see, it is taking all the formulas and also it is considering the other probabilities as well. So we'll just wait a few seconds. So as you can see, it has written read and messed up in a denominator. So it is even checking what mistakes has it generated, which is really good. It is just like as if somebody is solving this mathematical problem, but then in the form of AI. So that's really interesting. So now as you can see, it has given us the final answer and also step-by-step approach, which is well-known geometric formulas and applied them directly, which makes the reasoning very easy to follow. So the output is very clear and easy to follow, And across all these examples, it's been impressive to see how it consistently double-checked calculations using different methods. The thought process is always detailed, logical, and very easy to understand. So for somebody who wants to actually learn or go through these mathematical problems, this model will give a very detailed explanation. So I would highly suggest using this. So let's now move on to our next question, which would be a coding test. So the first question would be implement a function in Python that finds the longest palindromic substring in a given particular string. The function should have a time complexity better than O n raised to the power 3. They go of n to the power 3. So let us just see what is the time complexity. Will it generate the answer for us? The code. Let's just check it out. So as you can see, it has given us the solution code here and also the explanation part, and whatever the function it is using, it has briefly mentioned the explanation about it. And I think that the model did a very great job solving the problem and finding the longest palindromic substring. The approach was smart, efficient, and clearly explained. So instead of just brute force method, every possible substring which would be slow, it used a very clever expand around centers technique. And this method handled both odd length palindromes and even length palindromes as well, which was really clear and effective. So that was for the coding part. So now let's move on to a logical reasoning type of question, and let's see what answer does it generate. And we will also compare it with the OpenAI model here as well. So let's quickly check it out. A question here is: a man has to cross a river with a wolf, a goat, and a cabbage. His boat can only carry himself and one other thing. If left alone, the wolf would eat the goat and the goat would eat the cabbage. How can he get everything across safely? So let's quickly check out the answer. So as you can see, it's thinking of the end of reading the answer for us. Also, for the deep think messages, you can use 50 messages free per day. So we have already used 5 texts and we have 45 messages left for today. So as you can see, it has given a clear, detailed explanation and it solved the problem really very well. I think it carefully went through the rules and checked different possibilities. It understands that some pairs like the wolf and the goat or the goat, the cabbage can't be left alone. It also reviewed the constraints at the starting. It also reviews the constraints at the start. Starting from this, it looks at what would happen if the man takes each item across the river first and works out if it creates any problem. What I find really nice is about how the model adjusts its plan when something doesn't work. For example, when it tries taking the wolf first, it realizes talking to the wolf first, but realizes at the same time that it causes trouble and then rethinks the steps. This trial and error method feels very similar to how we as humans might solve the puzzle ourselves. So in the end, the model comes up with a very right solution and explains it in a very clear and step-by-step way. So as you can see, I've given ChatGPT this question and this is the answer it has generated, but then it wasn't that detailed as compared to DeepSeek model. So here I would rate DeepSeek model more because it gave me a very clear explanation with all the details set. You can clearly see the difference out here. So for anyone who wants to understand from depth, this DeepSeek model would be a great help. So let's quickly have a look on the DeepSeek R1 live preview benchmarks. So we have tested the model in real world conditions, but how does it stack up against other AIs on benchmarks like AIME, math, and competitive programming languages? So you have this on the screen. We have compared it with AIME, math, GPQA Diamond, Codeforces, Live Code Bench, and also Zebra Logic. So according to the benchmarks, DeepSeek R1 Live Preview blows the competition out of the water when it comes to math and logic problems, with a pass rate of 52.5% on the AIME 2024 challenge. It is really ahead of OpenAI's O1 preview and far surpasses models like GPT-4 on complex math tasks. So with this, we have come to the last part of the section, and here we will be comparing that who really wins. At first, you have seen that we have compared with the OpenAI model. So let's just quickly test some questions and just check it out that with OpenAI, which one performs much more better. So now we will compare DeepSeek versus OpenAI O1 model with some command prompts to see who really wins in different categories. So here I have this DeepSeek model. So my first command for this test is a math problem, and it says solve for x in the quadratic equation 3x to the power 2 plus 5x minus 2. So let's quickly see this, what answer is it giving, and we will be comparing it with the OpenAI O1 model as well. So as you can see, it is giving us all the available solutions using different methods as well. And see the first method, the second method, quadratic formula. It's basically giving you the full overview of all the methods which you find easier, and you can use that. And here is our final answer. So let's compare it with the OpenAI O1 model as well. So here I have this question, and I'll just check for the answer. It's taking a bit of time, but let's wait for a minute. So as you can see, it has only used one formula, which is the quadratic formula, and here we have the answer for this thing. But what I found is it provided a correct solution, but then it lacked, whereas our DeepSeek model, it provided much more detailed explanation. So I think DeepSeek wins for this maths question as well. For the second comparison, I have a coding problem. So let's check for both. First, we will be checking for DeepSeek model. And the coding problem is write a Python function to check if a given string is palindrome or not. And I'm waiting for the answer here. So as you can see, DeepSeek R1 Live Review model has provided us a correct solution along with a detailed breakdown of why each part of the code works as it does. So let's check for the O1 model as well. So now as you can see, for the coding task, the O1 model has given us the solution, but then it provides a working solution with clear code, but it doesn't explain the logic behind it. Whereas the DeepSeek model had provided the logic and also the solution with each detailed breakdown. And I think for this also the winner would be DeepSeek R1 Live Review because it provides better and clearer explanation. Now let's move on to the third test, which would be the logical reasoning. So here is my question, the logical reasoning, which is if a man has 5 apples and gives 3 away, how many apples does he left with? So let's check for the DeepSeek model. So now you can see it has given us the answer and also the correct answer, but it has explained each and every logic to go through this question and why have we used this particular logic as well. So that's a pretty breakdown, detailed step-by-step explanation. Let's check for the OpenAI O1 model as well. So here I have my question. Let's wait for the answer. See, it has given us a straightforward answer, which is approx 2 apples. But then it hasn't mentioned the logic behind it. Same as it was same for the coding task. I think since both of these models have provided the accurate, correct answer, but here also the winner would be DeepSeek because it has provided with a lot of explanation and transparency as well. So this is the wrap up of the video today. And if you're looking for an AI that excels in reasoning, problem solving, and transparency, it's definitely a contender. While OpenAI and other models are fantastic, DeepSeek brings something unique to the table. Step-by-step logic, clear explanation with an edge when it comes to math and coding challenges.
Learn's YouTube channel. In this session, we will learn how to run DeepSeek locally in Windows command prompt. But before that, let's take a look at the DeepSeek and all the hype about it. DeepSeek, the latest in generative AI, is making waves with its advanced reasoning and problem-solving capabilities. With global AI adoption accelerating, DeepSeek emerges as a powerful contender, seemingly outpacing its rivals in efficiency and depth. Built on cutting-edge architecture, it excels in complex reasoning, coding, and multilingual understanding. AI is the new genius, and DeepSeek is pushing its boundaries further with unmatched performance. Its ability to handle intricate prompts with precision makes it a game changer. Unlike traditional models, DeepSeek leverages superior contextual awareness for human-like responses. Its efficiency in real-world applications refines productivity and automation. Businesses and developers are rapidly integrating it for high-level decision making. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icons to get notified. Now, before we get started, we need to check the space first. Let me explore the File Explorer once. So you can see the downloads is almost full. Now we have another volume D which has a little bit of space. Let's use that. Now let's change the location of downloads to drive D. For that, go to Downloads, open Properties, and here go to Location. Maybe if you want to create a new file, that's also okay. Let's try that. So here, let's create a file, and I'll name this as temporary downloads. Maybe you can also use underscore to avoid confusion. And this might ask for some permissions, like let's say you already downloaded an application or something like that, and you set environment for that, right? So let's see, that's the one. So automatically the computer will change all the environment variables for you, just in case if you have any other applications running from downloads directly. Meanwhile, while this particular files are copying, let's wait for a moment. Let's minimize everything and open a new tab on Google. So to run DeepSeek locally, we might want to use a few things. Firstly, Ollama. So let's download Ollama. Go to the Ollama thing in the third link. That's the one we need. Now we need to download Ollama into our local system. For that, let's explore the models. So this is the first one, the first link. This is the one we are looking for. So before downloading that, let's enable Ollama. For that, we need to download and install Ollama. Download for Windows. So the downloading and installation might take a little bit of time. Don't worry about it. And we have started the download. Now we will explore the DeepSeek before all this download thing settles down. Let's explore a little bit about the DeepSeek models. So here you can see we have 7B, 1.5B, 8B, 14B, and let's also view all. So the B stands for billion parameters. So DeepSeek has a lot of modules based on the learning parameters, right? A couple of them have 8 billion. 671 is the highest, I guess, 400 GB. And because of space constraints, we will go with the first one, which is 1.5 billion parameters one. You can choose the model based on your space in your computer. So I'll go with the 1.5B1. So just click there and you'll get all the drop down options. Go with the one you want. And for that, just copy that code there. Ollama run DeepSeek -R1 1.5B, right? That's the one. And let's open the command prompt. Okay, before that, we need to install Ollama first. So the file has been downloaded successfully. Navigate to the downloads location. Start the setup. It might take a couple of time. Once the setup is completely done, then we will open the command prompt. And then copy paste that particular code. Then everything will be automatically downloaded and loaded for you. So DeepSeek will be ready to run locally on your CMD. So what's the benefit of running DeepSeek locally? Basically, when you want to communicate with your generative AI, you might want the internet connection with you. If you are able to download and set the generative AI, in our case, DeepSeek, in your computer, then it is beneficial for you so that it can run without the internet connection. It might take a little time, don't worry. Once the setup is done, look at the bottom right corner. You'll get a slight notification, a smaller notification which says Ollama is set up and running. Similar to that, you can just get Ollama is running now, something like that. Just a couple of moments while the final settings are done. There you go, the setup is done. Close it. Now check the tray there. Should be having an Ollama logo present right there. There you go. That's the notification we were looking for. Ollama is running. Now to check, you can also check the logs of Ollama which are presently in your computer just for cross verification. Also, make sure that to copy that Ollama run DeepSeek R1 code there to run it on your command prompt. Just press Windows icon with R to have the run command, and you can type CMD to execute the command prompt. There you go. Now make sure to copy that code. Once the Windows command prompt is active, you just have to paste it and hit enter. Command prompt is loading. It Might take a little glitch. Let's wait until it shows up. Let's try again. CMD, hit OK. Let's wait for a moment while the command prompt pops in. Let's check if there are any other activities. There you go. We have multiple prompts. Let's close all the other ones which we don't need. I think it's still loading. Let's close this as well. Let's give it a retry. CMD, OK. And let's wait. So here is the log file which we were looking at earlier. Let's close the log file which we don't need it. Yeah, the command prompt is active. Paste, enter. Now you should be getting something called manifesting. So that means the package is getting downloading, pulling manifest. There you go. So based on the model that we chose, which is 1.5 billion parameters, it's typically a smaller version of the DeepSeek that we were looking at. The biggest one was 675 billion parameters, which is close to 400 GB. If you have enough space in your PC, then you can go with the highest version. So due to space constraints, I'm going with the smaller one. The procedure is same. You just have to paste the code and run. So at the last where you have 1.5B, right? In place of that, you'll be having 675B. That's the only difference. It might take a little bit of time to download based on the package you're using. If you're going with the higher package, a bigger package, then the download time might even end up more than 24 hours. And if you don't have enough space, it might collapse in between. So I'd recommend select the one which suits with your memory space. Now the files are downloading. It might take a little time. Let's wait for that. The first one is downloaded, second, third. So I think it's downloading in terms of packages. So we have the fifth package, verifying. There you go, successfully downloaded. Now we can type in a message. Let's say, let's type hi DeepSeek or hello DeepSeek to verify. So hi DeepSeek. So you can see when you open the prompt, you'll have that thinking mode, right? You can see it is also thinking. Now let me type my request here. So it also said as hello, how can I assist you? So my request is I wish to learn neural networks. So you can see that when you open DeepSeek on Windows browser or Google browser, Firefox, any of the browsers, it'll show you the thinking process, right? Here also you can see that thinking process, start of think and end of think. The only thing is unable to display the thought process over here. But fine. Now let's continue with the command prompt, which is I wish to learn neural networks, and hit enter. Now let's say it will help you to learn neural networks in a stage-by-stage process in the learning order. What exactly is neural networks? What are the key components of neural networks? Neurons, activation, weights and biases and everything, right? Similar to ChatGPT or even other competitors in terms of generative AI. And it is also giving you procedures and sample codes here, right? If you wanted to execute these codes on Jupyter Notebook, then you can just import NumPy as NP from TensorFlow, etc. And also you have some sample codes for generating a model, how to execute that, everything. So I guess that's the end of the line for the prompt. Now, this was the trial run on how to run DeepSeek locally on your Windows command prompt. Now, you can also develop a completely new user interface and experience for your DeepSeek to run on locally. So far, so good. For the sample purpose, this is good. Now, let's type in buy and see how it responds to the text. There you go. It might be confused, but it might give you an alternate approach. Yeah. So it looks like your message got cut off. Okay, could you clarify?
So without any further ado, let's get started. So welcome to this demo part of this video. So here, as you know, we will be doing three things. First thing, speech to text recognition. The second thing, text generation from a particular sentence or a word. And the third thing, we will do sentiment analysis. Okay, so we will perform this one by one. So let's start with something called speech to text recognition. Okay, using Hugging Face. So first I will rename this. I will write here Hugging Face speech to text. Okay, yeah. So first I will install transformers library. It is already installed on my system, but again, just for you guys, I'm doing this. Okay, pip install transformer. So now let's see what is transformers. So transformers is a powerful Python library created by Hugging Face. So that allows you to download, manipulate, and run thousands of pre-trained open source AI model. Fine. So as you can see, requirement already satisfied. It means like already installed. So these transformer models cover multiple tasks across modalities like NLP, natural language processing, computer vision, audio, and multimodal learning, like many things. Fine. So now I will do from transformers import pipeline. Okay. So now let's run it. So now what is pipeline? Okay. So a transformer pipeline describes the flow of data from origin system to destination system. Fine. Because you already know transformer means you can run or manipulate thousands of pre-trained open source AI model. So pipeline describes the flow of data from origin system to destination system and defines how to transform the data along the way. Okay. So let's check the versions transformers version. Okay, that long tab. Okay, why it is coming? Import transformers. Yeah, so we have currently 4.42.4 version of the transformer. Okay, so I'm using Google Colab. Okay, so you can use either Jupyter Notebook, Visual Code Studio, or Colab. Okay, so now let's import libraries. Import Librosa. Okay, so what is Librosa? So Librosa is a Python package for audio and music analysis, right? Because we are doing speech to text, so we need this. So it provides various functions to quickly extract key audio features and matrices from the audio files. Okay, and this Librosa can also be used to analyze and manipulate audio files in a variety of formats such as WAV wave, MP3, M4A, and like that. Okay, so next we will import Torch. I hope everyone know Torch. So Torch is nothing PyTorch. It is a machine learning library based on the Torch library used for applications such as computer vision and NLP. And originally it was developed by the Meta AI and now the part of Linux Foundation, umbrella. Let's import one more thing. Import. So now let's import IPython. Okay, capital IPython dot display as display. So now you will be wondering what is this IPython display. Okay, so it is an interactive command line for the terminal for Python, and it can provide a IPython terminal and the web-based notebook platform for Python computing. And this IPython have more advanced features than the Python standard interpreter, and we quickly execute a single line of Python code. Nothing. Okay, for that I'm using this. And the next is from transformers import WAV to vectorizer for CTC and WAV to vectorizer to tokenizer. Okay, so now what is this? So WAV2 vectorizer for CTC is supported by the notebook on how to fine-tune a speech recognition model. Okay, and this tokenizer. So tokenizer is nothing. Tokenization is a conversion of a text into meaningful lexical tokens belonging to categories defined Alexa program. In case of NLP, so those categories include nouns, verbs, adjective, punctuation, etc. Okay, now, and the last library, let's import NumPy as NP. I hope everyone know NumPy. What is NumPy? Again, NumPy is a Python library used for working with arrays. It also has a function, for working in domain like linear algebra, Fourier transform, and matrices, and many others. Fine. I hope everyone know about these library which we have imported. Okay, so let's move forward. Right, tokenizer equals to 2 to tokenizer dot from pre-trained. This is why I love this Google Colab. You will decide just some words and it will show the suggestions. Facebook. So this is again one pre-trained model. Okay, so we are just importing it. Base 968. This is nothing, the name. Okay, then model equals to WAV2 for CTC dot from pre-trained, then Facebook WAV2 vectorizer 2, then base 960. Fine. Now let's run it. So now you can see. So we are loading this. Okay, they are downloading. Okay, so you can ignore this warning. So now let's load the audio file. So here I will write audio, sampling rate equals to librosa dot load. Okay, so you know about librosa, right? Then I have v dot m4a. So I have already one speech or one audio, you can say. So I will play it, don't worry. Before the final output, I will show you 16,000. Okay, so now I will write okay, I've already loaded, I guess. Okay, no issues. I will load again. Okay, the file is loaded. I will rename it to V. Yeah, fine. So now the error won't come again. We have v.mp4a. Okay, so now we have to do. Okay, let me try it. We have v.mp4a, but I don't know why it is not coming. Okay, let me copy the path. Now it will run, I guess. It's running. Yeah. So now I will write here audio, sampling rate. Okay, now listen carefully. Then I will write display dot audio, then path, comma, autoplay equals to true. Okay.
Hello and welcome. This is an AI voice message.
I guess you heard, but again, let me play it again.
Hello and welcome. This is an AI voice message.
Okay. So it is saying ki, hello and welcome. This is an AI voice message. Fine. So now what I will do, I will input some values. Input values equals to tokenizer, then audio, comma, return tensors equals to pt. Fine. Dot input values. Okay, then here input values. Okay, input values. Okay, yeah. So now logits will come here. So we have to now store the logits, which means non-normalized predictions. Okay, so logits equals to model input values dot logits. Okay, then here I will write logits. Okay, it's running. Done. So now what we will do, we will store predicted IDs, then we will pass the logits to values to softmax to get the predictive value. Okay, so here I will write predicted IDs equals to torch dot arg max. Okay, then logits comma dimension equals to -1. Okay, then I will pass the prediction to the tokenizer decode to the transcription. Okay, so here I will write transcriptions equals to tokenizer dot decode predicted IDs to 0. Running fine. So now let's see our output transcriptions. So now you can see hello and welcome. This is an AI voice message. So now let's play it again.
Hello and welcome. This is an AI voice message.
Amazing, right? So this is how you can use Hugging Face for the speech to text recognition. It's a very small code, line of code, as you can see. Okay, so now let's move forward and do the sentiment analysis, okay, or text generation. So let me open new drive. So yeah, so now I will write here, I will write sentiment slash text generation Hugging Face. Okay, so first of all, let's import the files. So first I will write import warnings, then warnings dot filter warnings. Okay, I will write here ignore, then we'll import numpy You already know what is NumPy, and import Panda. So these are some basic Python library, and I hope everyone knows. And import matplotlib for the plots, matplotlib dot pyplot as plt. Then I will import cbon for the graphs, the statistics graph. Okay, sns, then sns dot set. So now we'll import sklearn model train test split. So sklearn is nothing. Scikit-learn is probably the most useful library for machine learning Python. So this library contains a lot of efficient tools for machine learning and statistical modeling, including classification you can do, regression you can do, clustering you can do from this sklearn. Okay, from sklearn dot model selection, import train test split from sklearn dot matrix, import f1 score, comma, confusion matrix, comma, ROC AUC curve or score. So again we'll import teams from transformers, import pipeline. Everyone know what is this. Then import torch. Okay, now let's run it. You have too many active session, terminate existing to continue if you are interested in using one more session. Okay, wait. Yeah, fine now. Which one is open, bro? Terminate this. Terminate this. Terminate this. No. Okay, fine. So now let's do sentiment analysis. So we will explore sentiment analysis using a pre-trained transform model. Okay. The Hugging Face library provides, convenient pipeline, as you already know, function that allows us to easily perform sentiment on the text. So now let's first import the necessary dependencies and create a sentiments pipeline using this line. So I will write here classifier equals to pipeline sentiment analysis, then type classifier. Okay, so it will download the pre-trained sentiment analysis pipeline. Pipeline is not defined. How? Okay, error is there. I hope it will run now. Yeah. So now we can pass a single sentence or a list of sentence to the classifier and get the predictive sentiment labels and associate confidence score. Fine. So now just for the testing classifier, so let's write this is a great movie. Okay, now let me run it. So now you can see here label positive. So label positive typically refers to the outcome or a class of interest that the model is designed to predict. So here we are just checking the sentiment analysis model. Okay, so this is why I wrote this. Okay, so let's check one more. This was a great course. Then I did not understood any of it. Now let's check this. Yeah, perfect. And the score, you can see the accuracy score 99%, which is almost close to 100%, and which is amazing. So now you have access to a GPU, so you can also utilize it for the faster processing by specifying the device using the parameter. Okay, so now what I will do first, I will, okay, wait, yeah, fine. So now I will import dataset airline tweets equals to pd dot read. PD means pandas library here we are using. Okay, now first import, I will import here itself. So I have twitter dot tweets dot csv. Okay, tweets dot csv. Let it upload. Yeah, done. So now let me airline tweets dot head. Why dot head? Means it will show me the top 5 rows. Okay, 0 1 2 3 4 5. Okay, you can see tweet ID, airline sentiment, neutral, positive, neutral, negative, then this. Okay, so now let's do something. Okay, so what I will do, df means data frame airline tweets, then I will write airline sentiment. We have airline sentiment, this column. Okay, comma text. I need these 2 columns. Okay, df dot head 5. So yeah, so airline sentiment is neutral, and this is what this text is all about. Okay, because these 2 are the main things, text and the sentiment. So now let's make plot, count plot. Then I will write df comma x equals to airline sentiment, then palette equals to this. Then here I will write plt dot x label airline sentiment. Okay, then plt dot y label count plt dot show. So it will draw one graph. Okay, spelling is wrong. Yeah, so it will show neutral, positive sentiment and the negative. So as you can see, the negative sentences or the sentiments are the more. Okay, so we have now 3 classes which do not match the 2 class available in the Hugging Face pipeline. So therefore we will filter out all the rows which have been labeled as neutral. Okay, so df equals to df, and again df airline sentiment, fine, was not equals to neutral. Okay, then df target equals to df airline sentiment dot map. Then I will write here positive 1 and the negative 0. Fine. Negative will be 0. Okay. Then print number of rows, comma, df dot shape. Okay. So now you can see number of rows are 11,541. Okay. So now I will write predictions 5. It will, okay, predictions is not defined. Okay, so now what I will do, so here I will write text equals to df text and to list dot to list. Then here I will write predictions equals to classifier text. Okay, so here write probabilities equals to prediction, then score if predictions label dot starts with P means positive. Okay, else 1 minus prediction score. Okay, then I will write for prediction and prediction. Why it is not running? This is taking time, too much time. I don't know why. So as you can see, finally we have the output of predictions values. So this depends on system to system. My system took almost 17 minutes 47 seconds to complete. Okay, so now let's run it. Okay, predictions is not defined, bro. Now predictions. Yeah, so now I will write here predictions equals to np dot array. Np means numpy dot array. Then I will write 1 if prediction label is positive dot starts with p. Okay, else 0 for prediction and prediction values. Yep. Okay, fine. So now let's check the accuracy of our model. Print accuracy. Okay, then I will do round up the values. So here I will write np dot mean, then df, then the target, right? Yeah, then I will write equals to predictions, then I will write into 100 comma 2, then I will write percentage. Okay, fine, looks good. Yes. So as you can see, our accuracy is 88.99%, which is very good again. So now let's do some confusion matrix. Confusion matrix, then df target comma predictions comma normalize equals to true. Okay, then I will plot confusion matrix. Okay, df then target comma predictions comma normalize equals to true. Okay, my bad. That here confusion matrix comma labels. Okay, so here I will plot a confusion matrix using Seaborn. Okay, so here I will use ARGS, which is confusion matrix np.nArray, so which is labels list. So I will write plt dot figure, then figure size equals to 8,6. That's SNS dot set font scale equals to 1.4. Okay, then let's create the heat map. Confusion matrix comma and not will be true. Okay, then I will write fmt equals to g, then confusion map equals to blues, then x labels equals to labels, then y labels equals to labels. Okay, yes, so now I will write plt dot title will be confusion matrix, then plt dot x label will be predicted values, then plt dot y label will be actual values, then plt dot show. Okay, why the chart is not coming? Okay, so I have to write plot confusion matrix, then I write cm, then negative comma positive. Okay, now the chart will come. Okay, yeah, so now you can see here this is actual, and this is a confusion matrix, and the negative and the positive ratio is there. Okay, so now let's print the now let's check the ROC AUC score. So I will write here print ROC AUC score, then here I will write ROC AUC score then df target comma props. Okay, so 94. Okay, so first let me tell you what is this ROCAC score. So this is the area under the ROC curve. So what it does, it sum up how well a model can produce relative scores to discriminate between positive and the negative instance across all the classification threshold. So with this ROC score of 94, 0.94, which is 94%, we can conclude that a pre-trained sentiment analysis model has achieved a high level of accuracy and effectiveness. So in predicting the sentiment labels. So this indicates that the model is capable of accuracy classifying text into positive or the negative sentiment categories. Okay. So now we'll do text generation. Okay, so text generation involves generating creative and coherent text based thing. So I will write here text. Okay, so text generation involves generating creative and coherent text based on a given prompt or starting point. So what we will do first, we will import the necessary dependencies and load the data set of the poem. Okay, so here I am write poems. Let me write poems equals to pd.read.csv. Don't worry, I will give you these files. Okay, description box below I will add. So here I will write robot frost. Okay, dot csv. Fine, and then I will write poems dot head 5 or head, just have to write head. Module pandas has, okay, not dot underscore csv. Yeah, okay, it will show the top 5. Stopping by woods on a snowy evening, fire and ice. The aim was song, collection, content, year of publication. Okay, so now what we will do, we will write content equals to poems content dot drop na to list. Okay, so to generate text, we extract individual lines from the poems and use the pipeline text generation function to create a text generation pipeline. Fine, so here I will write lines equals to, then I will write for poem and content. Okay, for line in poem dot split into next line. Okay, then lines dot append, then I will add line dot right strip. To the right it will add. Okay, fine. So now lines equals to line for line in lines if length of line 0, then show me the lines 5. Okay, so now you have seen here whose woods these are. I think I know. Then the next line, his house is in the village though. That's the next line, he will not sing. Okay, like this. So now let's import that pipeline text generation module. Okay, gen equals to pipeline. So these are the pre-trained model. You already know generation Okay, so now I will write here lines. Let's run it. Yeah, done. So in line 0 we have whose votes these are. I think I know. Okay, so now we can now generate tags by providing a prompt and specifying the parameters such as max length and num return sequence. Okay, why? Because we have imported this tag generation module. Okay, for example, see okay, sorry, lines 0 dot max length equals to 20. So now it will generate this to the maximum 20. Okay, till 20 word maximum length. Okay, check. Okay, okay, expression cannot contain perhaps double equals to where? Okay, wait, now it will run. So see, the line was this much only. Whose words these are, I think I know. Whose words these are, think I know. But here, the generated text, I wish to go to church because I feel like. Okay, this is how you can do, text generation. Now let's check for the more. Gen lines 1. Okay, then max length equals to 30, comma, num return sequences equals to 2. Okay, so our first line was this: his house is in the village though. Okay, 0 1 2 3 4 5. Okay, so here you can see his house in the village though. However, you might say that the place was the same with the place this. So these are the generated text. Okay, and this is another return sequence second. So there are two, one and the second. Okay, so now let me import text tab. Okay, then creating function wrap x. I don't need this. Then return text wrap dot fill x comma replace white space equals to false comma fix sentence endings equals to true. Okay, so now out equals to generated lines 0 to maximum length equals to 30. Then print wrap out to 0. Then generated text. Okay, so now we are setting the pad tokens to EOS tokens. Okay, so whose these are, I think I know, and this is the maximum 30 till 30. Okay, so now I will write here. Okay, preview equals to. Okay, so now what you can do, you can generate a prompt to generate text on a specific topic like this. Prompt equals to transformers have a wide variety of applications application in NLP. Okay, so this is my prompt. Okay, this I'm not importing from the data set. Okay, so I will write out equals to gen prompt comma max length equals to 100, print wrap out. Okay, here I will write, anyways, here I will write generated text prompt. Okay, so it is running. Let's wait. Yeah, so okay, some error is there. Okay, so here the issue is with 100 words. Will go till 50. Yeah, so let me do it again. 100. Yeah, so now you can see we can generate text using by giving a prompt. So we have covered three topics in this. First thing is speech to text using Hugging Face. Second thing is sentiment analysis using Hugging Face, and the third is text generation using Hugging Face. Okay, and in this text generation we did with two methods, one with the data set and second thing with the by giving prompt like in ChatGPT, you can say. On July 25th, OpenAI introduced Search GPT, a new search tool changing how we find information online. Unlike traditional search engines, which require you to type in specific keywords, Search GPT lets you ask questions in natural, everyday language, just like having a conversation. So this is a big shift from how we were used to searching the web. Instead of thinking in keywords and hoping to find the right result, you can ask now Search GPT exactly what you want to know, and it will understand the context and give you direct answers. It's designed to make searching easier and more intuitive without going through links and pages. But with this new way of searching, so there are some important questions to consider. Can Search GPT compete with Google, the search giant we all know? What makes Search GPT different from AI overviews, another recent search tool? And how does it compare to ChatGPT, OpenAI, popular conversational AI? So in this video, we are going to explore these questions and more. We will look at what makes Search GPT special, how it compares to other tools, and why it might change the way we search for information. Whether you are new into tech or just curious, this video will break it down in simple words. Stick around to learn more about Search GPT. So what is Search GPT? Search GPT is a new search engine prototype developed by OpenAI, designed to enhance the way we search for information using AI. Unlike a typical chatbot like ChatGPT, Search GPT isn't just about having a conversation. It's focused on improving the search experience with some key features. The first one is direct answer. Instead of simply showing you a list of links, Search GPT delivers direct answer to your question. For example, if you ask, what is the best wireless noise cancellation headphone in 2024? Search GPT will summarize the top choices, highlighting their pros and cons based on expert reviews and user opinions. So this approach is different from the traditional search engines that typically provide a list of links leading to various articles or videos. The second one is relevant sources. Search GPT responses come with clear citations and links to the original sources, ensuring transparency and accuracy. So this way you can easily verify the information and delve deeper into the topic if you want. The third one, conversational search. Search GPT allows you to have a back and forth dialogue with the search engine. You can ask follow-up questions or refine your original query based on the responses you receive, making your search experience more interactive and personalized. Now let's jump into the next topic, which is Search GPT versus Google. So Search GPT is being talked about a major competitor to Google in the future. So let's break down how they differ in their approach to search. The first one is conversational versus keyword-based search. Search GPT uses a conversational interface allowing user to ask questions in natural language and refine their queries through follow-up questions. So this creates a more interactive search experience. On the other hand, Google relies on keyword-based search where user enter specific terms to find relevant web pages. The second thing is direct answer versus list of links. So one of the Search GPT's standout feature is its ability to provide direct answers to the question. It summarizes information from the various sources and clearly cites them, so you don't have to click through multiple links. Google typically present a list of links, leaving user to sift through the result to find the information they need. The third one, AI-powered understanding versus keyword matching. Search GPT uses AI to understand the intent behind your question, offering more relevant results even if your query isn't perfectly worded. Google's primary method is keyword matching, which can sometimes lead to less accurate results, especially for complex queries. The fourth one, dynamic context versus isolated searches. So Search GPT maintains content across multiple interactions, allowing for more personalized responses, whereas Google treats each search as a separate query without remembering previous interaction. And the last one, real-time information versus indexed web pages. Search GPT's aim to provide the latest information using real-time data from the web, whereas Google Vast Index is comprehensive but may include outdated or less relevant information. So now let's jump into the next topic, which is Search GPT versus AI overviews. So Search GPT and AI overviews both use AI, but they approach search and information delivery differently. It's also worth noting that both tools are still being developed, so their features and capabilities may evolve and even overlap as they grow. So here are the differences. The first one is source attribution. Search GPT provides clear and direct citation linked to the original sources, making it easy for user to verify the information. Whereas AI overviews include links. The citation may not always be clear or directly associated with specific claims. The second one is transparency control. Search GPT promises greater transparency by offering publishers control over how their content is used, including the option to opt out of AI training. AI overviews offer less transparency regarding the selection of content and the summarization process used. The next one is scope and depth. Search GPT strives to deliver detailed and comprehensive answers pulling from a broad range of sources, including potential multimedia content. And in AI overviews offers a concise summary of key points, often with links for further exploration, but with a more limited scope. Now let's jump into the next part. Search GPT versus ChatGPT. Search GPT and ChatGPT, both developed by OpenAI, share some core features but serve different purposes. So here are some differences. The first one is primary purpose. Search GPT designed for search, providing direct answer and sources from the web, whereas ChatGPT focuses on conversational AI, generating text responses. The second one is information sources. Search GPT relies on real-time information from the web, whereas ChatGPT knowledge based on this training data, which might not be current. The third one is response format. Search GPT prioritizes concise answers with citation and source links. So whereas ChatGPT is more flexible, generating longer text, summarizes creative content, code, and etc. The next feature is use cases. Search GPT idle for fact-finding, research, and tasks requiring up-to-date information, whereas ChatGPT is suitable for creative writing, brainstorming, drafting emails, and other open-ended tasks. So now question arises, when will Search GPT be released? Search GPT is currently in a limited prototype phase, meaning it's not yet widely available. OpenAI is testing with a select group to gather feedback and improve the tool. So if you are interested in trying Search GPT, so you can join the waitlist on its webpage, but you will need a ChatGPT account. A full public release by the end of 2024 is unlikely, as OpenAI hasn't set a timeline. It's more probable that Search GPT features will gradually added to the ChatGPT in 2024 or in 2025, with a potential standalone release later based on testing and the feedback. So with this, we have come to end of this video. If you have any question or doubt, please feel free to ask in the comment section below. Our team of experts will help you as soon as possible.
Did you know that within just a few lines of code, you can transform an AI model into something far more powerful? Something that responds to questions, connects to live data, pull insights from databases, and even interacts with other apps in real time. That's what LangChain allows you to do. And it's quickly becoming the go-to framework for AI developers. Think about this. You're about to create something amazing, an AI that can think, learn, and grow in ways we once only dreamed of. And here's the best part. You don't need to be an AI expert to make that happen. LangChain is like a toolkit that connects the most advanced large language models like OpenAI's GPT to real-time data, allowing you to build AI applications that are smart, flexible, and highly interactive. LangChain is more than just a way to make AI development easier. It's a framework that allows different language models to work together seamlessly. So whether you want to understand user questions with one LLM, create human-like responses with another, or pull in data from an API or a database, LangChain makes all possible. The framework takes care of heavy lifting, connecting models, managing data flows, and even customizing how your AI interacts with external sources. Now the question is, why is LangChain so popular? It has become one of the most fastest growing open source projects because it's solving a huge problem for developers. The challenge of integrating generative AI and LLMs with external data and complex workflows. As AI becomes more central to our lives in 2024, LangChain is helping developers create smarter, more powerful applications. So whether it's just for chatbots, content creation, or advanced data analysis. In this tutorial, I'll show you exactly how to get started with LangChain, from setting up your environment to building the first AI-powered app. I'll walk you through it. So LangChain makes it possible to train models on our own custom data, opening up more possibilities for building specialized intelligent applications. By the end of this video, you will be ready to start building with LangChain, and trust me, once you see how easy it is, you'll wonder why you didn't start using it sooner. Let's start with a simple question: why should we use LangChain? Imagine you're working with large language models like GPT-4 or Hugging Face models, and you want to take their capabilities further, like integrating them with your own data sources or allowing them to take action based on information they retrieve. This is where LangChain comes in. LangChain is like an open source framework that allows you to build intelligent applications by connecting large language models with external data sources. It can turn static AI interactions into dynamic, data-aware workflows. One of the best parts is you don't have to manually code everything from scratch. LangChain abstracts away much more complexity of working with LLMs, allowing developers to focus on building functional applications instead of wrangling API calls and managing data pipelines. So LangChain is set to play even bigger role in AI development because it enables you to harness true power of generative AI by connecting it with real-time data and external tools. So now we have understood what LangChain is. Let us now understand how to install LangChain. So let's start with the installation of LangChain. We'll just simply go to the website docs part, and we'll just read through this documentation. So here it has explained what LangChain is and what are the framework consisting of. So we also have these tutorials on how do we install LangChain. Okay, so for installing, you can just simply click on this quick start and see here it has written how do we set up on Jupyter Notebook. So this is the command if you want to install LangChain. We will use the pip command. So just simply you can copy this command pip install LangChain, and you have to open your command prompt or the terminal in your computer, and here you have to simply copy paste the command. So as you can see, it will load all the packages which is required for installing LangChain. So you can see your requirement already satisfied. This is because I had already installed my LangChain before. So we have understood how to install this LangChain by using this command, and you can also install the LLM chain. We'll understand it later. Now let me just show you what else you need to install. First, we have understood this LangChain. Then we have the Pinecone client. So we'll just simply search here Pinecone client, and it will redirect us to this page.
So Pinecone client is actually a vector store for storing and retrieving embeddings, which we will use in the later steps. So Pinecone is also used to actually, create secret API keys. So here you can also create the API keys. You can also read the documentation part. So we'll understand how to create API keys using OpenAI. But first, let us install Pinecone client in our system. So we'll again go to command prompt this terminal and we'll just copy paste pip install Pinecone client. So you can see here it will download and install all the packages required. So it has been installed. Now the third thing we're talking about is OpenAI client. So we'll use OpenAI models for a large language task. So we'll just simply search here OpenAI. Okay. And so it has redirected us to this page, OpenAI platform. And okay, before starting this, so this is the platform here where you can create, export an API key in OpenAI. Okay, so you can see here overview, quick start, concept, everything is there. And to create an API key, we'll just simply click here and here you have to select this option, create a new secret key. Suppose I give my secret key name, anything you can give. Suppose I give test 1, 2, 3. Okay, and permissions is all, and we create the secret key. Now you need to actually save your key. We'll just copy this key because it will be required later while debugging the code. So we will just copy paste this secret key. We will require it later and then done. So these are the keys I have created. So actually ChatGPT and other LLM models like OpenAI and Hugging Face uses LangChain to integrate with other APIs to create your own custom LLM models or chatbots. So suppose here we have logged in our ChatGPT here, and if I search here who won the WTC World Cup in 2023. So here it has shown the answer, but for example, if I search who won the cricket match World Cup, so here as you can see, the ChatGPT has given answer as my last knowledge update, the 24 Men's World Cup has not taken place yet. This is happening because this ChatGPT older version has not been trained on the latest upcoming news or whatever the new technology is. So by using LangChain, you can integrate with other APIs and you can create your own customized LLM models or chatbots, which help you to train your own custom data using various tools and APIs. So before we move on, I've already showed you how to create the secret API key and how you have to store the API key address. So first we have already understood how do we install LangChain here. So by using the pip command, we do it. And so you also need to install Python 3.8 or later installed in your system. So I already have Python installed. And to check that, you can just simply, I already have it installed in my system. So to check that, I'll simply just type here Python -- version and click enter. So as you can see, it has shown me the Python version which is installed in my computer. So the second step is already we have discussed, which is OpenAI API key here. So second step, we have already discussed how do we create our OpenAI API key. So we have to sign up in our OpenAI, then go to the API keys section and then create a new secret key. And these are the keys I have created, and you can just keep it later. Later you'll use that. So now we'll come to the third step, which is create a project directory and setup. So what we do is we have Jupyter installed in our system. So we'll just go to command prompt here and type JUPY, Jupyter Notebook. So it will redirect us to the Jupyter Notebook installed in our system. So if not, we can just simply go from here. It is loading right now. We have to wait. Now you just need to click on this new and Python 3 PyKernel, because Python has been installed in my system. So we will use Python as our kernel here. And here you can just give the prompts, the command. Before that, you have to create a Python file, which we can also create this Python file in Visual Studio Code. Just simply go to Visual Studio Code here and just simply click on File, New File, and I'll just type here python.py. And you can you have to first store the API key. For this, we use the command OpenAI underscore API underscore key equal to, and just give your secret key. Okay, you can just simply copy paste your secret key and just store this. So this ensures that your API key is stored securely and it can be used whenever needed. Now the step 4 is to initialize a project and install the required libraries. So you need to add some additional libraries like Streamlit to make a user interface. So let's add that too in our project folder. You can either create a text file named requirements.txt and then install all these. We have already installed the OpenAI LangChain. We just need to install Streamlit. So here you can just give the command pip install Streamlit. So as you can see, this I have already installed Streamlit before. Same wise, you can also install OpenAI if it is not installed in your system using the command terminal, the Windows PowerShell. So we have understood this, what all packages and what all we need to install. Now the next step is to build your first LangChain app. To create a simple app which uses a input query, and the app will generate a response using OpenAI's GPT model. So you have to create a Python file named main.py here. So as you can see, I've already imported this main.py, and this is my code here. Import Streamlit as st from LangChain and the constants I have created, and then I have initialized the OpenAI with our API key. So you have to just type this prompt here. I'm using VS Code here. You can also do it in your Jupyter notebook. And then to create the Streamlit app, you have to give a title, LangChain demo with OpenAI. So this is the title I have provided. And then the text input for prompt. The prompt is st.text input and enter a prompt. You can just type enter a prompt or whatever you wish to. And then display the response. So if prompt response is LLM.predict prompt, so you can use the predict method for LLM. So here what the app will, so after creating and debugging this in the terminal, so your app will initialize OpenAI using your API key, and the user inputs a prompt through the Streamlit interface. LangChain processes the input and sends it to the OpenAI's GPT model, and the AI generates a response which is then displayed in the app. So now you can use all these prompts to run on your app. So to do this, you can just, to see your app in action, you can just go to the terminal and run the following command, which is Streamlit run main.py. So you can just simply go to the terminal here and just simply type the command, which is Streamlit run main.py. So by giving this prompt, a new tab in your browser will open displaying the app, and you can also type any question into the input box. So now we have understood all these steps. So this was a quite basic tutorial on how to install LangChain and then, integrate it with the app. You can also customize and expand. So LangChain's flexibility allows you to integrate other APIs also, external data sources, or even add memory to your AI application. So whether you're building a simple chatbot or more complex AI system, the possibilities are endless. So by following all these steps, you will have a fully functioning app running in your system in no time.
What if I've told you I've tested over 1,000 AI tools? Yep, after all that exploring, experimenting, and a few late nights, I've finally narrowed them down to absolutely the best. In this video, I'm going to share my top picks of 10 tools from each of the 5 biggest AI categories that are actually worth your time. Whether you're into image creation, writing, voice tools, video generation, or AI coding assistance, I've got something lined up for you. These aren't random tools that kind of work. These are the ones that stood out, the ones that genuinely get the job done. So if you have ever felt overwhelmed by the flood of AI tools out there, this video is gonna be your cheat sheet to the top performers in every category. Let's start with the category of image creation. In the first place, we have Midjourney. If you're after breathtaking, artistic visuals, this one is for you. It's especially great for concept art, fantasy scenes, or anything with surreal, polished look. Next is DALL-E E3, integrated right inside the ChatGPT. What makes this tool stand out is how well it understands prompts. It nails small details and you can even edit parts of your image directly. Super useful for content creators or marketers who need fast, accurate visuals. Third is Stable Diffusion, and it's go-to for anyone who wants full control. It's open source, so you can run it locally, train your own models, and even build your own styles. If you're technically or just love to tinker, this one is for you. Coming to number 4 is Leonardo AI. It's made with game developers and storytellers in mind. It has pre-trained models for characters, environments, and even items. So if you are building a world, this tool makes it faster and easy to bring it to life. At number 5, we have Adobe Firefly. This one's perfect for professionals. It fits right into the Adobe ecosystem if you're already using the Photoshop or Illustrator. It's a smooth experience. The image quality is high and text effects are great for branding or designing work. Number 6 is Playground AI. This is probably the most flexible tool on this list. It's web-based, fast, and great for trying out multiple styles without any complexity. If you want something lightweight but powerful, definitely check this out. Artbreeder comes in at number 7 and it's a bit different from others. Instead of generating images from prompts, you mix and evolve existing images, great for character design, especially faces. It's super collaborative and creative, though a bit limited in image resolution. Number 8 is Night Cafe. This one's great if you want variety. It supports multiple generation styles like VQGAN and Stable Diffusion. There is also a strong community aspect, so you can share your work and get inspired by others. At number 9, we have Photo. It's clean, simple, and ideal for creating social media graphics, posters, or marketing visuals. You don't need any design skills. It's perfect for your quick results. And finally, number 10 is Deep Dream Generator. This one's all about the weird and abstract. It creates psychedelic dreamlike visuals that are super unique. It won't fit every project, but experimental or surreal work, it's awesome. Next category is voice generation. These AI tools can narrate, speak, or even clone your voice with shockingly realism. Whether you're creating YouTube videos, podcasts, audiobooks, or building characters for games, these are the voice tools that actually deliver. In the first place, we have 11 Labs. It's the most natural sounding AI voice out there. You get emotion, depth, and even voice cloning that sounds incredibly real. Coming to the second is Murph AI. This one is great for polished voiceover, perfect for videos, presentation, and training content. It even includes background music and timing control. At number 3, we have got Lovo AI, also known as Genai. With a huge voice library and support for 100 plus languages, it's ideal for creators who want expensive multilingual voiceovers. In the fourth place, we have Play.ht. It's fast, reliable, and offers detailed control over the tone, pitch, and speed. Great for podcast, articles, or any voice-first content. Number 5 goes to Resemble AI. This one's all about real-time voice cloning and emotionally delivering. Perfect for interactive content like games and virtual assistants. At number 6, we have Descript Overdub. Audio by editing text. It's a lifesaver for podcasters and video creators fixing mistakes or adding new lines. Seventh on this list is Typecast. It combines realistic voice AI with animated characters, making it perfect for explainer videos, YouTubers, and storytelling content. At number 8, we have Speechify. Originally made for reading, but now you can use it to turn any text into clean, human-like speech. Great for audiobooks and productivity. Number 9 is Synthesis. A solid choice for business voiceover, whether it's ads, explainers, or training videos. This one gets it done with professional sounds. And finally, in the 10th place, we have Podcastle. It's an all-in-one podcasting platform with built-in voice generation, recording, and editing. Perfect for creators on the go. Now let's talk about writing. Whether you're crafting blog posts, emails, scripts, or social media caption, AI writing tools can save you hours and spark ideas you wouldn't have a thought of. I have tested dozen and these are 10 that stood out how well they actually help you write smarter and faster. In the first place, we have ChatGPT by OpenAI. It's a gold standard. From brainstorming to full-on article drafts, it handles everything with context and style. Especially with GPT-4, it's like having a writing assistant that just gets it. Second is Jasper AI, built specially for marketers and content creators. Jasper comes with tons of pre-built templates for product description, ad copy, blog intros, you name it. It's fast, efficient, and optimized for high converting content. At number 3, we have Writersonic. This one's amazing for versatility. It does blogs, landing pages, Google Ads, and even long form content. It also has a chatbot, so it feels more interactive while creating. Fourth is Copy.ai. If you need social media post, product description, or email subject lines in seconds, this tool nails it. It's super intuitive and beginner friendly, perfect for quick content sprints. In the 5th place, we have Notion AI. Built right into Notion, this tool helps you expand, summarize, and brainstorm inside your notes and docs. Great for people who want writing help in their daily workflow without switching tools. Number 6 is PseudoWrite. This one's made for creative writers such as novelists and storytellers. It helps with characters, development, plot twist, and rewriting the scenes. If you write friction, this is a secret weapon. 7th is Ink Editor. It combines AI writing with SEO optimization. So if you want your content to rank while sounding human, this tool does both. Great for bloggers, content marketers. Coming to number 8 is HypeWrite. It is like a smart autocomplete that works across your browser. It helps you draft emails, social posts, and even essays. At number 9, we have got Writer. Clean, fast, and super affordable. Writer is a solid tool for small businesses and freelancers who want quick content without any complexity. And finally, number 10 is WordTune. It is not a full-blown writing platform, but it's amazing at rewriting, rephrasing, and polishing your text. Great for improving tone, clarity, and shortening long sentences. Alright, now let's move on into the most powerful category, which is AI video creation. Whether you are a content creator, marketer, educator, or just someone who wants to make videos without cameras, editing headaches, these tools can seriously level up your workflow. In the first place, we have got Pictory. This tool turns scripts or blog posts into professional-looking videos in minutes. It picks stock footage and adds music and even guarantees subtitles all automatically. Next up at number 2 is Synthesia. It's famous for its AI avatars that looks and sounds like real people. Just type in your script, pick an avatar, and boom, you have got your studio style video with zero filming. In the third place is Runway. This one's creative powerhouse. You can remove the video backgrounds, edit scenes, and text commands, and even generate a new video content using Gen 2. It's especially great for short form content or experimental visuals. Coming at number 4 is InVideo. It's built for marketers, content creators who want to make polished promo videos, reels, or even YouTube content. Tons of templates, stock assets, and AI script assistance makes it fast and easy. Fifth is Lumen 5, ideal for turning blog post or article into animated videos. You just paste in your text and it automatically adds visuals, animations, and transition to match your message. Great for social media and explained content. At number 6, we have Descript. While it is more known for podcasting and editing audio, its video editor is crazy useful. You can edit videos by editing the transcript. It's great for talking head content, interviews, and repurposing long form recordings. Number 7 is Wheat.io, a browser based editor that is surprisingly powerful. You get subtitles, transition, audio cleanup, and more, all with a super clean UI. It's great for social media content and quick edits on the fly. Eighth is Rephrase.ai. This one lets you create personalized video messages using AI avatars. Perfect for sales, onboarding, or sending custom messages at scale without having to record anything manually. In the ninth place, we have Steve.ai. Super beginner friendly. It turns simple text into videos using animations and voiceover. Great for explained videos, internal training, or educational content. And finally, number 10 is Eli.io. It creates AI avatar videos from just a prompt or script, similar to Synthesia, but with a focus on e-learning and corporate training content. Scalable, clean, and no need a production crew. Now let's get into the most game-changing areas of AI, coding assistance. Whether you're a beginner or a pro developer, these tools can help you write better code, debug faster, and even learn new languages or frameworks without getting overwhelmed. In the first place, we have GitHub Copilot, powered by OpenAI. This tool is an autocomplete on steroids. It suggests whole functions, helps you write boilerplate, and even explains code, all from inside your editor. If you're coding on a daily basis, this is a must-have. Second is Codium. It's a free, fast, and supports a wide range of languages. It works like a copilot but adds some extra customization. And a lot of devs love it for its speed and clean interface. At number 3 is Replit Ghostwriter. Especially great for beginners and educator, Replit's AI can help you code right inside the browser. No setup needed. It also helps you explain errors and teach you as you build. Fourth is Tabline, one of the easiest code compilation tool. Tabline runs locally for privacy and works across multiple IDEs. It's great for developers who want predictive coding without sending data to the cloud. In the fifth place, we have Amazon Code Whisper. Designers to integrate smoothly with AWS tools and workflows. It's perfect if you're building cloud-native application or working on AWS ecosystem. Coming at number 6 is Codex by OpenAI. It's an underlying model behind Copilot, and if you're working in an experimental or custom environment, it offers a deep integration potential for AI-driven apps. Number 7 is Mutable AI, a newer player focused on speeding up your workflow with smart suggestions, automatic doc generation, and code refraction. It's great for clean, productive level code. 8th is Kite. It is one of the OG AI assistants for Python and still holds up if you want lightweight, fast suggestions without overwhelming features. At number 9, we have SourceGraph Cody. It's made for enterprises terms that work on massive code bases. It gives powerful contextual help and scales well across big projects. And finally, number 10 is Ask Cody. It's super handy for generating snippets, SQL queries, and even API docs. A nice tool for quick tasks when you don't want to dive too deep.
So now what is RNN? RNN are a type of neural network that are designed to process sequential data. They can analyze data with temporal dimensions such as time series, speech, and text. RNN can do this by using a hidden state passed from one timestamp to the next. The next hidden state is updated at each other timestamp based on the input and the previous hidden state. RNN are able to capture short-term dependencies in sequential data, but they struggle with capturing long-term dependencies. Why the LSTMs are made? So moving forward, let's discuss types of LSTM gates. So LSTM models have three types of gates: the input gate, the forget gate, and the output gate. So let's first discuss the input gate. The input gate controls the flow of information into the memory cell, deciding what to store. The input gate determines which values from the input should be updated in the memory cell. It uses a sigmoid activation function to scale the values between 0 and 1, and then applies pointwise multiplication to decide what information to store. Next is forget gate. Controls the flow of information out of the memory cell, deciding what to discard. The forget gate decides what information should be discarded from the memory cell. It also uses a sigmoid activation function to scale the values between 0 and 1, followed by pointwise multiplication to determine what information to forget. The last one is output gate. Controls the flow of information out of the LSTMs, deciding what to use for the output. The output gate determines the output of the LSTMs unit. It uses a sigmoid activation function to scale the values from 0 to 1, then applies pointwise multiplication to produce the output of the LSTM unit. So these gates implemented using sigmoid function are trained using backpropagation. They open and close based on the input and the previous hidden state, allowing the LSTM to selectively retain or discard information, effectively capturing long-term dependencies. So now let's discuss application of LSTM. LSTM models are highly effective and used in various applications, including video analysis, analyzing video frames to identify action, object, and scenes. The second is language simulation, tasks like language modeling, machine translation, and text summarization. The third one is time series prediction, so predicting future values in a time series. The fourth is voice recognition, tasks such as speech to text transcription and command recognition. The last one is sentiment analysis, classifying text sentiment as positive, negative, or neutral. So there are many more examples of LSTM. So now let's move forward and understand LSTM model and how it works with example. Let's consider the task of predicting the next word in a sentence. This is a common application of LSTM networks in natural language processing. So I will break it down step by step using the analogy of remembering a story and deciding what comes next based on the context. So imagine you are reading a story. As you read, you need to remember what has happened so far to predict what might happen next. So let's illustrate with a simple example sentence. The cat sat on the dash. So you want to predict the next word, which could be mat or roof or something else. An LSTM network helps this make prediction by remembering important parts of the story and forgetting irrelevant details. So now let's dive into step-by-step process. So step-by-step explanation using LSTM. The first one is reading the story, input sequence. As you read each word in the word sentence, you process it and store relevant information. For example, you understand it's a determiner. Cat, you know it's a noun and the subject of the sentence. Sad indicates the action performed by the subject. On, preposition indicating the relationship between the cat and the next noun. So this sequence diagram showing the words being read and processed. So second comes forget gate. As you move through the sentence, you might decide that some details are no longer important. For instance, you might decide that knowing the is less important now that you have cat and said. So the word forget gate help discard this less important information. So this sequence diagram you can see on the screen showing how relevant information is discarded. So the third one, input gate. When you read on, you need to decide how relevant this information is. So this sequence diagram in the screen is showing how new information is integrated with the last one. Okay, the fourth one is the cell state, memory part. So this is like your memory of the story so far. It carries information about the subject cat and the action set on. So it updates the new information as you read each word. Okay, the cat sat on the, retaining the important context. So this sequence diagram showing how the memory is updated with the new information. So the last one is output gate. When you need to predict the next word, the output gate helps you decide based on the current memory cell state. So it uses the context. The cat sat on the. So the predict the next word might be mat, because cat and mat are often associated with the context. So it can predict anything. The cat sat on the table or on the sofa, anything. But mat, why I'm saying mat? Because cat and mat are often associated in the same context. So this diagram is showing the prediction of the next word based on the current memory. So there are many applications where you can use LSTM in predicting time series or next word in the sentence. So by the using of LSTM gates, input gate, forget gate, and output gate, and updating the cell state, the network can predict the next word in a sequence by maintaining relevant context and discarding unnecessary information. This step-by-step process allows LSTM network to effectively handle sequence and make accurate prediction based on the context. Sora is here. OpenAI has introduced Sora, an advanced AI tool for creating videos, now available at sora.com. Earlier this year, Sora was launched to turn text into realistic videos, showcasing exciting progress in AI technology. Now, OpenAI has released Sora Turbo, a faster and more powerful version available to ChatGPT Plus and Pro users. Sora lets users create videos in 1080p quality up to 20 seconds long and in different formats like widescreen, vertical, or square. It includes tools like a storyboard for precise control and options to remix or create videos from scratch. There is also a community section with featured and recent videos to spark ideas. ChatGPT Plus users can make up to 50 videos per month at 480p resolution, while Pro users get access to more features like higher resolution and longer video duration. While Sora Turbo is much faster, OpenAI is still working to improve areas like handling complex action and making the technology more affordable. To ensure safe and ethical use, Sora includes features like visible watermarks, content moderation, and metadata to identify videos created with Sora. Sora makes it easier for people to create and share stories through video. OpenAI is excited to see how users will explore new creative possibilities with the powerful tool. So welcome to the demo part of the Sora. So this is the landing page when you will log in Sora. So let me tell you, I have the ChatGPT Plus version, not the Pro version. So I have some 721 credits left. Okay, later on I will tell you what are the credits. Okay, so let's explore something here. So these are some recent videos which I have created or tested, you can say, and this featured version is all the users of Sora which are creating videos, so it's coming under featured, so we can learn or we can generate some new ideas like this. Okay, like this parrot and all, like this is very cool for learning. And these are some of the saved version, and these are all videos and uploads like this. So let's come into the credit parts. Okay, so you can see I have 721 credit left. So if you will go this help openai.com page, and this page you can see what are the credits. So credits are used to generate videos with Sora. Okay, so if you will create 480p square 5-second video, it will take only 20 credits. Okay, for 10 it will take 40, then this. Okay, for 480p this much credit, 25 credit, 50 credit, like this. 720 is different, 1080p different. Okay, so here it is written, please note that requesting multiple variation at once will be charged at the same rate as running two separate generation requests. Okay, so here this plus icon you can see, so here you can upload the image or video. Okay, so you can also do like this, you can upload the image and you can create the video from that image. Okay, and this is choose from library, your personal library, this library, right? And this option is for the variation. Okay, like these are basically presets like balloon world, stop motion, archival, film noir, or cardboard, and the paper. Okay, so this is the resolution, okay, 480p. This is the fastest in video generation. Okay, 720p will take like 4x slower, and 1080p 8x slower. I guess 1080p is only available in ChatGPT's pro version. Got it? Okay, so we are just doing. I'm just showing you demo, so I will choose this fastest version only. Okay, so this is the time duration, how long you want, like 5 second, 10 second, 15 and 20 seconds is available in pro version, okay, of ChatGPT. And this is how much versions you want to take. I will select only 2, okay, because it will again charge more credits to you. Okay, and these credits are monthly basis, I guess. Okay, these credits are monthly basis. Okay, see, again, recut, remix, blend, loop to create content. This will take again more credits. Okay, see here, ChatGPT Plus, up to 50 priority videos, 1000 credits. Okay, per month, I guess. Yeah, per month, up to 720p resolution and the 5-second duration. And ChatGPT Pro, up to 500 priority videos, 10,000 credits, unlimited relax videos, up to 1080p resolution, 20-second duration, download without watermark. Here you can download with watermark, I guess. I don't know. Yeah, we'll see about everything. Okay, ChatGPT. But ChatGPT Pro is $200 per month. So, yeah, it's expensive, right? So yes, let's do something creative. So okay, I will write here. Okay, polar bear enjoying on the Sahara desert. Okay, Sahara desert. Yeah. Okay, you can do storyboard as well, or you can create directly videos. Okay, so let me show you the storyboard first. Yeah, so frame by frame you can give different what to say, prompt. Okay, here you can give different prompt. Okay, polar bear with family. Okay, playing with sand, like this. Okay, and later on it will create a whole the video. Okay, third, you can describe again, you can add image, like this. Okay, this is a story created by the ChatGPT. Okay, let's create. Okay, add it to the queue. Okay, it's very fast actually, almost done. Yeah, see, with family, you can see playing with the sand. Okay, so these are the two variation. Okay, you can choose either this or either that one, or either that one. Okay, I'm feeling this much as, yeah. So here you can again edit your story, recut, you can trim or extend this video in a new storyboard. Okay, so basically recut features allow you to creators to pinpoint and isolate the most impactful frame in a video, extending them in either direction to build out of like complete scene. Okay, if we'll choose recut, okay, this thing, fine. Then remix. What remix do is, like, the remix features allows user to reimagine existing videos by altering their components without losing that essence of the originality, you can say. Okay, you want to add or remove certain things. Okay, what if I want to remove that this polar bear, or like this. Okay, or you can say we can change colors, or we can some tweak visual elements. And this blend, so this blend feature allows you to combine with different video. If I want to upload some videos, it will blend both the video, this video particular with that video which I will upload. Okay, right. And the last loop, by the name, loop features feature make it easy to create seamless repetition of the video. Okay, this is one option is ideal for background visuals, music videos, like this. Okay, so this is how you can create video in 2 minutes, I can say, just by giving prompt. Okay, this one is favorite, you can save it for the favorite, and this you can sharing options are there, copy link or this unpublished, and you can download. See, I told you without watermark is available in only pro version. So I have this with watermark, you can download. See, download a video in just a click, or you can download as a gif as well, right? And add to a folder. Okay, fine, this is the notification activity on, right? So let's create one. Okay, monkey with family driving car on the space. Yeah, so okay, I will choose this time 16:9. Like, it takes more credit of mine, it's okay. Yeah, add it to the queue. If you'll go to favorites, it will come this one because I chose it. Okay, and if you will ask how this Sora is working, so it's like text to image generative AI models such as like DALE 3, Stable Diffusion, and Midjourney. So Sora is a diffusion model. That means that it starts with each frame of the video consisting of the static noise. See, oh, it's cartoonish, but yeah. See, if you want Lamborghini, you can add that I want Lamborghini or Tesla, whatever. So this is how you can generate videos with Sora, in a quick 2 minutes. Hello everyone, I am Mank and welcome to today's video where we will be talking about LLM benchmarks, tools used to test and measure how well large language models like GPT and Google Gemini performs. If you have ever wondered how AI models are evaluated, this video will explain it in simple terms. LLM benchmarks are used to check how good these models are at tasks like coding, answering questions, and translating languages or summarizing text. These tests use sample data and specific measurement to see how well the model performs. For example, the model might be tested with a few examples, like few short learning, or none at all, like zero short learning, to see how it handles new tasks. So now the question arises, why are these benchmarks important? They help developers understand where a model is strong and where it needs improvement. They also make it easier to compare different models, helping people choose the best one for their needs. However, LLM benchmarks do have some limits. They don't always predict how well a model will work in real-world situations, and sometimes model can overfit, meaning they perform well on test data but struggle in practical use. We will also cover how LLM leaderboards rank different models based on their benchmark scores, giving us a clear picture of which models are performing the best. So stay tuned as we dive into how LLM benchmarks work and why they are so important for advancing AI. So without any further ado, let's get started. So what are LLM benchmarks? LLM benchmarks are standardized tools used to evaluate the performance of large language models. They provide a structured way to test LLMs on a specific task or question, using sample data and predefined metrics to measure their capabilities. These benchmarks assess various skills such as coding, common sense reasoning, and NLP tasks like machine translation, question answering, and text summarization. The importance of LLM benchmark lies in their role in advancing model development. They track the progress of an LLM, offering quantitative insights into where the model performs well and where improvement is needed. This feedback is crucial for guiding the fine-tuning process, allowing researchers and developers to enhance model performance. Additionally, benchmarks offers an objective comparison between different LLMs, helping developers and organizations choose the best model for their needs. So how LLM benchmarks work? LLM benchmarks follow a clear and systematic process. They present a task for LLM to complete, evaluate its performance using specific metrics, and assign a score based on how well the model performs. So here is a breakdown of how this process works. The first one is setup. LLM benchmark come with pre-prepared sample data, including coding challenges, long documents, math problems, and real-world conversation. The task span various areas like common sense reasoning, problem solving, question answering, summary generation, and translation, all present to the model at the start of testing. The second step is testing. The model is tested on one of the three ways. Few shot, the LLM is provided with a few examples before being prompted to complete a task, demonstrating its ability to learn from limited data. The second one is zero shot. The model is asked to perform a task without any prior examples, testing its ability to understand new concepts and adapt to unfamiliar scenarios. The third one is fine-tune. The model is trained on a dataset similar to the one used in the benchmark, aiming to enhance its performance on the specific task involved. The third step is scoring. So after completing the task, the benchmark compares the model's output with the expected answer and generates a score, typically ranging from 0 to 100, reflecting how accurately the LLM performed. So now moving forward, let's see key metrics for benchmarking LLMs. So LLMs benchmark uses various metrics to assess the performance of large language model. So here are some commonly used metrics. The first one is accuracy or precision. Measure the percentage of correct prediction made by the model. The second one is recall, also known as sensitivity, measure the number of true positive reflecting the correct prediction made by the model. The third one is F1 score, combines both accuracy and recall into a single metric, weighing them equally to address any false positive or negatives. F1 score ranging from 0 to 1, where 1 indicates perfect precision and recall. The fourth one is exact match, tracks the percentage of predictions that exactly match the correct answer, which is especially used for the tasks like translation and question answering. The fifth one is perplexity gauges. Here it will tell you how well a model predicts the next word or token. A lower perplexity score indicates better task comprehension by the model. The sixth one is BLUE, bilingual evaluation understudy. Is used for evaluating machine translation by comparing n-grams, sequence of adjacent text element, between the model's output and the human produced translation. So these quantitative metrics are often combined for more through evaluation. So in addition, human evaluation introduces qualitatively factors like coherence, relevance, and semantic meaning, provide a nuanced assessment. However, human evaluation can be time consuming and subjective, making a balance between quantitative and qualitative measures important for comprehensive evaluation. So now let's moving forward see some limitation of LLM benchmarking. While LLM benchmarking are valuable for assessing model performance, they have several limitations that prevents them from the fully predicting real-world effectiveness. So here are some few. The first one is bounded scoring. Once a model achieves the highest possible scores on the benchmark, that benchmark loses its utility and must be updated with more challenging tasks to remain a meaningful assessment tool. The second one is broad dataset. LLM benchmark often rely on sample data from diverse subjects and tasks. So this wide scope may not effectively evaluate a model's performance in edge cases, specialized fields, or specific use cases where more tailored data would be needed. The third one is finite assessment. Benchmark only tests a model's current skills, and as LLMs evolve and new capabilities emerge, new benchmarks must be created to measure these advancements. The fourth one is overfitting. So if an LLM is trained on the same data used for benchmarking, it can be lead to overfitting, where the model performs well on the test data but struggles with the real task. So this result is scores that don't truly represent the model's broader capabilities. So now what are LLM leaderboards? So LLM leaderboards publish a ranking of LLMs based on the variety of benchmarks. Leaderboards provide a way to keep track to the myriad LLMs and compare their performance. LLM leaderboards are especially beneficial in making decisions on which models to use. So here are some. So in this you can see here OpenAI is leading and GPT-4 second and the Llama third with 405 parameter B and 3.5 Sonnet is there. So this is best in multitask reasoning. What about the best in coding? So here OpenAI O1 is leading. I guess this is the Orion one, and the second one is 3.5 Sonnet, and after that in the third position there is GPT-4. So this is in best in coding. So next comes fastest and most affordable models. So fastest models are Llama 8B parameter, and the second one is LLAMA Llama 70B. And the third one is 1.5 Flash. This is Gemini 1. And lowest latency. Here it is leading Llama again. In cheapest models, again Llama 8B is leading. And in the second number, we have Gemini Flash 1.5. And in third, we have GPT-4o Mini. Moving forward, let's see standard benchmarks between Claude 3 Opus and GPT-4. So in general, they are equal. In reasoning, Claude 3 Opus is leading, and in coding, GPT-4 is leading. In math, again GPT-4o is leading. In tool use, Claude 3 Opus is leading, and in multilingual, Claude 3 Opus is leading.
Hey there, tech adventurers! Have you ever wished for an AI assistant that's super smart, lightning fast, and can help you code like a pro? Well, buckle up, because today we are diving into the world of Claude 3.7 Sonnet, or as some may like to call it, Claude Code. This AI model just launched, and let me tell you, it's making waves.
But what makes it so special? And how does it compare to OpenAI's ChatGPT, Google Gemini, and even Grok from XAI? Well, stick around because we are going to break it down all for you. So what exactly is Claude 3.7 Sonnet? It's the newest brainchild of Anthropic and it's designed to be one of the smartest AI assistant out there. Think of it as the next level upgrade to its predecessor, Claude 3.0. But wait, there's something extra special about this version. It's not just a general AI assistant, it has a superpower, which is coding. That's why people call it Claude Code. So whether you're writing Python, JavaScript, or C++, Claude Code can be your ultimate coding sidekick. Now let's talk about why Claude 3.7 is such a big deal. Imagine a super cool AI competition where we bring in the best of the best. Claude 3.7 Sonnet, ChatGPT 4, Gemini 2, and Grok 1.5. Now let's find out who is the smartest, who's the fastest, and who's the best at coding. First, let's talk about speed and efficiency. Claude 3.7 Sonnet is fast. If ChatGPT 4 were a high-speed train, then Claude 3.7 would be a rocket. It processes responses quickly, making conversation feel super smooth. And talking about Grok, well, it's got speed, but it's not that sharp when it comes to deep reasoning. Now let's compare between intelligence and understanding. Let's talk about brains. ChatGPT 4 is really smart, but Claude 3.7 has a special trick. It's better at understanding long and complex prompts. Imagine explaining a super tricky math problem to an AI. ChatGPT 4 does a good job, but Claude 3.7 really gets it and responds with a clear, accurate answer. Gemini is great for general knowledge, but sometimes it gets things mixed up. Now let's talk about coding superpowers. This is where Claude 3.7 really shines. It's designed to be a coding genius. Need to write a Python script? Claude's code got your back. Stuck on debugging? It finds errors fast and even suggests fixes. Want to optimize your code? It offers solutions that make your program run better and faster. While ChatGPT 4 is also an awesome coding assistant, Claude 3.7 often gives more structured, step-by-step explanations, making it easier for beginners and pros alike. Gemini can code too, but it sometimes struggles with more complex programming logic. And Grok, well, it's all catching up in coding department. Let's now talk about memory and context. One of the coolest things about Claude 3.7 is that it remembers context really well. If you give it a long conversation with multiple steps, it doesn't lose track. ChatGPT 4 is also great at this, but sometimes it forgets little details. Gemini, it's improving, but it can get confused in long discussions. Let's talk about safety and reliability. Let's be real for a second. AI safety is super important. Nobody wants weird or harmful responses. Claude 3.7 is built with strong guardrails, making sure it's helpful, respectful, and accurate. It's one of the safest AI models out there. ChatGPT 4 is also really good in this area, while Grok and Gemini are still fine-tuning their safety measures. Alright, so if you're into coding or even just thinking about learning to code, you need to check out Claude Code. Here's why. First of all, it's great for beginners. It explains things step by step, so even if you're new to coding, you won't feel lost. Second of all, advanced debugging. It finds and fixes errors in your code, sometimes before you even realize there's a problem. Third is code optimization. It suggests better, faster, and more efficient ways to write your programs. Multi-language support. So whether you're working in Python, Java, C++, or even web languages like HTML and JavaScript, Claude Code can help too. Clear explanations. It doesn't just give you answers, it teaches you how to solve problems. If ChatGPT 4 is a really good coding tutor, then Claude Code is like a super coach that makes you better programmer. So, is Claude 3.7 Sonnet the best AI assistant? Well, if you need a coding partner, absolutely. It's fast, smart, accurate, and safe. Compared to ChatGPT 4, it holds its own and even outperforms in some areas like speed and long context understanding. Against Gemini, it's more reliable and less likely to make mistakes. And versus Grok, well, Grok is still learning the ropes. And at the end of the day, the best AI depends on what you need. But if you're a coder or want to become one, Claude 3.7 Sonnet, that is Cloud Code, is the ultimate AI assistant for you. Alright, tech explorers, now it's your turn. If you want to see Claude Code in action, go try it out. Whether you're writing your first Hello World program or building a complex AI project, Claude 3.7 Sonnet is here to help. Who knows, with an AI assistant this smart, you might just become the next coding superstar.
OpenAI is one of the main leaders in the field of generative AI, with its ChatGPT being one of the most popular and widely used examples. ChatGPT is powered by OpenAI's GPT family of large language models, LLMs. In August and September 2024, there were rumors about a new model from OpenAI, codenamed Strawberry. At first, it was unclear if it was the next version of GPT 4.0 or something different. On September 12, OpenAI officially introduced the O1 model. Hi, I am Mayank. In this video, we will discuss about OpenAI model O1 and its types. After this, we will perform some basic prompts using OpenAI Preview and OpenAI Mini. And at the end, we will see comparison between the OpenAI O1 models and GPT 4.0. So without any further ado, let's get started. What is OpenAI O1? The OpenAI O1 family is a group of LLMs that have been improved to handle more complex reasoning. These models are designed to offer a different experience from GPT 4.0, focusing on thinking through problems more thoroughly before responding. Unlike older models, O1 is built to solve challenging problems that require multiple steps and deep reasoning. OpenAI O1 models also use a technique called chain of thought prompting, which allows the model to think through problem step by step. OpenAI O1 consists of two models, O1 Preview and O1 Mini. The O1 Preview model is meant for more complex tasks, while the O1 Mini is a smaller, more affordable version. So what can OpenAI O1 do? OpenAI O1 can handle many tasks, just like other GPT models from OpenAI, such as answering questions, summarizing content, and creating new material. However, O1 is especially good at more complex tasks, including the first one is enhanced reasoning. The O1 models are designed for advanced problem solving, particularly in subjects like science, technology, engineering, and math. The second one is brainstorming and ideation. With its improved reasoning, O1 is great at coming up with creative ideas and solutions in various fields. The number third is scientific research. O1 is perfect for tasks like annotating cell sequencing data or solving complex math needed in areas like quantum optics. The number fourth is coding. The O1 models can write and fix code, performing well on coding tests like human eval and code forces, and helping developers build multi-step workflows. The fifth one, mathematics. O1 is much better at math than previous model, scoring 83% in the International Mathematics Olympiad test compared to GPT 4.0's 13%. It also did well in other math competitions like AIME, making it useful for generating complex formulas for physics. And the last one is self-fact checking. O1 can check the accuracy of its own responses, helping to improve the reliability of its answer. You can use OpenAI O1 models in several ways. ChatGPT Plus and team users have access to O1 Preview and O1 Mini models and can manually choose them in the model picker. Although free users don't have access to the O1 models yet, OpenAI planning to offer O1 Mini to them in the future. Developers can also use these models, OpenAI's API, and they are available on third-party platforms like Microsoft Azure AI Studio and GitHub models. So yes guys, I have opened this ChatGPT 4.0 model here and ChatGPT O1 Preview, as you can see. So I have this Plus model, okay, the paid version of ChatGPT. So I can access this O1 Preview and O1 Mini model. Okay, we will go with O1 Preview model and we will put same prompts in both the model of the ChatGPT 4.0 and the O1 Preview and see what are the differences are coming. Okay, so we will do some math questions and we will do some coding. We will do some advanced reasoning and quantum physics as well. Okay, so let's start with, so I have some prompt already written with me. So first one is number theory. Okay, so what I will do, I will copy it from here and paste it in this and both. Okay, so let me run in 4.0 and O1 Preview. So here you can see it's thinking. Okay, So this is what I was saying, chain of thoughts. Okay, so these are the chain of thoughts. First is breaking down the primes, this is, and then is identifying the GCD. And now see the difference between the output. See, output is 561 is not a prime number, and the GCD, greatest common deceiver, of 48 and 180 is 12. Okay, here see, ChatGPT O1 preview is giving the output in step by step. First, see, determine if 561 is a prime number or not. The number 561 is not a prime number. It's a composite number because it has this. Okay. Then second step, then the greatest common divisor. Then they found 12. And answer is no, 561 is not composite number because of this. And the greatest common divisor of 48 and 180 is 12. See, just see the difference between the two models. This is why ChatGPT O1 models are crazy for math, coding, and advanced reasoning, quantum physics, for these things. Okay, so let's go with our second step. So here, if you will see, you can see the attach file option in ChatGPT 4.0. Okay, you can come upload from your computer, but here we will see in O1 there is no attach file option. This is one drawback. Okay, so here upload from computer. So this is one small. Okay, and let me open this, and this is the question I have. Okay, yeah, so I will copy this, I will run this and this. Okay, see, it's start giving the answer, and O1 is still thinking, solving the equation, then analyzing the relationship. Okay, so ChatGPT O1 will take time, but it will give you more accurate, more step by step as you want. Okay, so here you can see solve for actions question, this, and here the steps you can see. Okay, this is more structured way, you can say, in a good structured way. Okay, ChatGPT O1 preview give you in good structured way as O1 mini as well. Okay, so yeah, so here they wrote just 1 and 2, this, and here if you'll see question 1, solve for x in this, and step 1 is this, step 2 is this, and step 3 is this, then the answer of x is equals to 3. But here simply they wrote we know this, and x equals to 3. For the second question, see, expanding the left hand side, this, but here step 1, square both sides of the given equation. Start by squaring both sides. Okay, it's written but not in good way. Okay, so this is why O1 is better for math. Okay, so now let's check it for the coding part. Okay, so I have one question. Okay, let me see what output it will give to. First I will write I need. Okay, leave it. I will copy it, and I will copy it as well here, run it and run it. See, it's start giving answer. Okay, and still this will adjust the parameters, ensuring the code generation, because ChatGPT O1 will think first, then it will analyze, then after that it will give you answers. Okay, here the code is done. See, here the code is done and it's still thinking. Step 1, and first here you can't see anything. See, step setup development environment, pip install numpy matplotlib, then this, and here nothing. And but I will ask it, okay, give me code in one tab. Okay, here also I will write give me code in single tab. Okay, so I can just copy and paste. So what I will do, I will open one online compiler and I will directly copy it and paste. Okay, so let's finish this. I hope it will work. So let me open W3 Schools compiler. Okay, yeah, same I will open for this W3 School. Okay, so let me copy the code and my bad and paste it here. Same works for this. Okay, okay, I will copy the code and I will paste it here. Okay, I hope it gives something. Yeah, cool. So yes, now you can see the difference between the output. So this is the output of 4.0 and this is the output of O1 preview. See, O1 preview output is this and this is the output of 4.0. So this is the difference. This is why O1 takes time, but it will give you more accurate result in a good way. Okay, so now let's check something else. So moving on, let's see some advanced reasoning question. Okay, so this is the logical puzzle one, the first one. Okay, so I will copy it and I will paste it here. Okay, this is for O1, this is for preview. Because why I'm not comparing O1 with mini? Because they both are same, but slightly differences there. Okay, so here we can see more difference between 4.0 old model versus new model, you can say. Okay, so now see, the answer is end in this much only, but it will explain you in a better way. See, thoughts for 7 seconds, explanation, that case 1 then case 2. Okay, with conclusion in both scenarios, summary, and this here, this one small explanation, and that's it, right? So they created O1 preview for more, it will describe you more in a better way, right? Now let's see some scientific reasoning as well. Okay, so let me copy it here. So still thinking, but start giving answer. Says thought for 16 seconds. So again, I will say that ChatGPT O1 is much better than ChatGPT 4.0. ChatGPT 4.0 is great for content writing and all, but ChatGPT O1 preview and mini are very good for reasoning, math, coding, or quantum physics, these type of things. Okay, advanced reasoning. Okay, ChatGPT 4.0 is great for generative text. Okay, like for marketing, writing copies, emails, and all of those. So now let's see some comparison between O1 models and GPT 4.0 model. When new models are released, their capabilities are revealed through benchmark data in the technical reports. The new OpenAI model excels in complex reasoning tasks. It surpasses human PhD level accuracy in physics, chemistry, biology on the GPQA benchmark. Coding becomes easier with O1 as it ranks in the 89th percentile of the competitive programming questions Codeforce. The model is also outstanding in math. On a qualifying exam for International Mathematics Olympiad IMO, GPT-4o solved only 13% of problems, while O1 achieved 83%. This is truly next level. On the standard ML benchmarks, it has huge improvement across the board. MMLU means multitask accuracy and GPQA is reasoning capabilities. Human evaluation. OpenAI asks people to compare O1 Mini with GPT-4o on difficult open-ended tasks across different topics. Using the same method as the O1 preview versus GPT-4o comparison, like O1 preview, O1 Mini was preferred over GPT-4o for tasks that require strong reasoning skills, but GPT-4o was still favored for language-based tasks. Model speed. As a concrete example, we compared responses from GPT-4o, O1 Mini, and O1 preview on the word reasoning question, while GPT-4o did not answer correctly. Both O1 Mini and O1 preview did, and O1 Mini reached the answer around 3 to 5x faster. Limitation and what's next. Due to its specialization on STEM, science, technology, engineering, and math, reasoning capabilities, Owen Mini's factual knowledge on non-STEM topics such as dates, biographics, and trivia is comparable to small LLMs such as GPT-4 or Mini. OpenAI will improve these limitations in future versions, as well as experiment the extending the model to other modalities and specialties outside of STEM.
Today, we are diving into the fascinating world of Google Quantum AI. We'll break it down step by step. What Google Quantum AI is, how it's different from classical computers, and why it's a game changer, and the real problem it's solving. We'll also explore the latest developments, their innovative hardware, the challenges they face, and why, despite the hurdles, it's still an incredibly exciting field with a bright future. Stick with me because by the end, you'll be amazed at how this technology is shaping tomorrow. So let's get started. The universe operates on quantum mechanics, constantly adapting and evolving to overcome the hurdles it encounters. Quantum computing mirrors the dynamic nature. It doesn't just work within its environment, it responds to it. This unique trait opens the door to groundbreaking solutions for tomorrow's toughest challenges. The question arises, what is Google Quantum AI? Quantum AI is Google's leap into the future of computing. It's a cutting-edge project where they are building powerful quantum computers and exploring how these machines can solve problems that traditional computers struggle with or can't solve at all. If not aware, classical computers use bits like 0 or 1 and solve tasks step by step, great for everyday use. Now, quantum computers use qubits, which can be 0, 1, or both simultaneously, allowing them to solve complex problems much faster. So think of Google Quantum AI like you're trying to design a new medicine to fight a disease. A regular computer would analyze molecules step by step, which could take years. But Google Quantum AI, on the other hand, can simulate how molecules interact at the quantum level almost instantly. This speeds up drug discovery, potentially saving millions of lives by finding treatments faster. Now, you must be wondering, why is it so necessary? Google Quantum AI is necessary because some problems are just too big and complex for regular computers to solve efficiently. These are challenges like developing life-saving medicines, creating unbreakable cybersecurity, optimizing traffic systems, or even understanding how the universe works. Regular computers can take years or even centuries to crack these problems, while quantum computers could solve them in minutes or hours. So the question is actually what problems they are solving. It is basically solving so many problems. I will list some of them. Number one, drug discovery, simulating molecules to find new treatments faster. Then comes cybersecurity, developing ultra-secure encryption systems to keep your data safe. AI advancements, training AI models much quicker and with more accuracy. Climate modeling, understanding climate changes to create better solutions for global warming. So in simple terms, Google Quantum AI is here to tackle the impossible problems and bring futuristic solutions to today's challenges. It's like upgrading the world's brain to think smarter and faster. So, Google Quantum AI has been at the forefront of quantum computing advancements, pushing boundaries from the groundbreaking Sycamore process to the latest innovation, Willow. In 2019, Google introduced Sycamore, a 53-qubit processor that achieves something called quantum supremacy. So, qubits or quantum bits are the core of quantum computers. Unlike regular bits, which are either 0 or 1, qubits can be 0, 1, or both at once. This is called superposition, allowing quantum computers to process vast data simultaneously. They are powerful but fragile, needing precise control and hold the key to solving complex problems. Sycamore solved a problem in just 200 seconds that would take the world's fastest supercomputer over 10,000 years. This was a big moment. It showed quantum computers could do things that classical computers couldn't. After Sycamore, scientists realized a key issue. Quantum computers are very sensitive to errors. Even small disturbances can mess up calculations. To fix this, Google started working on error correction, making their systems more accurate and reliable for real-world use. In 2024, Google launched Willow, a 105-qubit processor. This chip is smarter and more powerful, and it can correct errors as they happen. So Willow shows how much closer we are to building quantum computers that can solve practical problems. Google's logical qubits have reached a huge breakthrough. They now operate below the critical quantum error correction threshold. Sounds exciting, right? But what does this mean? Let's break it down. So quantum computers use qubits, which are very powerful but also very fragile. They can easily be disrupted by noise or interference, causing errors. So to make quantum computers practical, they need to correct these errors while running complex calculations. This is where logical qubits comes in. They group multiple physical qubits to create a more stable and reliable unit for computing. The error correction threshold is like a magic line. If errors can be corrected faster than they appear, the system becomes scalable and much more reliable. By getting their logical qubits to operate below this threshold, Google has shown that their quantum computers can handle errors effectively, paving the way for larger and more powerful quantum systems. So let's discuss what is a great hardware approach in Google Quantum AI that made it possible. Google Quantum AI's hardware approach focuses on making quantum computers stable and reliable for practical use. They group qubits, which are the building blocks of quantum computers, to work together, allowing the system to fix errors as they happen. So by keeping the chips at extremely cold temperatures, they reduce interference, which keeps the calculations accurate. This setup helps the system handle bigger and more complex tasks like simulating molecules for drug discovery, improving AI models, and creating stronger encryption for data security. It's a big step in making quantum computing a tool for solving real-world problems. So while Google Quantum AI has achieved incredible milestones, it still faces some key limitations, which are fragile qubits. Qubits are extremely sensitive to noise and interference, which can cause errors. Keeping them stable requires ultra-cold temperatures and precise control. Error correction challenges. Although Google has made progress in fixing errors, quantum error correction still isn't perfect and needs more work before quantum computers can scale to solve real-world problems reliably. Limited applications. Right now, quantum computers are great for specialized problems like optimization and simulation. For everyday computing tasks, classical computers are still better. Hardware complexity. Building and maintaining a quantum computer is incredibly expensive and complicated. The advanced cooling systems and infrastructure make it hard to expand these systems widely. Still in early stages, quantum computers, including Google's, are still in the experimental phase. They are not yet ready for large-scale practical use in industries. But despite its challenges, Google Quantum AI is paving the way for a future where quantum computing tackles problems that regular computers can't handle, like finding new medicines, predicting climate changes, and building smarter AI. It's an exciting start to a whole new era of technology, full of possibilities we are just beginning to explore. The future of Google Quantum AI is incredibly exciting with the potential to solve real-world problems that traditional computers can't handle. It's set to revolutionize industries like healthcare by speeding up drug discovery, finance through advanced optimization, and energy with better material modeling. So quantum AI could also lead to breakthroughs in AI by training smarter models faster and creating unbreakable encryption for stronger data security. As Google improves its hardware and error correction, its quantum systems will become more powerful and reliable, paving the way for large-scale practical applications. The possibilities are endless, and Google Quantum AI is the forefront of shaping a transformative future.
Imagine a world where computers can solve problems in seconds. Problems that would take today's fastest supercomputers thousands of years to crack. Sounds like a science fiction, right? Well, thanks to quantum computing, we are getting closer to that reality. And at the heart of this revolution is Microsoft's Majorana chip. But what exactly is Majorana? Why is it so important, and how does it change the future of computing? Let's break it down. Microsoft's Majorana chip is groundbreaking development in quantum computing, designed to create more stable, reliable, and scalable quantum computers. But to fully understand its importance, we need to break it down into three key aspects. The science behind Majorana particles, how Majorana particles improve quantum computing, Microsoft's unique approach with Majorana qubits. Let's dive into each of these. At first, let's understand the science behind Majorana particles. The name Majorana comes from an Italian physicist, Ettore Majorana, who predicted the existence of Majorana fermions back in 1937. These are unique subatomic particles that are their own antiparticles. This means that if two Majorana particles meet, they cancel each other out. But why does this actually matter? In classical physics, every particle has an opposite, that is an antiparticle. For example, the electron has a positron. So when they collide, they annihilate each other. But Majorana fermions are special. They are both the particle and the antiparticle at the same time, making them behave differently from anything else we have discovered in nature. For decades, Majorana fermions were just a theory. However, in 2012, scientists of Delft University of Technology in the Netherlands, along with Microsoft, provided the first experimental evidence of their existence in certain quantum materials. Microsoft then spent over a decade refining this research, leading to the creation of the Majorana-based quantum chip. Now let's talk about how Majorana particles improve quantum computing. Quantum computers operate using qubits, the quantum version of classical bits. Traditional qubits like superconducting qubits used by Google and IBM are highly sensitive to their environment. Even the smallest disturbance like a tiny temperature fluctuation can cause them to lose information, and this is called quantum decoherence. Majorana qubits, however, solve this issue by using a principle called topological protection. Here's how they did it. Majorana particles naturally resist external noise and interference. Information stored in Majorana-based qubits is spread out across multiple locations, making it much harder to corrupt. This results in lower error rates and more stable quantum system, which is crucial for scaling up quantum computers. Think of it like this. Imagine writing an important message to a single piece of paper. If that paper gets destroyed, the message is lost forever. But if you spread the message across multiple papers, losing one doesn't erase the whole thing. And this is how Majorana qubits protect quantum information. Now let's talk about Microsoft's unique approach with Majorana qubits. While other companies like Google, IBM, and Intel are building quantum computers using superconducting qubits, Microsoft took a different path. Their research team developed topological qubits based on Majorana fermions. And this approach is groundbreaking for several reasons. First of all, it gives more stability. Unlike superconducting qubits, which need complex error correction, Majorana qubits naturally protect themselves from errors. It provides better scalability. Traditional qubits require more enormous amounts of hardware to correct errors, but Majorana qubits reduce this need, making it easier to scale up quantum computers. It also provides higher efficiency. Microsoft believes that using Majorana qubits will allow them to build a quantum computer with far fewer qubits than other methods. What came before Majorana? Before Majorana, the quantum computing world was mostly focused on superconducting qubits. Companies like IBM, Google, and Intel have been developing these for years. Google's SkyMore processor made headlines in 2019 when it claimed quantum supremacy, solving a problem that would take a supercomputer thousands of years in just 200 seconds. IBM has also made significant progress, building quantum computers with over 1,000 qubits. But despite these achievements, quantum computers remained unstable and error-prone. And Microsoft's Majorana qubits aim to fix this, making quantum computing more practical for real-world application. Microsoft Majorana is a game changer. It's not just another quantum chip, it's a very new way of thinking about quantum computing. By using topological qubits, Microsoft is paving the way for more stable, reliable, and scalable quantum future. So what do you think? Will quantum computers change the world as we know it? Let us know in the comment section below. And if you really like this video, don't forget to like, share, and subscribe to Simplilearn for more tech insights. See you in the next one. So let's talk about the very first top AI tool, which is Skillora.ai. This AI tool aims to provide the best AI-driven mock interview experience. You can take mock interviews for any job roles and subject, receiving instant constructive feedback. Skillora's AI interviewer listens to your responses and asks dynamic flow-up questions to test your depth of knowledge. With the Essential plan, you gain access to 6 AI mock interviews per month. You'll receive instant feedback, ideal answers, and performance reports, helping you upgrade your skills for just $8 per month. The premium plan allows you to enjoy 15 AI mock interviews per month. You'll get the same instant feedback, ideal answers, and performance reports along with priority support, maximizing your learning for only $15 per month.
Next up, we have Visco's. Visco's Advanced AI Coach is designed to elevate your job interview skills, harnessing insights from over 10,000 companies. It offers tailored sessions that simulate real interviews, providing personalized feedback and performance analytics. It transcribes your performance and delivers a conversational experience akin to an actual interview. It also offers customized feedback and performance analytics, helping you refine both your answers and communication skill. During practice session, you can craft questions specific to your desired role and industry, ensuring relevance and depth in your preparation. Supporting various interview styles. The price for AVA services are available for free. Next up, we have interviewing.io. Interviewing.io is an AI-powered platform that provides candidates with simulated technical interviews. The platform uses machine learning algorithms to assess your coding skills, problem-solving abilities, and communication style. You can get 4 simulated technical interviews for $225. Next up, we have MockMate. MockMate is an AI-powered tool that allows you to practice answering common interview questions. This tool provides feedback on your answers and gives tips on how to improve your performance. The service is available for $29 per month. Moving on to ChatGPT. ChatGPT is an AI chatbot that can be used to practice answering interview questions in a conversational setting. The chatbot can be customized to simulate the style of an actual interview, and it provides feedback on your answers. The free plan allows you to get started with writing assistant, problem solving, and many more. You will have limited access to ChatGPT 4.0 mini, including data analysis, file uploads, vision, web browsing, and custom GPTs. All of this is available at no cost. Then we have the Plus plan, which is for $20 per month. The Plus plan amplifies your productivity by offering early access to new features, access to ChatGPT 4, 4.0 and GPT 4.0's mini, up to 5x more messages for ChatGPT 4.0. You can access to data analysis, upload files, vision web browsing, and DALL-E image generation. You can also create and use custom GPTs. Then we have My Interview Practice. My Interview Practice is an AI tool that allows you to practice interviews in a simulated environment. The platform uses AI to generate interview questions based on your chosen field and provides instant feedback on your responses. This tool is particularly useful for those who want to practice their interview skills in low-pressure environment. The Plus plan is for $49 per month. You get 1 month of access. And the Premium plan is for $57 per month, and you will get access to additional features and many more benefits. Next up, we have Udly. Udly offers real-time interview coaching using AI. It analyzes your speech and body language, providing feedback on how to improve your performance. Udly services are available for free. Now you might be wondering how AI tools can help you ace your job interviews. AI tools can assist in several ways. At first, we have research companies. AI tool provides information about companies' website, news articles, and social media, helping you tailor your answers to the interview's question. Practice questions. AI tool help you practice answering common interview questions, boosting your confidence and preparation. Feedback. AI tool offers feedback on your answers, highlighting areas for improvement and refining your responses. Personalized advice. AI tools provide tips and advice on improving your interview skills, giving you an edge to your next job interview. Choose the right AI tool and select an AI tool that fits your needs and preferences. Use the tool consistently, starting a few weeks before your interview to maximize its benefits. After practicing with the AI tool, get feedback from others to identify areas for further improvement. Dress professionally and be punctual for your interview to make a positive first impression. Show enthusiasm and confidence during the interview to leave a lasting impression on the interviewer. AI tools can significantly aid in interviewing preparation. By using them effectively, you can enhance your chances of success in your next job interview. So that's a wrap on our Generative AI Full Course. If you have any doubts or questions, you can ask them in the comment section below. Our team of experts will reply you as soon as possible. Thank you and keep learning with Simplilearn.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.